Hello everybody and welcome back, and in this tutorial we are going to look at a library in Python which is called scapy. Now what scapy allows us to do is actually configure our own packets and send them by our own needs. So we can send the packets, wait for a response back, we can print the response, we can do a bunch of other things, so we can basically manipulate with the packets that we actually send to the target. Now this helps us to understand better our ARP spoofer that we are going to code. So first of all, what we want to do is actually just check how the ARP packet is constructed to see its available fields and to actually change some of the fields and see what we can do with the ARP packet. But before we do any of that, I just want to introduce you to a certain command that you can run in both command prompt on Windows and in terminal in Linux. If you just type ARP -a, you get the ARP tables of this certain machine. As we can see, the ARP table is basically a table consisted of the IP addresses and the MAC addresses. Now what this allows our machines to do is to actually communicate with one another, since now my machine knows that the IP address of 192.168.1.1 is affiliated with this MAC address right here. So once it wants to communicate with the 192.168.1.1, it basically communicates with this MAC address. What ARP request allows us to do, which we will code just in a second, is it allows us to get the MAC address of a certain IP just by sending the ARP request. Then someone sends the ARP reply back and we get the MAC address of our target. So let's see how we can do that. Scapy, as I said, is a library by itself. We can just run scapy instead of Python, and in order to do that you just type scapy, and this should open the scapy interpreter, which allows us to construct our own packets. So we can see it has opened. It looks similar to the actual Python interpreter, and here syntax is a little bit different. You can do a bunch of other stuff you can do in Python, but most of the stuff you can actually do. So first thing we want to do is see what actual fields does the ARP request have, or basically ARP packet. It doesn't have to be request, it can be reply also. And in order for us to actually do that, we need to type just ls, and in the brackets type ARP, close the brackets, and it will print out the available fields that the ARP packet has. As we can see, the p destination is the IP field of a target we want to actually get the MAC address from. The hardware destination is the MAC field of the target, which the hardware address or MAC address we want to get. The p source and hardware source is basically our IP field and MAC field. The OP is basically the type of packet we want to send. The 1 stands for the request and the 2 stands for the reply. So you can send this OP value to be either 1 if you want to send an ARP request, or 2 if you wanted to send the ARP reply. So let's see how we can actually construct a packet in order to get the same MAC address from this command from our router. So the IP address of router is 192.168.1.1, and we want to get the IP address or the MAC address of that router. Let's pretend we do not know it. So in order to do that, what we can do is first of all create a broadcast packet. So in order to do that, you just need to press equal ether, and in that broadcast packet, since we will concat it to the ARP packet, we want to select that we are actually sending this packet to the broadcast MAC address. Now what the broadcast MAC address is the MAC address where actually every machine on our local area network will receive this packet, and if some machine knows the answer to our question, it will respond back. In order to select to a broadcast MAC address, we need to select the DST field right here to be equal to this MAC address. So just select it like this, equals to FF, and once again FF. This is the MAC address of the broadcast, this is the broadcast MAC address which we are going to send the packet to. So just click enter right here. And since we created the broadcast packet, all we want to do right now is also create the ARP packet. So in order to do that, you just make ARP packet, for example. Let's call the packet like that. We set it to be equal to the ARP. So just type capital ARP, open and close the brackets. And let's say we want to actually set the, let's actually see what we want to set in this ARP packet. So we want to set the p destination field to be the IP address of our router, since it's the router's MAC address we are looking for. So in order to do that, you just need to select this field right here, copy the name of it, paste it right here, and type equals, and there you can actually set it to be the 192.168.1.1, which is the IP address of our router. Press here enter, and you successfully constructed the ARP packet, which has this value under the field of P destination. In order to check it, you can just type ARP packet.show with open and close brackets, and there you will have all the things that this ARP packet has specified. Now, as you can see, some of these things are specified by default, such as the HW source and the P source, which is our MAC and IP address, which basically is set by default since the escapee can recognize what our IP address is and can see what our MAC address is. Now, if this for some reason doesn't specify for itself, you can check both of your MAC and IP address by just typing ifconfig in your terminal. As we can see, my IP address is 192.168.1.7, which is selected under the P source field. My MAC address is this MAC address, which is selected under the hardware source field. So let me just, in case you are not seeing this very well, let me just zoom it like this. Then I will move this a little bit to the side, just like this. Move this all the way down. Just make it a little bit prettier. Okay, so it's good right now. And we can see that all we actually have to do right now is concat these two packets. Since we are looking for the actual MAC address of the router, we want to send our request to the broadcast MAC address so all PCs or all machines on the network can receive it. In order to make these two packets into one packet, we can just do the final packet, so let's call it final packet, equals, and all we have to do is just make a simple statement that looks like a division in Python, so broadcast, and then the /ARP packet. So we created our final packet, which we are going to send right now. So in order to check the fields of your final packet, you can just type final packet.show, same as the ARP packet, and you can see that our final packet has the Ethernet field, and under the Ethernet field it has the ARP field right here. This source is our MAC address, this destination is the MAC address of the actual broadcast, and this right here, the type, is the type of packet that we have under our final packet, which is the ARP packet. So 0x86 basically, or pardon me, 806 stands for the ARP packet. So all we have to do right now is send this packet to the target, or basically to the broadcast MAC address, and wait for a reply back, which then we will store in a certain variable which we can print afterwards. So let us call that variable answer, since the answer is what we are looking for after sending this packet. And in order to send it, we can just type srp, and in the brackets, we need to specify which packet are we going to send. So we are sending, of course, the final packet, since that is the packet that actually consists of both the Ethernet and ARP field. We can set the timeout to be equal to 2 seconds. And we can set the verbose to be equal to true. So we can see what actual, oops, let me just check this out. What actual things is this performing? Since this answer will actually return a list, and the list consists of the answered and unanswered basically responses, we want to select only answered, so we will select the first list, which will be under the value 0. So click here enter. As we can see, finished sending 1 packet, received 1 packet, got 1 answers, remaining 0 packets. So someone sent our answer back. In order to print that answer, we can just use the actual, let me just show you, we can store it in the variable, which we can call MAC address, which will be the MAC address of our target, which we want to get under this field, which is the hardware destination. And all we want to do is select the answer, or let me, before I do that, just show you. If I just type here answer, you can see that the results is under the other. So what we want to do is select a certain, let me just show you. If you just type MAC address equals and then answer, we take the first argument and the second argument of that list, And what the field that we want to actually get is the HWDSD, which is the hardware destination. So all we have to do is press dot afterwards and type HWDSD. So just press here enter, and now our MAC address is stored in the MAC address variable. So we can just print MAC_address, and you can see that right now we got the MAC address of, let me just check this out. Why did we get our own MAC address? That is a really good question. Well, for some reason, maybe I selected something wrong, but for some reason, oh, pardon me, we are not looking for the actual, or we are actually looking for the hardware destination. And what did I actually select right here? Let me just double check everything in order to see if I selected it correctly. Let's print the MAC address. Okay, so hardware source. Of course, I was confused a little bit because I selected right here the hardware destination as to the actual field where the router's MAC address will be, but the hardware destination is actually our own MAC address. And now you might be asking, why is that, since here it is the hardware source, which is our own MAC address. Well, this that we sent is a request, and the value that we are printing is the value from the response which was sent from the router. So basically, the router's packet is having these two fields flipped as to us, so the hardware destination will be our MAC address and the hardware source will be the router's MAC address, since the router is the one that is sending this packet back. And we can see that the router's actual MAC address is this one. So that would be basically it on how to actually get the MAC address from a target. Now, in order to actually create a malformed packet, what we can do is actually craft a packet which will specify wrong thing. Now, by wrong thing, I mean that we can actually fool our Windows 10 PC into thinking that the MAC address of the router is our MAC address. Then what our Windows 10 PC will do is it will send all the packets back to us. And since we haven't anything else specified, the actual Windows 10 PC will lose its connection to the internet. So let us see how we can create a malformed packet. So let me just see if I can, what we can do is actually make a variable called packet. And this variable packet will be an ARP packet, which we will then send. And what we want to do is, since the first packet we actually sent was a request packet, which was under the OP and equal 1, what we want to do is make OP equal 2, since right now what we are sending is the actual response. We want to send the response to the Windows 10, even though they never sent us our request. We want to send them a response saying that we are the router. So we can do that with OP equals 2, which is the actual response. The hardware destination is equal to the actual MAC address of our Windows 10 PC, which we can actually get since we don't actually have. So let us see how we can get it. We can make our final packet .show. We can just change a little bit of code in our final packet. So in order to do that, we need to change the final packet dot, let me just check it right here. I believe it is the the P destination has to be equal to the IP address of my actual Windows 10 PC. So let me just check it out. It is 192.168.1.5. So we select 192.168.1.5, whoops, not 6, 5, instead of the router's IP address. And all we have to do is actually just use the same command from before. Final packet, timeout, we want to send the, oops. Wait, let me just check this. Don't actually execute these two commands. My keyboard actually, not really sure why it did it, but we can just ignore these two commands, and we want to send this final packet once again. So in order to send it, we use the same thing as before. So we will use a variable answer again, And that answer, we will send the packet, so we can use the final packet to send it. Timeout will be equal once again 2 seconds, just in case. We can use the verbose to be false right now, it doesn't really have to be true. And we use the first list answer right now, so we see if it got answer. It got answer under the section other, and all we want to do is actually set the MAC to be equal to the answer. We select the first value, open square brackets 1, and we want the hardware source. And we want to actually print MAC right now. So this is the MAC address of my Windows 10 PC. And right now we can actually send the malware packet to my Windows 10 PC. So let me just run ARP-8 in my Windows 10 just to see once again what the actual MAC address of the router is. So the MAC address of the router is this, and now we will change it to be this, since this is the MAC address of my Kali Linux machine. So let us see how we can do that. We will select a packet variable to be equal to ARP packet OP2 once again, since we are sending the response. The hardware destination, so hardware destination will be equal to the MAC address of our Windows 10 PC. So let's copy it, select it under the double quotes, paste it right here, and then all we have to specify again is the actual P destination, so the IP address of our Windows 10 PC, which will be the 192.168.1.5. And here, what we want to select is the P source. So P source, not really sure. Let me just move this to the side so you can see it a little bit better. So P source equals the IP address of the router actually. So what we want to select is that our source IP address is actually 192.168.1.1, which will then trigger the actual, where is my actual packet going? Okay, so here it is, which then will actually trick the router into thinking, I'm not really sure what is happening with my actual terminal, but it doesn't really matter. What I just added at the end of this command is the actual bracket, which for some reason added up right here, but it doesn't even matter. Right now we need to send this packet in order to trick our Windows 10 PC into thinking we are the router. So how we can send? We can just use send and then packet, since that is the name of our packet. We can send the verbose to be false since we don't need it. And we just send the packet. And right now, if I just type ARP-A once again, you can see that right now the MAC address of the router has changed. So we successfully changed the ARP table in our Windows 10 PC into thinking that we are the router. As you can see, the IP address of my Kali Linux machine and the IP address of the router both have the same MAC addresses, which shouldn't be like that. So we successfully ARP spoofed our Windows 10 machine with one packet. We crafted the packet and then we sent it to the target. What we will do in the next video is we will actually make a program that will do this in a while loop, so we can actually spoof the Windows 10 PC as much as we want, and also we need to spoof the router as well. So we need to spoof two targets in order to make this actually work, since only spoofing the Windows 10 machine will not do us any good, since the router still knows that the MAC address of the Windows 10 PC is its true MAC address, and we want to spoof the router as well, so the router sends packets back to us. So we will see how we can do that in the next video. Hope you enjoyed this little demonstration. Not really sure what happened with my terminal right here, but everything finished well. Hope you enjoyed it, and I hope I see you in the next video. Bye! Hello everybody, and welcome to the beginning of the new Python for Ethical Hacking course. Now, in this course we will be coding our own tools that we covered in the Ethical Hacking course. Now, for some of you that are coming basically first to this course and didn't watch any other ethical hacking courses instead of this one, I'll make sure to make this course beginner friendly and explain everything as we go. We will start off by actually installing our environment, setting up our Kali Linux machine, which if you are not a beginner and you actually watch some of the ethical hacking courses, you probably already have the Kali Linux machine installed, so you can skip the introductory part and go right into the coding section. Now, what we will be doing in this course is, as it says, we will be coding some of our own tools that we will use for our ethical hacking attacks. Now, if you take, for example, any ethical hacking course, it consists of scanning, enumeration, basically exploitation, backdoors, keyloggers, brute forcers, and any other attacks on the websites, for example. There are lots of other things as well, but all of those things you actually perform with tools that other people created. Right now, what we want to do is actually code some of our own tools and make them useful for our future attacks. So, we will start off by coding some of the port scanners. For example, we will try to create something similar to the Nmap. We will start off our attack by scanning the port, scanning the target, checking out for the banners for the versions of software running on the target system on an open port. And then we will proceed to actually exploitation and attacking, brute forcing SSH, for example, brute forcing FTP, and other protocols as well. We will also code the reverse shell, which if you're coming from my previous ethical hacking course for beginners to advanced, you probably already have an idea what the reverse shell is, since I covered it in that course. But right now, what we will do with that reverse shell, we will take and add some different functions and try some different things with it, as well as actually maintaining everything we did in the ethical hacking course. Now, if you didn't watch that, don't worry, I will cover everything from the beginning in that program, and we will also cover everything in great details, as I will try to explain it the best even for the users who don't know anything about Python. Now the thing is, I will not be actually showing you the how to code in Python. Basically this is not a Python course, but I will, however, explain everything as we go and code our own tools. Since actually coding or teaching you how to code in Python will take a lot of our time, I will tell you everything that we are going through in great details. So don't worry, even if you don't have any previous experience, you can still attend this course and you can learn a lot from it. Now, as I said, we will start off by actually creating our virtual environment. We will need the Kali Linux machine. We will need the VirtualBox program as well. Now, the Kali Linux machine is where we will actually run our attacks, where we will code our own tools, where we will compile them and run them. It is good to say, or I should say actually, that you can also run all of these attacks on Windows, or not run, you can actually code on Windows if you want to. If you, for example, have Python on Windows, you can actually code all of these tools in Windows environment. Now, if we run into something that can't be run into the Windows environment, I will make sure to actually say that before we start coding. But for you to best follow this course, I would advise you to actually download Kali Linux, or if you have it, you can just run it up. For those of you who don't have it, I will show you in the next sections, or basically in the next videos, how you can download and install your Kali Linux machine. Right after that, we'll go straight into the port scanning section, where I will teach you how you can actually code your own port scanner. So that would be about it for this introductory part. I hope you will enjoy this course. I hope you will learn a lot from it, and I hope you will use it for your own purposes, as long as they are on the legal side. So that's another thing I should mention. Basically, please don't use this for anything that's not legal, such as scanning targets you do not own, such as attacking targets you do not have permission to attack, or basically anything that doesn't go into the legal side. So that would be about it. Hope I see you in the next lecture, where I will show you how you can download VirtualBox, the newest version, and Kali Linux 2019.8 version, or .a version, pardon me. So, hope you enjoyed this introductory video, and I hope I see you in the next one. Bye! Hello everybody, and welcome back. And in this video I will show you how you can actually download both VirtualBox and Kali Linux, the newest version. But if you have the older version, that one will work as well, I believe, even though you actually want to keep everything updated. And updating your VirtualBox, for example, is always a good thing to do. So we'll download the latest version of both of these programs and we will try to make our own virtual machine. Now, as you can see right here, I already have both of them downloaded, which this is the installation file that we will use in order to install VirtualBox, which I have installed right here. And this is the Kali Linux 2019.1a version for the 64-bit machine. So, in order for you to actually download these two files, you need to go to these websites right here. So, one of them is kali.org/downloads, and there you will have the newest version of Kali Linux available at the current moment. Now, if, for example, in the time where you are watching this course, there is a different version other than 2019.1a, feel free to download that one as well. And if you have any other problems regarding that version being different than this one, feel free to post questions and I will be happy to answer them. So right now what we want to do is actually download the Kali Linux for our virtual machine. So as you can see right here, we have different types of Kali Linux models right here. We have the 64-bit, the Kali Linux LXDE 64-bit, the Lite version 32-bit, and a bunch of other versions as well. Now the two versions that you should focus on are the Kali Linux 64-bit and Kali Linux 32-bit. Now, figure out what your main PC is. For example, my Windows 10 machine, which is this machine right here on which I am on currently, is a 64-bit machine, so I will download the Kali Linux 64-bit version. Now we can see the size of it is 3.3 gigabytes, and we can download it both from the browser and from the torrent. I will click here to download from the HTTP. This will take some time, that's why I already downloaded it before this video started, so I will not be downloading it now. You make sure to wait until all of these 3.2 gigabytes or 3 gigabytes are finished, and after that you can continue with the downloading of VirtualBox. So once again, if you have a 32-bit PC, download the 32-bit version. And after you do that, you want to go to the VirtualBox website, which is right here. So let me go one directory back. You just type in VirtualBox in your Google search bar and you just click on the first link that pops up, which will be Downloads Oracle VM VirtualBox. This will lead you to this page where you can actually pick which one you want to download. As we can see, VirtualBox, the current version is 6.0.4. The platform packages, as we can see, they're separated for Windows hosts, OS X hosts, Linux distributions, and Solaris hosts. Now make sure to pick the version on which your main software, or main operating system is running. For me that is Windows, since I'm using Windows 10. So I'll just click right here on Windows hosts. And as you can see, it will start downloading the VirtualBox 6.0.4 version for me. Now this is a lot smaller file than the Kali Linux 2019 version, so this shouldn't take too much time to finish. But I already have both of these files, so I will actually close this and I will show you how you can install the VirtualBox in this video. So once both of these files are downloaded for you, I can close this right now. We do not need it anymore. What you can do is actually paste them both on the desktop, as it will be easier for you to find them. And right now we are only interested in this file right here. So this is the installation file for our VirtualBox. Now before I actually install it, let me close both of my machines. So just close it like this. This is just a virtual machine and this is the actual interface of our VirtualBox, which I will show you just in a second, right after I show you how you can install it. So what you want to do is double click the installation file. It will say preparing to install, and basically all you want to do is just click next on every question it asks you. So right now if I click here next, this part right here is something you won't have. Now I have this because I already have VirtualBox installed, so it asks me modify, repair or remove installation, since it can't really install it twice. So I will just remove my current VirtualBox. I will just click here remove. As I said, you will not have any of that. You can just proceed to the next step. I will click here yes. It will remove my VirtualBox. Currently, as we can see right here, it should be removed any second. And right after that finishes, I will show you the true process of installing VirtualBox, which will be basically just clicking next on every step. As we can see, I don't longer have the VirtualBox right here, so I will just click here finish. I will double click this once again, and we can see I will just go next on every step. So create start menu. If this is not checked for you, make sure to check it, so it actually creates a desktop icon for you on your own desktop, so you can actually easily navigate to the VirtualBox. So just click here next, proceed with the installation, yes, and then install. This shouldn't take too long. It will prompt you for the administrator password. Basically, if you allow this application to make changes, you press yes, and this will download in just 10 or 20 seconds or something like that, and you will be good to go. Then you can open the VirtualBox and we can proceed to the actual creation of our Kali Linux virtual machine. So it has finished. As we can see, we want to check right here Start Oracle VM VirtualBox after installation and click here Finish. Now we wait for the window to open up, this same window you saw previously, and this is something that you won't really have. So all of these are virtual machines that I actually created before. You will not have any of these if you are currently installing the VirtualBox for the first time. If you are not, if you already have Kali Linux machine and VirtualBox installed, you're probably skipping this section anyway. So all you have to do right now is actually click here on the new button right here. Now this new button right here basically presents the new virtual machine. So once you click on this, it will ask you for some of the questions in order to create for you the new virtual machine that you will use. So right here, you can name the machine anything you want. This is basically the name of your machine. I will name it Python Ethical Hacking. Doesn't even matter, you can name it anything you want. What I will do right here is, this is the important part, in the type you want to select the Linux, since we are using the Linux operating system, and right here you will have a bunch of these options for the Linux version, and you want to select the Debian 64-bit. Now if you installed Kali Linux 64-bit version, you select here Debian 64-bit. If you install Kali Linux 32-bit version, you want to select here Debian 32-bit. Since Kali Linux is actually based on Debian. That's why we are selecting Debian right here. So once you make sure everything is good, you have the type Linux, the version Debian, and then 64 or 32-bit. You gave it a name, and this is the folder where the machine will be saved. You proceed to the next step. Now the next step is basically the memory size which you will give to your virtual machine. Now this is basically your RAM memory. So for example, as you can see right here, I have 8 GB of RAM memory on this PC, and I want to choose how much RAM memory I want to give to my virtual machine. Now what this means is basically, if you have 8 GB like me, and you give 2 GB to your virtual machine, every time you start up your virtual machine, the virtual machine will actually occupy 2 GB of your RAM. So for your main machine, there will be left only 6 GB. So make sure to not select too much right here, or it might actually make your PC crash. For example, if I just type here 8 GB, it will not even open the machine, since there will be no memory left for my main PC. So I would advise you to put like 2 GB at least. You can go with 1 as well, I believe, but you don't really want the machine to run that slow. So all you want to do is just select the memory that you are capable of giving to the virtual machine. For example, if you have 4 GB, you can technically give 2 GB for the virtual machine, but it might be running a little bit slower since you only have 2 GB left for your main machine. But it doesn't really matter. For now on, we just want to select the appropriate memory for our virtual machine. Click here Next, and you want to select Create a Virtual Hard Disk Now, and click here Create. It will ask you what file type of the hard disk you want. You just click here Next, which is selected as VirtualBox disk image, dynamically allocated. What this means, basically dynamically allocated, it will not fill up the space as you use the machine. Now the fixed size, if you for example give 50 gigabytes of your hard disk memory to this virtual machine, it will already make those 50 gigabytes as full. You will not be able to use them or to do anything with them unless you delete the virtual machine itself. The dynamically allocated will however not take any memory right now, but if you actually use it, can take up to 50 gigabytes of memory. So click here next. I will just leave it on dynamically allocated since it creates it faster, and all it asks right here is the confirmation of the name and the amount of memory you want to give it from your hard disk. Now if your hard disk is for example 1 terabyte, you can give it 30, 20, 40 gigabytes, however you want. Make sure to not go below 20 gigabytes. So I will give this machine around 30 gigabytes of memory. So 32, doesn't even matter. I will click here on create. And right now, as we can see right here, we have Python ethical hacking, which has Debian 64-bit icon right here. You can see the specs of our virtual machine right here. And we will continue to actually installing Kali Linux itself in the next video. So, hope everything went right for you. We will continue with adding our ISO file that we received from the Kali Linux downloading process. And we will use it in order to run our operating system on this virtual machine that we just created. So hope you enjoyed this video, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to the third video of our introductory part. Right now, what we want to do is install our Kali Linux machine and get it to actually work. Now, this is a process that can take a little bit of time, since the installation process takes around 30 to 40 minutes on average, but this is something that we need to do in order to actually have our hacking environment set up. So what you want to do is start up your VirtualBox, so just click on the double icon right here. If you didn't install VirtualBox, make sure to check out previous video in order to see how to do that. This installation file, you do not need it anymore, you can just delete it and start up your VirtualBox. So right now we can see that right here we have our Python ethical hacking machine. Basically all you have to do right now is actually add this ISO file to the virtual machine storage before actually starting up the machine with this button. So how can we do that? We can do that by selecting the virtual machine and then going to the settings right here. So right here you will see a bunch of different settings for our virtual machine, such as system settings, display, storage, audio, network, serial ports, USB, and so on and so on. So let us actually go through these settings right here in order to see if everything is correct. So this is something we specified in previous video. This right here is not really important to us. On the system part, you can change your RAM memory if you want once again. If you think you gave it too much or too little, you can change it right here. The processor part is something that we didn't see in the previous video. Basically, this part right here allows you to actually give your virtual machine more CPU cores. For example, it will by default leave your machine on the 1 CPU core, but you can, for example, if you have a really good PC with like 6 or 8 cores, you can just give it 4 or 3 or anything, any number you want, but make sure to not give it too much, as it will leave a little for your main PC. So what I will do, I will just leave it on 1, and this right here is basically the percentage of core being used for your virtual machine. So if you just leave it on 1 and drop this to 50%, for example, what this will do, the virtual machine will only use the 50% of your 1 core, which is not enough, or maybe it even is, I never tried it. What I will do is I will leave 1 core to be used by our virtual machine, and I will give it 100% of power from that core. The acceleration is something that we do not care about, so make sure to check this if this is okay, this one as well. And next thing we want to do is go to the storage. Here we will add our Kali Linux ISO file. So what we want to do is first of all delete the empty attachment right here, so remove it, remove, and under the controller IDE right here you will have this disk with a plus right here. All you want to do right now is actually just click on this, so click on the disk with a plus. it will ask you, do you want to choose disk or leave empty? We want to choose the disk that we want to use. And what this disk is basically, it is our ISO file that we want to run as an operating system. So if you can't see it right here, which you most likely won't be able to see it, just click here on the Add button right here. It will lead you to your Explorer where you can navigate to the desktop or wherever you saved this ISO file and select it. So it is right here. I will click here Open, and I will double click it right here. As we can see, right now we have the Kali Linux 2019.1a AMD 64-bit version.iso. Once you select all of that, you can click here OK. The network part of settings we will cover later on after the installation, but for now on we are good to go, so just click here OK. Once you finish that, you are good to go and you can actually start up your virtual machine running Kali Linux. So just click here on this green arrow right here, which says Start. It will open up this window, which is our virtual machine. As it says right here, VirtualBox version 6.0, and all we want to do right now is actually select either one of these two options, so graphical install or install. Now you can proceed to go with any of these two you want. Basically they are the same, just the graphical install is a little bit prettier, but I'm used to going with the regular installation, so I will just click here enter on the install. Now before we continue, you might have noticed, let me just enlarge this so you can see it better. You might have noticed that we can't actually navigate with our mouse anymore. So in the installation process, you can navigate only with the arrows and with the enter. So click here either graphical install or regular install, and this will start the process of installation of Kali Linux for us. Now, during this process, it will ask a bunch of questions, which I will make sure to show you what you need to answer in order to get this to work correctly. So this is something that really is up to you, so you can select any language you want. I will just proceed here with the English. And the select your location is also up to you. Select your own location, or it doesn't even have to be your own location. I will just select here United States, even though I am not from the United States, I'm from Europe. And this is the configuration of your keyboard. So this can be a little bit tricky if you're used to, for example, QWERTY part and not QWERTZ. So make sure to check that out before continuing. Or, for example, if you have a different type of keyboard configuration, you can select it right here, as there are a bunch of others as well. What I will do is I will go with the American English, and this will finish up with the questions currently. Right now, as we can see right here, it is loading some additional components, so we will let this run. And hopefully our process of installation goes without any errors. Now once again, if you encounter any errors, make sure to post a question and I will be gladly answering you on your problem. So we can see configuring has finished. And right now, it asks us configure the network. Please enter the hostname for this system. The hostname is a single word that identifies your system to the network. If you don't know what your hostname should be, consult your network administrator. If you're setting up your own home network, you can make something up here. Now, this is completely up to you what name you will specify right here. I will just leave it as Kali. Basically, this is just something that will pop up in your terminal every time you open it. So you can just type here anything you want. I will just go with Kali. So navigate with your arrows to continue and press here enter. It will ask you to configure the domain name as well, which we do not need at the moment. So right now I will just leave this empty and click continue here as well. So right now it will ask you for your root password. Now here you basically type any password you want, make sure to remember it or else you will not be able to log in into your root account on Kali Linux machine. So just type here anything you want. In my case I will just use test1234. As we can see, if I go on to the show password in clear, oops, yeah, arrows don't seem to work. Okay, so here it is. You need to press spacebar in order to show password in clear. So test1234, and I will go to the continue, where it will ask me to actually re-enter the password. So re-enter once again, test1234, and go to the continue. configure the clock. So basically this is also optional. I mean, you do not really need to select your own time zone. You can just go with anything you want. But if you want to have the correct time and everything correctly, you can just specify the correct settings. So I'll just go here with Eastern. And let's see what will pop up next. I believe right now it might actually start the... Oh, there is the partition disk. I forgot about this part. So all you want to do right now is actually just click here enter on the guided use entire disk. Now the encrypted disk we will not install since it is not really needed for this course. So we will just go with the guide use entire disk. Click here enter. It will select disk to partition, and you will most likely have only this one disk that you selected, which is around 30 gigabytes as you remember when I specified it. So just click enter on that one. And for this part right here, you want to select the all files in one partition. As it says right here, it is recommended for new users, and if you're watching this video, you're most likely a new user of this, so you want to go with this so it doesn't present us any other problems. So just select here all files in one partition, click enter, and right here click finish partitioning and write changes to the disk. What this will do is it will ask us once again if we are sure we want to write the changes to the disk, as it says right here, if you continue, the changes listed below will be written to the disks. Now don't worry, this is only referring to your hard disk that you specified in the creation of virtual machine, which is only 30 gigabytes if you specified it like me. So this will only change write changes to that section of your hard disk. So write changes, yes, and this will actually start the installation itself. So what we will do, we will let this run, and I will see you as soon as a question pops up or anything that we need to answer in order to continue the installation process. So here we are at our first question that popped up, which is the configuration of the package manager. Now it says right here, a network mirror can be used to supplement the software that is included on the CD-ROM. This may also take newer versions of software available. Now what you want to go right here is select here yes, use a network mirror, so click here on yes. And the next part right here is the HTTP proxy information, which we do not really need to specify. So right here we can only just continue without typing in anything right there. Now what this will do is it will actually configure the APT as it says right here for a few moments, and then soon I believe it will prompt us with the grub bootloader question, where we actually want to select yes and install the grub bootloader to the master boot record. Now don't worry, I will read it out loud once the question pops up, and I will also tell you what you need to do. And I believe right after that, that will be the last question that will pop up, and the process of the installation of Kali Linux will finish then, and we can put up into our new Kali Linux machine. So let's just wait for this configuration of the APT to finish, and then we will continue. So let's wait for this. So here it is. I believe right now it will prompt us with the question. Not really sure why the screen is blue, but hopefully it will go away soon and we will get our question prompted. So here it is, installing grub bootloader, retrieving file 1 out of 3, and I believe right now it will prompt us with that question I was talking about. And here is the question. So you can read it if you want, or I will read it right now, as it says, it seems that this new installation is the only operating system on this computer. If so, it should be safe to install the grub bootloader to the master boot record of your first hard drive. Now you might be asking, well, this isn't really our first installation operating system. You have your main Windows machine, for example, system, but this is not referring to that. It does not know that it is run as a virtual machine. So basically, for this virtual machine, this is the first operating system, and we want to actually install the grub bootloader to the master boot record. So right here, select here yes and press enter, and all you want to do right here is basically device for the bootloader location, scroll down to the /dev/sda and click here enter as well. Now this will continue, or basically this will finish the installation of grub bootloader, and this will also finish the installation of our Kali Linux machine. This is the last part, as it says right here, finishing the installation. Now what it might actually do is it might prompt us with something like unplug your USB drive after a certain point of this installation, but we really do not want to do anything there, since it is referring to anyone installing this operating system on a main PC as a main operating system, because they would most likely be doing it via USB drive with the burnt disk image on that USB drive. But since we are not doing that at the moment, and since we are not really installing a real main operating system, instead we are installing a virtual machine operating system, we will just proceed with that question if we even get it prompted. So let's wait for this installation part to finish. And here it is, installation is complete, so it is time to boot into your new system. Make sure to remove the installation media, we don't care about this, just click here, continue, finishing the installation. And as soon as this finishes, we will be able to start our Kali Linux machine. I believe this will not take more than a minute or two, so don't worry. The longest part of our installation has actually been finished already, which was the installation part itself, and this is just some additional packages it needs to install or configure in order for our Kali Linux machine to actually start. So here it is finished. Right now we are rebooting or booting into our Kali Linux machine. Right here you can just let this run by itself, or you can press enter. It will load some of the components and it will start up our Kali Linux machine. Now I need to show you how you can log in, since if this is your first time, which it most likely is, you need to know the username, and you will also need to know the password that you specified in the installation process, so make sure to not forget that. The username for the logging in into the root account on Kali Linux is basically just root, so you just type under the username section root. It will be the same for everyone, and after that it will prompt you for a password where you actually just type the password that you specified in the installation process itself. So right now we will wait for that window to, or basically for that login to get prompted to us, and then we will specify everything we need in order to log in. So here, this is the login screen of the Kali Linux machine. You just type under the username root, and under the password you just type basically the password that you specified in the installation, which in my case it is test1234. Press enter and it will prompt you with your desktop for your Kali Linux machine. Now I will not be explaining in details the environment of Kali Linux itself, since this course is not really aimed towards that. So with a little bit of actually exploring additional videos or additional parts of the internet, you can actually find out a lot of great things about Kali Linux if you are new to it. Of course, I will make sure to explain everything that we use and everything that we need in order to actually make our programs. And also, if you might notice right now, since we are at the login screen, you might notice that our screen isn't really that big. It is only squared to this part right here. We want to make sure that our Kali Linux machine is full screen, so we can get the full quality of this video, and we do not need to really watch a small screen display. So I will show you that in the next video. That is something that you should really do in order to get the best out of this installation. So that would be about it. As we can see right now, we have our Kali Linux machine opened, and I will show you how to make it full screen in the next video, as well as some additional stuff you might need to do. So hope you enjoyed this tutorial, and I hope I see you in the next lecture. Bye! Hello everybody and welcome back. And in this tutorial I just want to show you how you can make your Kali Linux machine a full screen. Now I already recorded this video, but for some reason the video didn't have audio on it. So you might be asking, why are you not just redoing the video and showing us everything from the beginning? Well, basically something really interesting happened, and by interesting I mean there was an error that occurred and I was still able to get the full screen mode in Kali Linux, but I just want to show you how you can get it, and if you encounter the same error, what you need to do in order to actually get your Kali Linux into the full screen mode. Now that's why I will be running just the actual video of the screen recording that I saved while I was trying to make my Kali Linux full screen. I will narrate over it, don't worry. Let me just find which one was it. I believe it was the 23 minutes or something like that, so it was a rather long video. So here it is. And let me just put this into the full screen mode. So as you can see right now, I already, or not already, I still have the regular Kali Linux small box machine. It's still not full screen. And let me just show you what I did in order to get it to the full screen. So I opened up my terminal, as you can see right here. So just click on the icon on the left right here in order to do that, which you should know by now. Open your terminal, and here I'm typing the command prompt in order to open my command prompt on Windows so I can show you what the terminal actually is in Linux. So basically both of these are actually the same. The command prompt, which you might have actually encountered sometime on your Windows machine, is basically just a program that allows you to execute system commands, while basically the terminal in Linux is the actual same thing. Just this is in Windows and this is in Linux system. So let us continue. Let's see what else I showed right here, which I can't really remember. I will just go over every step I did in order to get the Kali Linux machine to be full screen. So let me just see. I opened up my Firefox, and yeah, the reason why I opened Firefox is because we have to find the repository on the Kali Linux website, which allows us to specify the link in our sources.list file. Now, for those of you who are new, you probably have no idea what I'm talking about, but don't worry, this process, I will show the entire process of actually doing it. So what I did is basically I just opened the Firefox, then I closed these basically windows, these two windows that pop up by default, and I just want to actually go to the official Kali Linux website. So as you can see, I'm typing right here Kali repositories. So I just type reposi and forgot even to finish the sentence, but it doesn't even matter. What you need to type in Google search bar is Kali repositories on your Kali Linux machine. Once you do that, you will go basically to the first link, which is Kali docs-Kali Linux, which is on the official site of Kali Linux. As you can see, this is the link. And all you want to actually find is the resources that we want to, or the repositories that we want to actually specify in our apt sources.list file. And those repositories, as you can see, I'm trying to find them. Here they are. You need to actually get the Kali rolling repository, as I am specifying right here. So you just go down, scroll down, and copy this part right here. Copy the entire link. As we can see, currently I am copying it, so we can specify it in our sources.list file. Then let me just go right here. So I opened after that my terminal, and right now what I will do is I will navigate to the sources.list file. Currently I am in the root directory, and I will navigate with the command called cd. As we can see, this ls command, once you type it in your terminal on Kali Linux, it will just list the directories in the current directory. So these are all the folders in my root directory. And with this cd etc, I'm changing my directory to the etc directory. And right now, if I specify ls once again, you can see in that directory, here is our sources.list file that we need. Now let me just go a little bit back. So what I did right here is I used the command nano sources.list, and what nano command does basically is it opens something similar to the notepad, so you can edit the file in there. It is a program that comes pre-installed in Kali Linux, and you can use it to nano any program, any file, any text file in order to see its contents and in order to change its contents. So we want to nano the sources.list file, which we found in the /etc/apt directory, which we navigated with this command cd etc/apt. Once we open that file, you will see that this is specified in that file. Now, we already have the thing that we copied. As we can see, if I paste the thing that I copied from the Kali Linux official website, you can see that these two links are the same. Now, if in your case they are not the same, what you want to do is you want to actually delete one, or not delete one, you want to paste the one that we copied in case that the one that I opened right here is not present. But since you can see in my case I already have two the same links, so I will not need this one. So as you can see right now, I will delete it from here. all these other links that are under the hashtag are the links that won't be used, and don't remove the hashtags from them since we don't really need them currently. So all you have to do right now in order to save this, so as you can see I'm just showing you what hashtag does, you need to leave it like this, so with one link. You want to Control O to save. Let me just see when do I do that. So it should be Control O to save, then enter, then Control X to exit the program. So let's go a little bit forward. As we can see, I press Control O, it asks me file name to write, sources.list, you press there enter, and then you Control X to exit. So let me just go forward, and as we can see, right after you do that, this is the command that you want to run, apt-get and then update. So once you run that, it will take a few seconds to finish, so let me just move that. As we can see, it finished. I use the clear command to clear my screen, which is an optional, you don't really need to use it. And the next thing I do is apt install linux -headers. Now, let me just see when I write the full command right here. So I will explain everything this command does, even though it doesn't really matter, you just need to run it in order to install the headers. And basically what this command does is it installs the Linux headers currently needed for our Kali Linux version. This command uname-r, if typed in terminal, will basically just print out the version of headers needed, or the version of headers that are currently on your Kali Linux machine. But with this command I specify to install the headers that are already made for my Kali Linux version with this command right here. So we let this run. It shouldn't take too long. Oh yes, here is the error that I encountered, which is basically a lock appeared. Anytime you actually get this error during the installation of any program or apt update and upgrade, it will say could not get lock and then the path to the lock. Now there are 3 locks, and in case you get this error, all you want to do is actually delete all these 3 locks. Now if you don't get this error, don't worry, you might not even get this error, but in my case I did get, so I had to delete all of those 3 locks. The first one is specified with this path right here, so you just use the rm command, which stands for remove, and then you just copy this path right here and paste it after the rm. This will delete the lock at that path, and then you can proceed to download. But as you can see, there will be a second lock that will appear on different path, and you will need to actually delete that one as well. So as we can see, I removed the lock right now, and I try once again, and right here you see that I actually have another lock on different path, so you just copy this path as well, and you perform the same rm command in order to remove that lock. As we can see here, I am explaining that, so let us remove it. As we can see right now, I removed it, and I tried to run the apt install Linux headers once again, and this is where I got another error for the third lock and last lock, which you need to delete before you actually are able to download this. Now the lock is at this file, so you just copy this file, you specify rm once again, and delete the lock at that path. And right now, if you run the apt install Linux headers once again, you will be good to go, and you will be able to actually download them in case you don't have them. Now in my case, let me just go this bit forward, in my case it was already the newest version, so I didn't have to download. Now let me see what I did next. So I will just forward this. Okay, so right here, after that, what I did is basically I went to my, let me just show you because I already passed it. So after you install the Linux headers, where you want to go is you want to go right here to the devices. So let me just let this run. So devices. Then you want to insert guest edition CD image. So click on that. As we can see, I clicked right here. And it will prompt with this window saying, contains software intended to be automatically started, would you like to run it? What you want to do is press cancel right here, since we do not want to automatically run it because it won't really work. So what you want to do is run a few commands and basically install the VirtualBox Guest Edition themselves, and you will be good to go and be able to actually get the full screen Kali Linux. As we can see right now, I'm installing some VirtualBox guest utilities, as I believe that I did it. So let me just see right here. apt get install VirtualBox and then minus guest minus utils. So you just press here Y. If it asks you do you want to continue, you press here Y for yes and N for no, and it will download those utilities for you. So let's go forward. Not really sure how long this took. It took quite some time, so a few minutes. It didn't prompt any questions during the installation, and right after you do that, what I did, oops, let me go one step back. So right after I did that, I changed my directory to this directory. So I changed my directory to media, and from there I want to change my directory to CD-ROM 0. Since there is where my VirtualBox guest editions are, which I imported previously with devices and then insert VirtualBox guest editions. So I go there, I will probably type CD, okay, so here it is. And then we can see a bunch of programs right here. The program that we're interested in is the VBox Linux editions.run. All of the other programs, as you can see, these .exe programs are for Windows. So you want to copy the VBox Linux editions.run, and what you want to do is basically just run that file. So as we can see, in order to run that file, you need to type sh and then ./ and then the name of the file itself. Then you can press enter, and this will start actually downloading or installing the VirtualBox guest editions for you. It says, do you wish to continue? I just pressed here yes, and it started installing it. So let me just forward this, so we don't wait for the installation. Okay, so it is still installing, and here is the error that I actually got right after it. As it says, VBox client failed to register, resizing support. Now, this is the error that you might get or you might not get. Basically, as I was saying in this video, but the audio didn't really record it, I was saying that the installing of the VirtualBox guest editions is most likely different for every Kali Linux version, and it really often gives some errors back. But the best thing you can do is actually just reboot after the error, and it might actually even work after that. It probably will work, or unless you actually specified something wrongly in the commands and you actually get a real error. This is not something that we should be worried about, so if you get the same thing right here, don't be worried. As you can see right now, all I did was just reboot the machine with the reboot command. So let me just show you. So I typed reboot, and now my PC, or pardon me, my Kali Linux machine will actually restart. As soon as it boots, you can see that it actually booted up in the full screen mode, and I get prompted the login screen in the full screen mode. So as long as you do all of the commands that I did in this video in the same order, even if you get that error, don't worry, just restart your Kali Linux machine and you will have the full screen mode enabled. As we can see, once I log in, my desktop and everything else is in the full screen mode. So that would be about it for the actual going full screen in Kali Linux video. I just wanted to show you this. Basically, as I said, I didn't really redo the entire process itself, since I just wanted to show you in case you get the error as well, so you know what you need to do. So that would be about it for this video. I hope you enjoyed it, and I hope I see you in the next one. Bye. Hello everybody, and welcome back. And in the previous videos, I showed you how you can actually install VirtualBox, Kali Linux, and your VirtualBox guest editions in order to have our Kali Linux machine in full screen mode. So right now, we can actually start to introduce ourselves with the Python environment in Kali Linux. So this is the similar desktop to before, to in the previous video, and right now just open up your terminal. Basically you can enlarge it if you want to, it doesn't even matter. I will zoom in just in case so you can actually see it a little bit better, which I will do with the view and then zoom in right here. It just makes you actually see this better and in larger letters. What I will do right now is I will actually make my terminal background not transparent, so you can basically see the code better once we actually start coding. So I will do that with the edit part, then preferences. Then let me just find it. Okay, so it is under colors section right here, transparent background. You can change it right here. I will just leave it to be completely black. Now you can leave it anything you want. You can make it fully transparent. You can make it different colors and so on and so on. But this is not really the part of our course. So all we have to do right now is actually open up the Python in order to show you the Python interpreter and how you can actually use Python in order to create programs in Kali Linux environment. So first of all, before we do any of that, let's ask ourselves, why are we even doing this? Why are we coding our own tools? Why are we using Python and not some other programming languages? Well, basically the idea behind actually teaching people how they can write their own tools is to differentiate you from basically anyone that's using the tools. Now, it is in the hacker world referring to as a script kiddie, is someone that always uses different people's tools and doesn't really know how they work in the background. Now, programming knowledge and coding those tools actually gives you an in-depth view and actually a better understanding of how those tools work and how does the process of attacking really work. And also one more thing, those tools that you use from other people, that you either download from GitHub or that you actually get from the Kali Linux itself, since Kali Linux comes pre-installed with a bunch of different hacking tools, which will not be the part of this course. Some of those tools will break sometime. So what you want to do in case some of those tools break and you need them, you can learn to code them yourself and use them whenever you actually want. And for example, some of the tools are not really specified for a certain type of attack, so you can actually, with your programming knowledge and hacking knowledge, combine those two and actually create a tool that will be specifically for a certain attack, which you can't really do if you can't really code or you don't know how to code any hacking tools. You only know how to use tools from different people. Now, as I said before, this will also give you a better understanding of what is happening behind the scenes, since you will be the one that is actually coding the attack itself. Now, the reason why we are using Python is basically from two reasons. First of all, the Python is you can say the hacker's programming language, since it is a scripting language and it allows us to create programs really fast. For example, C is a low-level language, and anything we actually code in Python in this course will take a lot longer or significantly longer to code in C. Python is easier, and also basically I chose this language because I will not be teaching you the programming itself. If you are in the position to, please, you can just take any Python programming course, beginner course, it doesn't even matter. You can just look at some of the videos at YouTube. So you can see the syntax for the Python. You will understand all of this a little bit better and easier. But don't worry if you don't want to or don't have time to do that. I will explain everything as well, just not in that detail, since we will be mostly focusing on the hacking part of the code itself. So, in order for us to actually open Python in Kali Linux, you just open up your terminal as we did right here, and all you have to do is just type Python. Now what this will do is it will open up the Python interpreter right here, where we can actually execute these commands or basically execute the program itself. Now Python interpreter is not really something that we will use in order to make our programs, but you can also always use it in order to test a certain part of the program, since it gives you the error right away. For example, there is an import function called import OS, which imports a library, and as you can see, if something like this happens right here, which you get 3 error and then 3 error once again, it means it executed properly. But if I try to import something that doesn't exist, which is OSS, it will give me a name saying no module named OSS. So this is Python interpreter. We can use it just to simply check our syntax if it is correct or not before actually putting it in the program itself. But another thing you might actually notice is that this is the Python 2.7.15 plus. So basically this is the Python 2. The Python 3 you can open, let me just show you how, with the Python and then 3. As we can see, Python 2 we open with just simply typing Python, and Python 3 interpreter we can all open with typing Python 3, which will lead to the same command prompt with these 3 arrows to the right, but this will be the Python version 3.6.8. So that is something you want to differentiate. That is how you can open Python. That is how you can use Python interpreter. Now let's see how we can actually write a simple hello world program and save it and actually execute it from our terminal. We do not want to use the Python interpreter, we actually want to create a program ourselves. So here, if you just type here ls, which stands for listing directories in the current directory in which we are, basically in order to check in which directory you are, you just type here pwd. It will print working directory as it says right here. P stands for print, W for working, and D for the directory. We are currently in the root directory, which is good, we want to be there. As you remember from the previous videos, you can actually navigate through the directories with the cd command. So for example, if you want to go to the documents, you could just type cd documents, press enter, and now if you just type pwd once again, we are in the /root/documents directory. But we want to go one directory back, which we can do with cd and then 2 dots. It leads you one directory back, which will lead us right back to our root directory. Right now, what we want to do is actually create the directory where we will actually save our Python programs that we will code. So let us make a directory. Now, in order to make a directory in a simple Kali Linux environment, you just type in your terminal mkdir, and then the name of the directory you want to create, which can be anything. In my case, it will be Python programs, because we are going to make Python programs and save them in that directory. You just press here enter, and if you just type here ls once again, we can see right now we have the Python programs directory as well as other directories that were there before. In order to go to our Python programs directory, we just type here cd Python programs, and we are now in our Python programs directory, and if you just type here ls here, you will see there is nothing in this directory, since it is a new one and we didn't have any file created at the moment. What we want to do is we actually want to create our first program, which will be a simple hello world program from Python, and then in the next videos and in the next section we will continue, or basically we will start with our first hacking programs, which will be the port scanners, or basically scanning the target. So, in order to actually create the program, you just type here nano, and then just specify the name of the program you want to create. In my case, I just want to call it test, and it needs to have the extension .py, since py stands for Python programs, and it must really have that extension in order for Kali Linux to be able to run it from the terminal. So nano that. And something you need to know while actually creating any program in Linux is that you need to specify the path to the Python libraries, which is the which you can do with hash and then exclamation mark and then /user /bin and then /python. This is something that you will specify at the beginning of every program that you actually code in Kali Linux, so make sure to remember this. Don't worry, I will also tell you this like every time that we actually code something, that you need to specify this path right here. And in order for us to actually print hello world, we can actually just do print, open brackets, close brackets, and between the double quotes, which is specified in the brackets, we can just type hello world. This is the entire program. Print function basically prints anything, or basically prints what is inside the brackets to our terminal, and we specify that it should print hello world. You specify a string to be printed out by putting it between the double quotes or single quotes. So let me just show you. Both single quotes and double quotes will work. You know it is a string when it actually turns green right here, so it changes color. Now this is not a must. If you, for example, change color from your terminal, it might be some different color, but it doesn't matter. You will notice when it is a string and when it is not. I will just use double quotes in this case. And in order to save this file, or to save this program, you just type here Ctrl-O, then enter, as it says file name to write, you want to type here enter, so it writes under that name, and Ctrl-X to exit. In order for you to, for example, clear the screen, you can just type here clear, which will just clear the terminal from previous commands. And let's see, if we type here ls once again, we now have our test.py. Now, for those of you who are really new to this, let me just explain what nano did. So nano, as we used it once we actually wrote our program, is basically opening our program, and actually it opens something similar to the, for example, notepad in the Windows, where you can actually write anything, whether it is text or part of code, and then save it to a file. As we did right here, we saved this part of code to the file test.py. So let's close this, and right now if we just try to run this, which we can do with either typing Python and then test.py if we want to run it with Python 2, or typing Python 3 test.py. Now before we can actually run this, we need to make this an executable, since if I just press here enter, whoops, it actually doesn't need to be made an executable since I specified the Python 3. But if I wanted to run it as an every other program with // and then the name of the file, which is test.py, it will say permission denied, since that program isn't really an executable. So in order for us to actually make it an executable, we can just do chmod, which stands for change mod, and then +x. This +x stands for actually making a file an executable, which you will need to do for every file you actually code, and then you specify the name of the file itself, which in our case it is test.py. So this command right here will make our file executable, and if I just type here enter and press ls once again, you can see right now we have the executable test.py, and this command // and then test.py should now work. As we can see right here, we are able to run the program, which just prints up hello world. So I just wanted to show you this, how you can actually create a simple program which just prints hello world. Some of the commands this we will use, which is such as chmod +x, such as nano, which we will use to open the file in, for example, something similar to a notepad, ls to list files, then // and then the name of the file to run the file itself, and I also showed you the Python 2 and Python 3 interpreters. So that would be about it for this video. This is just a simple video where I explained why do we need to use Python and what we will be doing. So in the next section, we will actually start coding our scanning tools that we will use for scanning the target. So hope you enjoyed this video, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome to the scanning section, where we will code the tools that we will use to scan our target. Now before we actually start coding, let's see what scanning really means. So in Kali Linux there comes a tool which is actually called Nmap. It allows us to scan the targets for the open ports, which could potentially run vulnerable softwares on them, which we can actually possibly exploit afterwards. So this is the first part of actually collecting some information about the target. We want to scan for its open ports, and we also want to see what kind of version of software are they running on those open ports. After that, once we find that out, we actually want to, for example, see if that version of software is vulnerable to some attack or not. Now, in order to do that simply in Python, in Kali Linux, you just type here nmap and then the IP address or the host name of the target. So if you just type here nmap and then let's say we use the IP address of my laptop, which is 192.168.1.15, which I checked out right now, and if I just try to scan it, which I can do it with this command, it will just scan my laptop for the open ports, and as we can see it finished relatively fast, and it found an open port which is port 80, which services the HTTP. So let's try to actually code something similar to this, which will allow us to actually scan a target that we specify and which will actually check if that target has an open or closed port. So let's see how we can actually do that. So let's just clear the screen with the clear command, and let's in our Python programs, first of all, let's delete the test.py from the previous video. We do not need it anymore. You can delete it with the rm command, which you should be already familiar with. And right now, let's create an actual directory where we will only save the files for our scanning. So let's call the directory scanning. Make sure to make it in the Python programs directory. So I will mkdir scanning, which is also a command you should be familiar with. And if I just type here ls, we have our scanning directory. So let me change my directory to scanning. and let's actually write the program and call it, for example, portscan1.py. So since we will code multiple ones, we will try to actually make them better and better as we go. So let us actually just type here portscan1.py. And let's try to write a simple port scanner which will just scan a simple port. So how can we do that? Well, first of all, as I said in the previous videos, what you need to do, in every Python program you run in Kali Linux, it must start with a line which is this. So hash, exclamation mark, /user/bin, and then /python. Now, why is that? If you skipped through those introductory videos, basically this just specifies the path to the Python libraries that we will use. So this is something that you must have in your program, and after that what we want to do is we actually want to import a library which will allow us to perform the connect function on target ports. Now, performing that connect function will actually allow us to see if that port is closed or opened. If we manage to connect to that port, that means the port is open. If we get connection refused, for example, that means that the port is closed. So we will use the library called socket. So we will just specify here socket. You specify the library to import with the import function right here. So import socket will give us access to all of the functions that are in this library called socket. And right now, what we want to do is actually create a socket object and then basically perform the function which will actually connect to the port itself. So in order to create the socket object, it can be a little bit tricky syntax, so make sure to follow with me. You can call it anything you want. I will call it sock in my case. So sock equals, this sock basically represents a variable, so we can just put anything to that variable with this equal sign. And we want to make it a socket object, so how do we do that? We just type here socket.socket, open brackets, so open and close them, and inside the brackets you want to type socket.af_inet, comma, socket.sock_stream. So this is how we actually define the socket object itself, and we actually put it as a value to this variable right here, which we called sock. Now, this socket.af_inet basically stands for the IPv4 address, so we will be performing the connection to the IPv4 host, which is the IP4 and not IPv6 address, and this socket.sock_stream represents that we are going to use the TCP packets in order to perform the connection. Now, TCP and UDP, we want to perform the TCP three-way handshake and not UDP packet. Well, basically, for those of you knowing, UDP is actually connectionless, but it really doesn't matter at this point. Right now, it matters that you know that this stands for the TCP packets. So we will be trying to perform the three-way handshake with each port of the host, but for now on, let's just actually try to perform it with only one port, and then we will see how we can actually scan multiple ports and not just one. So right now, what we want to do is actually just type here the value host, which we can set to be, for example, my laptop, which is 192.168.1.15. Now, make sure that you actually, don't worry, I will show you how you can install the virtual machine where you can actually perform all of these scans and all of these attacks that we will do. But from now on, you can just select any IP address you want, such as the IP address of your Kali Linux machine itself, so you can actually scan yourself, or the IP address of your actual main PC or Windows machine, in case you're running Windows. Now, how can you check the IP address on Windows machine? You just go to the tab right here, type here cmd, and then in your command prompt, once it opens up, you can just type your ipconfig, and the result of the ipconfig will actually give you your IP4 address, which is the local address, which in my case is this one right here. So make sure to navigate to the IPv4 address and select the address right here, which is in my case 192.168.1.4, which is the IP address of my Windows 10 machine. So we can scan my Windows 10 machine. Let's just type it right here, 192.168.1.4. we close the quotes since we specified the host. We also want to actually specify the port, so let's specify the port to be, for example, port 443. And we will try to perform the connect function to this port on this host. Now this is the most simple port scanner. Don't worry, we will make the more advanced port scanners later on, but for now on I'm just showing you the basic principle behind actually scanning and connecting to a certain port. So let's try to actually connect. So in order to do that, we actually need to make a function. So in order to specify the function, you just type here def and then port scanner, and in the port scanner what we want to do is in the brackets type here port. Now let me just explain this. In order to declare a function in Python, you need to use this def before it. Then the port scanner is the name of the function that we want to create, and the port is the argument that we will pass to the function. Now after that, all you need to do is specify two dots, which basically means that the code below and the code that we will basically tab in will be the part of the function itself. So how do we do that? Just press here enter, tab this, and we can just type here something like this: if sock.connect underscore ex, and then in the ex you specify two open or double open brackets and double close brackets, and inside them you specify host and then comma port. Let me just write this and then I will explain what this means. So first of all I will write the code of the function and then I will tell you what all of this means. Don't worry, I will explain it all. So print port and then %d is closed and then %port. Oops. And then we just type here else. Oops. Print port %e is opened. And then port. And then at the end we want to call the function itself. Okay, so this is basically our most simple port scanner. Let me just explain what I did right here. So let's start from the beginning actually. So we created the socket object. This is the stands for IPv4 and this stands for TCP packets. We declared the host variable to contain the IP address of our Windows 10 machine, and we selected the port to be, for example, 443. You can select here any port in order to try it. Don't worry, it doesn't have to be 443, or you can go with the 443 like I did. Then we declared a function which will perform this task right here each time it is called. Now the function is named port scanner and it will take one argument which will be called port. So after that we need to close it with two dots and then we need to tab every code that we want to be a part of the function. So for example, if I were to type here any code, this will not be a part of the function anymore since it is at the same line as the function itself. But if I were to do this, now it would be the code of the function since it belongs and it is tabbed properly. Let me just delete this as this is not really a code. And right now, what we do in the function itself, we perform the simple if-else statement. Now, you can look at the if-else statement as something like, basically, you can basically translate it to English. So if this doesn't work, or if this works, then do this, else do this. So if socket.connect retrieves an error, any type of error, which we actually check with this function right here, so sock.connect underscore ex, we try to connect to the host on this port, so on this host and on this port, which we specified in the double brackets separated by comma. If it retrieves an error, that means that the port is closed since we got the error back. So we will print to the terminal port is closed. Now this %d basically stands for anything that you specify after the string itself, it will be replaced right here. So since our port is actually number 443, if this port is closed, this will print port 443 is closed. Else, so in any other case, so if we don't get an error, that means we successfully connected to the target, and that means that port is actually opened. So in that case, we will print port and then the port number is opened. So let us save this and see if this will work. Now before we save it, this part right here is basically how you can call a function. So if I didn't have this part right here, this function will never be called and this program will not execute this at all. So we need to call the function and we specify the variable inside the function, which is our port variable, which will be used throughout this program. So let us save this, Ctrl-O to save, Enter, Ctrl-X to exit. And as you remember, in order to run this, we need to make it an executable first with the chmod plus X. Then we type the name of the file itself, so chmod plus X portscan1.py, and let's actually try to run it. You let it run, and we can see port 443 is closed. So right now, let us actually try to scan our Windows 10 machine with nmap to see if there is any port that is actually opened, so we can actually use that port in order to check if our program will print that port and then that number is opened. So let's type right here. This should finish relatively fast, and we can see these are the open ports on my Windows 10 machine. So port 445 is open, port 139 is open, and port 135 is open. So let's actually change our program. So nano portscan1.py. We open the code itself and we change this to 445, since 445 is one of the ports that was open. We Ctrl-O enter, we then exit this and we run the program once again with the dot and then slash portscan1.py. And we can see right now it prints port 445 is opened. So now we know that our program works correctly. It can actually scan port if the port is open or closed. But this is the most simple version of our port scanner, so we will actually in the next few videos try to make it better, implement some different functions, make it scan more ports than just one, and so on and so on. So hope you enjoyed this introductory video to the port scans. Now for those of you who are actually a little bit more advanced and know Python and know all of that, it might be a little bit too much explaining for your taste, but please stick around. Later on we will be coding some of the more advanced stuff, don't worry. And later on, the more we go with these programs, the less I will explain what I'm doing in them. So that would be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one where we will actually try to change some of the stuff in our port scan. So hope I see you there and take care. Bye. Hello everybody and welcome back. And let us continue with our port scanner. So let me just log into my Kali Linux machine. And in the previous video, we coded the most simple version of a port scanner. We provided the IP address and the port that we want to scan in the code itself. And we were able to actually determine whether that port is closed or open by performing the socket.connect function on that local host and on that local port. So let us see how that program looked like, so we can actually modify it. Now let me zoom this in so you can see this a little bit better. Let me just get this. So view, zoom in. I will zoom in twice so you can see everything really well. And if I just type here ls and go to my Python programs directory with this cd command, if I ls once again, I have the scanning directory, so I will go to the scanning directory as well. And here is my portscan1.py. So let us actually nano that portscan1.py in order to see what we can actually change in order to make this a little bit better. So let's think about this. First of all, there is really no point in actually making the user of our program actually specify the IP address and the port in the program code itself. Maybe some of the users don't really know how to actually open the program and how to specify and where to specify the local host. So what we want to do is we actually want to prompt them with the question to specify the IP address themselves and the port as well. So let us see how we can do that. Basically what we want to do is we want to delete these two values, so delete the IP address and delete the port. And instead of that, what we want to do is we want to actually prompt the user of our program to specify any IP address they want and any port they want. So let us see how we can do that. So we can do that with the raw input command. As we can see, raw_input will prompt the user with the question that we specify in the brackets. So you need to open and close brackets, and between the brackets open the double quotes as if you're specifying the string, and there we can just prompt the user something like this. So plus, or let's just type here star, doesn't even matter, this is just some decoration, and just type here enter the host to scan, then 2 dots and then space. So this means basically the raw_input function means that this will be prompted once the user runs the program, and it will wait for the user to specify the IP address or basically anything they want to specify. In our case, in this program, it will be an IP address, and soon as they specify that, it will continue running the code, and it will go to the port where we want to do the same. So raw input, we want to prompt the user to actually specify the port which they want to scan. So we just type here enter the port to scan, 2 dots and then closed question marks, closed double quotes and then closed brackets. So as we can see right here, right now if we actually run this, so Control O to save this, enter and then Control X to exit, and we run the port scan1.py, you can see that right now it asks us enter the host to scan, and it waits right here until we actually write something. So let us check the IP address of our Windows machine once again, since I restarted my computer since last video, and okay, so it's still .1.4, and if I specify 192.168.1.4 and I press enter, it will ask enter the port to scan. Now if I just specify here the port number, this will most likely crash. So let me just show you. If I specify 445, which is an open port on my Windows 10 machine, as you can see, it crashed. Now in Python 2, it will say an integer is required. So all you have to do is nano that port scan1.py and just type here raw input and then integer. So open brackets, integer, open another brackets, leave this as we specified, and at the end just close double brackets. Now what this will do is basically the value that the user specifies, it will turn that into the integer which is needed in order to perform the port scanner function. So let us save this once again and exit. And if I run this once again, so I specify the same IP address, 192.168.1.4. Oops, enter the port to scan. Okay, so let me just check this out. We probably need to specify it like this. So delete this integer and type before the raw input. Yeah, I believe this is what we need to do. So it first goes integer, then open brackets, then raw_input, then open brackets, and then this string right here, and then 2 closed brackets. So let's save this once again and try to run it. 192.168.1.4 and then port to scan 445. As we can see, then we get prompted port 445 is opened. So right now, first of all, we should not specify is opened, we should specify is open. I believe that is the correct English. Pardon me if I am wrong, but it doesn't really matter. So port is open. We can now specify any IP address. So let's see if we can actually run the program twice. So let me just clear my screen. We run the program with this command. We scan once again my Windows 10 machine on port 139, for example. Now port 139 is open, which is correct, and then let's actually try to scan my router, which is at the IP address of 192.168.1.1, and I scan the same port, and right now, as you can see, this will hang. Now don't worry, this is actually hanging because my router is really slow. So in order to prevent from this hanging on certain hosts, we can add a simple line one-line code to our port scanner in order to prevent this. So let me just control Y this in order to close the program itself. Let me nano the port scan 1.py, and all we have to do is right here specify socket dot set default timeout, and then default timeout will be in the brackets in seconds. So let's specify 2 seconds. What this will do is it will actually try to perform every action within the 2 seconds, and if basically the 2 seconds expire, it will just print the port is closed. So let's see if this will work. Control O to save, run this once again. Set default, okay, so this is a typo, whoops. It's not set default, we need E right here, so set default timeout. Save this and run the program. 192.168.1.1, 139. And we wait now 2 seconds. And that is more than 2 seconds, but I'm not really sure why does it take so long. But I always had this problem with my router. It doesn't really matter currently. What matters is if I run this on my laptop, which is .1.15, so that is the IP address of my laptop, and I specify port 80, we get everything within matter of seconds. So port 80 is open. Let's try now other port on my, for example, Windows 10 machine. Let's try port 33. Now this will actually scan and it will say port 33 is closed. So we did a little upgrade to our program. As you remember in previous video, we actually specified both the IP address and the port in the code itself, and right now we prompted the user to specify any IP address and any port they want. So let me just nano the program itself. So as we can see, we changed this part and we also added this socket.setDefault timeout to be 2 seconds. So in the next video, we will actually upgrade even more this port scanner, and we will try to make it scan multiple ports and not just one port. So I hope you enjoyed this video, and I hope I will see you in the next one. Bye! Hello everybody and welcome back, and in this tutorial let us actually make our port scanner to be able to scan multiple ports. So let us nano our port scan 2.py. In order to do that, we will actually need to remove this line, so you can either put it in a hash, so it actually counts as a comment, or you can delete the entire line since we don't really need it. We don't want to prompt the users for the port, since we will be scanning multiple ports, and if you want to, you can actually scan all 65,000 ports. But for now on, we will just want to scan first 100 ports, and we can do that with adding right here. First of all, let's delete the calling of a function and let's add a for loop. So for port, in range from 1 to 100, we want to call the function on that port. So what this will do is basically, first of all, the port variable will be 1, and for port 1, this will call a function port scanner for the number 1, which will scan the first port, and it will determine whether the port is open or closed. Then the port variable will increase by 1, and then it will scan the port number 2, and so on until it reaches 100 ports. So you can specify more ports right here, but for now on, let us just try to scan first 100 ports. I will be scanning my laptop, so let us run this. The IP address of my laptop is 192.168.1.15. I let this run, and we can see it finishes relatively fast, and the only port that is open on my laptop is the port 80. As we can see, port 80 is open, but let us actually try to scan first 1000 ports right now. So in order to do that, all you have to do is just specify right here another 0, and it will scan first 1000 ports instead of first 100 ports. So you specify the same IP address or the IP address of any host machine you are actually scanning, and we can see it finishes the first 1000 ports as fast as the first 100 ports. But you might notice right here that it is actually really hard to notice whether the port is closed or open, since all the letters are white, and here is the port 80 which is open. So let us actually try to code something that will make this the ports that are closed print in red and the ports that are open print in green. So we can do that with the help of a term color library, which actually comes in Python 3. So we'll have to adjust our code to Python 3. All we have to do is just fix the print statements first. So in Python 3, the print statements need to have the brackets. So let us add brackets at the beginning and the end of our print statements. So just add it right here. And also in Python 3, the raw input function is actually just input. It doesn't have the raw and the underscore before that. So right now, in order to actually color the print statements, we need to import the library. So for term color, import colored, and we need to call the colored function in our print statements, which we can do right here. So colored, open the brackets, then after the port specify comma, and then there we want to print the closed ports in red, and then add one bracket at the end. You need to do the same in the port is open statement. So here, add function colored, open brackets, then comma after the port, and we want to print that in green, as it is an open port. So all we have to do right now is save this and run this with Python 3. In order to run it with Python 3, we specify Python 3 before and just type here port scan 2.py. We run this, enter the host to scan 192.168.1.15, and as you can see, all the closed ports are printed out in red, and the open port, which is port 80, if we find it, should be printed out in green. And as we can see, it is printed out in green, and it is really easy to notice it. So our port scanner works well, it can scan multiple ports, and it can also print out the open and closed ports in different colors. So that will be about it for this video. I hope I see you in the next one, where we will actually start coding our advanced port scanner. Hope I see you there, and take care. Bye. Hello everybody, and welcome to the first tutorial of actually coding the more advanced port scanner. Now we will code this port scanner in the Python 2. Basically we will use Python 2 to code it, so let us see how that will work. Let us actually first ls, and let us nano advanced scanner.py. You can call it anything you want, it doesn't really have to be the advanced scanner itself, but I just named it like that because it will be easy to differentiate it from the other scanners. So right now we need to start with the regular line, which is user bin Python, and we need to import 3 different libraries for this program. Now why am I calling it advanced? Well, I'm calling it advanced since it will have a better help option, or I don't know how to say it. You can specify the help option with the program itself, and it will prompt the users how they can use the program, which will be really easy to use for anyone running it. They can also specify the ports, the number of ports, the host, and also we will run the program with a threading library, which allows us to scan the ports faster than without the threading library. So we will use different threads in order to scan different ports, which then will actually simultaneously scan the ports and get prompted us back with whether that port is closed or open. So the 3 libraries that we need to actually import are the socket library. So we will use from socket import star. Now this basically means that from the socket library we want to import everything. This star right here basically represents everything. The next library we want to import is the opt parse library, so import opt parse. This library allows us to actually specify the help options that we will get prompted to the user, such as actually specifying the ports and specifying the hosts, and if they specify, for example, -h, which will stand for -help, they will get the usage of the program printed out. And the third library is the library that I mentioned, which is the threading library. So from threading, we want to import everything. Now, why you might be asking, why are we not just importing, for example, socket library like this? Well, basically, since we are going to use this a lot, I believe, we just specify from socket import everything, so that we don't have to specify the socket prefix in every function we use for the program. So make sure to specify it the same as I did, since some functions, if you just specify it as an import socket and import threading, will not really work. So let's see what we actually need to do in order to get this program to work. What we will have is, we will actually have a main function, so let's call it main, which will take no arguments, of course. And here we will actually code the available options for the user. If the options are well specified by the user, then we will continue to actually scanning the target and printing whether the port is open or closed. So let's see how we can do that. We can do that with simply using a variable which we can actually call parser, which will then equal to the function we will use from the opt_parse library. So that function will be opt_parse and then dot. The name of the function is option parser, and then between the brackets in option parser, let us open and close the brackets, we want to specify, for example, the usage of the program itself. So we can just do that by specifying them between the double quotes, and here we will actually type here usage of program, so of program, and then 2 dots, space, and then here we want to specify what they need to specify in order to actually run this program. So plus, we want to plus this. Now this plus basically means it will add a string to another string, so we need to specify that plus and then open another quotes, so open and close the quotes, and minus h, capital H, or you can use lower letter h, it doesn't really matter, and then we want to specify target host, and then minus p, or let's actually use the h to be smaller, or bigger h will be the target host and smaller h will be the help option. Or we will even see, it doesn't really matter. Let's use minus p for the ports, and here we will specify target ports. So this is the simple usage of program that will get printed out once the user actually specifies the command wrong or doesn't really know how the program works, so they will get printed out this part right here, and after that they will know what they need to do in order to run this program correctly. So right now what we need to do, since we specified the minus h to be target host, which is the IP address of the host they want to scan, target, not target, and minus p to be target ports or port, so let's just leave it on port so that then they don't get confused. And right now, what we want to actually do is add both of those options to our parser. We use the add option function to do that. So parser dot add underscore option. And then we need to open and close the brackets. And what we want to do is specify some of the settings for our minus h option, which in our case is target host. So between the double quotes, specify minus and then capital H, if you specify capital H right here. And then after that, comma, and then, comma, and then you need to specify destination to be to our variable, which will actually take the input from the target host. So we can call that variable whatever we want. So let's call it tgt host, which stands for target host. Now this actually needs to go between the quotes, so let's specify the quotes right here. tgt host, then specify after that comma, and then the type of that variable is string, so type equals, and then we need to specify between the single quotes string, which stands for that variable actually being a string itself. And the help, which will be something that the user will actually get prompted, will be, for example, for this option, again between the double quotes, or the single quotes, pardon me, specify, or let's do it like this, specify target host. So this is just parsing the first option, which is minus h. Let's do the same for the second option, and we can do that just by copying this line right here. So copy Then we will paste it right here, so we don't actually write it, and we will change what we need to change. So the parser.add option is the same, and now we want to actually parse the option -p, which is the target port. The variable cannot be the same, so let's name the variable to be target port. The type of the variable will still remain the string, and the help will be specify target ports separated by comma. Now, why are we using target port separated by comma? Well, we will add a function to the user, or basically an option to the user to specify multiple ports that they will specify, or that they will actually separate by the comma itself. Now all we have to do is to actually first parse the arguments to the variable, so options, comma args, and then we need to use the parser, which is our variable right here, and we need to parse those arguments. Now basically, if you are new to this, this can be a little bit difficult syntax, but it doesn't really matter. This is just the syntax of the Python library itself. It is not really something to worry about. Basically, in this ops parse library, there are the functions such as add option, parse args, that are used to actually specify different settings for this program. This is really optional thing. We just want to make it the best we can. This really isn't really needed for the port scanner itself, as we saw in the previous videos where we actually managed to scan the ports, whether they are open or closed, without using this. But if we want to, for example, put this program on GitHub, we want to actually make it a little bit prettier and a little bit more user-friendly. So all we have to do right now is actually specify our variables. So we used two variables, the target host and the target port, and right now we need to set them to be target host equals options.target host. Since we only specified them in these two lines, we didn't really specify them as a variable itself. So right now we need to make sure that the target host is referring to the options.target host, which is this right here. We need to do the same for the ports, so we will use now the variable called tgt ports. In this variable, we will actually use the ports that the user specified that are separated by comma, so we need to actually see how we can actually separate them. We can do that simply with this. So first of all, equal sign, then the ports need to be string, and then from the options, we will use the variable tgt port, and we need to split them, so split each port with the comma. We will use the split function to do that. So what this will do, if for example we specified something like this, so 1, 2, 3, 4, we want to scan first 4 ports, what this will do is it will add all of these ports to the target ports, but it will separate them from the comma, since if you try to scan a port with a comma, it will not work and it will prompt us with an error. This function split allows us to actually split them by the comma itself. So all we have to do right now is actually check if the user specified correct arguments for the program, and then we can actually proceed to the scanning of the ports. Now we can do that like this. So if target host equals to none, which basically means if they didn't specify anything to be a host, and if target, or basically and or if target ports, since our variable right here is called ports, which is a list, basically holds on to the 0 variables or 0 ports, that means that our program has nothing to scan, or basically equals to none. We want to actually print the usage of our program, which is this right here. So usage of program, we want to print parser.usage. Once we print that, we want to actually exit the program. You can exit the program with this command right here. And in case that everything is good, so in case this isn't satisfied, we want to proceed to the function which we will actually call port scan, which will take 2 arguments and which we will call in the actual next lecture, not really now. It will take 2 arguments, which is target host and target ports. And this is basically the usage of our options right here. So let me just see if we actually run the main. So let's run it. And let's put this under the hashtag as a comment, since we don't really have the port scan function yet. So let us just save this, Ctrl-O to save, and let us try to actually run this. We need to make it an executable with chmod plus x function, and then we actually run the advanced scanner. And we get printed the usage of program, since we didn't specify -h for the host and -p for the port. So our help option works well. Now in the next lecture, we will try coding the port scan function, which will actually perform the threading on actual scanning the ports themselves, and then we will see how that will work. So hope you enjoyed this video, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and right now let us continue with coding our advanced scanner. So let me just nano the program itself, and in the previous video, as we saw, we managed to actually create the help options for our user. Right now let us create the port scan function, which we specified as the last line of our main function. So let us actually unhash this, and let us use a simple usage of actually running the main function, which is common in Python, which goes like this: if name equals to __ main __, oops, then run the main function. So let us now code the port scan function itself. As we saw right here, the port scan function takes two arguments, which is the host and the port. So let us code it right here. Def port scan. Make sure to name it the same as you named it in the main function, otherwise this will not work. And then we need to specify the two arguments, which we specify right here, which will be the host and the port or ports. We need to end it with the two dots, and everything that is tapped into under this function will be the part of the code. So first of all, what we want to actually do is, what if the user specifies a domain name instead of the IP? We want to actually resolve that domain name and actually get the IP address of that target. So for example, if a user typed -h for the host, and then after the -h typed google.com. If our program didn't resolve that google.com into an IP address, this program will crash, and it basically won't be able to scan, since it doesn't really know what google.com is. So what we will do is we will use a function called getHostByName in order to do that. But sometimes it might actually crash, so let's use a try and except rule, which will try one thing, which will be the resolving of name, and in case it can't resolve the name, under the except thing, we will actually specify to print out can't resolve the name of the host. So let's see what we actually first need to do in order to resolve the name, so, or the IP address from the name. So actually what we need to do is actually make a variable which we'll call target IP, and that target IP will host the IP address of the host. So we need to get host by name, which is the function we use, and from that we will specify in that function the target host, since that is the host that we need to get the IP from. So this is the entire function that we need to specify for this, and in the except we will just print can't resolve target host or something like that, or let's just print unknown host, and we can print something like this. Oops, the %, and then s, and then we can close this and then type %, and then target host. What this will print is basically, if you remember with the %t command, this is the same thing, just this is referring to a string. Now first thing, we need to make this single quote, so this will actually work. So let's recap what this will do. It will try to get host by name, or basically get the IP address, and if that doesn't work, it will print unknown host, and then it will print the host name. So right after that, we actually want to print that it is trying to scan the host itself. So let us just run the another try and except rule right after this first one. So we ran the first try and accept rule in order to get the host by name. And right now we want to actually get the name, so we can print it out. So target name equals get host by address, and then from target IP. Now as we can see, these are similar functions, but they do the opposite one from another. This one gets the host name, or basically the IP address from the host name, and this one gets the name from the address. So right now, once we actually type that, we want to actually print, and let's add a plus right here, and let's actually print scan results for, and then we can just do it like this, and then add the target IP. What this will do is it will basically print out scan results for that IP address. Or no, we want to actually do this in the accept rule, so pardon me, this is not a part that goes right here, so let me just delete this. This is the part that goes right here, so paste this under the accept, and in the try we actually want to print the target name. So print, and we want to type it right here with a plus, so it knows everything works well. Scan results for, and then we can add the target name. And since target name, we can actually try, since target name retrieves as a list, we need to use the first element of that list, which we will specify with this 0 in the square brackets. Now, if you're not familiar with the lists, or basically the counting in Python, the counting always starts from 0 and not 1. So the first element in the target name list will be marked with the number 0 and not with the number 1. So now that we did that, we can actually use the function that we used in the previous video, which is set default timeout, so we don't actually wait for an eternity for a single port to scan. So set default timeout to be, for example, 1 second, and right now we can perform a similar function or a similar part of code that we performed in our previous program. So for target port, so for target port, in target ports, which basically means for every port in all of the ports that you specified in the command, we want to actually run a different function which will scan those ports, and we want to run all of those ports with a different thread. So how can we do that? We will use a variable called t to select a thread, and we will use thread, open brackets, close brackets, and right here what we want to do is type here target equals, and after this target equals we need to specify the name of the function which will perform the scanning of the ports. So we will call that function, for example, connection scan, so con scan, then comma, arguments for that function will be actually just the target host and the target port, so make sure to separate by comma, then args equal open brackets and close brackets, and in those open and close brackets we specify target host, and we specify the integer of the target port. We close the brackets for this. So make sure you have 3 brackets at the end. Since we opened 1, 2, and 3 brackets, we need to close all of those 3 brackets. Now basically, you might be asking, why are we using integer? Well, we use integer for the same reason that we used it in the previous video, or pardon me, in the previous program, which is the portscanner2.py, I believe, since the socket library actually needs an integer value of port in order to be able to scan it. And all we have to do right now is actually start all these ports. So in order to start the port, you just use this variable and added a function called start. Simple as that. And all we have to do right now, which we will do in the next video, is actually code a simple connect and connect function which will determine whether the port is closed or open. So that's an easiest part, so don't worry, we already performed most of those things the same, and we will finish the program in the next tutorial. So hope I see you there, and take care. Bye. Hello everybody, and welcome back to the last part of our advanced port scanner. Right now we managed to actually make a function called port scan, which will actually try to resolve the IP address by hostname and hostname by IP address. Then for each port in the specified ports in our command right here, we will actually run a function called connection scan, which will actually determine whether that port is closed or open. We set that on all of the separate threads, and we also set the default timeout to be 1 second. We call that function down here, as we can see, port scan target host target ports. Then once it goes right here, it will start executing all of this code. Then it will run all of the different threads on connection scan function, which we still remain to code. So let us go up here, make def, or let me just def conscan. Once again, make sure that you specify the same name for the function as here. So conscan, and we need to specify the arguments, which will be target host and target port. Now right here we do not need to specify the integer, so all we have to do is specify the 2 dots at the end. And right now we will actually try to perform the same thing that we actually did in the previous programs, which is just trying to connect. So let's run the try and except rule. In the try rule we will actually try to make a socket. So let's make a sock object, which will actually we need to actually make it to be, first of all, the IPv4, so AF_INET, and then sock stream for the TCP. Now in the previous programs, you remember that this was like this, so socket.af9net and socket.sockstream, as well as this was socket.socket. Well, it is not in this case because, as I said in the previous videos, we imported it like this, so we do not need to specify the first socket part in all of those functions. So it is easier to just write one socket and not twice socket. So let me delete all of this, since we don't need it, since we imported the library as from socket import everything. And basically we will now try to connect to those ports. So we can just perform sock.connect, or open 2 brackets, close 2 brackets, and between we need to specify the target host and we need to specify the target port. So this is all we actually need to do in order to perform the trying of the connection. All we have to do right now is also print whether that port is closed or open. So print, if it manages to connect it, we will print, let's print it like this, so %d for the integer, then slash, and we will just type it right here, so TCP, so we know that the port is scanned with TCP, open. Let's add the capital O, maybe it looks better. I don't even know, you can write anything you want right here, and we need to specify the percentage and then target port, so we know which variable we need to specify instead of the %d. And let's add space right here. And in the except rule, all we have to do is actually print %d TCP closed. And close the quotes and then add the percentage and then target port. And finally, we need to print connection.closed or sock.closed. We want to close the connection so our program can close successfully, so sock.close. And this is our entire program. So if we coded everything correctly, which I believe we did, this right now should actually be able to scan our Windows 10 machine or basically any other website that you want to scan. So let us Control O this. Let me just double check if we coded everything properly. Everything should be good to go. So Control X to exit. And right now, if I just type here advanced scanner, you can see that we actually have, oh, I'm missing the double equal down here. So right here, make sure to specify double equal always, since one equal actually means that you're adding the value to a variable, and double equals basically checks whether these two are actually equal. So let's Control O, then Control X, and we get printed out the usage of our program. So right now, let's try to specify the usage of our program, which we will use 192 -H for the host, which we will use 192.168.1.4 for my Windows 10 PC. And -P, let's actually first of all scan one port, which will be 135. If I just run this, we can see scan results for 192.168.1.4, 135 TCP open. Now let's actually try to scan multiple ports with the different, with separated by comma. So 135, 22, 443, 445. Let's try to scan this. As we can see, it finished. It found two open ports, so 135 TCP open, 445 TCP open, and 22 and 443 are closed ports. So as we can see, it finished relatively fast, and it also prints out in the nice manner whether the port is closed or open. Now if you want to, so let me just, you can actually make the same thing as in the previous video, whether the print statements will be printed out in red or green, whether the port is closed or open, but I will not be doing that right now since I already showed you how to do it. Just make sure that you need to run it afterwards with Python 3, since the term caller library that we used in the previous videos is actually only in Python 3. And the print statement is different in Python 3, everything else I believe will stay the same, but if you want to print, the difference in printing in Python 3 and Python 2 is, for example, let me just show you, in Python 2 you can just specify it like this, so print hello, and in Python 3 you will need to specify it like this, print hello. You need to specify all of the print statements between the brackets. So let me just delete this since we do not need it. Let us now try to actually scan a website. So let's actually try to scan for one port. So let's try to scan for 135, the website, which is this one. Now you can specify any website you want, and you just basically select it right there. You select the port, and let's see whether that port is closed or open. Now I hope I specified the correct name. Scan results for this IP address. As we can see, it successfully resolved the IP address of this website. Now we can check it out by copying the website and using NSLOOKUP, which is a program that is already pre-installed in Kali Linux, to see whether the IP addresses do match. And as we can see, they do match indeed. So the IP address for this host right here is this one. And also the port that we scanned is actually a closed port. So our program works really well. Basically, this is the only thing we can actually do with the ports. We can scan them, but in the next videos we can actually try to see whether some of those ports will return something back to us. Now sometimes whether, for example, the port is 22, which is SSH, or 21 for the FTP, the software running on those open ports can actually return a banner from the version of those software running. So we can actually see what version of software is running on a certain open port. But in order for us to do that, I will show you in the next video how we can actually install a virtual machine, which is called Metasploitable. We'll use Metasploitable 2 in order to have something to scan and in order to have something to attack in the future videos. So hope you enjoyed this video, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and right now I will show you how you can actually install the Metasploitable, which we will use to actually scan and attack later on. Now it is rather simple to install. All you have to do is go to this website right here, which is information.rapid7. You basically just in your Google search bar you can just type Metasploitable download, and this is one of the first links that will pop up. All you have to do after that is actually specify all of these right here, which is basically first name, last name, and so on. Once you submit that, it will lead you to a page where you can actually download the Metasploitable. Once you click that and download it, I don't think it is that large, perhaps a few megabytes, like 100 or something like that, not really sure. Once you do that, you will receive something like this. So if I just open this, you will receive this zip file right here, so Metasploitable Linux, which is basically the Metasploitable 2. I believe right now there is Metasploitable 3, which is Windows based, but it takes too much hardware in order to run. Basically you need like 4 gigabytes of RAM minimum in order to run that Metasploitable 3 machine, which is a lot comparing that we are also running the Kali Linux machine at the same time. So we are instead using the Metasploitable 2, which is the Linux machine. Once you actually extract the files, you will have these 5 files right here. The important file right for us is the metasploitable.vmdk, which we will use to actually set up as a disk for our virtual machine. So all you have to do after that, is open up your VirtualBox. So let me close this, and you can actually navigate and make a new virtual machine. Call it whatever you want. I will just call it Metasploitable, and make sure to make it to be Linux, and in the version of Linux go down here and select Other Linux. Now I'm not really sure whether it's 32-bit or 64-bit. Let's just leave it on 32-bit and click on the next. As far as the memory size, 512 megabytes will be more than enough for this machine, so just select next. And right here, instead of actually using the virtual hard disk now or creating the virtual hard disk, we want to use an existing hard disk, which is the hard disk that we downloaded from our Metasploitable. So just go use an existing virtual hard disk, then select right here to select your hard disk, and then try to find it wherever you saved it. As we can see, I saved it on my desktop in new folder. It is this file right here, which is the size of 1.8 gigabytes. You select it right there, click open, select it right here, and you can see right now I have metasploitable.vmdk. So I click here on create, and I am good to go. I created my Metasploitable virtual machine. Right now all you have to do is click here on start, and basically this will start the Metasploitable and it will install it for you. So let's see if this will work, since I had problems with Metasploitable in the past, but I managed to download it before. But as we can see right now, it says unable to boot. Please use a kernel appropriate for your CPU. Now, in case you get this error, just close the virtual machine. So click on X, power off the machine. Go to the settings of the virtual machine. Go under the system and then on the processor, and in the extended features, click on the enable PAE. So click on that, then click on the OK right here, and then try to start the virtual machine once again. Right now, I believe this will fix the error and it will actually start installing the Metasploitable. As we can see right here, it is actually starting up and there is no error, and all you have to do right now is just wait for it to install. It will not prompt you any questions, it will simply install it for you. It is not as complicated as the Kali Linux installation, and as soon as you install it, you will have another virtual machine which you can scan. Now after the installation of the Metasploitable, what I will show you is how you can actually make both the Metasploitable and your Kali Linux machine to belong to your local area network. Now by belonging to your local area network, I basically mean to have the IP address which will belong to your local area network. For example, if I go right here, let me just open my command prompt, and on my regular Windows 10 machine I type ipconfig, you can see my IP address is 192.168.1.4. I want my Kali Linux machine to have a similar IP address which will start with the same 192.168.1.something, and also my Metasploitable to be with the same start of the IP address. So let me show you what I mean. First of all, in order for you to log into the Metasploitable, you just need to specify msfadmin as username and msfadmin as password. This will actually open the terminal command line for this machine, where you can execute the same commands that you can execute in the Kali Linux terminal. As we can see, if I type ifconfig in my Metasploitable, you can see that my IP address is actually 10.0.2.15, which doesn't really belong to the range of IP addresses for my local area network. In order to change that, both for your Kali Linux machine and both for your Metasploitable, all you have to do is actually close both of these machines. So I will close my Metasploitable. I will also close my Kali Linux machine. So power off. And all you have to do is go to your VirtualBox, find those two machines. So let me just wait for my Python ethical hacking machine to actually close. While it's closing, we can actually change the settings for the Metasploitable. You click on the machine, go to settings, go to the network settings, and here instead of attached to net, change that to be bridge adapter. And here you can change the name of your adapter if you want to. I will just leave it by default on this. I will click here OK. I can now start the Metasploitable virtual machine once again. And I will do the same for my Python ethical hacking Kali Linux machine. So I'll go to the settings. I will go to network. From NAT change it to bridge adapter and leave it on this. As I said, you can change it if you want to, but make sure to find the one that actually works. Now one thing also I need to mention is if you are using a wireless adapter, sometimes wireless adapter won't really work in Kali Linux and they're not supported by Kali Linux, so your best use is to actually use the cable internet connection. Now you can try the wireless adapter as well. Maybe your wireless adapter is supported, but most likely it will not be. Now you can check what wireless adapters are actually supported by Kali Linux online, and you can actually buy a cheap one for like $10, so that is another option you can do. So once you select all of that, click on the OK, and let us see if Metasploitable booted up. It did. We log in with the msfadmin and msfadmin, and if I just tap ifconfig once again, you can see that right now my IP address is 192.168.1.5. It is no longer 10.0.2.15. And this .1.5 now belongs to my local area network range for my IP addresses. So that would be about it for this tutorial. I hope you enjoyed it. And in the next tutorial, we will actually continue coding we will start coding the simple program which will actually retrieve the banner from open ports, whether they actually send the version of software running on them. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody and welcome back. And right now let us actually try to code a simple program that will actually retrieve a banner from an open port from the software that is running there. So first of all, you need to open both Kali Linux and the Metasploitable. As we can see right here, I have them both open. Also, you need to check the previous video if you didn't in order to make your IP addresses match to the local area network address. As we can see, it belongs right now, since my IP address of my Kali Linux is right now 192.168.1.7 and the IP address of my Metasploitable is 192.168.1.5. So they both do belong to my IP range of local network, and right now we are good to go and actually can try to code the simple banner retriever. So first of all, let me zoom this in so you can see it. We will go to the Python programs and we will go to the scanning. There we will make a program with nano called retBanner, which basically stands for return banner, and we start with the simple line of hashtag user bin Python. So right now let's first think of what we need to code. So what we need to code is basically something similar to a port scanner. So we will try for a certain range of ports, for example for first 50 ports, we'll try to actually connect to those ports, and when connecting to those ports we will actually try to receive something from those ports. Now by receive I mean receive some bytes if they send any, and if they do send, those bytes will most likely be something like either prompting us to log in or either sending us the version of software that they are running. So let's see how we can actually do that. All we need to do for now on is import socket library, since with that library we will be performing all of our actions such as connecting, retrieving data from that port, and so on. So let's make a function called main. As usual, that will be our main function. Now let's first try to actually retrieve a banner from a single port. So let's actually add a port to be 22, which is the port for SSH, which I know that it is by default open on the Metasploitable. Since Metasploitable does have a bunch of ports open, you can use nmap to scan your Metasploitable in order to check it out, but trust me, it is an open port. And right now we can specify the IP address to be the actual IP address of our Metasploitable, which is now 192.168.1.5, I believe. Yeah, it is .1.5. And all we have to do is actually create a variable which will be banner, which will store the result of actual port sending us banner back. So let's see how we can do that. What banner will be? It will be something that we will return from the function return banner, which we didn't code yet, and we will code it right now. But that function will actually take an input of IP address and of the port, which is the port 22. And then simply after that, if banner exists, so if we received anything, we can just print something like this, plus IP, which is the IP of our metasploitable, plus, whoops, and then we can do something like this, plus banner, so it looks better. What this will do is basically it will print something like this, so plus 192.168.1.5, whoops, then the this sign right here, and then the banner right here will be something like this. At least I believe that is something that it will be printed out. So all we have to do right now is first of all call our function, which is main, and we need to call the return banner function, which we use right here. So this is a non-existent function. We need to make it, and it will be rather simple to make since we will use something similar as to the port scanning function. So banner takes the input of the IP and the port. We place the two dots right here, and we will actually try to connect to that port. So first of all, let's set the default timeout. So socket.set default timeout, oops, to be, for example, 2 seconds. And now we will create a socket object. Let's call it s socket.socket. We don't need to specify anything in the brackets. It doesn't really matter if we specify whether it's IPv4 or TCP protocol. We can leave the brackets closed without anything, and all we want to do right now is to actually connect. So connect to the IP and the port. So use the double brackets, open and close, and select the IP and the port in those brackets. And the banner, which is our variable right here that we selected, will actually be what we receive from that host that we scan. So as.receive, and we want to receive 1024 bytes. So this is a function that we didn't use yet. It basically stands for receiving. Once we connect to the target, this function right here will try to receive 1024 bytes or less from the target, and it will store those 1024 bytes in the banner variable. Now we hope that within those 1024 bytes is the actual banner of the open port software that is running on SSH. So all we have to do after that is return the banner itself, since we specify the banner variable to be this function, which will return then the data to our banner variable. And in case that doesn't work, we will just return from the function itself. So we won't really print anything or do anything, we will just return without saying anything. So let us save this. I hope everything is correct. So yeah, it should be. Right now we want to chmod the red banner, and if I run it, invalid syntax, okay, so there is some error that we need to fix, such as this one. This error right here needs 2 dots, so let's save it right once again. And as we can see, we successfully were able to retrieve the banner of the SSH port running on the Metasploitable tool. So now, right now we know that on the port 22, the Metasploitable is running SSH-2.0, OpenSSH 4.7 P1 Debian-8 Ubuntu 1. So right now, for example, if we wanted to, we know that this is the banner of the open port, and if you wanted to, you can copy actually this, and you can try to, for example, search on Firefox for any specific vulnerabilities for this particular software. So let's see if there are any. You can just search it like this, so this and then exploit or something like that, it doesn't even matter. Or vulnerabilities, you can search anything you want, and maybe their software or that version of the software is currently vulnerable or outdated or something like that. As we can see, OpenSSH security vulnerabilities for the version 4.7p1, which is our version, as we can see, 4.7.p1. Then you would go to that link and try to actually find some vulnerabilities that you can exploit. But right now, let us actually try to make it scan multiple ports. Oops. We do not only want to scan the port 22. What we want to actually do is we want to type here for some variable x, for example, in range 1 to 100, let's say. We want to perform all of this. Now the IP address can stay like this, or let's actually prompt the user for an IP address before the loop. So we will just use the same IP equals raw underscore input for the Python 2, or we can actually just use input. So it actually works both for the Python 2 and Python 3. I believe it will. We will see. Enter. Oops. Star, so it looks better. Enter target IP. So once we get prompted that, we enter this loop, which will do all of this for each port in range from 1 to 100. So let's see if we actually retrieve anything. And we can actually strip the new line, or let's see if it even retrieves the new line. Let us just run this program. I'll show you what I meant by that, but let me just run it. Return banner 192.168.1.5 invalid syntax. So what is now invalid? Let's just go with the raw input. Perhaps that is making a problem, but perhaps not. So let us try. Global name port is not defined. What do you mean global name port is not defined? Oh yeah, we specified here port. So instead of the port, since we use variable here x, we will just delete x and make it port. So for port in range 1 to 100, maybe that is more easy to understand. We want to go to this function for each port number for the same IP address. So change that, Control O to save, Control X to exit, 192.168.1.5, and we can see we actually received something for different ports. We received 4 different banners, which this one I really don't know what this is, but we were able to receive an FTP banner for the port 21, which really isn't specified right here. So this is something that we should add. We want to add which port are we receiving the banner from. So let us do that. And we want to strip the ports from the banners from the new line, so we don't have this open space right here after every port scan. So nano return banner. Let's see how we can do that. We can do that simply. We can remove the new line by doing strip open brackets and then -n. I believe this will do the work. And what else did we want to do? We want to print out the port as well. So we set this, then plus IP, then plus, and we can do plus slash. Let me just do it like this. So plus slash, and then plus port. So if I'm not mistaken, it should work. It should look something like this: 192.168.1.5, port 22. And let's separate it like this, and then something, and then for example open SSH or something like that. So it should look something like that. Let us see if I'm correct. Just clear the screen since this looks really weird. Okay, so we are missing something somewhere. Let us see. What are we? Oh, we are missing a plus right here. So plus port, and then after that we need to specify another plus. And now we should be good to go. 192.168.1.5 cannot concatenate string and integer object. Sounds good, but let's now make our port, since it says that it can't really add an integer to the string, so we need to make our port number to be a string in this case, just in this case where we print it out. In any other cases, for example, this function, it will be an integer, but once we print it out, we need to make it to be a string, so this actually works. So 192.168.1.5, and here we get the same result as before. Not really sure why it is still printing out the new line. Let's see if we can fix that as well. Banner equals s.receive, and then let's try it right here. So strip, but it shouldn't really present any problem. Let us try it once again. I mean, it's not really that big of a thing, but it's still, for some reason, making it with a new line. It doesn't even matter. What matters is that we have an actual program that can successfully scan for the banners of software running on the open port. So that will be about it for this video. In the next video, I will show you how you can create a program which will compare the banners from the scan with the file that contains all the vulnerable software versions. So for example, you download a file from the internet that contains all of the vulnerable software versions, and if our scan retrieves a banner that actually matches some of those banners in the file, we will say that the target is vulnerable. So hope you enjoyed this video, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and in this video we will code our vulnerability scanner. So as I said, what we'll be doing is we'll actually perform the same port scanning while retrieving the banners from the open ports, and also after that we want to add a function which will check those banners with a text file that contains vulnerable software banners. So I made that file right here, so if you notice vulnerabilities.txt, if I nano it, what I have right here is a bunch of some gibberish right here, and then at the third position I have the banner from the SSH port from our Metasploitable, which is the one that we received in the previous video with our return banner program. Then after that I also have something which doesn't make any sense, just so we have multiple things in the file itself. So right now, let us actually nano the file that we will create, or the program that we will create. Let's call it vulscan.py, and we will start off with the same line as in every program, so user bin Python. And we need to actually import 3 libraries for this program. One of them is the regular socket library, which allows us to actually perform the connection and to receive the data from the target. The other one is the library that we will use in order to check whether the specified file of vulnerable banners exists or not, and whether we actually can execute it or read from it or not. We will use the OS library to do that. This OS library comes with some functions that allow us to check whether the file exists, so that's why we are using it. And the last library is the sys library, which we will use in order to check out the number of arguments specified in the command of the program. Since we will specify the command, or basically what I imagine this program to be, is something like this. So when you run it from your terminal, you will run it like this. So vulscan.py, and after that you want to specify vulnerability banners.txt. So we want the command of the program itself to be vulscan, and then the name of the file from which we want to read the vulnerable banners. So let me just delete this right now, and let's see how we can actually code that. First of all, what we want to do is actually code our main function, so def main, 2 dots, and the first thing we want to check out is to use the sys library in order to check whether we have the correct number of arguments specified in the command itself. So if you count the arguments, the first one is the name of the file, and the second one is the name of the file that we will use from the for the vulnerable banners. So at the total there are 2 arguments. As I said, one the name of the program and one the name of the file. So we want to check if length of the number of arguments, so sysargv, equals to 2, which it should equal to 2. We want to have 2 arguments. We want to first of all set the file name which is the file of our vulnerable banners, to be argument under the number 2. So sys.argv, and then at slot 1. Now you might be asking once again, why am I saying that it is an argument number 2 and then in the bracket specifying 1? Well, I will remind you that in Python counting actually starts from 0. So the first argument will be the argument or the name of our program itself, and it will be labeled as 0. Then the second argument will be the file name, and it will be named as 1. Right now, when we said that the file name is argument 2, we want to check whether that file even exists. So maybe the user specified the file name wrongly, and we want to check whether that file exists. So if we will use if not, os.path is a file, so is file, and we need to specify in the brackets file name, since that is the file that we are using. So this basically means if this file doesn't exist, or if this isn't a file, we want to print minus file doesn't exist. Oops, okay, so like this. Then we want to exit the program itself with 0. We also want to check whether the user has permissions to read from that file, so we can do that with this if not os.access. So if we do not have access to the file name and then os.r_ok, we want to print access denied. Since, for example, maybe the user is trying to run this file as a simple user and the text file that they want to read from is the root administrator or the root privilege file, and we cannot read from it, so we will just print access denied, and then we will also exit the program itself. So right now, since we checked two possible options, we want to add the else statement to this if statement. So we have the if statement. If the length of the arguments is equal to 2, which is correct, then we will check this and proceed to the next part of the code. But if it is not equal to 2, that means that the user specified a different number of arguments, whether that is too little arguments or too much arguments. So we want to print the usage so they know what they need to specify. So usage, oops, and then we can do it something like this. Wait a second. So usage plus the string of the program name itself. So we can do that with the sys.argv and then 0, since 0 is the first argument, which is the program name. And then we want to add a plus, so plus the vulnerable file name. So we can do it like this. What this will print is basically the usage and then the name of the program and then the name of the file, or basically this part right here, which will let user know that they need to specify a text file with the vulnerable softwares. So after we print the usage, we also want to exit the program. And in any other case, if actually they specified correct command, we want to continue executing the program. So let's see how we imagine this program to work. Well, first of all, what I will do is I will create a list of ports, the most used ports such as SSH port, FTP port, HTTP port, and so on. And we will actually scan multiple hosts and not just one host. So for example, in the previous videos, we were specifying the IP address of Metasploitable. And right now, let's specify for this program to actually scan the entire local host, local network. So how can we do that? Well, first of all, let us make a port list which will contain 22, 21, 22, 25, 80, for the HTTP, 110, 443. You can add as many ports as you like. I will just leave it on here. And right now we want to actually make a loop that will loop through all local machines on our local network. Now, since I don't really want to do all of them right now, I will just scan 2 or 3 machines. So we can do that with 4x in range. And that let's do from 4 to 6, since my IP address of the Windows 10 machine is ending with number 4. The IP address of my Metasploitable is ending with number 5, and that's why we are using from 4 to 6, so we can scan those 2 targets. If you wanted to, for example, scan the entire local network, you would just type from 1 to 255, since that is the maximum number of hosts available on a local network. But right now we will just leave it on 6 and 4, since we are scanning only 2 hosts. And we want to set a variable that so our program can know what the IP address of those hosts are. So we use for x in range, and now we want to set the IP for each loop to be 192.168.1 dot. Then we close the double quotes and add the string of x. Now why are we doing that? Well, basically if you have an IP address .192.168.1, we want to loop through this for each x from 1 to 255, so it will look something like this. Then this x right here will actually change value each loop, so we can scan different targets. So that's the idea. Now after we did that, we want to actually loop through the ports themselves. So for port, in our port list, which is this right here, we want to actually run the same function as in the previous program, which is the return banner function. So let's just do that. So for port, in port list, banner will equal to return banner with the IP and port as the arguments for that function. And now we check if banner was received. So if banner was received from that certain port, we want to print print plus the IP plus the want to print the slash, so we can separate the slash and the port, or pardon me, the IP and the port. So we want to type the string from the port. So remember that you cannot print an integer, so that's why we use the string from the port number. And then we want to add the banner. Or first of all, we want to add the 2 dots so we can separate the port and the banner themselves, and now we add the banner then. And right now, we also need to make a function that will actually check whether this banner is in the vulnerable banners in our txt file. So we will do that with function check once, which will take an input of the banner and the input of our file name, so the name of the file that we'll specify in our command. And these two, which is the red banner and check once, we will code in the next video. So for now, we coded a good part of the code. We have our main function right here, which we should actually call down here. And in the next video, we will code the rest of these functions. So hope you enjoyed this video, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to the second tutorial of our vulnerability scanner program. So right now, what we did by now, we coded the main function, and right now we are left to code the return banner function and the check once function. So first of all, we will code the return banner function, since that is something that we are familiar with. We used it in the previous video, so in the previous program. So let's just make it real fast. The function takes an input of the IP and also of the port. Then we put the 2 dots, and we will run the try and except rule to actually check whether we can connect to that port or not. So we will use the same as before. So socket set default timeout to be around 2 seconds. And after that, we want to actually perform the as equals socket.socket, and without actually specifying any other arguments between the brackets. So right after that, we want to actually perform the connect function itself. So s.connect to the IP and to the port. So IP, port. And after that, we want to receive the banner with the banner equals s.receive 1024 bytes. So after that, all we want to do is just press return banner, and in the accept rule we want to just return. So this is the function that we already coded before. There is not too much to explain. It is same as before. So let us continue with our check vulnerabilities function. So def check once, which takes an input of banner and file name. So let me just check it right here. So banner and file name. Right after that, we will use something that we didn't use before, which is actually managing files in Python. In order to open a file in Python, you basically need a variable, which will be the file descriptor, and you need to just type open. In the brackets, you need to specify the file name, which in our case, it is just a variable file name. And after that, you need to specify the mode in which you want to open the file in. Now there are three available modes. One of them is read, the other one is write, and the third one is append. So you can specify all of those three with a simple one letter, which is W for write, R for read, and A for the append. In our case, we only want to read from the file, since we want to read and compare the contents of the file with the contents of banner that we received from the scan. So we will just specify double quotes open and close, and then between them the R for read. Then you close the brackets, and that is how you open a file in Python. Now we want to actually read from that file, but we want to read line by line, since we specify the vulnerability.txt file to actually have vulnerable software that are separated by each line. So let me just show you. If I just save this in a second, and here I have vulnerabilities.txt. If I nano the vulnerabilities.txt, here I have some gibberish, and in the third line I have the actual software that is running on Metasploitable 2 on port 22, so the SSH port. And we will then compare each line with the banner that we received from the open ports, and if they are equal, or basically if we find this to be in some kind of a banner, we will print that the software is actually invulnerable, and we will print it to the screen. So let us close this and nano back to our polscan.py. And now we want to use a loop which will basically say for line in file.readlines, open and close brackets. This is a function that we use to read line by line, and we will store each line in a variable that we name just line simply. We want to actually compare right now, so if line, and we want to strip out the new line characters, which is \n, and then between the double quotes, is in banner. So if this line dot strip the new line is in banner, we want to print server. So we will just type it right here. Server is vulnerable. Oops, is vulnerable. And then we want to print the actual vulnerable banner. So banner.strip, and then we will strip the new line so it doesn't present any problem to us. And basically this should be the entire program. All we have to do right now is actually run the program on our targets and see if it will be able to find the SSH port as a vulnerable software running on our Metasploitable 2. So let us save this, Ctrl-O to save, enter, Ctrl-X to exit. We have our vulnerabilities.txt file containing the vulnerable banners. We have the vulscan.py, which is our program. Now let's actually try to run it. And it gives us the usage. Since we specified it wrongly, we need to specify the name of the file with the command. So we will specify it like this, vulscan.py, and then vulbanners.txt. So right now, if I press here enter, it will perform the scanning of the localhost machines from 4 to 6, from the IP address ending with 4 to 6, and then hopefully it will find the Metasploitable SSH port as a vulnerable software running there. And as we can see, it has finished. It found the open ports, it found the versions of software running on those open ports, and it also found that the server is vulnerable with this software running. It scanned the Metasploitable on port 22, found the banner, and right after that it printed out that the server is vulnerable because this banner right here is also contained in this vulnerabilities file.txt. So of course, with the real scans, you won't really be using a file like this. What you want to do is actually download from the internet a file that contains vulnerable software names, and then you can compare it like that with your scan. So that will be about it for this section. In this scanning section, we coded our simple port scanners, and then later on we coded the advanced port scanners. We also finished off with the program that returns the banner of those softwares running, and we finished off our scanning section with the vulnerability scanner on open ports. So hope you enjoyed this section, and hope I see you in the next lecture where we will continue coding. Have a nice day and take care. Bye. Hello everybody and welcome back. And in this section, what we will do is we will look at some of the attacks that we can use on the ports that we actually got from our scanning section. So for example, we scanned our Metasploitable, we found out SSH was vulnerable, we found out open ports such as FTP open port on 21, we found out SSH open port on 22. Now let's see how we can actually do some of the attacks in order to compromise the target machine. So first of all, let's see how we can legit log in to the SSH. So we know that the target, and by target I mean our metasploitable machine, is running the SSH port open, so we can see that the IP address of our metasploitable is 192.168.1.5. So let's actually try to SSH to 192.168.1.5. Oops, SSH, not SH8. So SSH 192.168.1.5. And here we can actually see some of the stuff that we get from the program itself. So this is everything that we need to take in matter once we actually start coding the our SSH brute forces, for example, or our program that will connect to the target and actually execute the cat@c shadow, for example, command, which is the command in order to see all of the saved passwords on the target Linux system. So let me just show you. First of all, the authenticity of host can be established, okay? The RSA key fingerprint, and this is the fingerprint of the target, and it asks us now, are you sure you want to continue connecting? So this is the question that can actually present us problem once we start coding, since we actually have to answer it before we start connecting and sending passwords and usernames and so on. So let's see what happens once we specify yes. It will say, warning, permanently added 192.168.1.5 RSA to the list of known hosts. Now I'll also show you how you can delete that afterwards, but right now let us see how we can log in to the metasploitable over SSH. Now I believe in order to do that, the password is just msfadmin. Now you will notice that once you type right here, that will not be printed out. That is normal, just click enter after specifying the msfadmin, and permission denied. Not really sure why is the permission denied. It might not be msfadmin, so let's try it core. Okay, so in order, let me just find out what, first of all, the SSH password is for the Metasploit, then I will log in. Okay, so the problem was that I need to specify the account on which I'm logging on, so I want to log into the MSF admin account, so MSF admin at 192.168.1.5. Now it will ask for the password, which is MSF admin. And as you can see right now, we successfully logged in into the Metasploitable over SSH. If I run who am I, you can see I'm msfadmin, ifconfig, you will see that this command will give me the IP address of our Metasploitable machine. So this means I'm logged in into the Metasploitable, ls will list files from the Metasploitable, and so on. Now you can exit it with just typing exit, and connection will be closed right now. But what we have to do right now is actually create a program that will automate this entire process for us, and then after we actually log in, it will try to send back the output of the cat@c shadow command, which will actually just send the root username and password, and other accounts as well, usernames and passwords. Just the passwords will be hashed, but we will actually try to crack them later on. For now on, we just want to get them. So let's see how we can do that. First of all, let me just go out of the scanning section, and let's make a directory called sshftp. No such file or directory. Oh, we cannot have the slash, so let's just call it sshftp, just like this. And here we have sshftp, where we will code some of our future attacks on the SSH protocol and FTP protocol. So let's go to the directory, which is this one. And right now, let us actually nano something like nano ssh login.py. We want to actually create a program that will be able to connect to the target over SSH and actually execute the command itself. So first of all, let us just, for now on, for this tutorial, as a beginning, just code the main function, and then later on we will code the connecting function and then sending the command function. So first of all, we need to start the user bin Python line in our code. And we need to import a library that we are first encountering for now, which is pexpect. It will allow us to automate some of the processes in our SSH logging in. So after we do that, let us create a main function, so def main, which will take no arguments as always. We will set the host, which will be the IP address of our Metasploitable, which is 192.168.1.5. We will set user to be equal to the msfadmin, and we will set the password to be equal to msfadmin. So for now on, we only want to actually be able to log into the SSH with our Python program. So we specify the user, we specify the admin. Right now we will create something called child, which will be our SSH shell. We want to perform the connect function on that, which is the function that doesn't really exist, so we will have to code this function in the next video. And we want to paste to that file the host, the user, and the password. So first of all, let's paste the user, then the host, and then the password. So this function connect, which we will code in the next lecture, will take these three inputs, which we will perform the connection with. So after that, once we perform the connection, we want to make a function called send_command, which will actually send the command to this SSH shell, and then the command will actually be cat@c shadow. So this function right here, which we'll also need to code, will take an input of the SSH shell, which we stored in the variable child, and it will also take an input of the command. So we can specify that command to be cat@c shadow, and for example, let's say we only want the root password, so we will grab root and then ps, pardon me, ps, or we can actually type ps. What this will do is, I didn't really show you this yet, but if you open a terminal, you can actually run two commands at the same time. So for example, this command is a one command. This command will basically list the @c shadow file, and then it will only try to find for the lines that contain root in them. And then if you separate the commands with the dot and then comma, you can run a different command, which in this case we will try to run ps for no reason at all, just to show you how it works, which is showing the processes running on the target system. So let me show you if I just save this for a second. If I just go cat@c shadow, you can see here are here is that file that we need that contains the password, hash value and password for root, as we can see right here. So we will be just going for this line on our target system. And if you just type here the cat@c/shadow and then grep for root, you can see we only get the line that contains the root. But if you just type cat@c shadow and then grep root and then dot and comma and then ps, we can see that we grab the line that contains the path for root, and we also list the running processes on our Kali Linux machine. So you can concat as many commands as you want. So if I just type here ls as well, you can see it does both of these commands, and then the third command, it just lists the file in the current directory, which at the moment is just sslogin.py. So let us nano this file right here. We basically finish the main function. The real coding of this program is actually to code this connect function and this send command function, but it really isn't that hard. Let me just close the brackets right here so we don't get this syntax error. And down here we only want to actually call the main function. Now let's save this, and that will be about it for this tutorial. And in the next one we will code these two functions that we are missing. So hope you enjoyed this introductory part for SSH attacks. Hope I see you in the next lecture where we will continue coding our SSH login program. Hope I see you there, and take care. Bye. Hello everybody and welcome back, and let us continue on coding our SSH login.py. So in the previous video we actually started with our main function. We actually specify the host, the username and the password. Now all we have to do is code this connect function right here, and we need to code this send command so we can actually retrieve the output of this command. So let us see how we can do that. First of all, let us start by coding the connect function, since it is more complicated and since we actually use it first. So let us go up here. We'll need to call it the same, so connect. It takes an input of user, host and password. And first of all, if you noticed, once we actually try to connect with the SSH to the Metasploit, it asks us, are you sure you want to continue connecting? That was the part where I told you this could present a problem to us, since that string could actually potentially ruin our program if we do not include it in our login SSH. So let us call that SSH_new key. We will need to name it the same as it is. So it was something like, are you sure you want to continue connecting? So if we receive this string, and we will receive this string, what we want to do is actually we want to actually expect this to come to us, and then once it comes to us, we will just send yes. So we will send to the target yes, so it proceeds to actually giving us the input for the username and password. Let us continue. We can just use the const string, which we will receive, so that will be SSH. This is something that we are using. So this is the same string that we used once we actually ran it in terminal. So as you remember SSH, then we had to type msfadmin, so we will just type here plus user, since the user variable is already specified to be the msfadmin. So the user variable, and then plus the @ so @ is a must, you need to have it, and then the IP address of the target, which is in our case host. So this is basically this command right here, which we ran, ssh msfadmin 192.168.1.5. If you run this in terminal, it will prompt you for username and password right after this string right here, which we specified. So right now, what we want to do is actually, we want to spawn this or run this string, so we can do that with the child command. So the child, what this will be is pexpect. This is where we use our library, and we expect to spawn this const string, which is this value right here, which is our command in order to connect to the SSH on our metasploitable. Now, what we return, or receive, let us see what we can return from that. Return, we will just call it ret. We'll just type here child.expect. So this is something that we will actually expect from the target to send us back. We can use the pexpect.timeout. We can use the SSH new key, since the SSH new key is something that we expect right after we try to connect. As you remember, first thing that popped up was the "Are you sure you want to continue connecting?" And we after that are prompted with the password, which can either be capital P or not capital P, so we will specify both of them. We do that with this, so first capital P, capital P, then this pipe right here, then the small letter P. Then we close the brackets right here, and we can continue with password. So you just press the two dots right here, and this will actually just specify whether or basically expect either the password with capital P or password without the capital P. So let us close this as a string and close the square brackets from this part right here, so don't get confused, since I almost got confused why was this in brackets and this wasn't, but this square bracket right here is referring to this square bracket right here, and we also need to close this normal bracket at the end, so let me just close that one as well, like this. And after that, we want to check whether the return value, since what we get from this command right here is either a 1 or a 0. If we retrieve a 0 and the return or the ret command or variable, pardon me, is 0, that means we weren't able to connect. If it is 1, that means we are able to connect, and we are prompted this line right here. So if we are prompted this line right here, we want to send yes to the target, so it actually goes to the next step. So let us see how we can do that. If I just type right here, if ret equals to 0, we will print, minus error connecting. And we will return from this function. If ret is equal to 1, we will actually send to our SSH, which is our child, we will send the yes answer to this question. So child, we can do that with the command or function send line, and all we have to do is specify in brackets the string we want to send, in our case that is yes. So once we send that, we want to actually expect this password to come up, so we will type it right here. Return is now equal to child.expect pexpect, this is so hard to write, pexpect.timeout, and then here we will specify the same thing as here, so let me just copy it so I don't actually write it twice. Here it is, we expect the password field to get prompted to us, and we close these brackets right here. If right now the ret is equal to 0, we want to also close the program. So we will just print once again, error on connecting. Since if this red right here is also equal to 0. That means something went wrong and we can't connect to the target, since almost always you will receive this after the question, are you sure you want to connect or to continue connecting? Error connecting. We close the string and we return. But in case that it isn't 0 and that is number 1, so we want to send the password, since we get prompted to enter the password. Right now we want to child.sendLine password, which is this variable right here, and we want to basically expect some kind of a prompt from the SSH. Now that prompt can either be a $sign, an arrow, 3 arrows, a hashtag, it doesn't even matter, we will just expect any of that. What we will do, we will create a global variable with a list from all the things we can expect. So first of all, let me just type child.expect, and we want to actually expect a prompt. And what prompt is something that we didn't create yet, so here it is. Prompt will be a global list which will actually hold most of the things that we can actually expect, so something like this, a single arrow, $sign, make sure to leave space on all of them, so just like this. Now let's close this list, and we will expect to get prompted anything like this, which will basically mean that we successfully logged into the target, since we sent a password and we got our terminal back from that target. So right after that, what we want to do, if we expect that and we receive that, all we want to do is return the child, which is our SSH connection. Right after that, in our main function, we will actually send command to that child, which will actually gather the password from our root user. Now this send command we will code in the next lecture, as well as we will test our SSH login.py program. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back. And let us finish our SSH login program, so we can actually successfully log into our Metasploit framework machine, or pardon me, Metasploitable, and actually execute the cat@cshadow command. We want to grab for the root password, and we also want to run some other command in order to see if we can run multiple commands with our program. So let us navigate to our Python programs, sshftp. There I have my ssh login.py, and let me just zoom this in so you can see everything better. Okay, let's nano ssh login.py. And all the thing we have to do right now, since in the previous video we coded the connect function, which should successfully connect to the target, right now what we want to do is actually code a function that will send the command of grabbing the root password from that target system. So we are expecting prompt right now, as we can see in our connect command, we are expecting prompt, and as soon as we get the prompted, that means that we logged in successfully, we return the connection from our SSH shell, and right now we want to code this function right here, which is send command. We want to send to the target system or target connection, which is this child variable right here, and this is the command that we want to execute. So our send command function should take 2 arguments. One of them is the basically the connection, or basically the child, and the other one is the command that we want to execute. So let us go up here. Let's make def send command. Once again, make sure that it is named the same as in your main function. It takes an input from the, now we can put here anything we want. So let's say connection, and it takes the command. So this is our function. Let me just not forget these 2 dots at the end. And all we have to do right now is basically just connection dot send line command. This is all we have to do in order to send to the target the command. Let me just fix this since there is no G at the end of the connection. And all we want to do is expect the prompt once again, since after the command has been executed, we will get another prompt back. So child.expect prompt. And what we want to print is print, or not child, child is our variable, we need to actually type here connection, or maybe it is easier if we change this to child, so you don't get confused. Basically the child and the connection is the same thing. So let us switch all of this to child. So you don't get multiple variables right here, and let us print child.before. What this will do is this will print the output of our command that we executed on target system. So let us go to the main function once again. We set the host to be the IP address of a Metasploitable, which I will run right now. So go, if you don't have it running at the moment, just go onto your VirtualBox, start the Metasploitable. Right now I will check if it is still the 192.168.1.5. But we don't really need to have this. We can actually prompt the user to enter the name for that host that they want to scan. So raw underscore input. We already know what this function does. We want to enter the host to target. So we can use something like that. We can even prompt this for the user. So raw input, enter SSH username. And we can prompt for the password. So basically raw underscore input, enter SSH password. So we prompt the users for everything. So this doesn't actually target only one target, which is in our case Metasploitable. So users can actually specify any host they want to scan. Let me just go right here, log into my Metasploitable, MSF-admin, and MSF-admin. I check the IP address of our Metasploitable. It is .1.6. So it did change from the previous video. Let me save this and let's actually try to run this program right after we make it an executable with the chmod +x. So ssh login.py. And right now if I run this, we get the question to enter the host target. So 192.168.1.6. Of course, don't put the same IP address right here. Check the IP address of your Metasploitable on your system. So once you specify this, press enter. The username is MSF-admin and the password is MSF-admin. Right now we let this run and we can see that we actually get the command to be permission denied. So what does this mean? This means that this user, MSF-admin, doesn't really have the permission to actually access that file that stores root password. Now, this can be something that can happen if you basically brute force or log in or hack a non-root account on the SSH. You will not be able to get the permission to run this cat@c shadow command. But let me show you how it looks like once we actually can get that. So I have another virtual machine right here, which is the OS virtual machine, I believe. Let me just check this out. Now you don't need to install it really. It's basically almost the same as the Metasploitable. If we do need it, however, later on I will show you how you can install it, but for now on we really don't need it. The SSH is basically something that you can brute force on any target system that has port 22 open. So right now, since I know the credentials for the root account for the OS virtual machine, so let me just see, failed to open a session. Okay, so let me just run a different one instead. Since I have a bunch of the machines right here, I can just run any of them and see if we can actually get the root password from that machine. So for some reason, those machines are not running. Failed to open session, details. Okay, doesn't really matter. What matters is if you actually log into the root account from any SSH target, you will be able to execute the cat@c shadow, which will actually get you the root password for the root account. But let's see what else we can actually execute if we go to our ssh login.py. Let's actually execute something that we can, which would be to, for example, let me just remove the grep root. Let's try to ls what's in that directory that we log in. So if we just specify everything once again, so .1.6, MSF-admin, we can see that the only directory in that target is the vulnerable directory, which really is the directory on our Metasploitable. So if you just type here ls on my Metasploitable, you can see there is vulnerable right here, as well as here. So we successfully coded a program that can actually log into the SSH and execute some of the commands and bring the output of those commands back to us. Now what we want to do is actually try to make this an attack. So let us actually in the next videos try to make an SSH brute forcer, which will execute a bunch of the connection tries with different passwords and see if it can brute force the SSH account. So that would be about it for this tutorial. I hope you enjoyed it, and I hope I see you in the next one where we will start our SSH brute forcer. Hope I see you there, and take care. Bye. Hello everybody, and welcome back. And right now in this video we will start off by coding our brute forcer for the SSH. Now in the previous videos we managed to code the SSH login program, which will just perform the login process onto the SSH on a certain target, and it will try to execute some of the commands. We noticed that we cannot execute the cat@c shadow command on the target system since we didn't log in into the root account. But if you, for example, find out the root passwords for some target and manage to log in, you will be able to execute the cat@c shadow command and get the root hashed password. But right now, let's see what we can do in order to make this program a brute forcer instead of just a simple login program. So let's see first of all what we don't need to change in this program in order to make it. We know that the connect function will always be the same, so we can just copy this function. Let me just copy it. Since we don't really need to change anything right here for now, maybe there will be some minor changes to this, but maybe not even that. So for now, let us just nano brute ssh.py. We'll add our standard line, which is user bin python. And what we want to do is first of all import the same library as in the previous video, so pexpect. And basically just paste the function, which is the connect function. Now, the reason why we are just using this function is because this connect function will work, it's basically the same for every SSH, so we don't really want to change it, we only want to use it. We already coded it, so there is really no point in us coding it once again. So all we have to do right now is code our main function, which will actually take the brute forcing process. So let us code it def main. We code our main function. We will select the host to be raw input, so we will prompt the users to enter the host IP address. So 192.168.1, oops, not that, enter IP address of target to brute force. We close the double quotes, we close the brackets. We will prompt them for the user. So for example, if they want to brute force the user, they can do that. So let's type here user equals raw input, enter user account you want to brute force. And the password is something that we will actually try with multiple different passwords. So we will need a password file which will contain multiple passwords which we want to use in order to brute force the account. So let us first of all make that file. Since we don't have it, we'll just make a simple nano passwords.txt. And there we will, for the purpose of this tutorial, add the msfadmin as a password, so we actually see that this program will work after we've continued coding it. So in order to do that, let us just type here some random password. So administrator, admin123, password 123, msfadmin, and hello world, for example. So we just leave this on this. We save this. We know that this is the correct password for our metasploitable machine. So let us save this and exit and go back to our brute force SSH. So we prompt the users for the username and the IP address of the host, and all we want to do is open the file. So we will open the file which contains our passwords in order to read from that file and in order to brute force the account with those passwords. So in order to open the file, you just type here any variable, in case I will name it file right now. And to open a file, we use simple open command and then the file name between the quotes. So passwords.txt. We can use single quotes, no need to use double quotes. So this is the name of your file. If you named it the same as I did, so if you named it differently, make sure to specify a different name right here. And all we have to do right now, put a comma and select a mode that we want to use, which in our case is just reading from that file. Right now, what we want to do is actually just make a loop which will go through this password file and read every password line by line. So in order to do that, we can just use for password. So for a single password in our file.readlines, now we used this readlines function before. It basically just reads a single line or a line by line from this file. Now what we want to do for each password is actually try to perform the connect function. So we will use our child once again as a variable equals connect, which is this function right here. And all we have to do is pass this host and user variable and the password variable to the target, or pardon me, to the function. So connect, we want to specify the user since this is the first argument in our function, then the host, and then the password, which we read from the password file. So password, and close the brackets. So we will perform this function, and if it manages to connect, we will get the child back. So what we want to do is, if this function works correctly, or everything is executed in this function, we want to actually print that we found the password. Since if it connects correctly, that means that we found the successful password for this account, and we can print that we found that password. So print password found, and we can concat this with the password itself. Now, for example, we can now in the accept make the password not found, so this is the incorrect password, print with the minus, wrong password, and we concat the password to that. So let's see what our program actually does. So it reads the password, it tries to perform the connect function with that password. If it manages to perform that function, that means that we found the password, so we will print password found. In any other case, if it doesn't manage to connect to that target, we will print wrong password, and we will continue to the next password in the passwords.txt file. So let us see what we can do right now. Everything right here should be good. Let's just call the main function in order to check if this will work. So we will just call it like this, save this program. Let's make it an executable, so root SSH, and let's run the program. Enter IP address of target to brute force 192.168.1.6. The user account we want to brute force is the MSF admin. And as we can see, it didn't manage to find the correct password. Now let's see why is that. So let us nano the file. As you can see right here, it said that all of these passwords are wrong passwords, which is not correct. We know that this password right here is correct password, so we might need to do some minor changes to this in order to make it work. First of all, what we want to do is, first of all, to make sure that our passwords are printed out as they should be. So let us print the password. Let me just find where is the, oops, I nano the wrong file. I need to nano the brute force file, so nano brute ssh.py. And for password in file.readlines, we want to just print password. So let us put this all under the hashtag, so we can just print the passwords from now on, so we can actually see what is wrong with this program. It doesn't even matter what the IP address is, so we can just print the passwords, and we can see that the reason could probably be because these passwords have a new line character right after that. So in order to change that, we need to strip the new line character from each of these passwords. As you can see, once it prints them, it leaves an empty space below each password. So let us see how we can fix that. SSH log, once again, I nanoed the wrong file. Let us go right here. Print the password. For password in file.readlines, we want to make password equals password.strip. And then we will add the new line character, which is the \n. So we strip the password from that new line character, and let's right now save this and try to print once again. 192.168.1.6, which is not really necessary right now. And right now we get the passwords printed out as we should. So let us try to brute force once again and see if it will work right now. All we have to do is hashtag this print password, or we can just delete it. We don't really need to print that. And we want to remove the hashtags from all of these lines. So right now, let us see how this will work. If we run the program once again, we enter the correct IP address, 1.6. We enter the user account, MSFadmin, wrong password, and it still didn't manage to find the MSFadmin password as a correct password. So that is a problem that I didn't encounter before, but I believe I have a few ideas why is that like this, but I will show that in the next video so we don't waste too much of our time fixing the program. I will just fix it by myself and then I will tell you what the problem was and how we can fix it. So hope you enjoyed this video and I hope I see you in the next one. Bye! Hello everybody and welcome back, and let us actually see what was the problem in our bruteforce.sh.py file. So I found out what the problem was, and the problem was that this actually performed the brute force function relatively fast, and that's why I didn't even have enough time to perform the connection fully, or should I say it didn't perform the connection till the very end. So in order to do that, what we want to do is add a timeout. So this doesn't perform this fast, we want to add a timeout, but we do not want to add too big of a timeout, since then it will brute force one password per every 3 seconds. So we want to add a timeout, for example, 1 second or half a second. And the part where we actually want to add that timeout is the child.expect prompt. So go down here, and all we want to do is add a comma right here. So this is the part where it can actually perform the part of this function really slow. So it actually depends from the target as well, how fast it will give us the prompt for the SSH. It actually depends from our speed of the internet as well. So we want to give a certain timeout so this can actually have enough time to prompt us back with our prompt. Now there is also one more thing that we missed, which is the prompt itself. We didn't copy it, we just copied the function, so we need to copy the prompt itself. But first of all, let's add the timeout right here to be 0.5 seconds, which I believe should be enough. If it is not, we will change that. And we need to add the prompt as in the ssh.login.py file. We need to add the prompt from the strings that we actually want to get from the target. So we add this. Let us just copy it from the previous program, so I don't actually spend time writing that. So I will just copy this part right here. This is the prompt that we expect, nano debrute SSH, and I will paste it right here. So I paste this right here. We have the timeout, and right now, if I just try to run the program once again, so brute force SSH, we enter the IP address of our Metasploitable. The user account will be msfadmin, and let's see, so wrong password, and we get the password found. So right now we successfully coded the brute forcer, as we can see that it found the password which was the correct one, which is the msfadmin. And let's see how fast we can make this go. Since our timeout is 0.5 seconds, let's see if we can actually make this go a little bit faster if we make a timeout, or if we actually remove the timeout. So let's nano the brute force.sh. We will remove the timeout to see if it will go any faster, and if it does go faster, if it finds our password. So 192.168.1.6 msfadmin, enter user account you want to brute force. For some reason right now this isn't working, but that's why I said that we need to use the actual timeout. So let us actually add it back. Obviously we can't go without it, so let us add it to be 0.5 seconds. It goes relatively fast even with the timeout being 0.5 seconds. So we can actually use this as a program, as a brute forcer, so it is relatively fast. msfadmin. So another thing you can actually do is try to make a threaded version of this program, so it actually runs every password brute force on a single thread simultaneously. So that is another option you can do. Right now, let us see what else we can add to our brute forcer. So first of all, we can actually try to execute the command once we find the right password. So you can try to execute the cat shadow command if you want to, if you are brute forcing our root account, or we can just try to test it out if we are able to even execute the command right after we find the password. So how we can do that? We can actually first copy the send command function from our ssh.login.py, which is right here. So just select this function right here, since we don't really need to code it twice. We go to our brute force ssh.py and we add our send function right here. So here it is. All we want to do is see where we can actually add that function and what we can execute. So let's see right here. So we try to connect. If we connect, we print that the password was found, And right after that, we can actually execute the command target system. So send command. We see what arguments that command takes. So it takes the child and the command. We can just paste this child to the send command function. And also we want to send the command, for example, let that command be pwd, so print for kindergarten, or who am I, it doesn't even matter. You can try to execute any command you want. For now on, we just want to see if this will work. So let's press this enter. Let's enter the IP address, so 192.168.1.6, MSFadmin. We start the brute forcer. It found the password and it also executed the command, which is the who am I, MSFadmin, and we got the prompted back with our terminal output. So here is it, who am I, the command is the output is MSFadmin. So if we check that on our Metasploitable, you can see if I just type who am I, we can see we get the MSFadmin. So this works correctly. But right now we can actually try to add a little bit of a color to our program. So we did that in the previous videos. Right now we will import a term color library. So import colored, which will allow us to print incorrect passwords in red and correct passwords in green. So you know that in order to do this, we need to actually have the Python 3 library, and in order to have Python 3 library and this program to work, we need to change every print statement and every raw input statement in order to match the Python 3 syntax. So print statements should be something like this, and we add the colored function, we open another bracket, and then right after here what we want to do is set a comma and print that in green, since this is the password found. We close the two brackets, and we want to do the same here. So red password, when it is incorrect, should be printed out in red. And right here we want to print the open bracket, colored, open another bracket, and then leave this like this. Also we want to change the raw input into just input, so just leave the raw underscore, delete right here the raw underscore, and save this. Also here are two print statements which we need to change as well. Error connecting, we need to set that between the brackets, and here as well error connecting needs to be set between the brackets. Let me just see if that's it. So let us try to run this. Python 3 bruteforce.sh, print child before, so we also need to nano that, so print child before needs to be in the brackets as well. And also let's actually remove this end command, since we don't really need that. We just want to make a brute forcer, so let's see if now it should work. No module named pexpect. So Python 3 doesn't seem to actually have the pexpect. Okay, so no module named pexpect. Let's see if we can install it for Python 3. In order to install it, you can just type pip3 install Python 3. Oops, not Python 3. Pexpect. So let's try that one. Now, we might not even have the pip3 installed, I'm not really sure. But we can try to, if this doesn't work, it doesn't really matter. What does matter is that our brute forcer does work. It can find the right password for the SSH account. It can brute force relatively fast, and we actually can attack a single target with a good password list. Such, for example, is those password lists with 10,000 most used SSH passwords, which you can use in order to test on some target that you have permission to scan on. So we successfully downloaded the pexpect library. Now let's try to import it in Python 3 to see if it worked. Pexpect. So it works like now. Let us run the root sh.py. Enter IP address of the target to brute force 192.168.1.6. Enter user account you want to brute force, MSFadmin. So wrong password. Let's see if it will find it, and we can see our program works. We found the correct password, we printed it out in green, it is easily noticeable, and our brute forcer is now complete. So hope you enjoyed this video, and I hope I see you in the next one, where we will actually start coding some of the FTP attacks. So hope you enjoyed this, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back to the next lecture. And right now, let us start off by a simple FTP attack. So we in the previous videos coded some of the SSH tools, such as the brute forcer for the SSH. We managed to attack the target with our simple passwords.txt file, and we managed to find the correct password. Right now what we want to do is try to code something similar for the FTP. So we know that our metasploitable is running FTP port open, so if I just run nmap of our metasploitable, which is now 192.168.1.6, not 16, 6, and I run this, you can see that it has the port 21 TCP open. FTP open. So this is a really common port to be open on many servers. Now, one of the main vulnerabilities right here is that this is not really secured, which I will show in some of the next lectures. By secured, I mean these credentials for this. So if I FTP the target, FTP 192.168.1.6, apparently we do not have the FTP right here. Apt install FTP. Not really sure if this is possible, so we are installing FTP in order to perform the FTP connection to the target. What I was saying is that these credentials from the target, since we will have to specify the username and password for the FTP port, can easily be sniffed on a local network. So they are unencrypted, they go literally just in plain text, and you can pick them up if you are sniffing on the local area connection, which I will show you once we get to the section where we actually attack our local network with sniffing packets and sniffing passwords and so on. But for now, let us see how we can actually log in to the FTP with our FTP brute forcer. But before we code the FTP brute forcer, I want to show you a simple attack which is called FTP anonymous login. Now, some of these server admins allow other users to perform anonymous login in order to check some files. So we can easily write a simple program which will do the same. So we will try to anonymously connect with just non-existent username and password, and we will see if that will work. But first of all, let me see if right now, if I go and type the FTP, which I would do if my terminal worked. So let me just, oops, not here. I want to go to my Kali Linux machine, clear the screen, and try to FTP to my metasploitable machine, which is 192.168.1.6. We get the connected to this IP address. We get the version of FTP running, which is a vulnerable version. So I know that because of the there is in the Metasploit there is a module that actually exploits this. So you can check it out by yourself if you want to. For now on, it's just good to know that it is a vulnerable version. But not to this attack. I believe we will not be able to anonymously log in, but I just want to show you, since there are a lot of servers or administrator of servers that actually allow this to be used on their FTP. So right here we need to specify the name. I'm not really sure, I believe it is msfadmin. Please specify the password, msfadmin. And we can see login successful, remote system type is Unix, using binary mode to transfer files. So we know that the username and password for the metasploitable is msfadmin and msfadmin, but let's see that we don't really know that. We will try to brute force with a password list the same for the SSH. Just right now we will brute force the FTP port, so let us see how we can do that. In order to exit this, just type here exit. Now let us first of all nano our anonymous login ftp.py. So nano, let's call it anon login ftp.py. We want to start off with our user bin Python line, and all we have to do right now is to import a library which will allow us to perform the connection to FTP more easily, which is the library ftplib. So this is the name of the library. We can import it. I'm not really sure if it comes for Python 2 or Python 3. If it doesn't come for Python 3, we will pip3 install it, don't worry. And all we have to do right now is actually, let's first of all prompt the user for the host to actually attack, which will prompt with the enter the IP address. Whoops. So we'll prompt the user. And let's actually run a function anon login on our host. So this function doesn't exist, we will code it right now. This is our simple, you can call it a main function, even though it is outside any function, we will not put it anywhere. We will just code the anon login. So def anon login, and we will specify that the argument for that function is the host name, since we specify the host in the argument bracket. So host name, host name. And what we will try to do is actually just perform a simple connection to the FTP with some random username and password. So we will try to actually make an FTP variable to be ftplib.ftp of this host name. This is just the syntax for this library that we imported, and all we want to do is perform the login function that our FTP library allows us. So FTP login, in the function all we need to specify is the username and password, so we can just type here anonymous, and we can just type here anonymous as well. Doesn't really matter, we can specify anything we want since this is really random. And all we want to type right here is print if this manages to actually execute and we manage to log in with these credentials, which we probably won't since I don't think Metasploitable is actually allowing the anonymous FTP login, but we will see in just a second. Let us first of all print the, for example, plus string of our hostname, or actually our hostname is a string, so we don't need this string before that, so plus hostname. Let's make a space between this, and we want to plus FTP anonymous logon succeeded. So we put a dot right here, we close this, and we want to FTP quit in order to exit the FTP connection, and we will return true, as this did work. So if this works, we will get this printed out and we will know that the anonymous login is enabled on the target system. If it doesn't, however, we will just expect any error, so we can just do exception comma E, which stands for basically any error that occurs during this connection try. We want to just print, oops, let's use the double quotes since we use the double quotes in the upper part, plus hostname plus FTP anonymous logon failed. So this is basically the entire program. As we can see right here, what we are doing is just trying to connect to the target with some random credentials. If that manages to actually work, we will print that anonymous login succeeded. If it doesn't and we get some error, we will print that it failed. So let us see how this will work. If we save this program, Ctrl X to exit, we chmod it in order to make it executable. Let's run it right now, and let's see, enter the IP address 192.168.1.6. We let this run, so it says FTP anonymous logon failed. So we can see that the Metasploitable target doesn't have the anonymous logging option available. So that is good for every server, since there are a bunch of other attacks that can open up if this is actually available on some server over FTP. But trust me, there are a lot of servers that actually allow this for some reason. Let me just fix this since here we don't have a space. Let's specify space right here. So FTP or anon login FTP. Let's specify just a space right here, and that will be about it. So this is our anonymous login program, which works, I believe. Now all we have to do is test it on some of the... Now all you have to do is actually do multiple tests, multiple attacks on FTP servers, and you will manage to find sometime a server that actually allows this, which can potentially allow you to proceed with the further attacks. But from now on, in the next video, we will code a much more common attack, or something that we can do on any FTP server, which is basically to brute force the credentials in order to log in over FTP with the correct credentials. So we will do that in the next video. Hope you enjoyed this one, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to this tutorial where we will code our FTP brute forcer. So let us first of all think what we need to do in order to do that. Now it is very simple. It is very similar to the SSH brute forcer. All we need to do is specify a list of passwords, or basically our password list file, which we will use the same one as we used in the SSH brute forcer. So we'll use this same passwords.txt file. So if you don't have it, make sure to create it. Let me just nano it so you can see which passwords are here. So we have some random passwords, which is, for example, admin123, password, and so on, and the correct password, which is msfadmin. Now then all we want to do is use the FTP lib library in order to perform the connection with a certain username and a certain password. Now in order to make this even better, we can try to actually brute force with both of the usernames and both of the passwords. Now what I mean by that is we will not prompt the user to actually specify a username or password for that account, for that FTP account. we will actually make a passwords.txt file which will contain both users and both passwords, separated by 2 dots. Now this is a very common password file, so you can find a bunch of password lists like this online that contain both user and password separated by 2 dots. It looks something like this, so admin 2 dots administrator, then we can use some numbers, we can add right here password, we can add right here root password. Here we will add root as well as msfadmin, and after that we will add msfadmin, which is the correct username and the correct password, and here we will have world, hello world. Now let me explain this once again. This is the username and this is the password. This is how we will actually import the file, and we will watch the first part. What we will do is, first of all, we will read the first line of the file, which will be all of this. Then we will split that line where the 2 dots are, and then we'll use the left side of that line as a username and the right side of the line as a password. So that is the basic idea behind our brute forcer. So let us save this password file. Let us nano ftp brute.py. First of all, use the user share or user bin Python line and import the ftp lib library. So this is all good. Right now, all we want to prompt the user for is the host IP address. So we can do that with simply just typing right here host equals, and then let's use raw underscore input, enter target's IP address. So we prompt the user for this, and this is everything that user needs to specify. Let's put it as a star, so we decorate it a little bit. And all we want to do right now, well, actually we need to prompt it for one more thing, which is the password list file. So they can actually specify that too. If they don't want to use the one right here, we can prompt that to actually specify the path to the passwords.txt file. So passwd file, let's call it like that, equals raw underscore input, enter passwords file. Or let's specify the username and passwords file, so user / password file and path. So they know that they need to specify the entire path. Since if that passwords.txt file is not in our current directory, they will need to specify a full path to that file in order for our program to be able to find it. So once we prompt the users this, all we want to do is run the brute login with the arguments as host and the passwd file. Now this brute login function doesn't really exist. We will code it right now. As I said, all we want to do is use the ftp lib to connect and to send the username and passwords, and we want to open the password file and read lines and split the users by the 2 dots, so everything on the left will be users and everything on the right will be passwords. Now let's see how we can do that. First of all, let us make our brute login function. Let's call it the same, otherwise this will not work. It takes the input of a host name and it takes the input of a passwd file. So password file and the host name. We specify the 2 dots right here. And right now, first of all, let us actually open the file that we asked user for, so we can actually open it. Or we can just type here try to open it. So if the user specifies the wrong file, we will prompt them with the error that that file doesn't exist. So try to, let's make it pf. So this is the variable for our file. Let's open it with the argument passwd file, since that is the variable that we specified right here, and we also sent it to our root login function. And we want to open that file for reading. So let me just put here comma instead of the dot. We want to read from that file. So we try to open it, except print, we want to print file doesn't exist. So all we have to do after this is actually perform the same for loop that we did in our SSH brute force login. So all we want to do is for each line in our pf file.readlines, so for every line that we read from that file, we want to split it by the 2 dots. So the username, we can call it like this. The username will be everything as I said from the left side. So how we can do that? We can use line.split And in the brackets, we need to specify where we want to split it. And we want to split it by 2 dots, as we saw in the passwords.txt file. And in order to specify that the username should be everything on the left, we can just add in the square brackets 0 right here. This basically means that once the line is split, it will make a list of actually all the components that are in that line splitted by 2 dots. And the first component will be the component from the left, which is labeled as 0, since in Python, as we said, the counting starts from 0. The component on the right, which will be the second and the last component, will be the password, which will be labeled as 1. So we can do that with simply just typing right here, password equals line.split. Split, we want to split it by the same part, so we split it by the 2 dots. And we take the second argument, which is the everything on the right. So this is how it should be. And let us print that we are now trying to brute force with this username and password. So print let us use Python 3, since I'm not really sure how this will work with Python 2. So just change everything to be for Python 3. Not really sure how this path right here, since sometimes this split can either work or not depending on the Python. At least I had some problem before with it, but let us just make this a Python 3 program. So just remove the raw underscore input and just type your input as same as here, and all the print statements just put inside the brackets. So simple as that. And what we want to print right here is basically just trying, and then let's add the username plus let's split it by the slash, and let's add the password, so password. So what this will print is basically something like this, trying admin admin. So it should print something like this. So let us see what else we need to code. All we want to do is actually code the actual logging in right now, so we can try that. So try to log in. We will set the FTP variable to ftplib.ftp from our hostname, which is the host IP address, so hostname. And right now, our login variable will actually perform the login itself. So FTP login on the username and password. So we close the brackets right here. And in case this works, we want to print that we found the password. So print, we add plus, login succeeded with, and let's add the username plus slash plus password. We close the brackets, we add a space right here, so our program actually doesn't get the error. And we actually want to quit the FTP session right after this, so ftp.quit, we can do it with this. And all we want to do is return from our function, we want to return the username and the password, in case we actually want to use it for some future attacks. But right now, all we want to do is code a good function. So right now, all we are left to specify is actually what happens if it fails. So except, we only want to actually pass, since we don't want to waste the memory and the time for our program. We don't want to execute any code right after that. All we want to do is actually, let me just double check all of this. So we split the line, we print trying this, we perform the connection, and in case the login works, we print that login succeeded with this username and password. Actually, this right here we do not need, so let's just remove it for now on. Let's see right here. All we have to add right now is, in case everything right here finishes, we want to print, for example, if it doesn't find the password and it actually went through the entire list, we want to actually print right here, print. So let us add the double quotes, password not in list, so that we know that there is not password that actually can be used in order to log into the FTP in this passwords list. So let me just double check this once again, or let us just try to run it and see if it works. It probably won't. We will probably have to change some of the things. So let's first of all run it with Python 3, since that is the Python that we used in order to make it. We enter the target's IP address 192.168.1.6, and we press enter. Enter the user password file path. Right now, since our user pass file path is the actual same directory, we only need to do is to specify the name itself. And let's see, trying admin, password not in list. We can see that it didn't find the password. Password not in the list. But let me just see, why does it print this after every try? So let's see what we can do with that. As we can see, we have the same problem as in our SSH brute forcer, that we have the empty space right here. And another problem that we have is this line right here, which is printed out every time we actually try to brute force with a certain username and password. So let us nano ftp brute this line right here. We actually want to tab out. That is the reason we actually want to tab it one line out, since it is actually belonging. If we tab it in, it will belong to this for loop and it will print it every time. So we fix that just by tabbing it out. And in order to actually remove the new line, all we want to do is just type here dot strip from the new line character. Oops. So let me just find this. So here it is. So right now, if we run it once again, let's see what will happen right now. 192.168.1.6 passwords.txt. Trying an admin administrator, trying 123.123 admin. So let's see if it will manage to find it. Trying root password 123, trying root MSFadmin, so the next one. And we can see it actually did work. Login succeeded with MSFadmin. And we get the password not in list. So let us actually edit a little bit this more. So we don't want to actually prompt the users with this if we find the password, since this can be really confusing. If you actually use a big file and it actually manages to find the password, we don't actually want to prompt the users at the end that the password is not in list. So let us see how we can do that. We can do that by simply exiting the program right after we find the password. So let us see right now if it will work. So 192.168.1.6 passwords.txt. It will try to brute force, and right now let's see, it should actually quit the program right after we find the password. Now this is going a little bit slow, but better something than nothing. So here it is, but it still tries to actually go further on. Not really sure why. Let us see how this will work. So let me just check this out right here. Not really sure why this didn't work. Maybe if we actually instead return from the function, so let us return the username and password. So if we return, it shouldn't actually print anything afterwards. So let us try once again. Passwords.txt. Let's let this run. The next password should be the password for our account. And we can see right now, if we use the return, it actually returns from the function, so it doesn't actually continue doing it, and we actually get printed login succeeded with MSFadmin/MSFadmin. So we successfully coded our brute forcer. It does work. We can see that we can actually brute force the passwords with our passwords.txt. It separates the list of our passwords for the username and for the password. And that would be about it for this tutorial and for this attack on FTP. Hope you enjoyed it, and in the next section what we will do is we will actually try to code some of the tools used for password cracking. Now, for example, if you get a hashed password from anywhere, from a website, SQL database, from a target system, or basically anywhere else, we can see how we can actually run the attack in order to decrypt that password and in order to crack it. So that would be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to this section. And in this section what we will be doing is we will actually try to code our own tools in order to try to crack some of the passwords. Now what we will be doing is we will first of all try to see how we can actually make a simple string. For example, if a user inputs admin as a string, we will try to make a program that will output the hashed value of that string. Now we will use different types of hashes such as MD5, SHA-1, SHA-224, SHA-256, and so on. Now, before we do any of that, let's actually first of all make a directory for this section. So make directory password cracking. You can call it anything you want. Let me change the directory to there. And let us first of all make a simple program that will perform the hashing of different types of hashes. So in order to do that, let us first of all name it hasher.py. So we will nano that program and we will add our user bin Python into the beginning of that program. Now there is a library that we need to use in order to perform this, which is called the hashlib library. So we will import it. What this library does, oops, let me just spell it correctly, so hashlib. What this library does, it basically just allows us to perform the hashing itself with a few lines of code. So in order to do that, let's first of all add the hash value. So we will make a variable called hash value, which will basically be a simple word that the user will specify. So we will prompt the user. So let us do that with the input, which means that we will be running this with the Python 3. So input, and let us prompt the user to enter a string to hash. Okay, so what this will do, it will prompt the user, then they type any string, for example admin, and we will output to that user the admin hashed in different types of hashes. So let us see how we can do that. Let us make, first of all, let us try to output the MD5 types of hashings. Those are the most simple ones, and those will be easier to hash. They are the shortest ones as well from the ones that we will be doing. So let us make the hash object first of all. And we will call it hash object 1, since this will be just the first value of our string. So we need to make that object to have the MD5 hash, so hashlib.md5, since this is the one that we are going to use right now. And we want to actually add to that hash object the hash value that we prompted user to specify, so hash object 1 dot, and we want to update it with the hash value, which we will encode actually, so hash value dot encode. And what this will basically do is it will add this string to this hash object, which then we will actually turn into an MD5 hash with the hex digest function. So in order to use the function, all we want to do is print the hash object 1 dot hex digest. So this function will basically turn this string into the actual MD5 hash. So let us see how that will work. So if everything is coded correctly, we should be getting the MD5 hash out of our program. So Python 3. First of all, let's make it an executable. Python 3 hasher1.py. It prompts us for a string to hash, and let us type here admin. And you can see we get a bunch of random code and the bunch of random letters right here. In order to check if this really is an MD5 hash, we could just open our Firefox and we will just paste this hash into our Google in order to see if anything will pop up. Now if this really is the admin hash, the first thing that will pop up is that this hash is actually the MD5 hash for the word admin. So let us see how we can check that. So just go right here and just paste the hash and click enter. Once this loads, we will see what do we get prompted back. Hopefully it indeed is the admin password. And we can see decoded hash MD5, the same hash equals to the admin. So our program works correctly. But this is just the MD5 hash, so let us see how we can actually make multiple hash values from this same word. So we will add all of the hashed values. Let us first of all nano our program back. Let us create the hash object 2, and in this object we will just try to perform the SHA-1 hash. So hash object 2 equals hashlib.sha1. Now the process is the same for every type of hash, so hash object 2 equals, dot update. All we have to do is copy the same value right here, so hash value string.encode, and we just want to print the string turned into a SHA-1 hash, so hash object2.hexdigest, which is the function that you will most likely use every time you perform some of these programs that are passwords cracking wise. And all we want to do right now is actually save the program and see if it will work. So if we just type here admin once again, we see that we get two types of hashes. One is shorter, which is the MD5 hash, and the other one is the SHA-1 hash, which is a little bit longer. Now let's actually try to see every type of hash that we can actually make. So in order to do that, let us just copy this so we don't type it like 3 more times. We will just copy it, we'll paste it once again, and we will paste it once again, which should be enough. Now all we want to do is change these numbers. So first of all, this one should be number 3. Change here 3 as well, change here 3 as well, and instead of SHA-1, what we want to do is use, for example, 224, so SHA-224. Here we can use SHA-256, and we need to change this to 4, so hash object will be 4. Same here, but here we can use 512, which will be the longest hash. As you will see that this one will be the longest hashed value of this word that we specify right here. So let us change this to be all 5. And right now, if we save this, we close the program, we run our program and type here admin, you can see that we get actually different types of hashes that are all different, that each one is longer than the previous one. So this one is SHA-512, this one is SHA-256, this is MD5, this is SHA-1, and this is SHA-224. So, for example, you can actually realize that this is SHA-512 because it is the double time longer, it is twice as long as the SHA-256. So this is just some of the examples that how you can actually make a string to be a hash value. In the next videos, what we will do is actually try to crack some of these hash values and get a string out of them, which is the most useful part. I just wanted to show you how this works and what is the process behind of it so you can understand it a little bit better. For example, if you run this once again and use password, you will get a different types of hash for every version of the hash that we used. So we can see nothing really matches as before. That's because this is a different word, and we will try to use another program which we will actually try to get the SHA-1 hash out of that program to match with a certain string from the password list. So hope you enjoyed this introductory video to the password cracking, and I hope I see you in the next lecture where we will try to actually brute force a SHA-1 hash. So hope you enjoyed this, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back to this lecture. And right now what we will do, as I said in the previous lecture, we will try to make a program that will ask an input from a user for the SHA-1 hash, and what we will do then is we will use a password list in order to try to brute force that hashed value and in order to prompt the user back for the password that we found. But we will give a little twist to this, since we will actually use a password list that we get from the internet. So what we will do, we will use two libraries. One of them is the URL open library, the other one is the hashlib library, and we will actually try to read the passwords from the internet file. So from the file of passwords that is actually stored on some website. Now, for that file, what we will use is, first of all, we will use the some GitHub password list. So let me just find it. I will just type the 10 million password list, or 10,000 password list, doesn't even matter. I believe something will pop up. And all we want to do is actually click on the first GitHub link that we find and go to that password list.txt. We will not download it, we will read it from the internet. So click on the first link right here. Let's just wait for this to open, and we can see right here, this is the link that we will use in order to read the passwords from. As we can see right here, there are the passwords. Oops, let me just... So here they are right here, and we want to read each one of those. We want to hash it to SHA-1, and then we want to compare it to the inputted hash from the user to see if they match. If they do match, we will print that we found the password, and we will print the password in plain text. If they don't match, we will just skip and go to the next password. So let us see how we can do that. Let's leave this open, so I'll just tab it down so we can open it later on. From now on, what we want to do is just import some of the libraries. So let's first of all nano a file called sha1 hash.py. Let's make our standard first line to be user bin Python, and let's import from urllib.request. We want to import URL open, since this is the only function that we will use from this library. Now this is a library which allows us to perform the request to the internet pages, and in order for us to open the page from the GitHub where we found the 10,000 passwords, we will need this function called URL open. Now, next to that function, we will also need the hashlib function from the previous video, so let us just import the hashlib as well. So, first thing we want to do right now is actually ask for an input from the user for a SHA-1 hash. So we will call it just SHA-1 hash as a variable equals input. Since we are using Python 3, we will specify input and raw and not raw underscore input. We will just type it like this. So enter SHA-1 hash. Let's add value as well. So we will prompt this to the user, and right after we prompt that to the user, what we want to do is we want to use the function called URL open in order to open the URL from the website that we found on GitHub, from the password list that we found on GitHub. So in order to do that, we will specify that in a variable called password list, or in a list called password list. What we need to do is actually first of all make that a string. So since the URL open function will not really return the string, it will return the contents of that actual page. What we want to do is actually make that at the end to be a string. So let us just add the open brackets. And what we want to do is first of all copy the page itself. But you might notice that if you just specify this link, what it will do is it will get the contents of this entire page right here, which we don't really want. What we want is we want to actually get only the passwords from this page, and we can do that by going right here on raw and selecting this link right here. So you can see that the link is the same as before, just right here it added the raw dot. So if I go one directory back, you can see that the link is identical, just right here it doesn't have the raw dot and then GitHub. So let's add it, go to that link. We can see we will get into the, oops, so it does have something else besides that. Let me just see what. My internet is kind of slow right now, so that's why it is loading this long. Let me just go right here on raw. And there is probably something else missing, but what we want to do is just copy this link, which is from the raw page, where there are only passwords and nothing else. You want to copy that link, then you want to paste it between these brackets. But we actually, before we paste it, we need to use the URL open function. So use the URL open. Oops. Open another open and close brackets, add the single quotes, and between the single quotes, paste the link. So here we have the link. Let me just zoom it out so we can see the full thing, since this is too much zoomed in. So here it is. We have the link right here to our page, and all we want to do is actually use it as a .read. Since this we can actually interpret as a file, so what we want to do is actually read from it, and actually use the decodation, since the UTF is the well-known encoding for the websites. Let me just go right here and zoom this a little bit more out so you can see everything as well as I do. So here it is. Now the letters might be a little bit small, but don't worry, as soon as we start coding something else, I will make sure to zoom it in. And right now, this is the entire line that we need to specify in order to open this password list file that is on the GitHub page. So we paste the string, so everything in these brackets will be a string. We use the UTF encoding, and we read from the link that we specified between the brackets. So all we have to do right now is actually read from that link. So for every password in this password list, we need to first of all split it from the new line, since if I go back to my Firefox, you can see that all of these passwords are one beneath another, which means that all of these passwords actually have a new line, a character which is a /n, which in Python stands for the new line. So in order to do that, what we need to do is specify here for I, which will be our variable, over which we will iterate in the loop for I in passlist dot split, and we want to split the password list everywhere where we find the new line character, since that will mean that we will split it after each password. So we want to split it after the new line character, and for every password what we want to do is perform the hex digest function, which will actually make a SHA-1 hash from that string password. So we want to use a hash guess, which will be our guess of the password, equals hash lib.SHA-1. Since we are using the SHA-1 hash as we specified to the user, now you don't need to use the SHA-1, you can use MD5, SHA-512 of any type of hash you want. And we want to make sure that this type of hash is the bytes. Now, what this will do, since we are actually specifying the password list from the internet, we need to use the bytes function on our password, and we need to encode it with the UTF-8, which is the standard encoder on the website pages. Now, all we are left to do right now is specify the hex digest function, which will make the SHA-1 hash from our string. So hex digest, and right now our hash guess should have a SHA-1 hash from the certain password that we are iterating over. All we want to do is now check if this hash guess, so if hash guess is equal to SHA-1 hash, what we want to do is basically print the password basically in plain text. So we will just do it like this. The password is, and then let's add the string from our I variable. Now, maybe you are confused by the I variable, so I will just use password right here. I will change it right here to also be a password. So if hash guess equals, and we want the string of the password. So this should actually work, I believe. We will print this, and then we want to actually quit the program itself since we found the password, so we can quit. And we want to type here else, or else if, since I want to specify the, oh no, we can actually just use else, doesn't really matter. We can just type here print, use a minus, password, guess, and when we can concat the string from the password, so we can do something like this. And what we want to do is actually add the plus, so plus doesn't match. So let us make a space, does not match, trying next, and then 3 dots. So what we can do is something like this, and if it finishes everything right here, what we can do is just print password not in password list. So if this is coded correctly, which I'm having a little bit of second guessing about this line, but we will check it soon enough, we should have successfully actually try to guess the SHA-1 hash value or the string value of a SHA-1 hash with this password list right here. So let us save this. Let us save it. chmod +x SHA-1 hash.py. And let me just check the, for example, 5th password, which is, or let's use the baseball. So let's use the baseball, which is around 10th password from the beginning. We will copy it, and we will use our hasher to get the SHA-1 hash. So in order to check what the SHA-1 hash, first of all, is, let us see which one will it be from the beginning. So it will be the second one. So let us just use the hasher that we coded in the previous video. So hasher, enter string to hash, and we want to paste the baseball. We press enter, and this one right here should be the SHA-1 hash of the baseball. So let's copy it, copy the SHA-1 hash, and let us run our actual SHA-1 guesser, so SHA-1 hash.py. If hash guess equals okay, so this is a standard mistake I make. As always, you cannot have equal right here, you need to have double equal, so add another equal right here. Let us try once again. No module named URL lib. Okay, so we are missing L right here, so it has to be URL library.request, so URL lib, it has to have 2L, so make sure to specify that correctly as well. These are just some of the minor mistakes. Enter SHA-1 hash value, we paste it, we enter, we let this run, and we can see that it really fast found the correct answer. So password guessing does not match, it tried to guess all of these passwords, and the password is baseball, and then it quit the program. So what we need to fix right now is first of all this space right here, so we want password guess, and then to add a space, so we can see correct passwords, and we can also add the actual colorization of these statements right here. So let us go right here, SHA-1 hash.py. First of all, let me find the space that we need to add, so it is right here, just add space right here. And we can actually import the from term color, import colored. So what we will do is we will print the correct password as always in the green, so we will use colored, open another bracket, and then after this what we want to use is green, close bracket. Let me just see if this is enough. So okay, so these 3 brackets open, 3 brackets closed. We want to do the same right here, just we want to print this in the red, so colored, open brackets, password guess, string password does not match, trying next. We need to add the comma and then red, add another bracket, and this should be it. So if we save this and we run our program once again, SHA-1 hash value, we paste it right here, we can see it finishes relatively fast. Let's see how long it will take to actually guess the last password in this list. So let us scroll all the way down. And let's use the Brady. So we will see how long it will take for it to iterate over, I believe, 10,000 passwords to see how long it will take for it to find the SHA-1 hash. So in order to first of all get the SHA-1 hash, we need to run our hasher.py, but not with Python 2, we need to run it with Python 3. We paste the Brady right here, which is the string that is, or the password that is last in the passwords.txt file. And the SHA-1 hash will be the second one right here, since that is what we specified in our hasher program. And right now what we want to do is first of all run the SHA-1 hash.py. We enter this right here, we press enter, we can see it is brute forcing, and we can see that in under 1 second it finished all 10,000 passwords, and it found that the password is Brady. So this works really fast. It can guess up to 10 or 15,000 passwords per second, so this is really good. Of course, if you use a more complicated hash value, this will take a little bit longer, but don't worry, it will not be that noticeable to you. So we successfully coded our SHA-1 hash guesser. So we opened the file from the internet, we read from it, we hashed all of the passwords in that file, we compared to the hash value that the user specified, and then we actually printed if that hash value match. So that will be about it for this video. What we will do in the next one is we will actually try to perform the MD5 brute forcer, which is the hash type, which is the shortest one in our hasher.py program. It is the one that is shortest, so it will be the fastest thing to brute force, and you will see it in the next video. So hope you enjoyed this one, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial, where we will actually code a simple MD5 brute forcer. Now in the previous video we coded something that will guess the SHA-1 hash password, but right now let us code something that will guess the MD5 hash. But that's not all of the things that we will change. In the previous video we actually coded a program that will read the passwords from the internet, and right now let us actually code a simple program that will read the passwords from the file that we have in our own Kali Linux machine. So for example, in our own directory we have passwords.txt, and what we want to do is actually use that file in order to try to crack the MD5 hash. So first of all, let me clear the screen. We have our hasher and our SHA-1 hash.py. What we want to do is actually nano md5 brute.py, so let's call it like that. And we start off with our usual string, user bin python. So let us, at the start, import the term color, since we will be printing everything in color for better look. And we will also import the hash lib, which we need in order to turn the MD5 or the string into an MD5 hash. So first of all, what do we want to do? Well, the user of this program needs to specify the MD5 hash, so we want to actually prompt the user to specify it. So we will call that the pass hash, so let us call it like that, pass_hash, equals input, and there we want to actually prompt the user, enter MD5 hash value. So we prompt the user for that, and after this we also want to prompt the user for the actual password list that they want to use in order to crack that MD5 hash. So that password list can be anything, so we will just call it word list or password list, or doesn't even matter. So we want to press here or type here input, and we want to specify to user that they need to enter the path to the file name. So enter path to the password file. So this is the only thing that the user needs to specify in order to run this program. And right now, let us actually try to, let us code the program that will actually perform the action of brute forcing. So first of all, we want to try to open the file that the user specified. In case they actually mistyped it, we want to print that file doesn't exist. So pass file, let's call it like that, since we call this pass hash. This will be pass file equals open, and what we will try to open, we will try to open the word list for reading, as we only want to read the passwords. Now we will try that, and if that doesn't work, we can print this. For example, let me just add the double quotes, print no such file at that path. So at that path, let's add exclamation mark and close this, and we can actually put this in a function so it looks a little bit better. Def try open word list, and we need to tab all of this into that function. So tab it just once. Let's actually copy this to be after the actual function itself. So just copy the input values, put it below the actual function itself. Now let's go right here. And what we want to do right now is actually just try to change every single password from that file into an MD5 hash. But before we do that, what we want to do is actually call the try open on the word list, so it actually gets executed, except right here. And if that doesn't work, we also want to quit the program so it doesn't continue executing, because it will run into an error. And after this, what we want to do is actually loop over the password file for every word. So let us do that for every word in our word list, which makes sure that, let me just see right here, for every word. Now, since we opened the word list in our pass file, we need to specify the pass file. So for every word in pass_file, what we want to do is, first of all, print that we are trying to hash that word into an MD5, and then after that we will actually try to compare it to the actual hash value that the user specified to see if it matches. So print, we want to use colored. We want to specify, first of all, open brackets right here, then double quotes, trying. We want to add the word, and since that every word in our password file will have a new line character, we want to actually strip it from that new line character so we don't run into any problems. So strip the new line character, close the brackets, and we want to print that in red. So if I'm not mistaken, this should be good to go. Next thing we want to do is, since this is Python 3, we actually have to encode that word with the UTF-8. So in order to do that, we will just make a variable called encode word equals the word itself dot encode. This is the function that actually allows us to encode it before we actually make an MD5 hash out of it. So encode, and in brackets we need to specify which encoder we want to use. We want to encode it with the UTF-8. And all we want to do after that is actually make out of the encrypted word, or encoded, pardon me, not encrypted. We actually want to make the MD5 hash, which we can do with the same function that we used in the previous videos, which is hex digest. So let us call that function, or that variable, MD5. It will equal to the, well, let's not call it MD5 since it might actually cause some problem. Let us call it MD5 digest equals hashlib.md5, since that's the hash value that we are looking for. We want to strip the encrypted, or pardon me, not once again encrypted, encoded word from anything it might cause problem with, so strip it. and we want to actually use or add the function. First of all, let me just add hex digest right here, and then I will check if we need to add a certain bracket right here. So first of all, we use the MD5. On this encrypted word, we strip it from everything that is needed. We need to close another bracket right here, since the first open bracket and first closed bracket is the part of the strip, and the second closed bracket is the part of this. So first it will make the MD5 hash out of it, or it will make the actual object of MD5, and then it will hex digest it in order to make the MD5 hash. So this should work. We just added a function onto the end of another function, so let me just enter this, and all we want to do right now is if MD5 digest equals, so make sure to specify 2 times equals to our pass hash. If they are equal, that means that we found the password from the list, and then we will print the password in the plain text. We will print it in green, so print colored. Let's make it like this, so password found, and then we add the word itself, since word is in plain text. We do not want to add the MD5 digest, since we aren't really interested in sending the user back their hash. So plus word, whoops, and then we want to print that in green. So green, we close the single quotes, we close double brackets, and all we want to do is exit the program. So let us see if everything is correct. We read the word from the password file, we print that we are trying that current password, then we encode it with the UTF-8, then we make an MD5 hash out of that encoded word, then we compare the MD5 hash with the hash value that the user specified at the beginning of the program, and if they do match, that means that we found the correct password, so we will print the word in green, and then we will exit the program. Now in case that we don't find the password, we want to print at the end, so just print password not in list, and close this. So if I'm not mistaken, if we save this, this should actually work. So first of all, let us make a simple password file, nanopass.txt, let's call it like that. Let's add here admin, password, hello 123, 123 hello. We can add anything, so password 123, capital password, and then let's use, for example, something that will be our MD5 hash, which will be, for example, football. And then something once again, so admin 123. So we will save this, then we will encode, or not encode, we will hash the football string with our hasher program and get the MD5 out of it. So let us save this. We have it right here, so pass.txt. Let me just zoom this in. Then we will run our hasher, but before we run it, let's just see where is our MD5. So it is the first value that we will receive, that is the MD5. We run our hasher to get the MD5 hash out of football. Here it is. We will copy the MD5 hash. Oops, so copy the MD5 hash. Then what we want to do is run our MD5 brute. But let's first make it an executable. Then Python 3 MD5 brute. Enter MD5 hash value. We paste the hash value of the football word. We enter the path to the password file. Since the path.txt is in the same directory as our MD5 brute, all we need to do is specify the name of that file. And it says name path file is not defined. Now, I'm not really sure what that means. Also, path file is actually only the variable in the actual function, so we'll just add here global path_file. This should, I believe, fix the problem, because global variables are also allowed to be used outside of the function, but if you declare a variable inside of the function, it will not be recognized by the rest of the program that doesn't actually have anything to do with that function itself. So let us add global path file. Maybe this will fix the problem, maybe not. So path.txt. And it did fix the program, and we actually managed to find the correct password. As we can see, trying admin, trying password, none of this really worked. Then it tried football, and it said password found, football, and it quit the program. It didn't continue executing for any additional password, so that is good. we successfully coded an MD5 brute forcer, which can crack MD5 hashes. So now you can by yourself do or make the brute forcer for any other hash value. So just change the MD5 to be SHA-512 or SHA-256, whatever you want. And basically the principle behind those programs will be the same as in this one. So hope you enjoyed this tutorial. What I will do in the next one is I will show you a library that comes in Python, which is called the crypt library. Now it allows us to actually hash the passwords with a salt value. Now I will explain everything in the next video, but for now on that would be it. Hope you enjoyed it, and I hope I see you in the next lecture. Bye! Hello everybody and welcome back, and in this video I want to introduce you to a library that comes in Python which is called the crypt library. So let us see how we can actually import that library. First of all, open your Python 2 interpreter, since we will be using it in Python 2. Now you can also use it in Python 3 if you want to, but you might need to actually pip3 install crypt. So in order to import it in Python 2, all you have to do is actually just type import crypt. So it comes pre-installed. You will not have to install it for Python 2. Let me just check if it actually comes pre-installed in Python 3 as well, so we can actually try to import it there as well. And you can see that it actually does come in Python 3 as well. So let me first of all zoom this in so you can see it better. And what this allows us to do is actually make or to encrypt a password in plain text with a salt value. Now, a salt value allows us to actually encrypt the same word with the same crypt function, but to actually have a different value, hashed value, once it actually finishes the encryption. That's why it uses salt. So the same word will actually, with different salt, have a different encrypted value at the end of the process. So let me just show you. If we make a variable, for example, called word, and that word is just admin, for example, so we have a string attached to this variable, and that string says admin. Now let's use a value called crypt word. So this is a variable that we will use to store the crypted word or encrypted with the crypt function from our crypt library. All we have to do is just type crypt.crypt, and we can specify the word in the brackets separated by comma with the salt. Now the salt will be 2 letters that you specify between the double quotes. So let me just show you. If I just type here hx, for example, then finish it with double quotes and press enter, you will see that if I just type here print crypt word, you can see that we get something different from the word admin. But you might notice that it actually has the first 2 letters the same as our salt. So if we, for example, wanted to do it once again, so we want to use a crypt function, so crypt.crypt, and we want to use it on word, whoops, and right now what we want to use is a different salt, so let's use DL. For example, you can use any 2 letters you want, close the brackets, type here enter, and if we actually print the crypt word once again, you can see that the value is completely different from the value of the previous crypted word, which we actually encrypted the same word, which is just admin. So this is more advanced actual technique to encrypt the passwords, since allows or prevents hackers from actually being able to brute force the passwords once they're using salt. Since if they find the hash value of the value admin, they can actually have multiple hash values for that word, since the salt is applied to that process. Now what we will try to actually code is we'll actually try to code the brute forcer for the crypt library, or we will try to brute force a certain word which is encrypted with this crypt function right here. But in that process we will actually know the crypt value, since we can notice right here, or the salt value, since if we look right here, we know that the salt value will always be the first 2 letters from the word that is encrypted. So we can see that right here we use the hx as a salt for the encryption, and we can see that the encrypted value actually had first 2 letters to be hx. Now then we actually try to use the DL, and we can see that the encrypted value at the end had DL as first 2 letters. So this allows us, even when we see something like this, to know what the salt is of that encrypting process. So we know that the salt was the L. which then we can specify of our program that we know the salt, and we can encrypt every password from our password list with the same salt, and then we can actually try to compare it to this salt, to this hashed, encrypted value right here, and if they do match, we found our word in plain text. So let us see how we can actually do that. Let us close this right here. Let us nano cryptforce.py, that is how we will name it, since we are actually brute forcing a password that is encrypted with the crypt library. We add the user bin Python as usual, and we import our crypt library right here. Now, first of all, let us start by actually creating our main function right here, which this function, what it will do, it will actually prompt the user for the password file, and then basically that user will input the password file and we will read from the password file. But let's first of all, before we do that, create the password file itself. So save this, even though we didn't code anything, and let's remove the pass.txt from the previous video, since we will create a little bit different password file. We will create the password file that actually contains both usernames and passwords, just the passwords will be encrypted with the crypt library. So let us go to the Python interpreter, import crypt. For this demonstration, we will actually use our, let's say, basketball, since in the previous video we used football. So basketball is the word, and encrypted word will be crypt.crypt. We want to encrypt the word, and we want to use, for example, the salt, which is GH. So just specify it like this, print encrypted word, and this is our encrypted word basketball with salt GH. So let us copy this, we will put it in our password.txt file, nano pass.txt, so we will nano a new file, and here we can actually specify anything, so admin password. Now imagine all of these values are actually hashed with the salt from the crypt library, so admin password 123, admin, root tour, root passwords, root, and then we add the hashed value right here. Then we can add admin root, and so on and so on. So the point of our process is that once it reaches right here, it will notice that this is the GH, which stands for salt, and then it will try to encrypt the password basketball with the actual password list that we specified that contains words. So this is the first program that will actually use two different files in order to crack it. This is the file which actually contains the password that we want to crack, and the file that we will use from which we will be brute forcing, we will name something like dictionary.txt, and then we will actually encrypt every password from the dictionary with the same salt value and compare it with these values right here from these passwords. So let us save this. Let us nano a dictionary.txt, and here we can just type your password, root, admin, football, hello world, and then let's add basketball, and then admin once again, or admin 123. Now this is our dictionary. This is the file that we will use to brute force the password. So let us save this. We have these two files right here, dictionary.txt and pass.txt. Now let's make sure to not confuse ourselves with that. So basically I will explain it once again, but for now on, what we want to do is actually first of all open the password file, and by password file I mean the file that will actually contain the encrypted value, so we will call it pass file equals open, and then we will simply just open the pass.txt. We can open it for reading, or we can actually prompt the user to specify the file, so it doesn't even matter, since you can just type here raw input or whatever you want if you want to actually prompt the user for the actual password file. But for now, let's just use this right here, since we only have one password file. It doesn't really matter. This is just for the demonstration purposes. And what we want to do is for each line in this password file, so this is something that we are familiar with, we use it a lot, so for each line in passfile.readlines, since our pass.txt file is separated with usernames and passwords by the two dots, we first of all want to separate the username and we want to get the password from that. So if we can just do if this in line. So if this is found in line, what we want to do is we want to make a user variable to be line.split by the actual two dots, and we want to make the user to be the first part of that line, and the password will be the second part of that line. So let's call it crypt password actually, since we will pretend that all of those passwords are actually encrypted with the crypt library, even though only the one for the basketball is, but it doesn't even matter. This is just for demonstration. So line.split, we want to split it by two dots. We want to use the second part of that line, and we want to strip it from any, for example, spaces that are there, or from any new lines. This is something that we must always include, the new line, since this character, even though you can't see it once you open the password.txt file, it is there and it will present problem if you do not remove it. So for now on, let us just print the actual crypt pass in order to see if we successfully removed everything that is unnecessary in our file. So let's save this, but first of all we need to code the calling of the main function, and let's actually make this an executable. So cryptforce.py, chmode it, and then we need to run it. We will run it right here. Global name crypt pass is not defined, so print crypt pass. Let us see why is it not defined. Oh, it's not crypt pass. It's not crypt pass. It is crypt word. Pardon me. So crypt word. We'll print it right here, and this is good. So we got the passwords without the new line characters. So we get it right here. This is the value that we are looking for. This is what we want to actually decode to be a basketball. I believe that was the word that we are looking for. So all we have to do right now is first of all go back to our file. We want to remove the printing of the word since we don't really need to print it. Now we know that it is good. So what we want to print is, let us print cracking password for, and then add the username which we are cracking for. So the user variable is the first part of the line. So we will want to crack the password for that user, and then let us use a function called crackPass. That's what we will call it, and we will pass to that function our crypt word. Now this function doesn't exist, of course, so let us code it up here. So crackPass, we need to name it the same as in the code itself, so crackPass. Let's first of all make this a small letter, so not capital, and this crackPass will take the crypt word as an argument. So it will take the crypt word as an argument, and first thing we need to do, as I said before, we need to declare what is an actual salt in this password. So an actual salt is the first two letters of the crypt password, and the first two letters we can select like this. So salt will actually be the crypt word, and the crypt word from the first letter to the second letter. So this is how we can actually create the salt variable to actually contain the first two letters of our crypt word password. And all we want to do right now is open the dictionary file, which we can actually select as dictionary. I'm not really sure how we can spell it. Dictionary equals open, and then we will open our dictionary.txt for reading. So we opened our dictionary, and what we want to do for every word in this dictionary, we actually want to first of all strip it from the new line as always, and we want to crypt it with this salt right here and compare it to the actual value of the crypted password. So let us do that. So for every word, for word in dictionary, for word in dictionary dot readlines, first of all we want to make sure that the word equals word dot strip from the new line character, since we do not really want that. And right now what we want to do is actually crypt the word with the actual salt. And we can call that right now crypt pass, since we use the crypt word variable already, so our crypt pass will be equal to the crypt.crypt from the word from our dictionary with the salt. So salt we selected right here. So this should be good, and all we have to do right now is actually check if crypt word equals to crypt pass. So if our crypt word that we got from here, so this crypt word right here, from our pass.txt file, which is encrypted with the salt, if it equals to the crypt pass, and crypt pass is the variable of the password that we use from our dictionary with this salt, then we found the password. So we will just print found password, and we will add the word in plain text. So we do not want to add the crypt word, we want to add the crypt, just the word. So this should be good, I believe. And all we want to do from here is just return to the main function, since we successfully finished this function. And in case that doesn't happen, we want to print password not found. And then we also want to return back to the main function. So if I'm not mistaken, this should work. And right now, if we just save this, we have our dictionary.txt right here, pass.txt. And if I run the crypt force, let me just see, cracking password for admin, password not found, cracking password for admin, password not found, root, basketball. So we managed to actually find the password right here, which is not really that noticeable. So we will fix it with the term color right now. But let me just check something first of all. So, okay, so it is good. I was a little bit confused why it cracked 3 times for the admin and 3 times for the root. But then I realized that we actually specified the admin 3 times as the first username and the root 3 times as the first username. What I am concerned about is this password not found. So let us just see why that happened. Why did it say password not found? Let's actually return the word. Let me just check whether this will work. Okay, so that doesn't work. For some reason it prints out password not found, but we can fix this easily with the else, and then we want to print password not found. But no, this shouldn't actually be like that. So let me just think about it. We will iterate over every word in the dictionary, so we do not want to print it right here. Let's see what happens if I just run it like this. Cracking password for basketball, found password. Oh, I think I know what the problem is. I should have printed it right here. Let me just try it. Password not found. Let us try right now. I'm not really sure why does it. Oh, okay. So yeah, since we call this function multiple times down here, we do not want to specify it right here. We want to specify it, oops, right here. Think about this. If I quit right here and then print, oh no, let's actually return right here. I'm sorry for this, but sometimes even I get confused about these silly things. So let me just see where we can actually add it. Print, or not print right here, so password not found. This is really that big of a deal, but it is always good to have everything specified correctly, and we do not want it to have it like this. So what we want to do is actually type it right here, and let us run this once again. But we still do get password not found, even though it is not anymore printed after every username. So let us actually now fix the actual colorization, term color import colored, this password not found, we can actually, so we can do it like this, return true. If let's try it like here, if crack password, then pass, else print password not found. Now this is really not that. Let me just see, no module name term color. From term color import colored. Okay, it doesn't really matter at the moment. Let me just run this once again. Okay, so for some reason it doesn't even matter, so we'll just not print this password not found. Can't really think about it right now. It is not really that important. What is more important is that we actually specify the colorization so we can more easily notice the actual password if we find it. So colored, we want to print this in red. Make sure to always use this as a Python 3 since term color is in Python 3. Here we want to just return, and here we want to print this in green. So we will print this in green. We close the double brackets right here, then we unhash this statement right here. Let me just save this right now, and right now if I Python 3 this, name y is not defined. What? Oh, so here I specified by an accident y, so let us just see it right now. Okay, so we do find the password, so it is basketball with our encrypted value. So let me just cat the pass.txt. We can see that this value right here is equal to basketball, which is actually correct since we specified that at the beginning of the video. So that would be about it for the password cracking section. We didn't manage to actually fix this, which is basically just continuing to crack even after finding the password, but it doesn't really matter. It isn't that important. Maybe later on I will actually try to fix it and show you how I did it. But what is more important, that in the next section we will actually start off by actually attacking or coding some of the attacks in our local area network. So we will try to code the rspoofer, the packet sniffers, the FTP credential sniffers, and a bunch of other programs as well. So hope you enjoyed this password cracking section, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and in this section, as I said, what we will be doing is we will be coding our own spoofers, sniffers, DNS sniffing, packet sniffers, basically FTP credential sniffers, MAC changers, and so on. Now, the first thing that we will start with is the actual MAC changer, since that is one of the most simple things we can code from now on. What it allows you to do is actually change your MAC address, which then potentially can be used to bypass some of other security measures that the target might have. For example, if you want to actually connect to the certain Wi-Fi, and that certain Wi-Fi either uses, for example, a whitelist or a blacklist, you can then use a program to change your MAC address in order to bypass either the blacklist or the whitelist. If your MAC address is, for example, blacklisted from a certain wireless point, or basically anywhere else, you can bypass that with just changing your MAC address to a different MAC address, and then you will be able to connect. Now, if there is a certain whitelist on the target running, for example, they only allow a certain type of MAC addresses, you can then, for example, run a deauthentication attack on the wireless, or change your MAC address to the MAC address of the client that was connected to the target wireless, and then proceed to actually enter the wireless hotspot. So there are a bunch of other things you can also do with the MAC changer, but for now on, let us see how we can code it. Now, in Kali Linux, there already comes a program that can do it for you. So for example, if you just type MAC changer, you can see that it will actually print you the usage of the program itself. So MAC changer, let us see -- help, what it has as an options. It has the help option. The most important options are right here, which is the permanent. So reset to original permanent hardware MAC address. Now this is your official MAC address that you actually get. It is hardwired into your device. And basically, this is the MAC address that you will actually have once you buy, for example, a new laptop or a new PC or something like that. Now, we have an option to actually set a fully random MAC address. What this will do is, for example, let me just show you. So MAC changer, print the MAC address and exit. Let us see my current MAC address. So minus show. Not really sure why this option doesn't really work. So MAC changer help does work. Minus P, minus S. Not sure why doesn't it work, but it doesn't really matter. What we can do is we can actually set a fully random MAC address with the -R command. So just run -R. Oh, so yeah, of course, in order for you to actually run this command, you need to specify your interface, so your networking interface. Now, in order for you to check your networking interface, you need to just type ifconfig in your terminal, and you will see your bunch of networking interface if you have multiple connected, such as some wireless networking interface, some cable networking interface, the loopback interface, which we are really not interested in at the moment. So what we are interested in is this interface right here, which you most likely all have, or not most likely, you must all have if you're running Kali Linux, since it is by default the name of the interface for the Kali Linux. Now, you might also have some different name interface, such as VLAN 0 for the wireless interface. You can check that one out as well, but for now on, in order for you to check the MAC address of this interface, you can just copy the name and run the MAC changer, and first of all, show the MAC address, and then for that interface. So you just type here -- show, and then the name of the interface itself. And you can see that the current MAC is this MAC address for my interface, or for my Kali Linux machine at the moment. And my permanent MAC address is the same MAC address, since we didn't really change it yet. So make sure that at the end of every command you specify the name of your interface, otherwise this won't work. In order for me to actually change my MAC address, I will use the option -R. And then I will also add my ETH0 interface, which I'm currently connected on the internet with, and run this once again. And we can see right now that the current MAC was this one, and the new MAC address which this program gave me is this one right here. It is fully random, but if we wanted to, we can actually specify the MAC address that we want. So it is best used once you encounter a whitelist on a target. You can specify any MAC address you want. So let us see how we can do that. Let's run the MAC changer --help. So we can specify it with -m, and then -mac equals this. So we will use -mac equals, and then we will specify some random IP address, or pardon me, MAC address. So let us do that. -mac equals, and then we can specify 223344556677. Make sure to separate all of these digits by the double dots. So right here, they are all separated. So 2 digits, then 2 dots, 2 digits, and 2 dots. That is the syntax for the MAC address. And at the end, we need to add the name of our actual interface, networking interface. And we can see that the current MAC, which was the MAC that we changed previously, is now changed to the 223344556677, which we specified in our command. And this is basically how MAC changer works. But this is not a program that we coded, so what we want to do is actually code something similar to this. It can be either rather simple, or if you want, there are 2 ways to do this. We can do one way with the actual MAC changer, which will just take a few lines to code, and we can do another way, because there is a way to change the MAC address with the Linux commands themselves. Let me just show you how you can do that. So you can do that. First of all, you need to put your interface down. So in order to put your interface down, you need to type here ifconfig ETH0 down. Once you press enter, if you just type here ifconfig once again, you can see I no longer have the ETH0 networking interface specified right here, since I put it down. And then once you put it down, you can change the MAC address with this command. So ifconfig, then the interface, which is ETH0. Then you need to specify HW for the hardware, and then the ether, since we are changing the Ethernet interface. We want to specify after that the new MAC address, which will be 334455667788. Cannot assign requested address. Okay, so it doesn't really matter. Let's just do AA BB. CCDDEEFF. And we changed our MAC address to be AABBCCDDEENFF. if we check our MAC address with the actual MAC changer, we can see that our current MAC address is AABBCCDDEEFF. And all you have to do after that is actually put your interface back up with the ETH0, ifconfig ETH0 up. And if you just type ifconfig once again, you're good to go. You can see that your ETH0 is back once again, and you have it up and running. Your Ethernet MAC address, here it is specified, it is new one, and it is the one that we changed to. So those are the two ways that you can change the MAC address. The second one was over the Linux commands, and the first one was over MAC changer in Kali Linux. So we will start coding our MAC changer in the next tutorial. Hope you enjoyed this little demonstration, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back to the tutorial where we will actually code a simple MAC changer for our Kali Linux machine. So let us get started. First of all, what we need to do is get out of the password cracking section and make a directory where we will actually make basically something like, let's call it, for example, our local network programs. Not really sure how I can call it differently, because all of these attacks, or not attacks, all of these programs that we'll be coding will be applied to the local network. Since, for example, if you want to run a packet sniffer, you will be running it on your local network against the machines that are under the same IP address range and under the same router and the same network as you are. So let us change our directory to there. I really am not that good with the directory names, but it doesn't really matter. So let's nano MAC changer. MAC change, let's call it macchanger.py so we don't confuse it with the actual MAC changer. And let's add the user bin Python. Let me just, since my connection is failing, let me just service network manager restart. Well, you don't need to do this, don't worry. There is just some problem with my network at the moment, but it doesn't matter. Now, what we will be using right now is a library called subprocess. Now what that library allows us to do is actually to execute system commands and check out their output in order to actually see whether we got the correct MAC address changed or not. So what we can do is actually, first of all, import it. So import subprocess, this is how you specify it. And let's get to the main function, def main, which as always doesn't take any arguments. And what we want to do right now is, before we actually change the MAC address itself, we want to make sure, or not make sure, we want to actually check out what the interfaces we have, or what the interfaces the user of this program has specified. So for example, if a user specifies ETH0, then we want to use the ETH0 in order to change the MAC address on that interface. So let's actually prompt the user with the interface. Matter interface equals, and what we will do is we will actually input, so we want to prompt the user to enter interface to change MAC address on. So then they would enter, for example, ETH0, and then we will use ETH0 to change the MAC address on that interface. So that is one thing that we want to specify. The next thing we want to specify is the MAC address that the user wants to change to. So the new _MAC _address can be equal to the input. Connection failed, okay. Just disconnect for now on, doesn't even matter at the moment. So new MAC address, interface, input. We want to prompt the user with that. So we just add here a star instead of a plus, since a plus is when we actually manage to do something. Enter MAC address to change to. So this is the MAC address that they want the to change to. So we get two variables. One of them is the interface and the other one is the new MAC address. So right now what we want to actually do is check the output of the ifconfig command on a certain interface, since the MAC address is specified in the actual output of the ifconfig. So let me just show you. If I save this and run ifconfig, you can see that the MAC address is specified in this command. So what we can actually do is run the ifconfig from our program, check out the output of this command, then change the MAC address, then check out the output of this command once again. And if they are different, that means that we successfully changed the MAC address. and then we will print MAC address changed into the desired MAC address. So let us see how we can do that. MAC change. We added two variables, and right now what we want to do is first of all check the output of the ifconfig command. So first of all, let us do that and place it in a variable x. So just call it simply x subprocess, or we can actually call it, so you don't get confused, we can call it before change. So subprocess dot check underscore output. This is the function that we will use in order to check the output of the actual command that we will be running, which is ifconfig plus interface, but let's add a space right here. So interface is the interface that we specify, and this is the command that we are going to run, ifconfig eth0. So if you run ifconfig eth0, as you can see, you only get the data for the eth0 interface as well as the MAC address in that data. So let us see right now. We check the output, we store it in a variable before change. Then what we want to do is actually change the MAC address, and we will make a function for that. So let's call it change underscore MAC underscore address. We want to specify to that function the interface that the user specified and the new MAC address that they want to change to. So let us first of all code that function right here, def change underscore MAC underscore address. We pass their interface and MAC, so we'll just use it like this. Let's leave it like this. We place the two dots, and all we want to do is just run three commands which we ran in the previous video, which are the actual Linux commands. So ifconfig, and then put the interface down, then use the command to change the MAC address, and then put the interface back up. So in order to do that, we can use the subprocess library and use the function called call. So subprocess.call. This function right here will execute the command in the brackets. It is similar to this function right here, which will execute the command in the brackets and also store the output to some variable. It will check the output as it says, and this will just actually call this function or call this command, and it will execute it. So we want ifconfig with space plus interface and plus actually putting it down. So make sure to add spaces right here, so otherwise this will not work. Let's close the square brackets and close the normal brackets. Then what we want to do is call the subprocess.call. Then we want to actually use this command ifconfig space, then close double quotes, plus interface, so on our interface, plus the double quotes open, then space HW for the hardware, then space, then another double quotes, and then plus open double quotes ether, then space, then close double quotes, and then plus the MAC address. So if I'm not mistaken, this should be similar to something like this: ifconfig eth0 HW ether, and then for example AA BBCC BBEEFF. So this is the command that we want to actually run. So let us see if everything is good. Everything should be good. So we close the square brackets, we close the normal brackets, and all we want to do is actually call the same thing right here, just to put it up, to put our interface up. So we paste this, and all we have to do is change this from down to up. And this is the entire function of the changing the MAC address. So all we want to do is actually call it right here, which we did. We called it on the interface that the user specified, and we called it on the MAC address that the user specified. And all we want to do right now is add a variable which will be after change equals subprocess dot check underscore output. So same thing as right here, just this we ran before the changing of MAC address, and this we ran after changing of MAC address. So open square brackets, ifconfig plus interface, close square brackets and close the normal brackets. Here I made a typo, so here we have to actually close the square brackets first and then the normal brackets. And then after this, all we want to do is actually compare these two. So if before change equals to after change, so if these two variables are equal, we will print, we can print basically something like failed to change MAC address to, and then we can add the MAC address that user specifies, so new MAC address, and we close the brackets. And then else if these two variables are not equal, that means that we successfully changed the MAC address, we want to print MAC address changed to, and then we add the new MAC address, and then we add another on interface, and then we can plus the interface. Hopefully this is all good. So let us try to actually run this after we call the main function down here. So we call it right here, then we save this program, save it like this, and if everything is good, this should actually work. If we close this, we make it an executable, MAC change. We run the ifconfig eth0 in order to check what the current MAC address is. So let's try to actually reverse this MAC address with our program. So MAC change, enter interface to change MAC on, eth0. eth0 is not defined. So let us see, input and eth0 is not defined. Okay, so that could be because of the actual 0 in the interface. So let me just type here string from the input. Maybe that is causing the problem. So let us just check once again. eth0 is not defined once again. Oh, so we are running it with Python 2. We need to run it with Python 3. So let us do it once again. Subprocess.call. Inconsistent use of tabs and spaces in the indentation. So we are getting some of the errors, which is good. So we will just actually fix them. Let me just see where the error is. Subprocess.call ifconfig plus interface plus up. So it is somewhere around here. Not really sure what the actual error is, but this function right here also has a different type of specification, so we don't need to specify it like this. We can specify the command also like this. So ifconfig, then close this, then comma, and then the interface. Then we can do it like this, so delete the empty space and then comma up. I believe this will work as well. We can do the same right here, so delete the pluses, delete the empty spaces in the strings, add comma, delete plus, add comma, delete empty space, comma, delete plus, delete empty space, delete plus, and add comma. So I believe this will work as well. Then let us delete this here as well. And this should work as well, but also we need to change it here if that is creating the problem. Not really sure why it's creating the problem. Maybe it is some syntax. So just delete the pluses, empty spaces, and add a comma. And right now we should be good to go. So let me just check this out. Python 3. Inconsistent use of tabs and spaces in indentation. So inconsistent use. Okay, so here it is. Instead of the tab, I pressed spaces, so what I need to do is actually tab it, and right now it should work. Now it will probably work even before. I just thought the error was in the syntax, so that's there. eth0 right here, enter MAC address to change to, so we can just use ff, ee, dd, cc, bb, aa. So abcc, aa, bb, cc, dd, ee, ff. We press here enter, and here we get the successful message. So MAC address changed to this MAC address on interface eth0. Now we can check that out just by typing ifconfig eth0, and even though it does say that, we didn't manage to actually change it. Not really sure why. Cannot assign requested address, so we cannot assign that address. Now some addresses cannot be assigned, not really sure why, so let us try it once again. So the the MAC address is this currently, and if we run the program once again, eth0, the 223344556677, MAC address changed to this on interface eth0, so let's check it if it really did change right now. and right now we successfully changed the MAC address. So our program works. We managed to change the MAC address to 223344556. Now let's just add a little bit of actually cleaning up our code, and by that I mean actually fixing some of the print statements. Print MAC address change to new MAC address. On interface, let's add the 2 dots right here. Let's also print this in colored so we know when it's managed, so it looks prettier. It looks prettier if printed in green. Add the comma, add green, close another bracket. Here we can add comma, add red, close another bracket. We can print colored here as well. So when it fails, it will be red. Open bracket right here, and import the from term color, import colored. Save this, see if it works. Python change, ETH0. We know what our current MAC address is, so we'll change it to AABBCCDDEEFF. We press enter and we get MAC address changed to this. If we check it out, we successfully changed the MAC address and our program does indeed work. So that will be about it for this tutorial. We coded our own MAC changer, and we will continue coding in the next lecture. So hope I see you there, and take care. Bye. Hello everybody, and welcome back. And in this tutorial we'll talk about the ARP spoofing. So since we are going to code in the next tutorial the ARP spoofer, which is basically used in order to intercept, it is the base of intercepting the connection between 2 different users on the same network. So for example, as I have a picture right here, let's say this is our Kali Linux machine, which is the MIT-M connection. Now there are a bunch of tools that actually perform the ARP spoofing, but what we will be doing is we'll be coding our own tool. So the basics behind of this is that there is a packet called the ARP packet, which allows the users on the network, and by the users I mean the machines, to identify one another. So there are 2 types of the ARP packets. One of them is the request packet, and one of them is the response packet. So in the request packet, some machine asks for the MAC address of a certain IP address. So for example, let's say this machine right here, let's call it machine R, which stands for router. We are A, which stands for the attacker. And this machine right here will be W, or pardon me, just V, which stands for victim. Or I could just do T for the target, but it doesn't even matter. For example, let's say this machine V, which is victim, asks for the MAC address of the router. So what this will do is it will send out the request saying something like this. So basically, what's the MAC address of the 192.168.1.1? For example, let's assume that this is the IP address of the actual router. Let me just write it right here. And what the victim machine will do is it will ask for the MAC address of this router. Now, it will send out the request, and any machine that actually knows what the MAC address of this IP address right here is, which is the MAC address of the router, will send back the reply saying the MAC address of the 192.168.1.1 is at this MAC address. Then the victim PC will update its ARP tables with the MAC address of the router's IP. But what happens when we actually perform the ARP spoofing? Well, what does happen is in the normal connection, as you can see right here on the green line, the communication goes between the victim and the router in a straight line, because they are both identified correctly, and the router knows the MAC address of the victim and the victim knows the right MAC address of the router. But if we run our ARP spoofing attack, we can actually spoof both the victim and the router into thinking that we are one another. So for the victim, for example, we would send the packets that would say that we are the router, and to the router, we would send the packets that would say we are the victim. So let me just draw it like this. And then, instead of the victim sending packets directly to the router, they would send packets to us, which we would then forward to the router. And then the router would perform forwarding further on, and then when they receive packets back which are meant for the victim, they would send those packets back to us. And that makes us to be a man in the middle by interfering their connection. Now we can do that for every PC on the local area network, so we can actually sniff some of the passwords that are, for example, not encrypted and that are going through our own Kali Linux machine. For the first time, all we will be doing is just running a simple ARP spoofer. We will use the escape library in Python, which is a famous library for the actually configuring packets, sending packets, and a bunch of the networking things we will be doing in that library. But for now on, in the next lecture, only thing we will do is just make a simple ARP spoofer. So this is just a little theory behind it, and I hope you understood it. If you didn't, don't worry, you can just post a question and I'll be more than happy to answer it. But this is rather simple. As it says right here, we are basically just a man in the middle interfering both of these people's connections. So that would be about it for this theory video. We will code the ARP spoofer in the next one, and then after that we will code some packet sniffers which will allow us to actually sniff some passwords that are going through from the victim PC router. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and in this tutorial we are going to look at a library in Python which is called Scapy. Now what Scapy allows us to do is actually configure our own packets and send them by our own needs. So we can send the packets, wait for a response back, we can print the response, we can do a bunch of other things, so we can basically manipulate with the packets that we actually send to the target. Now this helps us to understand better our ARP spoofer that we are going to code. So first of all, what we want to do is actually just check how the ARP packet is constructed to see its available fields and to actually change some of the fields and see what we can do with the ARP packet. But before we do any of that, I just want to introduce you to a certain command that you can run in both command prompt on Windows and in terminal in Linux. If you just type R -A, you get the ARP tables of this certain machine. As we can see, the ARP table is basically a table consisted of the IP addresses and the MAC addresses. Now what this allows our machines to do is to actually communicate with one another, since now my machine knows that the IP address of 192.168.1.1 is affiliated with this MAC address right here. So once it wants to communicate with the 192.168.1.1, it basically communicates with this MAC address. What ARP request allows us to do, which we'll code just in a second, is it allows us to get the MAC address of a certain IP just by sending the ARP request. Then someone sends the ARP reply back and we get the MAC address of our target. So let's see how we can do that. Scapy, as I said, is a library by itself. We can just run Scapy instead of Python, and in order to do that you just type Scapy, and this should open the Scapy interpreter, which allows us to construct our own packets. So we can see it has opened. It looks similar to the actual Python interpreter, and here syntax is a little bit different. You can do a bunch of other stuff you can do in Python, but most of the stuff you can actually do. So first thing we want to do is see what actual fields does the ARP request have, or basically ARP packet. It doesn't have to be request, it can be reply also. And in order for us to actually do that, we need to type just ls, and in the brackets ARP, type ARP, close the brackets, and it will print out the available fields that the ARP packet has. As we can see, the P destination is the IP field of a target we want to actually get the MAC address from. The hardware destination is the MAC field of the target, which the hardware address or MAC address we want to get. The P source and hardware source is basically our IP field and MAC field. The OP is basically the type of packet we want to send. The 1 stands for the request and the 2 stands for the reply. So you can send this OP value to be either 1 if you want to send an ARP request, or 2 if you wanted to send the ARP reply. So let's see how we can actually construct a packet in order to get the same MAC address from this command from our router. So the IP address of router is 192.168.1.1, and we want to get the IP address or the MAC address of that router. Let's pretend we do not know it. So in order to do that, what we can do is first of all create a broadcast packet. So in order to do that, you just need to press equal ether, and in that broadcast packet, since we will concat it to the ARP packet, we want to select that we are actually sending this packet to the broadcast MAC address. Now what the broadcast MAC address is the MAC address where actually every machine on our local area network will receive this packet, and if some machine knows the answer to our question, it will respond back. In order to select to a broadcast MAC address, we need to select the DST field right here to be equal to this MAC address. So just select it like this, equals to FF, and once again FF. This is the MAC address of the broadcast, this is the broadcast MAC address which we are going to send the packet to. So just click enter right here. And since we created the broadcast packet, all we want to do right now is also create the ARP packet. So in order to do that, you just make ARP packet, for example. Let's call the packet like that. We set it to be equal to the ARP. So just type capital ARP, open and close the brackets. And let's say we want to actually set the, let's actually see what we want to set in this ARP packet. So we want to set the P destination field to be the IP address of our router, since it's the router's MAC address we are looking for. So in order to do that, you just need to select this field right here, copy the name of it, paste it right here, and type equals. And there you can actually set it to be the 192.168.1.1, which is the IP address of our router. Press here enter, and you successfully constructed the ARP packet, which has this value under the field of P destination. In order to check it, you can just type ARP packet.show with open and close brackets, and there you will have all the things that this ARP packet has specified. Now, as you can see, some of these things are specified by default, such as the HW source and the P source, which is our MAC and IP address, which basically is set by default, since the escapee can recognize what our IP address is and can see what our MAC address is. Now, if this for some reason doesn't specify for itself, you can check both of your MAC and IP address by just typing ifconfig in your terminal. As we can see, my IP address is 192.168.1.7, which is selected under the P source field. My MAC address is this MAC address, which is selected under the hardware source field. So let me just, in case you are not seeing this very well, let me just zoom it like this. Then I will move this a little bit to the side, just like this. Move this all the way down. Just make it a little bit prettier. Okay, so it's good right now. And we can see that all we actually have to do right now is concat these two packets. Since we are looking for the actual MAC address of the router, we want to send our request to the broadcast MAC address so all PCs or all machines on the network can receive it. In order to make these two packets into one packet, we can just do the final packet. So let's call it final packet equals, and all we have to do is just make a simple statement that looks like a division in Python. So broadcast and then the /ARP packet. So we created our final packet, which we are going to send right now. So in order to check the fields of your final packet, you can just type final packet.show, same as the ARP packet. And you can see that our final packet has the Ethernet field, and under the Ethernet field, it has the ARP field right here. This source is our MAC address. This destination is the MAC address of the actual broadcast. And this right here, the type, is the type of packet that we have under our final packet, which is the ARP packet. So 0x86 basically, or pardon me, 806 stands for the ARP packet. So all we have to do right now is send this packet to the target, or basically to the broadcast MAC address, and wait for a reply back, which then we will store in a certain variable which we can print afterwards. So let us call that variable answer, since the answer is what we are looking for after sending this packet. And in order to send it, we can just type srp, and in the brackets we need to specify which packet are we going to send. So we are sending, of course, the final packet, since that is the packet that actually consists of both the Ethernet and ARP field. We can set the timeout to be equal to 2 seconds. And we can set the verbose to be equal to true. So we can see what actual, oops, let me just check this out. What actual things is this performing? Since this answer will actually return a list, and the list consists of the answered and unanswered, basically, responses, we want to select only answered, so we will select the first list, which will be under the value 0. So click here enter. As we can see, finished sending 1 packet, received 1 packet, got 1 answers, remaining 0 packets. So someone sent our answer back. In order to print that answer, we can just use the actual, let me just show you, we can store it in the variable, which we can call MAC address, which will be the MAC address of our target, which we want to get under this field, which is the hardware destination. And all we want to do is select the answer, or let me, before I do that, just show you, if I just type here answer, you can see that the results is under the other. So what we want to do is select a certain, let me just show you, if you just type MAC address equals and then answer, we take the first argument and the second argument of that list, and the field that we want to actually get is the HWDST. which is the hardware destination. So all we have to do is press dot afterwards and type HWDST. So just press here enter, and now our MAC address is stored in the MAC address variable. So we can just print MAC_address, and you can see that right now we got the MAC address of, let me just check this out. Why did we get our own MAC address? That is a really good question. Well, for some reason, maybe I selected something wrong, but for some reason, oh, pardon me, we are not looking for the actual, or we are actually looking for the hardware destination. And what did I actually select right here? Let me just double check everything in order to see if I selected it correctly. Let's print the MAC address. Okay, so hardware source. Of course, I was confused a little bit because I selected right here the hardware destination as to the actual field where the router's MAC address will be, but the hardware destination is actually our own MAC address. And now you might be asking, why is that, since here it is the hardware source, which is our own MAC address. Well, this that we sent is a request, and the value that we are printing is the value from the response which was sent from the router. So basically, the router's packet is having these two fields flipped as to us, so the hardware destination will be our MAC address and the hardware source will be the router's MAC address, since the router is the one that is sending this packet back. And we can see that the router's actual MAC address is this one. So that would be basically it on how to actually get the MAC address from a target. Now, in order to actually create a malformed packet, what we can do is actually craft a packet which will specify wrong thing. Now, by wrong thing, I mean that we can actually fool our Windows 10 PC into thinking that the MAC address of the router is our MAC address. Then what our Windows 10 PC will do is it will send all the packets back to us. And since we haven't anything else specified, the actual Windows 10 PC will lose its connection to the internet. So let us see how we can create a malformed packet. So let me just see if I can, what we can do is actually make a variable called packet. And this variable packet will be an ARP packet, which we will then send. And what we want to do is, since the first packet we actually sent was a request packet, which was under the OP and equal 1. What we want to do is make OP equal 2, since right now what we are sending is the actual response. We want to send the response to the Windows 10, even though they never sent us our request. We want to send them a response saying that we are the router. So we can do that with OP equals 2, which is the actual response. The hardware destination is equal to the actual MAC address of our Windows 10 PC, which we can actually get since we don't actually have. So let us see how we can get it. We can make our final packet .show. We can just change a little bit of code in our final packet. So in order to do that, we need to change the final packet dot, let me just check it right here. I believe it is the the P destination has to be equal to the IP address of my actual Windows 10 PC. So let me just check it out. It is 192.168.1.5. So we select 192.168.1.5, whoops, not 6, 5, instead of the router's IP address. And all we have to do is actually just use the same command from before. Final packet, timeout, we want to send the, oops. Wait, let me just check this. Don't actually execute these two commands. My keyboard actually, not really sure why it did it, but we can just ignore these two commands, and we want to send this final packet once again. So in order to send it, we use the same thing as before. So we will use a variable answer again, and that answer we will send the packet. So we can use the final packet to send it. Timeout will be equal once again to seconds, just in case. We can use the repose to be false right now. It doesn't really have to be true. And we use the first list answer right now. So we see if it got answer. It got answer under the section other. And all we want to do is actually set the MAC to be equal to the answer. We select the first value, open square brackets 1, and we want the hardware source. and we want to actually print MAC right now. So this is the MAC address of my Windows 10 PC, and right now we can actually send the malware packet to my Windows 10 PC. So let me just run ARP-8 in my Windows 10 just to see once again what the actual MAC address of the router is. So the MAC address of the router is this, and now we will change it to be this, since this is the MAC address of my Kali Linux machine. So let us see how we can do that. We will select a packet variable to be equal to ARP packet OP2 once again, since we are sending the response. The hardware destination, so hardware destination will be equal to the MAC address of our Windows 10 PC. So let's copy it, select it under the double quotes, paste it right here, and then all we have to specify again is the actual P destination, so the IP address of our Windows 10 PC, which will be the 192.168.1.5. And here, what we want to select is the P source. So P source, not really sure. Let me just move this to the side so you can see it a little bit better. So P source equals the IP address of the router actually. So what we want to select is that our source IP address is actually 192.168.1.1, which will then trigger the actual, where is my actual packet going? Okay, so here it is, which then will actually trick the router into thinking, I'm not really sure what is happening with my actual terminal, but it doesn't really matter. What I just added at the end of this command is the actual bracket, which for some reason added up right here, but it doesn't even matter. Right now, we need to send this packet in order to trick our Windows 10 PC into thinking we are the router. So how we can send? We can just use send and then packet, since that is the name of our packet. We can send the verbose to be false, since we don't need it. And we just send the packet. And right now, if I just type ARP-A once again, you can see that right now the MAC address of the router has changed. So we successfully changed the ARP table in our Windows 10 PC into thinking that we are the router. As you can see, the IP address of my Kali Linux machine and the IP address of the router both have the same MAC addresses, which shouldn't be like that. So we successfully ARP spoofed our Windows 10 machine with one packet. We crafted the packet and then we sent it to the target. What we will do in the next video is we will actually make a program that will do this in a while loop, so we can actually spoof the Windows 10 PC as much as we want, and also we need to spoof the router as well. So we need to spoof two targets in order to make this actually work, since only spoofing the Windows 10 machine will not do us any good, since the router still knows that the MAC address of the Windows 10 PC is its true MAC address, and we want to spoof the router as well, so the router sends packets back to us. So we will see how we can do that in the next video. Hope you enjoyed this little demonstration. Not really sure what happened with my terminal right here, but everything finished well. Hope you enjoyed it, and I hope I see you in the next video. Bye! Hello everybody, and welcome back to this tutorial. And right now, let us code our ARP spoofer, which will spoof the router and the actual target, which will be on our Windows 10 PC, in a while true loop. So right now, let me just see, go to my Python programs, go to scanning, or pardon me, not scanning, go to local area or local network programs. Here we have our MAC change from the previous videos, and we want to nano ARP spoofer, spoofer.py. So press enter right here, enter our usual user bin Python line, and we want to import the actual scapy library, and we can do that with the import scapy.all as scapy. So this is the way that we actually want to import it, so we can use an easier syntax, and for now on that is all we want to import. So what we are going to do in a main function, so let me just add it right here, main function, we call it right there, and then we will code it right here, and all we want to do is actually try and accept to spoof, and accept, to spoof the target. So we will run a an actual function which we will call spoof_arp, and there we will specify the IP addresses, and we need to run it twice since we are actually running spoof_arp, since we are actually running the two different spoofs, which one will be for our router and one will be for our Windows 10 PC. And also what we want to do is actually try this in a while true loop. What this will actually mean, let me just show you, is that we are going to run this as long as we don't interrupt with our keyboard. So we'll just code it like this. Let me just add a little bit space so this looks a little bit prettier. And let's see what we want to actually paste to our spoof ARP. We can't really paste the MAC addresses since we don't know the MAC addresses of our targets. What we do know is the IP addresses. So we know that the IP address of my Windows 10 PC is .1.5 and the IP address of my actual router is .1.1. So let us specify the two arguments for both of these functions to be the IP addresses of the router and also the IP addresses of the Windows 10. So we can do that with the 192.168.1.1, comma 192.168.1.5. We now do the same right here, but we will do this in a different order. So first we will specify the IP address of the Windows 10, and then we will specify the IP address of the router, since we are spoofing different targets with this. So since we made our spoof function, what we want to do is actually code that function right here. So let us code it with the spoof arp. We need to set def right here, and we need to paste the arguments, which will be, the first argument will be the target IP that we actually want to target. So in the first case that will be the router, and the second argument which will be the IP address that we actually want to fake. So the target IP underscore IP and the spoofed IP underscore IP will be our two arguments right here. The spoofed IP basically means that the IP address that we are going to pretend to be while sending the packets to the target IP address. So in order to actually be able to do all of that, what we need to do is actually get the MAC address of our target. So in order to get the MAC address of our target, we will select the MAC to be equal get target MAC from the target IP. Now this function doesn't exist, of course, so we have to code it. We named it def get target IP, so we will name it the same right here, or not IP, MAC, and as an input it will take the IP address. Since we specified right here that we want to select an input of the actual IP of our target, and all we need to do right now is actually specify the same process that we did in the previous video, which will get us the MAC address of the actual target. So we can select the ARP request, for example, since we are sending the request to be equal to the scapy.arp. We need to select the p destination, which is the destination of our target, to be equal to the IP of that target. And we also need to select a broadcast packet, which will actually be the ether packet, which will contain the MAC address of the broadcast, or basically which will contain the broadcast MAC address. So we will do the same as in the previous video, ff, and once again ff, close the quotes, and all we have to do is concat these actual packets to a final packet equals broadcast /arp underscore request. So let us recap. What we are doing is we are creating a request that will actually contain in the p destination field the IP address of our target. Now all of the other fields we don't have to actually select, since they are, as we saw in the previous video, automatically selected by the ARP, by this KP itself. We created the broadcast packet that will actually that actually has a field of the broadcast MAC address. This means that it will send to any machine on the local area network, and we used both of those packets to make it a one big packet, which we called final packet. So all we have to do is actually type right here that the answer, so we will do the same as before, equals kp.srp, which stands for basically sending and receiving the answer. We want to send the final packet. Let's select the timeout for this packet to be equal to 2 seconds, just in case. And all we want to do is select the verbose to be false, since we don't really need to actually look at it, and that it doesn't really provide any useful information to us, and we want to select the first list, which will be the list of our answers. We don't care about the second list, that's why we only use the first part of the list that we receive from the actual response. Now all we want to do is actually select right here that the MAC equals the answer. We select the first part, then the second part, and we want to select the hardware source, which, if you remember in the previous video, I made a mistake. I, for example, specified the hardware destination, and I was confused why we actually got our Kali Linux MAC address. But right now, since this is a different packet, this is a response that we are getting, we need to specify the hardware source, since this is the source of the target that is sending us back the response. You just see, so software update not now. And all we want to do right now is return from this function with our MAC variable, which has the actual MAC address of our target. So then we will specify the MAC address right here, as we have it right there. And all we want to do is actually send the packet. So we will call that packet, which will be spoofed packet. We want to select it to be an ARP packet, so you can do that with kp.arp. Now you might notice that in the previous video we only used the ARP, we didn't have this kp. Prefix. Now, since we are using this as a Python program and we imported it as a library, as kp, we need to use this kp prefix in every function that we use from this kp library. So let's code this packet. We want it to be our response, which we can select with the OP field equals to the hardware destination, with the actual is the actual MAC address of our target that we are spoofing, which we got from the getTargetMAC function. So we will just paste it to be equal to MAC, since our variable returned the MAC address from that target. The P destination is the actual destination of our target, so we can just select the target_IP. And the P source will be the source or the IP address of the machine that we want to actually fake, which is the actual spoofed IP. So in this case, we are sending the ARP request, or pardon me, the ARP replies to the router, pretending that we are Windows 10. So all we have to do right now is, since we created our packet, all we have to do is actually send this packet to the router. So we can use the functions kp.send. We send the packet and we set the verbose to be equal to false. False. So close the actual brackets, and basically this is it. This is our entire ARP spoofer. As we can see right here, we are both spoofing the ARP tables of the router and the ARP tables of our Windows 10 PC. So let us see how this will actually work. So let me just save this. Before I do any of that, let me check the MAC address of the router in ARP-A with the ARP-A command, so ARP-A. We can see that it is all good for now. 192.168.1.1 is set to be at this MAC address, which is 04-CO, and so on and so on. So with this program, we should be able to change that for as long as we want. So we have our ARP spoofer. Let's make it an actual executable. And let's run it with Python 3. We let this run. Expected and intended blocks. So let us see what is wrong with our code. We nano it. Okay, so we didn't code anything in the keyboard interrupt part. So we can just try right here to code the actual exit the program. So let us try that now. No module named scapy.all. So let us see why doesn't it have scapy.all. Let's actually go to the Python 3 in order to see how we need to import the scapy. So import scapy. From scapy.all import scapy. We see if Python 2 has it. So import scapy. So Python 2 actually has it. So let's actually try to run it with the Python 2. We are running our ARP spoofer with Python 2 right now. And if I just go right here and run the ARP-A once again, okay, so we are still, okay, so right now, as you can see, we saw the live moment where it actually changed to the MAC address of our Kali Linux machine. So our ARP spoofer is working. We are successfully actually spoofing the target. As we can see that the MAC address of my Kali Linux machine and the MAC address of the router are both the same on our Windows 10 ARP tables. We can see if we run it once again, it will remain to be the spoofed MAC address as long as we are running this program. And since we are not actually forwarding the packets between each other, you can see if I go on my internet, so let me just click on the Google Chrome, and if I actually try to open a page, any page, it will not connect to the internet. So we can actually try to go to the facebook.com. We press enter in order to try to actually load the page. You can see it is not loading it. It will not load the page fully. As you can see right here, I lost my connection. I get the error that there is no internet. So this actual program, in case you're not forwarding the packets, can actually make a DOS attack on the entire local network. So nobody on the local network, if you were to example spoof multiple targets, will be able to actually connect back to the internet. So let's see in the next video how we can actually make the packets go from our Kali Linux machine to the router and Windows 10 PC, so we don't actually kick everyone off the internet, but we will see that in the next video, as well as actually fixing our program with a few different things. So hope you enjoyed this video, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to the second tutorial of actually coding our ARP spoofer, and let us see what we can do in order to fix a few things with our program, such as actually forwarding the packets as we run the ARP spoofer. So let us nano our ARP spoofer.py. Here is our program, which we coded in the next video. And let's actually code a function that will restore both the IP address, the MAC addresses in the ARP tables of Windows 10 and in the ARP tables of our router. Since as soon as we finish making our program or running our program, we want to actually restore everything back to normal, so the target PC and the router doesn't actually lose the connection. So in order to do that, we can make a function which will basically restore everything. We will call it restore. In that function, what we actually want to have is the IP address of our target and the IP address of our router. So we will just set it right here. Destination underscore IP and the source underscore IP. So we make this function right here. All we want to select right here is actually getting the real MAC addresses from our targets. So we want to actually get target MAC from the destination IP, which is the IP of our router in the first case, and the IP of our Windows 10 in the second case. And we want to do that for the both machines. So let me just show you how we can do that. We get MAC or get target MAC from the destination underscore IP. We will actually put that into our target MAC address, since this will be the real MAC address of our target, and the source MAC address will be the source MAC address of the actual router in the second case. So get target MAC source underscore IP. All we want to do right now is actually send the packets with these two values. So packet equals scapy.send. Pardon me, not scapy.send. We first of all need to create the packet before we actually run it. We only created the MAC addresses. So open and close this. We make sure that it is a response. We select the P destination to be equal to the destination of the router's IP. The hardware destination equals the target MAC variable that we got with our get target MAC function, and the P source equals to the actual source IP underscore IP, as well as the hardware source equals to the source MAC. And all we want to do right now is actually scapy.send this packet. So we want to send this packet, and we want to set, as usual, where both equals false. So all we have to do right now is, as soon as we actually close our program, we want to run the restore function on these two MAC IP addresses. So we run it on both our Windows 10 and on both the routers, so restore also the Windows 10 machine. We need to perform 2 times this function for each of the machines, and then we can actually exit the program. So everything should be good to go. Let me just double check everything. Now, in order, if you actually wanted to target multiple machines, you can just put this in, for example, For example, for I in range 1 to 255, you can just make this, instead of the 1, to be, for example, the plus string of I, or something like that. You can just put it in an actual loop in order to actually spoof multiple targets, but we won't be really doing that right now. All we want to do is actually see how the ARP spoofer works, and in order to understand the process behind this a lot better than before. So everything should be good to go. All I have to show you right now is actually how to forward the packets once you start ARP spoofing. As you saw in the previous video, we weren't really able to connect to the internet. So let us save this, save it with Ctrl O. And in order to forward the packets, there is a file. Let me just remember how it is called. Okay, so the file was cat proc sys, the net. Let me just see. So we want to go IPv4, IPv forward. Okay, so that is the file. Let me just clear the screen. So if you cat the proc sys net IPv4 and then IP forward, you get this 0 in that file, which means we are not forwarding the packets. But if you echo into that file, so let me just show you, if you just write echo 1 and then the arrow to right, if you press enter on this path and you cat it once again, right now we have 1 in that file, which means we are forwarding the packets. So if we run our ARP spoofer once again with the arpspoofer.py, everything is running smoothly. Now, first of all, before we go to the internet, let us try to run the arp-a in order to see if we successfully spoofed the MAC address. As you can see, we still didn't, but if I run once again, right now the MAC address is spoofed. And right now, in the previous video, as you saw, we weren't able to access the internet, but if we click right here once again, we open the Google Chrome from our target PC. We, for example, want to run the twitter.com. All the packets will go through our Kali Linux machine, and we will be able to load the page, and we will not know anything that is going on around us. We will not know that our packets are being sniffed at, or not sniffed at yet, but being ARP spoofed, and that are going through a whole different machine before actually reaching the router itself. So we actually got the response. The only way for us to actually check that out if we are being ARP spoofed is to run the arp-a command and to see that we have an MAC address right here which shouldn't be there. As you can see, the first alarm would be that we actually have 2 IP addresses that have the same MAC address, which isn't really possible. So that would be the first way for you to find out how that you are actually being ARP spoofed. So that would be about it for this video. We successfully coded our ARP spoofer, but before we actually close this video, let me see if I just press Ctrl-C and open my command prompt once again. Let's see if our router MAC address actually returned back to normal. And as we can see, it did. So the MAC address returned back to normal. So once we actually start running this program, the target will not notice anything, since we actually made a restore function which will restore back the true MAC addresses of the target and of the router. So that would be about it for the ARP spoofer. We will continue coding in the next lecture. Hope you enjoyed this video, and I hope I see you in the next tutorial. Bye! Hello everybody and welcome back, and in this tutorial let us see an idea behind the actual SYN flood attack. Now the SYN flood attack is basically just sending the TCP packets to the target, spamming it with a bunch of packets, and then basically making an over connection to each port and make the target not being able to actually run any software on open ports or connect to the internet as well. So let's see how we can do that. What basically SYN flood is, as I said, we will just be sending a bunch of TCP packets to the target. Now this will not be enough to actually crash the target, since you're sending this from one PC, but if you, for example, have a botnet, which we'll see in the future lectures how we can actually create a command and control center with the multiple PCs connecting back to us, and then you can upload this software to each one of them and run the actual attack. But for now on, let us see the simple code behind it. So first of all, what we can do is, first of all, open Scapy. And what we can do with Scapy is actually see what the actual power of Scapy is. So let us create a simple packet. So the packet will actually have 2 layers. One will be the IP layer. So let us select the IP layer to equal the IP packet. For now on, we will not select any options. All we want to do is just print the IP layer or not like that. We want to actually add .show in order to see the fields of the IP layer. So with the IP layer, what we will do is we will actually concat the TCP packet to this IP packet. So we also want to add the TCP layer equals TCP. We open and close the actual brackets. We don't specify anything. And in order to put these two packets into one packet, we need to make, for example, a packet variable. And that packet variable will be equal to IP layer / TCP layer. And then if you just print packet.show, we can see all the fields from our packet. So in order to actually send this to someone, you can see a few fields that we actually need to change. That would be the source field and the destination field. Now the good thing about this is that the source field, which will be our IP address of course, and the destination field, which will be the target's IP address, don't even have to be true. Now the destination IP address has to be true in order for this packet to go to the right destination, but the source field, we can select our IP address to be anything we want, and target, while scanning it with Wireshark, will see a fake IP address. So let's see how we can do that. First of all, let me run Wireshark from my Windows 10 PC, which we will be attacking. So if I run Wireshark right here, basically Wireshark is a program for sniffing packets. We can not intercept, we can actually view the packets and their fields in the Wireshark as they flow on our network interface. So let me just show you. First of all, let's wait for the Wireshark to actually open. And then what we will do is we will send this packet with, first of all, the true source and the destination IP, and then we will try to fake the source IP and see if our Windows 10 machine will see the IP address of our Kali Linux machine, or will it see the IP address that we actually faked. So our Wireshark is opened. If you don't have Wireshark, don't worry, it is basically pre-installed in Kali Linux. You can just type Wireshark in terminal and this will open. You don't need to run it in Windows 10. But in case you are running it in Kali Linux, you need to specify the target to be your Kali Linux machine, which you can easily specify just by selecting the source and the target to be the same IP address. So you're basically sending packets from you to yourself, in case you don't have the Wireshark on any other PC. Or if you want to actually do the same attack right here, you can just download Wireshark. It is not really that hard. And then you can perform this and inspect the packets that we're going to send. So let's wait for this to load. It is a little bit slow because I'm running a bunch of things such as the actual virtual machine. And while it's actually opening, what we can do is select the source field and the destination field. So the packet.source field we can select to be the IP address of our Kali Linux machine, which is 192.168.1.7, and the packet.destination field can be equal to the IP address of our Windows 10 machine, since we are attacking Windows 10, so 168.1.5. And if we inspect our packet once again in order to see if the actual things that we specified are correctly specified, so they are right here. Let me just see if this is opened. Okay, so we got some window prompted. Let me see what this window is. It is some update. We don't need an update right now, but it doesn't want to close, doesn't even matter. And you select the interface that you are sniffing packets on, which in my case will be the Ethernet interface. In order to only filter out some of the packets, you can just type right here TCP packets, for example, or it is lowercase tcp. You press the blue arrow right here, and right now you will be seeing only the TCP packets. So let's see what happens once we actually send this packet. So in order to send a packet, we can just use the send, and in the brackets we specify what we want to send. We are sending the actual packet. If we go back right here, we stop this, and right now what we want to do is actually try to find our packet that we sent. So if we find it right here, you are looking at the source and the destination. Remember that the source we specified to be the Kali Linux machine, and the destination is the IP address of this Windows 10 machine, which is running the Wireshark. And we can see that our received the packet from the Kali Linux machine, which is 192.168.1.7, and we can see that the actual source field is the good IP address. So this is the packet that we send with our SCPI. So there are a few things that you can actually modify into sending malware packets or so on and so on. As you can see right here, if I go back to my packet and I add a load to be equal, or I'm not sure if I need to specify brackets, to be equal to hello string, or maybe it is packet.raw.load. Not really sure. Let me just remember what the actual syntax is for this. So let's see, packet.show. Okay, so yeah, we need to add another layer, which will be the raw layer, I believe. So packet will equal, or another packet, so packet2 can equal raw. Good, so, and all we have to do is make our packet to be equal to the previous packet and then slash packet2. So right now what we have is also a raw layer. If I just print it like this, so packet.show, you can see we have a raw layer that is concatenated to the TCP packet, which is concatenated to the IP packet. And what we can specify in the raw layer is this load field. And in order to do that, we can just type packet.load equals, between the double quotes, hello, this is a secret message. We close the double quotes and we send the packet once again. But before we send the packet, we need to start actually scanning for the packets once again. We do not want to save this. We only filter the TCP packets and we send this packet. We sent one packet, so we can now stop this. We want to find the actual IP address of our Kali Linux machine, so it is .1.7. Let us try to find it. It is not here. Let's go a little bit up. Okay, so here it is. This is the packet that we sent. If I go right here and you go to the transmission control protocol, let me just go right here. You go to the TCP payload, click on that. You can see the TCP payload is 30 bytes, and you can see that we actually sent, hello, this is a secret message to our Windows 10 PC. We actually sent some data to our Windows 10 PC with our SCPy library. Now let's see how we can actually fake the actual IP address of our Kali Linux machine. So we can do that just by changing this source field right here. So if I just type packet.source equals, for example, let's use the Google IP address, which is 8888. We send that. We start intercepting for packets in our Wireshark. Continue without saving. We only scan for TCP packets. We go back here and we send the packet. We go back right here. We close this and we can see our packet is right here. And in the Windows 10, it pretends that it is a Google server, which it really isn't. We just changed our packet source IP address to be the 8.8.8.8, and it still has the hello, this is a secret message that we encoded into our TCP payload. And as we can see, the Windows 10 has no other way into actually finding out who actually sent this packet. As we can see, all the other fields, the actual Internet Protocol field, let us find it right here, since there should be the source IP address, and we can see that other source IP address is the actual 8.8.8.8. So it really does seem that this packet came from the Google DNS servers, which it really didn't. Now, in order to create the SYN flood, which I talked about, all you have to do is create a packet. So let us go to our Python programs, go to our local network programs, and nano syn flood.py. And there all you have to do is add this line user bin python from scapy.all import all. You can just import, or pardon me, not all, we want to import. We can actually import everything with this star right here, so hopefully something like this will work. We can check it out. And all you have to do right here is actually make a SYN flood in order to, or basically create a packet and run it with a while loop or while true loop, and it will send the packets forever to each port. Now we will be doing that in the next lecture, so we don't make this one too long. So I hope I see you in the next lecture where we will actually code a SYN flood program. It is rather short, so don't worry. I hope I see you there, and take care. Bye. Hello everybody, and welcome back to this tutorial. And right now all we are left to do for our SYN flood program is to actually code it. Now in order to code it, we can just use a simple def function, which we will call SYN flood. So we can call it like this. Now what this function will take as an input will be the source and the target. Now you can also, if you want to send some certain message, you can add the load. So we can add it like this. Or let's add it as a message so you can actually know what I mean by that. This is basically the message that we sent in the previous video, which contained hello, this is a secret message. So we can actually run a SYN flood with this actual message right here. So what we want to do in order to make a SYN flood is actually spam every single port. Now in order to actually spam every single port, we can just use a simple for loop which will allow us to do that. So for s port. Now this s port will be the source port, or actually we don't want to loop with a source port, we want to loop with the destination port since we are sending this to the target. So what we want to do is actually for destination port of our target in range, and let's use so we don't actually crash anything, even though you can't really crash with one PC, I believe, in range 1024 to 65535. I believe that is the number of ports that there are on each PC. So we close this. For each destination port in this range, we will actually send the packet to the target. So we want to actually spam every port of the target from the 1024 port to the end. So all we have to do is do the same as in the previous video. We need the IP layer to be equal to the IP field or IP packet, where the source will be equal to source as we specified right here, even though we don't really have that actual variable yet, but we will just code it a few seconds, and the destination will be equal to the target. Oops. So destination will be equal to the target, and for the destination port in this range, we will actually send the packet for every port on the target. All we need to do right now is also code the TCP layer equals TCP. The source port will be equal, for example, to the port 4444. We want to, this is the source port, this is the port from which we are sending the packet, and the destination port will be equal to the destination port variable that we specified right here. So we close the brackets right here. We make our packet to be actual IP layer slash TCP layer. And all we have to do is send the actual packet. We are not using the send and receive function, since we don't really care about the reply of our target. We only want to spam it with packets so we can actually crash all the services running. And all we have to do is specify the source and the target and the actual message. Now in the TCP layer, we need to also add the raw layer, so we forgot about that. If we want to specify the message, which is not really needed, I just show you for the purposes. Let's call it raw layer equals raw, and the load will be equal to the message, so we can specify it like that. The load is the field in the raw layer, and here, if I'm not mistaken, we can specify it like this. So IP layer slash TCP layer slash raw layer, and all we have to do right now is run this as a while true. So while true, SYN flood of the source, or let's call it source, target, message. And now we need those three variables. So we will use source equals raw underscore input, and we can use something like this. Oops. Enter source IP address to fake. The target will be enter target's IP address, of course. So let me just, I forgot the double quotes. Enter target's IP address. And the message will be raw underscore input. Use the double quotes. Enter the message for TCP payload. And with this, I believe we are good to go. So let us save this. We chmod the SYN flood. So let's add it like this. We start our sniffing of the packets on Windows 10. Okay, so it started. Right now, all we want to do is run our SYN flood. Okay, so it took a little while to actually prompt us with this, not really sure why, but here it is, enter IP address to fake. So the source IP address is the IP address, either your true IP address if you want to, or basically any IP address you want to specify. Enter target's IP address, which will be 192.168.1.5, and the enter message for TCP payload will be, for example, hello world. And as we can see, it is sending the packets. If we go right here, you can see a bunch of these packets are actually being sent, and our Windows 10 PC is being spammed with these packets. As we can see, all we can actually see are the packets coming from the 8888. So let us close this, and let us close the actual SynFlooder, since we don't really need to crash anything. Exit this. Let us go to our Wireshark. We can inspect some of the packets. As we can see, the actual source port is the 4444. The destination port is the port on our Windows 10 PC. So I believe the next packet will have the destination port of the actual, let me just close this, of the actual number increased by 1, so 2386. So let us check that out. Okay, so it is. So we were spamming every single port on our target PC from the source port 4444, which you can even specify to be anything else if you want to. Doesn't really matter, as you can see right here. So I should have closed the terminal. Let me just go back to my terminal. Okay, here it is. And go to my Python programs and local nano the synflood. You can see we specify the source port to be 4444. We specify the IP address to be 8.8.8.8, and it also has our payload with data. Let me just go down here, which is the actual hello world string that we are sending with each packet. So that would be about it for our SynFlooder. You can see we sent a bunch of packets, and if you run this from multiple PCs, you can actually DDoS the server or the machine that you're targeting. So basically that would be about it for this tutorial. If you, for example, don't really want to actually send the packets to every port, you can just select it something like this. So the port equals, you want to actually specify only the port 80. So you can select the port to be 80 right here. I believe we are good to go. So, and then the port equals the port, and then you synflood it. So let us see how that will work. You run the synflood.py. We start once again to actually sniffing for the packets, enter IP address. Let's use 1.1.1.1. That is the IP address we want to fake. 192.168.1.5 is the IP address of our Windows 10. And we can just type here 1234. It doesn't really matter. We are sending the packets. And basically, if you were to, for example, run these packets, as you can see, they are coming at a huge rate. If you were to run this from multiple PCs and attack the destination port 80, you can actually make that host or that machine not being able to connect to the internet anymore. So let me just see. It probably won't work since we are running this only from a single PC. But if you, as I said, if you run this from multiple PCs, it will work. The target will be actually crashing, not being able to run software on any port that you are actually attacking, and not being also able to connect to the internet itself. Now, the reason behind my Google Chrome opening this slow is not really the program that we are running right here. It is actually just my PC being slow at the moment, since I'm trying to open 10 things at a time. We can see our program is still running. It prints out sent one packet each time it sends the packet. You can see I got the page cannot really open. Let's close the page and I will try to reopen it once again. Let me refresh the page since we can't really go to the internet. If I want to, for example, go to twitter.com, let's see if it can load Twitter. Okay, so it probably can. It is just doing it really slow, so sometimes you will lose connection, sometimes not. As I said, this program on one single PC is not strong enough to actually kick somebody off the internet, but two PCs possibly could be. So you can see it is loading, but really, really slow. We will not wait for this to finish. It doesn't even matter. Okay, so here it is. It actually finished, so let's close it. Let's close this program. And that would be all about the actual synth ladder. It is a rather simple program. We added some of our own things to it, such as the load that says 1, 2, 3, 4 or hello world or something like that. And that would be about it for this tutorial and this program, and we will continue coding in the next lecture. So hope I see you there, and take care. Bye. Hello everybody and welcome back. And in this tutorial right now what we are going to do is we will code our own small sniffer, which is actually going to be a little bit more advanced sniffer, since we are going to use some libraries and some protocols that we haven't encountered before. For example, what we will try to do is we will try to sniff for the MAC addresses over our networking interface, and we will try to actually put them down in bytes and see what we get from them. So what we want to do is basically code a simple Wireshark-like program which will allow us to see from which MAC address are we receiving packets from and to which MAC address are we sending the packets to. So let's see how we can do that. Now if you're an absolute beginner, this might be a little bit hard for you, but I will make sure to explain everything the best I can. And if you really don't get it, you can always go to the next lectures and get back to this one once you think you are ready and once you think you will be able to fully understand it. Now, even though this is a little bit harder than the previous programs, this is still nothing really special, as it will be a rather short program that will only print out the MAC addresses that we are receiving the packets from. And let us see how we can actually do that. We also want to print out next to the MAC addresses. We will, for example, print out the protocol over which they are communicating. So let's see how we can do that. Let me just zoom this in so you can see everything well enough. Let us go to our Python programs directory and let us go to our local network programs. So this is a program that will actually only work on your local one. It doesn't have anything to do with the actual other machines on the network. This is just something you can run on your own PC if you want to, for example, test out your knowledge while coding, or if you want to simply just see the MAC addresses that the packets are coming from. Now this can be useful if you want to, for example, detect the ARP spoofing or something like that. You can add a little bit of code to this program that we're going to make and make it an ARP spoof detector. But for now on, we just want to introduce ourselves a little bit more to certain libraries in Python, and we will make this program called, for example, macsniffer.py. And let's add our user bin Python, so user/bin/python to our program. And there are two libraries, or pardon me, three libraries, but one is not really necessary, so we can just remove it. We want to actually import the socket library and the struct library. So import socket. Now this library allows us to actually communicate over the internet. It will create a socket object on our PC, for example, and then it will try to perform the connection to other PC. It is what is most likely used for once you import this library, but for now on, we'll do programs like that later on, but for now we just want to import it so we can use some of its functions in order to perform the task of our program. So import socket, and from struct, import everything. Now what this struct library allows us to do is, for example, to import the strings as a binary, which allows us to actually manipulate the binary on a more deeper level. So I will show you what I mean. First of all, what we want to do is actually try to create a socket object, and then we'll print out the error in case that doesn't work. So let us see how we can do that. We can just use a simple try and except rule in order to perform the creation of the socket object, which we will just simply call s. So s equals socket.socket. And what we want to do is parse some of the arguments to this object, which will be the socket.af packet. Now this socket.af packet is different than the socket.af_inet, which we will be using later on. Basically the let me just show you. Socket.af_inet allows us to basically communicate using internet protocols, but socket.af_packet is something that we will use in case we, for example, want to manipulate the packets at a protocol level, which we actually want to do since we actually want to get the protocol from the sniffing itself. So let us see how we can do that. We specify the socket.af packet, we can put comma, we want to use the raw packet, so we can specify with the sock_raw, and after that we'll use a function which is called socket.ntohs, and in that function, pardon me, it's not comma, it is dot, so ntohs, open and close another bracket specifically for this function here. And what you want to specify in between the brackets is the number 0x003. Pardon me, there is one more 0, so 0x003, or 3 zeros and then 3. What basically this does is this function performs converting of positive integers from network to host byte order. And then after that we will import, as we imported the struct library, which will allow us, as I said, to convert strings to the binary, which we can then print out and get the full MAC address and the protocols that they're running on. So we made our socket object right here. These are the 3 things you need to specify. As I said, we are using the raw packet, we are using the AF_packet, since we want to actually manipulate the packets at the protocol level. And just in the except rule, we can just print out error on creating socket objects. So we can then close this, and we can actually exit the program, as it didn't work. So once we actually make this, what we want to do next is actually enter the while loop, or while true loop, since we want to do this indefinitely until we actually want to stop it. So we will just enter the while true loop. We can do it like this. This will run forever as long as we don't stop the program. And what we want to do is actually receive the packet, or receive every packet from every port that we get. And from that packet, what we want to extract is the source MAC address and the destination MAC address and the protocol field. So if I just show you, let me just go right here and open Scapy, which we are already introduced with. I will show you where we can get the source MAC address and the destination MAC address and also the protocol number. So let me just show you right here. It is the packet called ether. So if you just type here ls and then ether in the brackets, you can see that this packet right here actually has 3 fields, which is the destination, the source, and the type. This type right here is actually referring to the type of the packet, which will then be stored in the binary right here. And the source and destination is the, as it says right here, the destination MAC field to where the packet is going to, and the source MAC field from who the packet was sent from. So this is the packet that we want to interact with, since all these 3 things that we have are actually in this packet right here as 3 different fields, and we want to actually divide them by those 3 fields and extract all these 3 things. So let's see how we can do that. Let me just exit the Scapy, go back to my maxsniffer.py. So we enter the while true loop, and all we want to do is just print the packet equals, and then socket object, which we created right here with the socket.socket, we want to actually receive from this object, or receive to this object, from every port on our PC. Now there are, I believe, not really quite sure, either 65,535 ports or 65, we'll just go with 35, since that is the lower number. Now I always confuse these 2 numbers, so it doesn't even matter, we can just receive from this much ports. So packet equals receive from 65,535 ports. We want to receive the packets from those ports, and we want to store them in the packet variable. Now since this is a while true loop, this will go, basically first packet will go to this variable, then it will go back to the while true loop, then the second packet will go to this variable, and so on and so on. So what this while true loop will do is basically just receiving the packet. And what we want to do is, from that, we want to select the first part of the packet, so packet equals packet, and then we want to specify 0. We just select it right here, so packet 0. Since this is a tuple, we want to actually use the packet string from the tuple. Now, tuples are something I didn't explain, but if you're coming from Python, you basically know what that is. The next thing we want to select is the actual length of the Ethernet header. Now, the Ethernet header is basically something that I showed you previously in the Scapy, when I opened Scapy, so we know that it has 3 fields, the destination, the source, and the type of the packet that we are receiving. Now, I can tell you that the actual length of the Ethernet header is the 14 bytes, since the 6 bytes and 6 bytes are actually referring to, or first 12 bytes are referring to the destination and to the source MAC address, and the last 2 bytes are basically referring to the actual type of the protocol that the Ethernet packet has attached to it. So we can just select the Ethernet length to be equal to 14. Since I just told you it has 14 bytes. The next thing we want to actually do is strip the packet to the Ethernet length. Since this packet right here is not only containing the Ethernet header, it most likely, or not most likely, it definitely has other headers as well. For example, this could be something that we receive, for example, an ARP packet, so it will have ARP fields attached to this packet as well. So we want to strip everything from that. All we want to receive is actually the Ethernet header, and we can do that by just simply typing Ethernet header. So Ethernet_header will be equal to the packet. Then we open and close these square brackets, we add the two dots right here, and we type eth_length. Now, what this basically does is it strips the packet variable, which contains a bunch of other headers as well, from the beginning to the end of the Ethernet length. Now, we specify the Ethernet length to be 14, so you can actually just do simply like this. So you can just select here 14, which will select first 14 bytes, and right here, you basically did the same thing, but I prefer to do it this way, since then you know why I specified the number 14 here. So Ethernet_length. And right now we want to actually strip our Ethernet header from the MAC addresses and the type of protocol. Now, this is where the struct library comes in help. We will use a function called unpack, so we will use a variable, for example, called ETH, stands for Ethernet, and we will equal that to the unpack. And in this function, we actually need to specify two things. We want to specify different way how we want to actually unpack it, which needs to be between the double quotes, or the single quotes, pardon me, and the packet that we actually want to unpack, which is Ethernet_header. Now, before I specify this part right here, let me just show you right here the struct library table, basically, where we actually can see how we can unpack different types of packets. Since we know that our actual Ethernet packet has the 14 bytes, we actually want to separate it by first 6, then the next 6, and then after that we want to actually specify the last 2 bytes, which will be the type of the protocol the packet is having. So what we want to do is actually add this string right here. So we need to specify first of all the exclamation mark, so it knows that we are specifying this, then the 6s, and then the capital H, which will actually strip the first 14 bytes. And from these actual 14 bytes, we want to get the protocol after the MAC addresses. Let me just show you how we can do that. Basically, after this, all we need to specify is the ETH_protocol equals to the socket.ntohs, which is the function that we also used right here. And we want to specify right here, let me just show you, in the open and close brackets, the part from ETH, and then the third element, which we can actually select with the number 2. Since, as I said before, the counting in Python starts from 0 and not from 2. As you can see, the third element will be the protocol, as we saw in this KP. Let me just show you once again. So KP, if I open it, and you basically ls the ether packet, or ether header, pardon me, you can see that the third field is the actual type, which is the type of protocol. This is labeled as 0 field, as first field, and as second field. That's why in the square brackets we specified it to be the number 2. So nanomaxsniffer.py. After that, we basically separate everything with the print statement, so we can print something like this. We open and close brackets. Let's print with a plus destination MAC. And then after that, we can actually print, let me just do it like this. We can plus the Ethernet address, which will be the actual packet, the first 6 bytes of the packet, so we can specify that with this. So we can do something like this. So packet from the actual 0 to 6, since we know that the packet has 14, so we will split the first 6, then the second 6, and then after that we will split the protocol itself, but we don't really need to, since we actually selected it to be stored in this variable right here. So we selected the Ethernet address to be first 6 bytes, then we want to plus with the source MAC address, so source MAC will be equal to the basically the Ethernet underscore address, that's how we will call it, and in here we want to specify the packet, and then the second 6 bytes, which we can specify from 6 to 12 in these square brackets. What we want to do is close this. Okay, so we closed it. Now we have one bracket more. We forgot to close it right here, so let us close the bracket here. Here we have the brackets closed, and all we want to add is also the protocol, so plus, and then once again open the double quotes or single quotes, and then use the plus protocol. And then here we want to actually just add the string of this variable right here. Now, why we are using strings? Well, basically this is bytes, so we want to actually select this to be a string. Otherwise, we will get the error while actually printing this. So we want to actually just type plus the string from the ETH0 underscore protocol. Okay, so let me unzoom this so we can see everything well enough. And just close here another bracket, and that should be it. Now, this ETH0 is a function that we didn't code yet, so we need to code this in order for this print statement to actually work. This part right here will work since we actually stripped the protocol in the previous line, but this part right here we actually need to see how we can print the MAC addresses, since as we know, if I just go save this and just type ifconfig, you can see that the MAC address is split by these two dots, so we need to actually make a print statement that will actually take that in count. So we need to actually, first of all, nano the maxsniffer.py. Then here what we will do is we will add the function called def.eth underscore address, and we will parse the packet to it, and that packet we can just call A, doesn't even matter. You can call it anything you want, this is just the parameter for this function right here. As we can see, we are pasting or parsing to that function the packet first 6 bytes, and in the second line or in the second statement we are parsing the packet and then the second 6 bytes. So let's see what we can do with that. All we actually want to do is select some variable, for example called b, to be equal, and then in the double quotes we want to specify the actual printing of the MAC address, so we can print it like this with the, so let's do something like this. So we can do the percent and then dot to x, and then 2 dots, and then you can basically need to do this now 6 times, since we have 6 different fields in the MAC field separated by 2 dots. Now this part right here only represents the first 2 bytes of the MAC address, or pardon me, this X right here represents the hexadecimal, and this part right here only represents the first part of the MAC field separated by the 2 dots. So all we want to do is actually paste this 6 more times. So let me just add a space right here. We want to add a space, print once again, so print it basically 6 times since the MAC address has 6 fields. And then after we do this, or we actually don't need the space, we can just do it like this. Let us remove the spaces and we will see how it works in the print statement, and then if it doesn't look really well, we will just code it differently. And then this 2x right here basically represents the hexadecimal value, as I said, and we need to paste the parts of this A packet right here that we specify as a parameter to be put here instead of this percent and then .2x. Now this is just some Python syntax, so don't worry, this isn't anything referring to these 2 libraries or the packet itself. This is just how we specify to print this MAC address right here. And basically what we need to paste between each of these percent signs is, first of all, let's add the percent, and all we want to do is add open and closed brackets and pass the ORD, and then in the brackets of the ORD function we need to specify the A and then the first element for the first part of the MAC address. Now all we want to do is actually copy this. We want to copy it and we want to paste it 6 times, same as in the previous. Let me just add a space right here. So this is 4, this is 5, and this is 6. And all you have to do also is in these brackets add different numbers. So this will be 6th element, which we select by number 5, 4th element selected by number 3, by number, or 5th element selected by number 3, 4th element selected by number 3, and then the 3rd element selected by number 2, and the 2nd element selected by number 1. We also need to specify the commas between all of these elements, so let me just add it right here. Comma here, comma here. So we actually code everything properly. all we have to do right now is return this string, so return b, to be actually printed out instead of this line right here, and also instead of this line right here. And what this will do is actually print the MAC addresses from the packets that we are receiving from the Ethernet header. Now, this can be a little bit confusing part to you, but as I said, this is just similar to something like printing the print, and then in there you specify the actual %s for the string, and then you just specify in the percent in the brackets, you specify some variable a, for example, and then this variable a will be printed instead of this %s. Just right here, we don't have a string, we have hexadecimal, so we put basically %x, and then we parse this packet separated by 6 fields, since our MAC address has 6 fields separated by the 2 dots, and we paste them instead of this line right here. Then we return that line, and it will be printed out right here, and here also. So let me just delete this. Then we can save this program, so Ctrl O, Ctrl X to exit. Let's make it an executable. Now let's actually run it to see if it will work. And as we can see, this works properly. We got the destination MAC, which is the broadcast MAC address. We got the source MAC from this MAC of our router. Now I know that this is my router. And we also got the protocol, which is protocol 8, which I believe is the IP protocol. Not really sure. We can see we are receiving a bunch of those packets. So let me just fix some of these things, such as protocol needs to be specified correctly. And these 2 dots at the end really shouldn't be there. So let me just close this program. Nano it once again, maxsniffer.py. What we need to specify is, first of all, protocol. We need to change this, and at the end right here, at the last hexadecimal statement, we do not need these 2 dots, since we are not actually adding anything to it anymore. And if I run this once again, let's see how it will look. We can see destination MAC address, source MAC address, and the protocol number. Now, in order, if you don't know what the protocol numbers are, basically if you just go and type protocol numbers, let me just go to some link which will, okay, so list of protocol numbers. Let's go right here. You can see the values of the protocol numbers. For example, let us see something that we are familiar with, such as the TCP. The TCP is selected as the 6, and you can go down here and have a bunch of the others protocol numbers as well. So you can check them out if you want to. Us specifying the actual string for every protocol would be too much of a work, so we just basically print out the number, which is easier. And right now we have our MAC sniffer, which will sniff the destination and the source MAC address, and also the protocol from which the packet is going through. So that will be about it for this video. I hope you enjoyed it, and we will continue coding in the next lecture. Hope I see you there, and take care. Bye. Hello everybody, and welcome back to this tutorial. And right now what we are going to do is we'll actually code a program that will help us to sniff the credentials from the FTP login. Now the FTP is really insecure. It sends the credentials, by which I mean username and password, in an unencrypted plain text, and all we have to do if someone is logging in from our local area network to the FTP is sniff for the packets and run our program, which will print out the username and the password. So let us see how we can do that. First of all, let us go to our Python programs, and before I do that, let me just enlarge this. Where is the enlarge? Okay, so it's here. Zoom in, go to my local network programs, and let us nano ftp sniff.py. There, all I need to specify is first of all the line that we always need, user being Python, and we will use 2 libraries, one of them which we encountered before, which is the opt parse library, which we will use to parse our actual available options, which we will specify then to the user. And we also need to import this kp.all library, which will help us to actually sniff the packets and print the username and password from the packet. So let us import it. So import opt parse, and from kp.all import all, which we specified by this star right here. And for now on, what we want to do is first of all parse our settings, see what we will need in order to run this program. So what we will need is basically just to specify the usage of the program itself, which will just be running over the program, and specifying the interface on which you want to actually sniff. So basically, if you type, let me just show you, if you just type ifconfig, you have multiple interfaces. In my case, I just have two, and one of them is the loopback interface, and I will specify this interface to be the interface on which I'm sniffing on. So you will most likely also have ETH0 if you're running on the actual Kali Linux machine. So let us go to the FTP sniff and see how our code will look like. We need to make, first of all, the main function, and in that main function, first of all, we want to parse the options. So we will use the usual thing, the parser, which will be equal to the op_parse.option parser. This is something that we used before, so nothing really new for us. And in there, we want to specify the usage of the program for the actual user. So we can do it by this, specifying double quotes or single quotes and just printing usage of the program. So we close this, we can add in the new line, so backslash, we can use the backslash in order to specify the rest of the code in the new line, and all we have to add is another single quotes, and there we can specify the -e option to be the option for the actual interface. So we'll specify it like this, interface, and close it like this. So this will be the options that are going to be printed out to the user once they need to run the program. And all we need to do right now is actually add those options, which in our case is just the interface. So parser.add underscore option, and in the brackets what we need to do is specify the dash or just -i for the interface. We will select the destination to be equal to the actual interface itself, and then in the next line we can actually specify the type to be equal to the string, which we specify with this. Now why I'm not explaining this is something that we did previously at the beginning of the course, so this you should already be familiar with this code right here. And the help option will be specifying, for example, specify interface to listen on. So you can specify something like this, and all we have to do right now is add our usual line, which will contain options and arguments, and that will be equal to the parser.parseArgs. So parser.parse underscore args. We open and close the brackets, and right now we actually need to check if the user has specified this option. So if he didn't specify the option, what we want to print is we want to print our usage of the program. If they did specify the option, we want to continue into running our FTP sniffer. So we can check that as always with the if options.interface, since that is the actual destination that we specified as an option, is equal. We need to specify double equal, since one equal, if you remember, will be only giving the actual value to the variable. So we need to specify double equal in order to check if the options.interface equals to none. If they do equal to none, what we want to actually print is print the parser.usage. And once we print that, we can exit the program, since user didn't specify it correctly and needs to run it once again. In the else statement, we want to specify that conf.iface will be equal to our options that we actually used in the parsing part. So this is the options, the only option actually, options.interface, which we specified right here. And what we want to try is try to sniff for the packets with this command. So we will try and accept. Accept can be actually storing the keyboard interrupt. Since this is a sniffing program, we will sniff until the user actually wants to stop, which they can actually stop with just pressing Ctrl+C, which will close our program correctly. So keyboard interrupt, and then we will exit the program. In the try statements, we will actually run a function, which will be the sniffing function. So sniff, we want to sniff on the TCP port 21. Now the reason why we are sniffing on that port is because FTP is actually running on port 21. You can check that out on your Metasploitable, for example. If you open your Metasploitable and run an nmat scan or run any port scanner that we actually coded against the Metasploitable, you will notice that it is running FTP on port 21. And all the other machines and servers are also running the FTP on port 21. So we will use the filter to be equal TCP port 21. And the actual packet that we will prompt back to the function that we didn't code yet will be equal to the FTP sniff function. So we will call it just like this. And then We will code this function in the next lecture. So for now on, what we did is we coded our main function, which contains the available options, or just one option in our case. It checks if those option is specified once running the program, else we gives the options.interface to the conf.iface, which stands for interface. Then we try to sniff for the packets on the TCP port 21 and process the packet back to the FTP function, which we will code in the next tutorial. If the user wants to stop, they can specify the keyboard interrupt, or basically Control-C, in order to close the program. So let us save this, and we will continue coding in the next lecture. Hope you enjoyed it, and I hope I see you in the next tutorial. Bye! Hello everybody, and welcome back to this tutorial where we will code our FTP sniff function, which is specified in our main function in the previous tutorial. So let us open our FTP sniffer with the nano ftp sniff.py, and let us see, we specified right here the function to be named FTP sniff, so we need to name it the same. So let us name it def FTP sniff, and in that we need to specify the packet to be as imported as an argument to this function. Now what we want to do is first of all get from the IP header the destination, so we can print to where the packet is going to. So we can print the IP address so that we as an attacker know to which machine can we attack once we sniff the actual username and actual password. So we can select that to be in the variable dest equals packet.getLayer. Now the getLayer, we need to get the layer from the IP header and the field destination. So if you want to check it out, you can just open up Scapy, type ls the IP, and you will see the destination field in the IP header. After that, what we want to do is actually use the raw equals packet.printf. So make sure to specify the, oops, I am missing R right here, so it's printf. And we need to print the raw packet, so we can just do that with the actual, let me just show you, we want to use the raw.load field, which we can specify between the percent signs, so raw.load. You will see in just a second why we are specifying that once we actually get the user and the actual password. Now, in order to get the user and password, we need to use a library called RE, which will allow us to specify the actual way, or not the way, the actual pattern that we need to use in order to get the username and the password from this raw.load field, or basically now stored in the raw variable right here. The pattern I already checked before, and I will show you how it goes, so we don't actually waste time on that. But in order for you to understand this, you need to use the findAll function. So what this will do is first of all type ref.findAll, and what this will do is it will take two arguments as an input. One of them will be the actual pattern from what you want to search for, and the other argument will be the variable or the packet from which you want to search for. So we want to actually specify raw as a second argument to this function, since we want to actually get the username from this raw variable right here. And what we want to get as a pattern is first of all open single quotes, and there you can specify open and closed brackets. First of all a question mark, let me just find where my question mark is, then I, and outside of the brackets you specify user and space, open and closed brackets once again, and just type dot and then star. So this is a pattern which will allow us to only print the username from this raw field right here. We also want to do the same for the password, which will be the same pattern. So if you go right here, and in our PSWD field, we want to, or not field, this is a variable, so don't confuse these two with any fields from the packets. These are not the fields, these are just variables that we are specifying. We want to actually do the same thing, so re equal dot findAll, which will find all the actual patterns that are specified with this in this packet right here. So we want to do the same thing in between the double quotes or the single quotes. We will just specify this pattern right here and make sure to actually change the name right here, since it is not user anymore. We are looking for the actual pass, and also we want to get it from the raw field. So now that we actually specified the pattern in order to get the username and password from the FTP packet, now what we want to do is actually print to the screen the IP address from which the packets are coming to, or basically the IP address to which the username and password are being sent to, which is the target server or the server, any server running FTP. We want to print the username and to print the actual password. So let us see. Oops. We will check if user exists, so we can do that with the if user and then the two dots. We want to print, so print, we can do it like this in, with a star right here. Detected FTP login to, and then we can specify the plus, the string of the destination. Since the destination is our variable that stores the IP address of the server running FTP, we want to print that, and right below that we want to print the actual user. So under the plus we can use something like this. So user account, and then we add, now make sure to add a string from the user from the actual first element from the user. Now you might be asking, why are we specifying the first element? Well, this function right here will return a list from all the elements that are actually included in this pattern. And all we want to do is select the first element in order to get the username. Now most likely this user and PSWD fields will only contain one actual element, which will be the username and password, but they will be stored as a list. So this will be a list containing just one element. So even then we need to specify the element to be in the actual brackets. So in the square brackets we need to specify the element that we want to print. So same we need to do for the password, else if PSWD, if we actually find the password, we need to print with the plus password, and we can print plus string and also use the PSWD and square brackets and 0 inside them, so we actually specify the first element from that list. So this should be about it for this program. If we coded everything successfully, all we want to do right now is actually call the main function down here, so we can actually run the program itself. And right now we can actually check to see if this will work. So let us save this, and before we actually do anything else, let us go and open up our Metasploitable, since the Metasploitable actually has the FTP server or FTP software running, and we can test this on that software. We will run this program, then in another terminal what we will do is we will actually try to connect to the FTP over FTP onto the Metasploitable, and we will see if this program will catch the username and password and the IP address to the actual target. So let us see if this will start soon. Let me just close this. Let me open up a second terminal while this is starting. So new window. Let's enlarge this. Not like that, we want to enlarge it like this, to the side as well, same with this program, so we can see everything well enough. Zoom this in, which will actually go over this terminal right now, but doesn't even matter. All we will do right here is we will actually perform the FTP connection. Right here what we want to do, okay, so this is starting up. We want to run the program. Let me just see if it is an executable. It is not, so we want to make it an executable with chmod ftp sniff.py and run the ftp sniff.py. Now you can see nothing is being printed out except the usage. Okay, so yeah, I forgot about this. We need to specify the usage, so we need to specify -i and then the actual interface on which we want to actually sniff on. So eth0. You specify -i and you specify eth0 or any interface that you want to use. Right now our program is running, it is sniffing for the packets and it is waiting in case we actually try to connect to the actual FTP server. So let us first of all see the username and password, so msfadmin and msfadmin. Let us check the IP address of our Metasploitable. It is 192.168.1.4, and let us actually FTP to the Metasploitable, which we can do with the 192.168.1.4. It will ask us for the name. Now I have no idea, I believe it is msfadmin, and msfadmin as a password. We can see login successful, but we can also see in our second terminal that we received detected FTP login to this IP address, user account msfadmin, and password msfadmin. So we successfully sniffed the username and password, so all we have to do is just fix this part right here. We will just strip the /r and /n. So let us do that right away, nano ftp sniff.py. And all we want to change is actually printing string from the user and then dot strip. We want to strip from the character \r, and we want to strip from the character oops, let me open the single quotes, \n. We want to do the same right here, so dot strip from the character \r, close the brackets, and do once again dot strip from the character \n. Close this, close the brackets, save this right here, run the ftp sniff.py once again. Let us close this so we can check exit. Okay, so we need to specify the interface. I always forget that. The interface ETH0. We let this run and let us try to connect once again. So ftp sniff, msfadmin, enter, and msfadmin. Now for some reason it is still printing out the /r and /n, but it doesn't really matter. We know that those are the characters that come from the Python and not the actual characters from the username and password. What the more important thing is that we are able to actually sniff the username and password and to also sniff the IP address from which the login is coming to. Now what you want to do is actually run this with the ARP spoofer while forwarding the packets. Now we coded ARP spoofer before, so you should already be familiar with that, and you will be able to actually sniff the username and passwords from any account on the local network. So for example, if you're in a cafe and someone wants to log into the FTP server somewhere, and you can sniff their username and password easily. So that will be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and in this tutorial what we will do is we will see how we can actually sniff the usernames and passwords from any HTTP website that the target actually opens. Now make sure to actually, while running this program that we will code right now, make sure to have the ARP spoofer and the the packet forwarding enabled in order to get this program to work. So let us see how we can do that. First of all, what we want to do is go to our Python programs and go to our local network programs. There we can actually make a sniffer, so since this program will sniff any username and any password on the HTTP websites, you will call it sniffer.py, so nanosniffer.py. We start off with a usual line, which is user bin Python. And after that, we want to import two libraries. Now, they are the same libraries, but they are specified in the different order. So let me just show you. Import scapy.all as scapy, which is something that we encountered before. And from scapy_http, import http. So if you just save this, I will show you how you can install scapy_http, since it really doesn't come in the Kali Linux, since I had to install it like 10 minutes ago or something like that. You need to type pip install scapy_http, and you let this run, and what this will do is it will collect the library for you, and then after that you will be able to actually run the functions from this library. As you can see, for me the requirements is already satisfied, so all I have to do is actually code the program for now. So go to my sniffer.py, we imported the library, and let us use a function from scapy called sniff. In that function, what I will specify is the actual interface, which in my case will be once again ETH0. And all I want to do is actually code this function upwards. So we'll code it and we'll name it the same, so def sniff. It will take an input, as you can see, the input of the interface. And with that interface, we will use the scapy sniff function, which will be scapy.sniff. And then iface equals to the interface. We will not store anything basically, and we will process the packets to the function called process_packets. And basically these are the three arguments that we specified right here. We selected the interface to be equal to the argument that we parsed to the actual function. We said store equals to false, which means it doesn't store packets in the memory, and basically pr and back is the callback function that we will use in order to process our packets. So all we are left to do is actually code the process packets function. Let us go right here. Def process_packets. In that function, we will need to paste the argument of the packet itself. And what we want to check first is For example, if you have any knowledge in the actual websites, you know that everything is sent over HTTP requests and responses, as well as the usernames and passwords. So what we need to check is since we imported this KP_HTTP, we want to actually check if our packet we are processing has the layer HTTP. Most likely, we want to actually send the layer to be set the layer to be HTTP request, since in the request we are actually requesting to log into some page. Then the response, the server will send back the response saying either we log in successfully or we didn't. So what we want to actually specify right here is three things, the same as in our FTP sniffer. What we want to specify is the actual URL from which the username and password is coming to. So basically, if someone tries to log into the Facebook, we need to also print out that the login username and password is being tried on that website, which will be facebook.com. Since if we just print the usernames and passwords, it doesn't mean anything to us, since we don't really know where to use those usernames and passwords once we sniff them. So we need to check if packet has layer, and the layer will be called http.http capital and then capital R and then request. So HTTP request. This will perform the function of actually checking if this layer exists in our packet. And what we want to do is actually select the HTTP request packet to be equal, the URL to be equal to http request.host. So the host is the target that the user is trying to send the password and the username to. So we want to sniff that as well with the URL equals. URL is the variable that will specify the host to be in. So packet from the http.http request. And we want to take the field called host field. We also want to take the path, since we actually want to get the path to the page where they are logging in. For example, some pages can have multiple login forms, and the multiple login forms can be stored on different paths. So we will also want to get the path, which we can do with the packet and open and close brackets http.http request, and we want to get the path as well. So the path, once we do that, basically we can print the URL. So print it just like this, print URL. And all we want to do is now check if our SCAPI or our packet has the layer scapi.raw. Now, you might remember that layer from before. Once we actually send the self-crafted TCP packets with the load field containing our message to the target, once we actually run our SynFlutter, from there you should know the layer, and in this case that layer will contain any username and password that the target might specify. So let's see how we can do that. We can check that if packet.has layer scapi.raw, and from that raw layer, since the raw layer only has one field, and let me show you in case you forgot, if you open Scapi and you just type ls in the brackets raw, you can see that the raw layer only has the load field, which will contain the message. So let us exit this, and in our case it will contain the username and password. So open this up where we stopped. Let me just go back to right here, and then we press the .load for the actual username and password being stored there. We want to check for the actual keywords. Now the keywords are basically something that we are searching for in this raw layer. So we can specify them right here. Or we can just go down here, it doesn't even matter. We can just select the words to be equal to the open and closed square brackets. And there we can specify what we are searching for. We can search for password, username, basically anything that you might actually encounter in that field. As capital user and so on, it doesn't even matter. We'll just specify this for now on. Let us also add the capital password. This is our words list, which is containing the words that we're actually expecting the raw field to have once someone tries to log in somewhere. So all we have to do right now is actually iterate over these words and check if any of those words is in our field right here. So let's first of all add the two dots right here. And all we want to do right now is actually select, or pardon me, we don't want to actually select the .load right here. We only want to select scapi.raw, and we want to select the load to be equal to the packet in the square bracket scapi.raw. and then .load. Since we don't really want to specify all of this always, so we just put that in one variable so we can actually navigate more easily. And then for some variable I in words, which is our list that we created previously, we want to check if I is in string from our load variable. Make sure to specify string right here, otherwise this will not work. Specify 2 dots, and we want to print load. So let us actually check out what we just coded right here. If we first of all check if this packet has layer raw, which will contain usernames and passwords. If it does, we select the load field from the raw packet, from the raw layer, to be stored in our load variable, and then we iterate over this words list right here. In case any of those words is in the string of our load variable, we will print the load. And then after that we can actually break from this actual loop. Let me just go right here, since we sniff for the packets. So all you can do is first of all check if this is running, so chmod sniffer.py, run the sniffer. As we can see, everything works well enough, and all we have to do is actually just find the HTTP website on which we can sniff. So we can go to our actual fake Facebook page. Let me just see. Let's open it like this, so we can see everything good enough. And here, let's specify, for example, this and some random letters. We click here on login. For some reason it didn't catch it. Let us try another page. So let us try, for example, my router, but I'm not really sure it will work on router, but let's give it a try, why not? So let's see, we got an error, so that is actually good. So we know something is wrong. I mean, it's not good, but we know there is some error somewhere. So first of all, instance method object has not attribute get item. So let's check the line where the actual error is. If packet has layer escape.raw, so let me just go to my sniffer in order to see whether that was a mistake because we tried to connect to the router or something else. It could be just because of the router, so nothing really to worry about. If packet has layer, okay, so we actually need to specify this in the actual normal brackets. I just noticed that we specified it in the square brackets, which we really shouldn't do that. So make sure to change that. We need to make sure that here is specified if packet.has layer, and in the normal brackets escape.raw. And then also, let me just check down here. This should be like this, so this is good. This didn't work since has layer is a function, and a function can't really have an argument specified in the square brackets. So let me save this. Run the sniffer once again. Let me cancel this and reload the page. Okay, I reload the page, we get the IP address. I type something randomly, click here OK. But we can't seem to really get the username and password. But once again, that could be just because of the actual router and not because of the program itself. So let us try something else. It doesn't seem to work, but this actually redirects us to the HTTPS, so that could be the problem as well. Now, I don't really know any HTTP website that we can test this on. Basically, if you know one, you can just try this and test it and check out if this will work. Now, I believe it will work, even though I don't have anything to test it on. Let me just enlarge this and see if there is any other problem in the code. So nanosniffer.py. Everything should be correct. We have our words list over which we iterate. It prints the URL once it sees that we actually get the HTTP website. It checks if this packet has this layer right here. Then it prints the load. So for me, if you ask me, this should actually work on an HTTP website. Don't really see any error, nor we get any error while trying to run the program. But I don't really have any HTTP website to test on, as I said, so if you have, make sure to test it and feel free to comment whether you got it to work or you didn't, so we can actually update this video and get it to work. So hope you enjoyed this tutorial, and I hope I see you in the next lecture. Bye! Hello everybody and welcome back, and in this tutorial what we'll do is we'll actually code our DNS spoofer. Now, Now what a DNS spoofer is it is basically a program that will actually change the location of a certain IP address to a different location that we specify. For example, let's say the user wants to search google.com, or basically it will not work on google.com, this will only work on the HTTP websites, since the HTTPS websites are encrypted and we cannot really get the data from the DNS packet. So therefore, we cannot really redirect that actual site to a different website. But on all the HTTP websites that the target visits, what we can do is basically redirect them to a different website that will either be our fake website hosted somewhere else, or our fake website hosted on the Apache 2 on our Kali Linux machine. So what you can do, for example, is first of all, let me show you. In order to start up your Apache 2, you can just type service apache 2 start. And basically all you have to do is visit your IP address. So let us go onto the Firefox. And before we actually do that, let me check my IP address. My IP address is 192.168.1.9. And all you have to do is type that in your Google search bar. So you just basically type 192. Let me just leave these to load till the end so we don't get this slow Firefox. Restore, we don't want, we want to start a new session. And let me just remove this and type the IP address of my Kali Linux machine. Now this can be accessed by anyone on the local network. So for example, if you were at a cafe and basically someone else typed this IP address into their Google search bar, they would be able to access this page since you started your local web server, which is running on the Apache 2. And here you can specify any page you want. This is the Apache 2 Debian default page, as it says right here. But here you can actually copy any website. So let me just show you how you can do that. You can basically just go to the facebook.com. What this will do is it will open the Facebook page. So let us wait for that to finish. It opens the Facebook login page, and all you have to do in order to copy this page is you can just right click on it, go to the save page as. You click on the save page as, then it will save this page also with the files such as these pictures and so on that it needs to load. You can save it anywhere you want. I will save it in the downloads by default. So save. As you can see, it finished saving it. It actually completed. Now all we want to do is go to our terminal, navigate to the downloads, which is in the root. So my terminal is not working. Okay, so here it is. Change the directory to root and then downloads. And there you can see you have two files, which is the Facebook login signup files and the Facebook login signup.html. So in order to actually host the Facebook login page on your local web server running on Apache 2, you need to actually copy these two files to the Apache 2 folder. Now the Apache 2 folder is var/www/html. So this is the path where you need to specify these two files, or where you need to move these two files to, in order to actually host the Facebook page. So all you have to do, first of all, is delete all the files from that page at the moment, which in my case are these two files. So all I will do is just remove the index.html and remove the index.ngix Debian HTML. And all I want to do right now is move these two files to this directory. So I will move root downloads and then Facebook login signup. I just basically, if you don't know how to specify this name, all you can do is just tab. So you can just tab, and then it will by default select that name of the file. But in case you have multiple files, that will not work. So I'll show you how you can actually rename the file. So go to your downloads. You want to move. So move, and then the Facebook login or sign up, and then you want to actually move it to the Facebook -r. Let me just see. Okay. No such file or directory. So let me just double check this. Okay, so move, and then you basically, it will by default, when you press this, all you want to add is .html and move it to facebook.html. And if I just press ls once again, my HTML file has been actually renamed to the facebook.html. All you can do is the same with this part right here. So in order to rename it, just press move Facebook, and then it will, once you press tab, it will say it will by default specify the rest of the string, and you want to move it into basically just Facebook. And then you have these two folders, which then you can move to the actual folder where we need them. So first of all, we will move the Facebook directory. So we will move it to the actual /var/www/html. We move the Facebook directory, and we also want to move the facebook.html to the /var/www/html. We press ls, nothing here. We go to the /var/www/html, and we have these two files right here. But you will notice that if you, for example, now try to refresh the page of your actual Kali Linux web service, so 192.168.1.9, you will still have this right here. Well, basically not really sure why we still have this, but here, okay, so I refresh the page, we get our two files that are right there, but it is still not actually putting a page up here, a Facebook page up here. In order to actually put the Facebook page up there, what you need to do is rename this facebook.html file into index.html. Since the Apache 2 web server on Kali Linux can only reproduce the page once the main HTML file is named index.html. It cannot be named anything else, so let us do that. So move facebook.html into index.html, and once again, if you reload the page, let me just see why it looks like this. Actually, I have a really good idea why it looks like this. We really shouldn't have renamed the directory, because right now, since we renamed the directory, it actually can't load any other pages or anything basically else from the directory, since it is trying to actually open a directory with images that is named differently than this one. So let us see how we can fix that. We shouldn't have renamed it, so remove Facebook directory. And let us actually download this once again, so save page as. We will save it under this name and we will not rename it, so click save right here. It is saved. And all you want to do is move the directory, so move from the root downloads Facebook to the actual, let me just specify it right here. So /var/www/html. And we need no such file or directory, so let me just see. Sign up. Okay, so sign up files. You need to specify the entire name. As you can see, since there are two files right here, you need to add the underscore files, and then we can move it to the /var/www/html. Okay, and in our var www.html folder, we now have the Facebook files and the index.html. So all we have to do right now is actually refresh this page. And since the name is correct, you can see right now we get a normal Facebook login page that is same as this one. Just right here, for some reason, we are missing the Facebook sign right here, but it doesn't even matter. We get the Facebook page login right here that we can use to redirect the users to this page, for example. So, for example, if user wanted to visit some HTTP login page, you could actually redirect them to your fake login page right here, where after they specify some username or password, you can sniff their packets. So as you can see, once they actually specify the wrong username and password, they even get redirected to the real Facebook page. So this was basically a tutorial on how to actually copy or how to actually clone a page and host it on your own Apache 2 web server. Now once again, make sure that your Apache 2 is running, so you can check if it is running with the service Apache 2 status. Then it will print out it is active and running. In case it isn't, all you need to do is just service Apache 2 and then start. And this will start the Apache 2 for you. Then you need to copy the page that you want to fake onto the /var/www/html folder. And basically that will be about it. Next thing we want to do is actually redirect the users to that page. So we will do that in the next video. Hope you enjoyed this demonstration on how to clone a Facebook page. You can do that for any page you want. The process is exactly the same. And we will code the DNS spoofer in the next lecture. Hope I see you there and take care. Hello everybody and welcome back. And in the previous video what we saw is how we can clone any page and run it on our web server running on Apache 2. So right now what we want to do is we actually want to make a program that will be able to redirect users on the local area network to our own website. So let us check out if we still have it in the var/www/html folder. Here, if you type ls, you should have the index.html, which is the main HTML file for the page. And in this directory right here are all the necessary files in order to make the page look the same as the original Facebook page. So here are the pictures and other links for the redirection and so on. But before we do that, let us open up our Skippy. So we will open Skippy, and what we want to do is actually ls the DNS packet in order to see what are the actual fields of our DNS packet. So we can see there are a bunch of fields right here. The fields that we are mostly interested in would be this AN field, which is basically the answer field. This field right here will contain the answer to the DNS request, and that answer is something that we want to change in our DNS spoofer. For example, if a user searches for the some HTTP websites, the real answer of the DNS will contain the IP address of that HTTP website. Now we will sniff that packet containing the IP address. We will change the IP address to the IP address of our Apache 2 web server. For example, you can change to any IP address you want. It doesn't have to be our own Apache 2 server. And then we will send the packet or forward it back to the user. Then they will get redirected to the actual page that we want them to visit. So let us see how we can do that. But before we do that, let me just change my directory to root and then to the Python programs in the local network programs. And let me just zoom this in so you can see everything good. Clear the screen. And let me nano first the dns.py program. Now this program will show you how a DNS request look like and what happens once we visit, for example, or once we open up our Firefox. Now let us write a short program. So user bin Python. We will from skippy.all import everything with the star. And what we want to do is basically just sniff the packets, and we want to find the DNS packets. So in order to do that, what we will do is we will add the prn for the equal to the function that we will code right now. The function we can name the find DNS. So that is the name of our function. And what we will paste to this function is the packet. And then with this packet, what we will do is we will actually check if that packet has a layer containing the DNS. If it does have a layer containing DNS, we will print that packet and see how it looks like. So let us make that function right here. We need to call it same as we called it in the sniff part right here. So find DNS, and the argument for that function or the parameter for the function will be just p. That will be equal to our packet. So let's add the two dots at the end so we know that this is a function. And what we want to do is, as I said, we want to check if this packet has layer DNS. Now we can do that with a simple function called hasLayer. You just type if p.hasLayer, and in the brackets all you need to specify is the name of the layer, which in our case is DNS. So then two dots. What we want to do is just print the packet. So let us do it like this. Print p for now on, and let us see how this will look like. So let's save this for a moment, make it an executable, and run it. Now you can see everything is running. All we have to do right now is visit our Firefox, and let's see what we get printed to our screen. So let's wait for our Firefox to open. As soon as it opens, we should be getting some packets flowing around here. As we can see, we are getting packets, for example, the tech portal. You can see there is a bunch of gibberish right here. Some of the things we can't even read. Most of them are encoded. So let us see how we can actually extract useful things from these packets flowing around. Now these are just a bunch of the packets, DNS packets, that the Firefox performed the DNS requests in order to load this page right here. So let me just close this page, or we don't need to close it, we will just refresh it later on. Let us close the program. Let us nano it once again. So we actually print some useful things. So what we can do, we know that the DNS layer must have the IP header in it, so we can print the source from that IP header. For example, if you just specify the print and then IP in the square brackets and then dot source, what we will be printing is the source from the IP header. We can also print next to the source, we can print the DNS summary. As we can see, let me just show you, if I just do like this, DNS and dot summary, which is a function, what this will do is it will retrieve the IP address and the source or the link that we actually needed to visit in order to get the DNS request or response back. So let me just show you. If we just run the program once again, dns.py, and I go right here and refresh the page once again, you can see right now everything looks a lot prettier. We can see the DNS queries that are being sent and from which IP address are they being sent to. We can see these are from our Kali Linux machine, which is .1.9. These are from our router. These are the websites that we actually want to visit, and for some websites, when it can't really resolve the host name, it just prints the IP address. So we can see this is the page that we actually visited. If you, for example, just type the Firefox right here, no, pardon me, not Firefox, facebook.com, and we lower this. Let me just say it right here. You can see it performs requests to Facebook domains, as we can see. Also some other IP addresses. Also for some reason GitHub, not really sure why is GitHub there. And here is the DNS query for the facebook.com. So we can see how the packets look like. What we want to do right now is actually change the answer in that packet. So we saw that there is an AN field in the DNS packet and we want to change it. So in order to do that, let us code a program that will do that for us. So first of all, let us nano DNS spoof.py, and we will start off with our usual line /user/bin and /python. So we will need to import a library that we haven't encountered before. It is called netfilterq. Now what that library allows us to do is actually make a queue number from our IP tables in order to be able to forward the packet and in order to be able to change the packet while the user is sending them. Now, in order to import it, you can just import netfilterq. Before we do that, let us check out if it comes in Python 2 or 3. So import netfilterq. There is no netfilterq in Python 2. If we just check out Python 3, import netfilterq, we can see it's not even in the Python 3. So let us actually get it or basically just download it with pip install. So let me show you how. Pip install netfilterq. We just read this run, and what this will do is it will download the library that we need for our Python program. So it's saying collecting netfilterq. Soon enough it should probably, or if it doesn't work, we'll just try for Python 3, but it should work for the Python 2 as well. So it is still collecting it. We can see it is downloading it right now, and once it finishes downloading it with this command, failed building will, okay, so it failed building for some reason. Command user bin. Let me check if it will work for Python 3. It's saying collecting netfilterq. Hopefully it will work for the Python 3. Okay, so it is downloading it, but for some reason, once again, this says failed building will for netfilterq. So let me just check something out. Python 3, import netfilterq. Okay. Now what we will do right now is we will actually switch on to my laptop Linux machine. Now don't worry, everything will be the same. Just right now I need to switch to my Linux machine, and there I will show you how we can code this program that we need. So let us switch right now. Hello everybody and welcome back, and sorry for cutting this tutorial. Now I had to switch to my laptop in order to show you this, since my Kali Linux machine couldn't really recognize the kernel as being Linux kernel. Now, and there is a library that we need to import in our DNS spoofer program in order to get this to work. Now the library is called netfilterq. Let me just show you how we can install it. You can install it with this command, pip install netfilterq. You let this run and it should install the netfilterq library for you. Then we will be able to actually use this program, or basically to run this program once we actually code it. So just let this run. What this will do is it will install the library for you. If you want, you can actually use the Python 3 version as well. So for some reason it's getting an error. Okay, so let us try with Python 3. So pip3 install netfilterq. It gets the same error, but if I run Python import netfilterq, it is actually being imported, so don't worry. This error is something that I encountered before as well. So all we have to do right now is nano our program, which we will call dnsspoof.py. Let us start off by actually putting our usual line, which is the hashtag and then exclamation mark / user bin Python. And after that we want to import two libraries. One of them is our netfilterq library and the other one is scapy.all library. So import netfilterq and we can import scapy.all as scapy. So simple as that. What we want to do right now is actually make our queue, which is actually used in order to make a queue number from the IP tables. What this will allow us to do is actually sniff the packets and redirect them, or redirect the users to our own web server. So what I will do right now in this program is I will redirect the users to the web server on my Kali Linux machine, which is running at the moment on my main PC. And what I will do is in my program on my laptop currently, all I will do is specify the IP address of my Kali Linux machine. So don't get confused, I'm using the web server Apache 2 from my Kali Linux machine in order to redirect them to the fake Facebook page that we created previously. So in order to create the queue which I was talking about, you just need to specify this command. You can call it queue equals netfilter, which is the library that we installed, netfilterq.netfilter. And make sure to specify the Q right here capital, since this is a function and it will not recognize it if you put small letters. And all you want to do, since you added the object to this Q variable, you need to bind it. So Q.bind, and in between the brackets you need to specify the Q number, which we will specify to be 0 right now. And what we will do is we will actually process packet. Now the process packet is a function that we will code in order to change our packet and redirect the user. So let us call it process underscore packet. Close the brackets, and all you have to do is run the queue. So queue.run and open and close brackets without any parameters based to that. So all we have to do right now is actually code the function itself. We can do that with our def command. So let us make a function def process packet. Once again, make sure you call it the same as you called it in the bind statement right here. And all we want to process is the parameter packet. So we want to actually use a packet and make changes to it in order to perform our task. So what we want to do first of all is actually get the payload from that packet, since that payload is something that will actually contain the DNS request or the DNS response. In order to do that, we can use a function called getPayload, which will allow us to get the payload from a certain header that we will specify. So let's call the variable that we want to put the payload to scapy_packet. Scapy_packet equals scapy.ip, which is the IP header from our packet, which must be there if we are waiting for the actual DNS response and request packets. And all we want to specify between the bracket is the packet that we are using, which is this packet right here, and the function .getPayload, so packet.get_payload. _payload, open and close brackets, since this is also a function, and here we specified our scapy packet to have the payload from the received packet. Now if you want to, we can actually just print the packet itself, so just to check it out, so print scapy_packet, and let us see what will happen. So let us run this, chmod +x dnsspoof.py. Let me just enlarge this so you can see a little bit better. Zoom it once again and run the packet itself. Okay, so we ran the program, and if I just go and refresh this Google page right here, nothing happens. But if I go to a certain website, for example, we get nothing printed out yet. Okay, so let us actually get something to print out. Let me just close this right here. Nano the DNS spoof. And let me check this out right here. Okay, so the next thing we want to do is actually check if our packet has a layer for the DNS request or response. So how we can do that? Now, I just noticed that we got disconnected from the internet, and the reason is probably these 3 lines right here. So there is a certain thing that we need to run in order to get this to actually work. That's why we couldn't print any packet. You need to actually create this queue, you need to flush your IP tables, and you need to forward some of this stuff in order for this program to work. But don't worry, we will do all of that later on. For now on, all I want to show you is actually how to create this program, and then we will be running it. So print scapy.packet. What we want to check right now is if this packet has layer DNS. So we can do that with the if our scapy._packet dot has layer, which is a function that we used in the previous video. And the layer that we actually want to get right now is the DNS response. So it is much better to actually intercept the DNS responses than to actually intercept the DNS request. So it was much faster. So what we want to actually get is the DNS response. Now, in order to specify just the DNS response, in the brackets, all you need to type is scapy.dnsrr, which stands for basically response. Now, the DNSRQ stands for the request, but make sure to specify in the capitals DNSRR for the actual response. And now we need to type this or to tab this, and in order to get the query name for our actual response or request, we can just put it in a variable. Now the query name is basically something that the user typed in their Google search bar. So let me just show you. If you, for example, go to the Firefox and you just type facebook.com, that will be a query name which will be specified under the queue name in our DNS request. And then what we want to check out in our program is actually if there is a certain web page in that query name. So first of all, let us put it in a variable called queueName equals scapy_packet. So from our scapy packet, let me just write it correctly. So scapy_packet. From the DNS request, so DNSQR, which basically stands for the DNS request. What we need to get is actually the field queue name. So let us type it like this. If scapy packet has layer scapy DNS response, the queue name will be the scapy_packet from the request queue name. We are looking for this field, so let me just show you. Let me save this and open Scapy for a moment and just type the ls DNS. Let me just see if it is there. Okay, the DNSRR will be the DNS response, and in the DNS request, DNSRQR, we have the query name, and it even gives the example for it to be, for example, via www.example.com. Now right here can be specified any actual website, it doesn't have to be this one. So let us go back to our DNS buffer. We made the query name, and all we want to actually check right now is whether we have the actual name of the website that we want to redirect in this query name. So for example, in this case, what I will do is I will redirect this website right here. Let me just show you in the page so you can actually check the website itself. The website is actually this one. So what I will try to do is I will try to redirect this website right here. So let me just close this for a second and check if that website name is in the query name. So we can do that if this website name is in query name. Now once you test this program, make sure to specify the website that is over HTTP, otherwise this might not work. Or you can specify a website that is HTTPS if you're running the SSL strip and if the website is vulnerable to the SSL strip. So any other website that is running over TLS encryption will not work. So for example, if you specified here facebook.com or twitter.com, it would not work. So what we want to do right now, if this name is in our query name, that means the user actually specified this in their browser and they want to browse for this actual website. But we want to actually change the answer from that website and change the query name to be the IP address that we want to redirect them to. So we will make a variable called answer, and that answer will equal to this scapy.dnsrr, which stands for the response, and the RR name, which is a field in the DNS response. So let's specify it, will be equal to queueName, and the R data. So what we are doing right now is basically we are intercepting the request from the user, and then we are sending our own response back. and our data will be equal to the IP address of my Kali Linux machine, which is 192.168.1.9, which hosts the fake Facebook page. So let me just run the Apache 2 on my Kali Linux. Apache 2 start. Now once again, in order to start Apache 2, you just need to type service Apache 2 start, and what this will do is it will start the Apache 2 web server for you. So let us go back to our program, since that is something you should already know. And what we want to do right now is actually in the DNS packet change the AN field, which I showed you right here. So if you just type ls-dns, you will have the AN field, which is basically the answer. We want to change it to be the answer that we right now specified or changed. So let us do that. Let us make that to be equal to the actual answer that we coded right here from this variable. So skp_packet, the field from skp.dns, and then the field from the DNS, which is AN, will be equal to our answer. And we want to also change the number of answers, so sometimes some website page can have multiple answers, and sometimes the DNS response will send all of those answers back. For example, you can access, for example, Facebook on different IPs because there are more servers, and then the DNS response will send most of these answers back to the user. What we want to specify is that the number of answers will only be one, which is the one that we specified, and we can do that with this command. So skp_packet, the field skp.dns .an count, which stands for answer count, will be equal to 1, which, as I said, specifies the number of answers to be equal to 1. And all we want to do after that is actually set the skp_packet at the end to be equal, or not to be equal, we want to actually send the packet, or before we send it, we want to set the payload that we actually made right here. Or let me just delete this, so it's not the skp_packet. As we can see right here, we are processing packet, and we just named this skp_packet, which only has this payload. What we want to do is set the packet variable, or the packet, and set the payload with this function right here to be equal to the string from the skp_packet. So what we did right here, we took a normal raw packet, you took the IP field, we took the gate payload from that IP field, we checked or changed the DNS response, we set back the payload to be our changed DNS response, and what we will do right now is we will actually, let me just go right here, we actually want to send the packet. In order to send it, you just type packet .accept, and what this will do is it will forward the packet that we actually changed in this function. But before we do that, we actually want to change a few more things, since if I show you right here, if we go right here, let me just check this out. Open up my skp and ls the IP header. You can see that the IP header, which is a must header for the actual DNS request and response, has some fields called length and the checksum. What these fields do is basically they check the length and the size of this packet, and then they send the packet back to the actual user. Now, if the length and the checksum are actually different from the actual packet size, this packet will get dropped and our packets will not work. This is a security measure, so the user can make sure that no one interfered with the actual packet. So the packet will get dropped in case the length is not equal to the length of the actual packet. So what we need to do is actually delete these two fields from the actual packet that we are sending back to the user that we actually changed. But we will do that in the next lecture. For now on, we just change the packet. All we want to do in the next lecture is make a function which will delete unnecessary fields in our skp_packet. So hope you enjoyed this tutorial, and I hope I see you in the next one, where we will actually test our DNS spoofer and where we will do some of the minor changes to it. Hope you enjoyed it, and I hope I see you in the next tutorial. Bye! Hello everybody, and welcome back to this tutorial, and let us continue with coding our DNS spoofer. So in the previous lecture, what we did is we actually coded the process packet function, which took the request from the target, and then it checks if there is a certain website in the query name from the target, and if there is that website, we perform the redirection to our Kali Linux Apache 2 web server. So before you do anything right now, make sure that your Apache 2 web server is running. You can do that just by visiting the IP address of your Kali Linux machine, so 192.168.1.9 in my case. I go right here, I have my fake Facebook page right here, and I want to redirect the users to there. So let us nano our DNS spoofer. As we said in the previous video, before we actually run anything, what we need to do is make a little bit of changes to our skp_packets so that the target doesn't recognize that someone actually changed some of the fields in the packet itself. So what we will do is we will add right here, since before we actually set the payload, we want to make the skp_packet to be equal to the actual packet where we delete the field. So we will call the function del_fields, and we will parse to that function the skp_packet. So you will call this function right now, and we will paste to it the packet itself, which only consists of the payload from the IP header, which will actually be the UDP packet, since the UDP and since the DNS responses and requests are being sent with the UDP protocol. So let us code the function right here, def del_fields, which will take this skp_packet as an input. And all we want to do is actually check the UDP and IP header, since if we open up our skp and we ls the DNS, we can see there is nothing really important or that important to us, as the DNS packet itself is something that we changed before. But if we just look the IP header, as I showed you in the previous video, there are these two values, length and checksum, which we actually need to get rid of in order to send the actual real packet, which will not prompt users, or not prompt users, which will not drop because the length and the checksum of the actual packet do not match. And also in the UDP field, we have the length and checksum, so we know that the DNS is running over UDP, so we also need to delete these two values right here. And we can do that with simply using the del command in the Python 2. So let me just show you. Del fields, what we need to do is actually delete and specify what we want to delete. What we want to delete is skp_packet. From the, first of all, let's use the from IP header, we want to delete the .length field. Also, we want to delete the del skp_packet. From the skp.ip header, we want to delete the checksum, which we specify like this, so chk sum. Now, what we want to do is first of all copy these two lines right here, since we don't want to write them once again, and we could just paste it right here. And all we have to change is this IP header to be UDP, and in the fourth line also to be UDP. So we deleted all the unnecessary fields, and right now we can actually try to run the program, but before we do that, we want to return this skp.packet from our function. So return skp_packet, and that should be about it. Oops, skp_packet. Let us save the program. So program should be good to go. We made a function del fields, we return it to the skp.packet, and then we set our packet to have the payload from the string of the skp.packet, which will not consist any of these fields, and which will also have the query name to be specified for this IP address, which is our Apache 2 web server. So let us save this. Let me go to the commands where I saved them right here. Python 3. These are some of the or not backdoor, DNS spoof, cat DNS spoof.txt, or let us nano the DNS spoof.txt. Now, here are the commands that you need to run before you actually run the program itself. These are some IP tables rules, which will create the queue under the number 1, which is specified in our program, which will allow us to run our code without any complication. So first thing we need to do is, as you can see, we need to first flush the IP tables. So let me just cat it right here. Oops. Cat DNS spoof.txt, and just run the same commands as I do. So first of all, IP tables -- flush, which will flush our IP tables. Now we want to forward the queue, so for IP tables, capital I forward, and then -g nfq, and then the queue under the number that we specified, which in my case is number 0. If you specified any other number, make sure to specify it right here. So --q -number or just num and then 0. And we can copy these other functions so we don't actually type them. Just copy paste. You will need to type it since you're actually typing it for the first time, and make sure to actually save all of these functions to a text file so you don't remember, so you can have them anytime you want to run this program, since there is no point in actually remembering all of these commands. So we run everything like this, and what I want to go is I want to go to my desktop and run my dnsspoof.py. Let me just see, failed to create Q0. Okay, so what I will do is I will close my terminal. I will open it once again. What I will do is I will run all those 4 commands once again, so I don't actually get error second time. Okay, and now if I try to run the program, it is running, and all we have to do right now is visit the page that we specified in our program. Okay, so I forgot to specify to not print the packet, but it doesn't really matter. What we want to do is open the page. Let's first see if we can connect to the internet. Our program is running. We can see it is printing a bunch of random stuff. If we try to visit a page that we specified in our link, so this page is the page. We click right there, and you can see we got redirected to the fake Facebook page that we are hosting on our Kali Linux Apache 2. And even if the user, for example, specified wrong information right here and clicked on login, what they would do is they would actually get redirected to the real Facebook page telling them their password was wrong, even though it probably wasn't. So first of all, we know that our program works. The next thing we want to actually fix is the printing. So we don't actually want to print anything, so nano your DNS spoof, and just either hash this or just delete this line. Since we don't really need it, we don't want to print that. And right here you can specify any IP address you want. For example, let us see the IP address of the actual facebook.com. We can do that with the nslookup, facebook.com. And currently I'm probably having problems because I ran the queue. So let us close the terminal. Open it. So this is the best way you can actually restart everything. Let me enter my root mode once again, go to my desktop, enlarge this so you can see it a little bit better, and check the IP address of facebook.com. Okay, so Facebook doesn't work for some weird reason. Let us try a different IP address. For some reason this is not working. Let us try to ping our router in order to see if we are actually connected to the internet and can send the packets. Maybe we are having a problem, which is normal once you run these programs that actually interfere with your IP tables, with your connection. Sometimes you will get disconnected, especially when you actually run your ARP spoofers, as they sometimes know to kick somebody off the internet, and that somebody is most likely always going to be you and everyone else on the local area network. So let us see this. Let us actually restart Network Manager, and we can do it with service, Network Manager, restart. Just crashed. You're currently in the fallback mode. Do you want to restart Cinema? Okay, so not really sure what is going on right here. Ping 192.168.1.1. Okay, never mind. We can get this to work. It doesn't even matter. What I will show you is you can basically just check the IP address of any website you want, and you can just specify it in the path right here, which is, if I cat the DNS, which is this path right here. You just specify the IP address of the website you want to redirect to. So that will be about it for our DNS spoofer. Hope you enjoyed it, and we will continue coding in the next lecture back on our Kali Linux machine. Hope I see you there, and take care. Bye. Hello everybody, and welcome back. And in this lecture we will start by coding our advanced packet sniffer. Now by packet sniffer I mean some tool that will perform the network analysis for us on our own machine. So this is not something that you can actually use in order to hack something or brute force something or do something like that. But I found this program because I actually had it for a long time right now. I don't even remember from where I got it. It's been sitting on my laptop for a few years, and it is a really good program in order to get in order to understand the packets on a more detailed and on a more advanced level. So this is for sure not a program that will code for the beginners. So if you're not so if you are a beginner, make sure to actually get everything else done, then you can come back to this. Also, you will need to do some actual learning on the side here and there. I already have the program right here on my laptop. We will code it together for the best practice, and I will explain everything as we go. What this program will do is it will actually run an analyzer of all the packets that we receive. It will split them in fields. But you might be asking right now, aren't we doing that all the time in the previous section with the actual Scapy library? Well, the thing is, right now, we will not be using the Scapy library. We will be doing everything manually and trying to get the packets and fields and all the necessary things printed out by ourselves. We will not use some library that will help us do that. All we will use is the socket library, which is low-level networking or low-level network programming. So let us start off by actually calling this program. We will call it, for example, packet sniffer. So let me just go out of my local networks and let's make a directory packet sniffer, since this will most likely be the biggest program that we will actually code from now on. And let us call it, so go to the packet sniffer, change the directory to the packet sniffer, and right now, since we call the directory packet sniffer, we can call this sniff packets.py. We will make user bin Python. Now this is not really a sniffer that you can sniff the usernames and passwords. As I said before, this will give you an in-depth knowledge of actual protocols, the protocol fields, the Ethernet headers, IP headers, TCP, UDP packets, and so on and so on. So first thing we want to do is first of all import the necessary libraries, and as I'm seeing right here, we will need 4 of them. So one of them is the socket library. We can import it with the import socket. We can, we'll need 5 libraries. So also we will import 2 libraries that we didn't use before, I believe, which one of them is OS and one of them is the sys library. The next thing we need to import is the struct library, which will allow us to actually separate the fields of a packet that we receive. As you remember, previously we saw the struct library table, which allows us to actually specify the number of bytes we want to take in a certain variable or something like that. We will be using that right now extensively. And also we want to use the bin ASCII library, which you specify with the actual $I. So first of all, before we do any of that, let us check out if we have all of those libraries in our Python 2. Import bin ASCII, it is there, import struct, import OS, sys, and import socket. So these are all standard libraries, so you will actually probably all have them. In case you don't, you can just run a standard pip install and then the name of the library, but you will not need to for this program. Now I must admit I don't really remember what this bin ASCII library is for, but once we get to the actual function from the bin ASCII library, I'll make sure to tell you. So first of all, what we do in this program, we will create a main function which will perform the entire process, and it will call some other sub-functions which will actually analyze different types of actual packets. So for example, we will have a function that will analyze Ether header, we will have a function that will analyze the IP header, the TCP and UDP also header. So first of all, we want to create the global socket object, which we will use since we will use it in every other function as well. We need to set it to be a global variable, so call it global sock_created. And you also want to create another actual socket, which will be global sniffer socket. So it will be a global variable as well. So make sure to specify global before giving it any value. And what we want to do is actually, first of all, make our sniffer socket to be a socket object, and we can do that with if sock_created equals to, for example, false. Now you might be asking, why are we setting it to be equal to actually false? Well, before we actually call this function, what we want to do is before the main function, we want to specify that the sock created, so sock_created, will be equal to false, and the sniffer socket, we called it like that, will be equal to 0. So we said the sniffer socket will be equal to 0, which it means we didn't actually set the socket object yet to this variable, and the sock created will be equal to false, so we can perform this this part right here. So if sock created equals to false, it will perform something in the if loop. Since it is equal to false, we will code the part that will perform for sure. So let me just tab this till the end. And what we want to do is actually make our sniffer socket to be a socket object. We will use socket.socket, and in there we will use socket.pf_packet. We will use socket.sockRaw, so we can use actually the entire raw packet, and we will also specify an option socket.htons, and in there 0x003 or 0003, pardon me, I always forget 10. So what you want to do right now, what this means is what we want to do is take the entire packet and we want to do what we want with it. Basically the 0x003 will be the Ethernet packet which we will then analyze in more depth for the IP headers and other headers as well. Now what you don't want to do with this actual socket is you don't want to perform the bind function, since this is an actual raw packet or raw socket, however you want to call it, and it should not be bind to any specific port. So we are not going to perform the bind function. All we want to do right now is actually set the sock_created to be equal to true. So we successfully set our sniffer socket to be equal to this socket object right here. We set 3 different functions to it, and after that we set the socket created to be equal to true. All we want to do right now is receive any data from our ports, which we can do with data_receive, which will be a variable that will store the data, and we will run a function receive for that variable. So sniffer_socket, which is the socket object. Oops, not another equal. We want to specify .receive, and in the brackets right here, since I don't think we actually use this function receive, or we might actually use it in the port scanning section, but what this function actually takes as an input is the number of bytes that we want to receive from our actual server or from our ports in this case. So 2048 bytes. That is the number that we want to receive, and after that all we want to do is actually clear our screen, which we can use the OS function, or OS library, pardon me, which we import, I believe, for the first time. This library right here has a function called system, so os.system, which allows us to execute system commands. Between the brackets, all we need to specify is clear, since this is the actual command that we use to clear our screens. And after that we want to use our data receive in order to analyze the further on our Ethernet header. So what we will do is, first of all, we will tab data_receive and IP_bool will be equal to the analyze. Let me just check this out. Analyze ether_header from the data_receive. Now basically this analyze ether header is a function that we will code right now. This is not a function that actually exists. We need to make it before we actually do anything else, and it will store the data, the returning value to the data receive and to the IP bool, which the IP bool will actually take the value of true or false. So all we want to do right now is actually code the function the analyze Ethernet header, which we'll do right here. So def analyze ether_header. It takes an input of data_receive. So, whoops, I can't type. So it takes that value, and first thing we want to set right here is the IP_bool to be equal to false. Now if the function performs correctly, we will set at the end the IP bool to be actually equal to true, and then we will proceed with our main function further on. So first thing we want to do is something that we did in the previous videos, which is actually extracting the Ethernet header. We will use the same command, which is the struct, which is the actual function that we will use from the struct library, which will allow us to actually take the first 14 bytes, which is the amount of bytes that the Ethernet header can store. So we will use a variable called ETH_header, and then we will use the function from the struct library, so struct.unpack. And if you remember, this function actually takes 2 inputs. One of them is the actual pattern for specifying the amount of data, and the other one is the actual data from which you want to take the value from. So first of all, between the double quotes, we will specify the same thing as in the previous videos, which is 6s6sh, stands for actually specifying from the struct tables the amount of data we want to actually extract. Then in the comma, after that we need to specify from where we want to extract it. We want to extract it from the data underscore receive. We want to take the first 14 bytes, which we specify with this right here. These two dots, if you remember, means take everything from the beginning, which is from the first or from the 0 element to the 14th element. So once again, this basically unpacks what we got from our sniffer. Since this is the first success represents the MAC destination, the second success represents the source destination, and these 2 bytes basically represent the protocol attached to the Ethernet header, which we most likely are going to get the IP protocol, which we actually want to get and analyze further on. So this is just us extracting the Ethernet header from the packet. Now what we want to do is actually extract the destination MAC address and the source MAC address and also the protocol itself. So how we can do that? We can just use a variable called dest_mac equals to, and here we will use first time the bin ASCII library. We will use a function called hexlify, which will actually take our destination MAC address and it will turn it into hexadecimal. What this will allow us to do is actually print the MAC address in a different manner than in the previous videos where we actually use the %x in order to print different values of MAC address. Now if you have no idea what I'm talking about, don't worry, I will show you just in a second, but first of all let's define this variable right here with the bin ASCII.hexlify. And in the hexlify, we need to specify, since the destination MAC address will be the first 6 bytes from this 14 bytes Ethernet header, we need to specify it to be Ethernet_header, and we need to specify the first element. As we said, that will be the first 6 bytes. We need to do the same for the actual source MAC address, which we can just store in the actual variable called source_mac. It will be equal to the bin ASCII.hexlify, and this hexlify will take an input from the second element, which will be the source MAC address, so Ethernet_header, and the second element, which will be represented under number 1, and we close the brackets. This is the actual source MAC address from our Ethernet header. All we want to do right now is also select the protocol, so proto will be equal to Ethernet header, and then we need to specify the number 2, since this is the third element, and basically we will specify it to be in the number 8. Now I must admit I'm not really sure why right here we are using number 8. Okay, so basically the 8 will be the IPv4, since we want to actually get the IPv4 protocol later on, since we are analyzing the IP header after that, so make sure to specify it the same as I did with these 2 arrows pointing to the actual 8. And after that, let me just show you right here. We need to take the data to be equal from the remaining data of our packet. So we used the entire packet, we stripped the first 14 bytes, we actually took the different fields from our Ethernet header. As you can see, 3 different fields, each one of them taking the different amount of bytes, except this destination and source MAC address. And what we want to do is strip the remaining data to be equal to the data_receive, and then from the 14 bytes and then further on. Now what we want to do is actually in the next video, what we will do is we will print the statements where we will actually say that this is destination MAC address, this is source MAC address, and this is protocol. Then what we will do afterwards is we will actually set or check if the protocol is equal to the 8, and if it is equal to the 8, that means that it is an IPv4 protocol. We will select the IP bool value to be equal to true. Then we will return the data, which will be set to be from the 14 byte, and we will return the IP bool, which will be set to true, to our main function. And then afterwards we will check if bool equals true. If it is equal true, that means we got the IP header next, and then we will analyze the IP header. So that would be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and let us continue from where we stopped in the previous video. So let us first of all check out what we did from now on. What we did is basically we sought the destination MAC address, the source MAC address, and the protocol, which we got from our Ethernet header. Now we also set the data to be the remaining data with the stripped Ethernet header further on, and what we want to do right now is print all the stuff that we actually got. So first of all we will print something like this. So first few lines, Ethernet header, then remaining lines. So this is just so it can be a little bit prettier. After that, we want to print first the destination MAC address, which will be the strings from the dest MAC variable, and then the source MAC address. So print, and in the print statement, we want to select destination MAC, two dots, %s, and then basically two dots, %s. We just find where the percent is, and then repeat this for the 3 times since we typed it twice. So let me just copy this and paste it 2 more times. Also add the 2 dots between these 2 s's where it is missing. And here we have the actual pattern for the MAC address. So destination MAC, and now we need to add the values to these %s's, which we can do with the % and then open brackets, dest_MAC. We take the first 2 elements, so until the second element, or pardon me, third element, then the dest_MAC from the second to the fourth, dest_MAC from the fourth to the actual sixth, dest_MAC from the sixth to the eighth, and further on, let me just copy this so I don't really type it 2 more times. I will just switch the numbers. So copy, paste, and paste once again. Then I will add the comma first of all so we can separate them. So add comma right here. Also add comma right here and switch those numbers to be from 8 to 10 and from actual 10 to 12. So also close the normal bracket at the end. And if I'm not mistaken, this should be good. So we will be able to actually print the actual Ethernet header or the destination MAC address for now on. What we want to do is copy this entire line, and we'll just switch the things that we need for the source MAC address. So copy it, go right here, let me just go right here, enter and paste. And first thing we want to change is the dest to be to the source. So each dest change to be source, since that is the name of our source MAC address variable. So source, right here also, source, and right here, source. And also right here in the string itself, we want to print not the destination, we want to print source MAC. So everything is good for now on. All we need to specify once again is the actual protocol, which we will use the %HU for actually printing out the protocol itself, which will be a hexadecimal number, which will represent the next protocol attached to the Ethernet header. And then afterwards, if we will check if it is 8, if it is, that means it is an IPv4 protocol, and then we will go to the IP header. So first of all, we need to print it first before checking it. So print protocol, and then 2 dots, we can specify the %HU, and then afterwards we need to specify the % and then the variable which we want to specify instead of this, which is the proto variable. So specify proto. And right now, afterwards, we can actually perform a check function to check if the proto is equal to the hexadecimal. Proto is equal to the hexadecimal of 8. So first of all, not 2, we want to perform 1/8. If it is, however, that means it is an IPv4 and we want to actually print IP bool, or not print, we want to set the IP bool to be equal to true. So this is a variable that we set at the beginning of function to be equal to false. And right now, since this is the protocol, we want to set it to be equal to true. Since any other protocols we do not really care about, for example, if we get the ARP protocol, we will not analyze it since that would take too much of our time. This program by itself is already big enough for us to actually code it in multiple lectures. So all we need to do is check if the protocol is this hexadecimal value or this byte basically. And if it is, it will set the IP bool to be true. And right now, all we can do is return from this function. But not return nothing, we need to return the remaining data, since we stripped the Ethernet header right now, so we are returning only the remaining data, and we also want to return the IP bool value, which will be true. If it is equal to false, we will just drop the packet. So let me go down here to where we finished the actual, okay, so here it is. We called the function right here, and all we want to do right now is check if the IP bool value, so go down here, if IP_bool, that means it will check if it is true. If it is true, we want to analyze the IP header. So data_receive, and then the TCP_UDP. Now make sure to do not confuse this data underscore receive with this data underscore receive. Let me just find it. Where did we mention it first time? So this part and this part is not the same anymore. This function right here that we performed is storing the new data value, which will be the data value of with the stripped Ethernet header, to this variable right here. So right now what we are pasting to this function right here, that we will code in just a second, is just the remaining of the packet without the Ethernet header. So first of all, we will check the data underscore receive and the TCP UDP, which is a variable that we will call in order to check out whether the program will be TCP, whether the packet will contain a TCP or UDP fields. And we will use the function that we will code. So analyze underscore IP underscore header. And we paste to that function the data underscore receive. We close the brackets, and all we need to do right now is actually code the else statement before we call the function. So if IP bool is equal to false, we just want to return, and we don't care about the packet anymore. Since, as I said, all we want is the IP header to be found in our Ethernet header. So right now, all we need to do is code the actual IP header function, or the function that will actually analyze IP header. So let us call it the same, def analyze underscore IP underscore header, and we paste to that function data underscore receive. So first of all, in order to check the available actual fields in the IP header, we can use KP library. Just for a brief overview of the IP header, so you can see there are much more fields in this header than in the Ethernet header. Basically, in the Ethernet header, all we had was the source MAC address, the destination MAC address, and the protocol. And right here, what we have is a bunch of other fields that we also need to cover. So what we need to actually realize is how much of the bytes we need to give to every single field. So let me just close this right here and go to my Python programs and packet sniffer, and nano my sniff packets.py. Right here under the analyze IP header, we need to split the IP header into different fields. So right here, first of all, we need to unpack it. So struct.unpack, and in there, if you remember, we need to specify the actual amount of bytes that we want to actually get from this IP header, and also we want to specify the data receive to be equal to the first 20 bytes. So first of all, we need to specify data underscore receive to be equal the first 20 bytes from the actual data stripped from the Ethernet header. And right here, in order to select that, we need to specify exclamation mark 6H, 4S, and then 4S. So basically what this will do is, if you are concerned about this path part right here, as well as this part right here, also you can just go to the struct tables and check out these values of the code itself. So these are just a bunch of the different interpretation for different values for the actual data that we are parsing to this function. So the next thing we want to do is actually split the IP header into all different fields, but we will do that in the next tutorial, since that will take a little bit more time, so we don't make it too long. And then we will print each of the fields into the IP header statement, as well as checking out for the next protocol that is running, whether it is TCP or whether it is a UDP protocol. In case it is none of them, we'll just select it to be other, and then we will return the data, or the remaining data, that we will actually strip from the IP header after we actually print everything out, and we will also return the TCP UDP as a value for the next function. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to our packet sniffer. So basically what we are going to do now is continue analyzing our IP header. So let me open up our terminal, and in the previous video we started off by actually importing the first line of the function. So let us navigate to Python programs and to the network, or how did we call it? Let me just check it out. Packet sniffer, yeah, very creative. And let us nano our sniff packets.py. Let me enlarge this so everything is good to see. And you can see right here that what we did for now on is, first of all, it's not HRD, it should be HDR for header. And what we did for now on is use the struct unpack on the 20 bytes, which is the actual amount of bytes that the IP header has. So basically we saw the available fields in our Scapia library once again, and all we have to do right now is unpack those fields. Now some of you actually asked a question, now what does this mean right here? So we used it both in this program right here, and we also used it when we actually extracted the source MAC address and the destination MAC address from the previous section. Now basically this is just us splitting these 20 bytes into different parts with our struct library in order to actually be able to more easily split different fields in the IP header. For example, once we used here 6S, this first 6S corresponded to the destination MAC address, so we split it, and we used that 6S in this function right here. The second 6S was actually another 6 bytes, which basically corresponded to the source MAC address, and this capital H corresponds to the remaining 2 bytes, which was the actual protocol that we printed out right here. Or basically we printed out all of these 3 fields right here. So basically what we did, we split the ether header into 3 fields, and we actually corresponded it to this pattern right here. So same we will do right here, but if you notice that our, let me just open our IP header, has a lot more actual fields than the actual Ethernet header. What we need to do is actually use some of those fields. So let me just lsip. You can see it has a bunch of these fields such as version, IHL, TOS, which is basically the type of service, which is not really that important, but you can see that this, for example, version right here has 4 bits, and basically what we can do is just put these 3 into one actual field and then split it up by the bytes, or pardon me, by the bits. So we can try to do something like that. You can see it has a lot more than the previous actual Ethernet header. So we also have the source and destination IP address, which we know from the previous videos. It should be in the IP header, time to live, some different flags, and the length, ID, and so on. So we will have to actually add all of those fields. So let us nano snip packets.py, and let us continue with the first field, which is the version field. So in order to actually represent the version field, we can just type ver, or ver, equals IP underscore header, and we use the first part that we split with the struct unpack command, which will be the first H, which will correspond to the first 2 bytes, I believe. And then what we need to do is correspond it is the version, since first 3 fields of the IP header we will actually place in the one variable, or not in the one variable, but we will actually split it as if it was a one variable, and first 12 and the version we want to actually arrow to the 12, which represents the 12 bits. Now it will remove the other fields from the version variable, and it will shift this version variable 12 bits in order for us to actually get just the version itself and not other fields as well. We are doing this because some of these fields are a lot smaller than the others. For example, in the Ethernet header we didn't have to do that, since actual destination and source MAC address corresponded to the entire 6S part right here. So we didn't have to actually add it to anywhere, and here we actually do have to do that. The next field that we actually want to print out would be the IHL, which will also be the part of the first split part of the IP header, and we can also add it like this, so IP underscore header 0, which responds to the first element of our list that we created with this command right here. Now what we want to do is arrow it to the 8, but not only arrow it to the 8, we want to use a logical expression with this sign right here, which basically ends, and we want to add a byte 0x0f. Now the reason why we are doing this, but first of all let me just put this in the actual bracket, since we need to have the brackets while ending this. Why we are doing this is basically it will take the data from our IP header variable without the version. So we know that the version is actual first field in the IP header, and the IHL is the second field in the IP header. So basically, if we were to shift everything, we would take the both first fields in that actual variable. But since we already have the version, we do not want to have it once again attached to this variable right here. We will end it in order to lose both the field before and the field after the IHL field. So the next one that will be the last part of the first element will be the actual TOS, or if you want to, type of service. Now, as we said before, first three fields belong to the first stage, so this will be the last one. Let me just add it right here, equals IP header, so IP underscore header, the actual first element, which we specify with this 0 in the brackets, and all we have to do is end it with the amount of bytes or bits that we actually have. Oops, not this. I don't want the brackets, we want 0x00ff, which is basically, since this is the last element of our first element in the IP header variable or list, or however you want to call it, we don't really need to do this type of thing right here, since this was the element in the middle, so we actually had to perform some additional logic expressions. Now, if you don't really understand this, basically you can just search logical expressions in Python. It is just some bit and byte manipulation, so nothing really too hard, but for you it might be new. But as I said in the previous videos, this will be one of the more harder programs, if not the hardest programs in this course that we are actually coding. Now, for those of you wondering where did I get this program for, I actually searched it up, and it is actually on the cybersecurity. So there is the example of this program also coded and tested, so you can actually check it out there if you want to. It might actually give even a better and more detailed explanation for those of you who are actually wondering how this is all made. So the next thing we want to actually put right here is the total length of the actual packet. So we will just put that in the entire second element. We're just specifying the 1 in the square brackets, since this will correspond to the entire age right here. So total length once again stands for total length, and the next one will be the IP ID. We can call it like this. This is the ID field in the IP packet, or pardon me, IP header, and it will correspond to the entire actual third, or representing the 2 in the square brackets element. Now after that we have something called flags and flag or frag offset, however you want to call it. Let me just check it out in Scapy. If I said the name correctly, I believe I did, but it's always good to double check everything you're not sure of, since we as hackers don't really need to know everything about coding. Basically that's what I said in the beginning of the course. We are not coders, we do not care about the actual code being well written. All we want to do is for our code to be actually good and able to run. So you can see I was right, the flags and the frag are the next two fields. We can see the bit field 13 bits and the bit and the flags field 3 bits. So what we will do is we will actually use this to our advantage, and since we can see that flags only get 3 bits, we will have to shift it 13 to the right. Let me just double check everything here. Okay, we can exit the Scapy. So we are approximately halfway to our IP packet. Oops, not sniff jokes, sniff packets, but nano sniff packets. And let us add the actual flags variable. Okay, so we will call it just flags equals IP underscore header. The third or fourth element in our list shifted 13 bits. So the next thing that will also correspond to the fourth element will be the frag offset. So frag underscore offset equals IP underscore header, third element, and we want to add it to the amount of bits needed. So let me just find the actual, okay, so here it is, 0x1fff. Now, I'm not really sure if this would actually work with the binary, but don't try it. I didn't really try it. If you would specify binary, I don't think it will actually work, since there is not really a library that will run the binary itself, or that will read the binary itself. I might be wrong, but if you want to, you can actually try the binary instead. So just specifying the hexadecimal values into bits, or into basically zeros and ones. So next thing we want to specify right here would be the time to live. So IP underscore TTL, which stands for time to live, would be the IP underscore header. Fourth or fifth element, however you want to call it, this is the fifth element in the IP header list. And we want to move it 8 bits. Now, since that is not the only actual field that we will use in the fifth element, we also have the IP protocol. Did I just type 8? Okay, so here it is. IP underscore proto will be equal to the actual IP underscore header. and then the fourth or fifth element once again, and we use the same sign for the logical expression 0x00ff. Now, for those of you wondering where I am getting this information from, well, basically, if you want to check out the headers themselves, you can just go onto your Firefox and just type the IP header and see what are the available fields and how many amount of space or memory they actually take. So basically, we know that the entire IP header takes 20, but different fields actually take different amounts, so you need to check that out. IP header structure, maybe we can try something like that, so we can check out the structure of the IP header. We could have done the same with the Ethernet header, but Ethernet header was rather simple, or simpler than the actual IP header. So here it is. As you can see, here is the picture that actually might explain a little bit better for you, or you might be able to understand it in greater detail. So if only it actually opened the picture, IP header format. That is too small to see. Let me just find if they have a little bit of bigger picture. Maybe this is something useful. Not really. Let me go and find maybe this one. Okay, so you should be able to see something right here. As you can see, if I open up the actual program, so you can see the first field, for example, you can see that we actually use the version IHL and TOS as a first actual field that we split with this command. And we can see the version, the header length, and the service type are actually the first three fields, which we actually counted as one while splitting. Then we actually had to do some byte or bit manipulation, logical expressions, in order to get them to in order to get these variables right here to only contain the information from that specific field. Then, for example, the total length was entire one field that we split, so we didn't have to actually do anything with it. We just set that to be equal to the second element in the IP header variable. And afterwards, we continued with all other things as well. So we are currently right now, let me just see, we finished time to live. Here is the protocol and the header checksum. You can actually you can realize that it will actually be the same amount of memory or the same amount of size as the total length. So what we will be doing is we will only use the element from this list, the entire element, to represent the header checksum. So we don't need to do any byte manipulation, or pardon me, bit manipulation. We can call this checksum equals IP_header and the sixth element. So this is actually everything we have to do for the checksum. Now, the next thing which we need to specify is the source IP address and the actual destination IP address. So you can see that it actually takes double the size of the actual, for example, header checksum. And what we represent with this destination and source IP address in this command right here is this 4S and 4S. So one 4S will be the actual source, since that is the first one. So source address will be equal to the socket.inet_ntoa. Now this function will allow us to actually parse the IP address so we can actually print it later on. So all we have to specify in the brackets of this function. Now before I do any of that, let me just show you, for example, once you encounter some function that you don't know, all you have to do is actually just type socket.inet_ntoa in the Google search bar. We're finding that site. Okay, so not www, you just want to search the actual function. Let us actually go to Google, and then from Google we will search, since, for example, since this is actually not working, not really sure why, so socket.inet. Oh yeah, so I didn't really actually want to search since it had a dot, it actually thought it was a website. So you can see it is low-level networking interface, and that function, if you just scroll down, let me just find the name of the function itself. These are a bunch of the functions that are used for the socket programming, so anything you don't really understand or need more detailed explanation, of course not even I, or basically I don't think anyone normal would know all of these functions, since there's too much of them. Now you can know, for example, what some of them represent, but there is really no point in learning all of this. So here it is, inet_ntoa, it says convert a 32-bit packed IPv4 address to its standard dotted quad string representation. So since this is an actual representation of the IP address that we usually see, we want to be able to print this as a string, so that's why we convert it. So in the brackets, it takes an input of the actual IP address, which we can specify if we look like here. If we look right here as the seventh element, but in the brackets we will specify the number 6, and that's all we need to do for the source address. The same we can specify for the destination IP address, so equals socket.inet_nitoa IP underscore header, and we specify number 7 in the square brackets. Oops, 7, and close the brackets here. Now, the last two, which is the options and embedding, we will not cover, so basically we will skip those. All we want to do from this part right here is actually extract the data from the IP header. So let me just enlarge this right now, since we don't really need a picture at the moment. You can see we specify 20 to be the size of the IP header, as well as 14 to be size of the Ethernet header. But once we actually printed all the information, or basically extracted all the information from the Ethernet header, you can see we actually stripped the data from the Ethernet header. So then it processed the data to the IP header without the Ethernet header. Now once we actually parse all the fields we need from the IP header, we can actually extract the IP header from the data in order to continue analyzing the packet further on. So in order to do that, we will just perform the same we did in the Ethernet header. So from ._receive, we want to strip from the 20th byte further on, and that we will store in the data. So we don't need to specify 34, since the first 14 have already been stripped from the data in the previous function. So everything should be good to go. All we have to do right now is actually print all of the stuff that our IP header has. So let us see what we can do if we go down here and we print same thing we printed right here. So let us actually keep the size to be the same, which really will not work, but it doesn't matter. We can just add it like this and change the Ethernet header to be equal to the IP header. So we print that, so we know that these next fields will be from the IP header, and we will use the version 2 dots, the same %HU as in the Ethernet header that we used, I believe. Okay, so we did use it to print these statements. So let me just add the actual space right here, and %var, which is our version variable. Now we need to do the same for each actual variable, so IHL. We just type all of this in, so you should type it as well. Make sure to specify the correct name of all the variables so our program doesn't really crash. We need to specify this right here. Oops. Where is the %? Okay, so here it is. HU from the toss variable. Then we print the length from the total length variable, I believe. So, okay, we did call it like that. Print the next field, which is the ID field. Now this will take a little bit of time, so I will just skip until I write all of these fields. Okay, so here it is, everything is printed out, but before I continue, make sure to double check everything and make sure that the destination and the source IP address don't have the %HU, that they have the %S, so we can actually print the string. Now the reason for that is because of this function right here. As I showed you before, what this function does is it will turn the IP address into the printable string of the IP address separated by these dots. As you know, the IP address format is something like this. So this is the IP address, and this function will basically make this a string, so what we are printing is an actual string. That's why we have the %S. All we have to do right now is, since at the beginning, or not at the beginning, what we want to do is actually check, since down here we specified the actual function to retrieve the data receive and the TCP UDP, and if you check in our function, we really don't have anywhere anything named TCP_UDP, so we actually have to check whether this IP header has a TCP or UDP header attached to it, or if it even has some other header. But what we will be mostly interested in would be a TCP or UDP header, which we will extract further on. So in order to check what the header is attached to this IP header, we can actually use this variable right here, which is IP proto, which will contain the value of the next protocol that will be in actual packet. So in order to check what the TCP and what the UDP header numbers are, you can just go to here and go somewhere right here, and TCP protocol number. You can just type that in the Google search bar, for example. You can see that the actual transmission control protocol, or the TCP, is actually number 6. So you can just go down here. You can go list or not port numbers. We're not interested in the port numbers. That doesn't even matter. We saw that it is an actual 6. List of IP protocol numbers. This is actually more useful to us. I don't know why I clicked on this. So list of IP protocol numbers, and you can see TCP is under the number 6. If you go down here, you will find UDP under the number 17. So those are two numbers that we actually have to watch, and we need to specify them in our function. So if the IP proto variable contains number 6, that means that the TCP header is attached to the IP protocol header. To the IP header, and if 17 is in actual IP proto variable, that means we have a UDP header. So if IP underscore proto equals to 6, TCP underscore UDP variable will be equal to the string of TCP. Else if IP underscore proto equals to 17, what we want to do is that TCP underscore UDP variable to be equal to UDP. And else, for any other case, since those are not the only two protocols available to be specified in the IP header, we need to type the TCP UDP to be equal to other. Now this other will specify any other packet that this might actually contain, and all we want to do is return the data, which is data stripped from the IP header, and the TCP underscore UDP variable. And that would be about it basically for this IP header. We extracted everything, we printed everything, we checked for the actual TCP and UDP protocol, whether they are specified in the IP underscore proto variable, and then we return the data and the TCP underscore UDP. And then right here, what we will do in the next video, we will actually check whether we got the TCP or UDP, and then we will continue as we need. For example, if we got a TCP, we will extract it to the analyzed TCP header. If we got the UDP, we will extract it to the analyzed UDP header function. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to our packet sniffer. And in the previous video, we performed the analyzing of our IP header, and what we want to do right now is check for our TCP underscore UDP variable, whether it contains TCP or whether it contains UDP. So what we did right here, as you can see from the actual previous videos, we actually changed the IP bool, or checked the IP bool. If IP bool was true, we actually went to the analyze IP header function, and right now we are not actually checking the IP bool anymore. What we are checking is the TCP underscore UDP variable. So down here, since we returned the TCP UDP into this variable, we can check what we got. So if TCP underscore UDP equals to the string of TCP, now why we are specifying the string of TCP is because we returned right here we set the TCP UDP variable to be equal to TCP if IP protocol was equal to 6, which is the number for the TCP header. And right here, all we want to do is check whether it is TCP. If it is, we want to process or proceed to returning the data underscore receive to be equal to the function analyze underscore TCP underscore header from that data, so from data underscore receive. Else if TCP underscore UDP will be equal to actual UDP, we want to proceed with the data receive to be equal to analyze underscore UDP underscore header from the same data receive. Now we know that this data receive actually returned the data stripped from the IP header, so all we will be left to have is the TCP or the UDP header in our case. In any other case, we will just return from our function, and then we can down here call our program to be while true main. Now the reason we are using while true is basically because we want to run this for infinite amount of time, or not infinite, until we actually stop the program, so we can sniff for the packets for as long as we want. So let me just double check everything. Okay, everything should be good to go. Let us actually check our program if it is running right now. Let us put everything under the hash. Let's see if we can run the program, if our main function is good. So we will perform this, then we will go right back. And let us see if we can run the program right now. I'm not pretty sure, but we can give it a try just to see what we will get. So we run the sniff packets. We can see there is invalid syntax. Okay, let us see where the invalid syntax is. Okay, so we are missing the 2 dots at the main function, so make sure to specify that right here. Save it once again. And we can see that we get printed the Ethernet header and the IP header. We can see everything is printed in the good format. We get the destination MAC address, the source MAC address, the protocol number, the version, the source IP, destination IP. We get everything, and once a new packet arrives right here, we should be printing the new packet as well. But I can't seem to actually see a new packet arriving. Let us try to refresh this page, for example, and we can see we are getting a bunch of new packets right here. So everything is good to go. We can see everything is changing. Our program works really well for now on. Now what we want to continue is what we started, which is the TCP UDP header, so nano sniff packets.py. And let's make a first function, which it can be the actual, for example, TCP function. So we can code the TCP header first, since that will be a bigger header. It has more fields than the UDP. So let's do it first. Def analyze underscore TCP underscore header. And in that function, we paste the argument data underscore receive. We don't forget to add the 2 dots. And right now what we can do is actually perform the same task as the IP and Ethernet header. So we want to strip from all the fields, and we want to first unpack the actual header. So TCP underscore header equals struct.unpack. And what the pattern for this will be is something like this. So 2H, 2I for H. Now I'll show you why in just a second. So what we will do is we will actually try to find the same picture for the TCP header that we actually had for the IP header, in order to see how many size or what size do certain fields take and how many of them are there. Now what we want to strip from is actually strip from the data underscore receive, the 20 size, so the same as in the IP header. And you can see that the first new thing that we have right here is the I variable, or not variable, the I letter right here, which basically stands for the actual full length. So let us put this as a smaller window. Let us enlarge it like this, and we are not really interested in the list of protocols. We don't want the TCP header structure. What we want, or pardon me, the IP, what we want is TCP header structure. And we can open the any actual picture that we might get. So here is one of them. We can see the actual available fields for the TCP header format. So first of all, we will have the TCP, the source port and destination port, which, if you are familiar with the previous header, you will know that both of these will take actual 2 spots, or basically an entire element in our TCP header list, since the first 2 letters that are specified are the 2H, and 1H will each represent one field right here. So the first H will represent the source port, and the second H will represent the destination port. Now this I variable right here, as you can see, there is 2I. They represent the full length, as I said, so you can see that the sequence number and the acknowledgement number are actually the full length. So we will store both of them in the I, or we will extract them by the I, and we will store them in some variable that we will name later on. And then further on we have the 4H, so what we will have to do is these 3 parts right here we will have to split into 1H. The window will take an entire first H, the checksum will take an entire third H, and the urge pointer will take an entire fourth H. And these options right here we are not actually concerned about. So that is how we split the TCP header. So let us actually continue with, first of all, the source port and the actual destination port. So we unpacked our TCP header. Source underscore port takes an entire actual element, so TCP underscore header. And then the first element, the same we want to do for the destination port, equals TCP underscore header. The second element, the sequence number, takes the same, so we specify double I, which is the full length, so we can specify them as the entire element, so seq underscore num equals TCP underscore header third element, and same for the ACK number, equals TCP underscore header and the fourth element. Now you will see that the next thing we have is another H, so these are the three fields that we need to split into that H. These are just some flags, and these are basically the actual offset and the reserved. So what we will do is we will actually perform the same logical expressions as before in order to split them up. First of all is the actual data underscore offset equals TCP underscore header. The fifth element, header, fifth, not P. Why do I continue typing P? Okay, so 4. And then what we want to do is actually move that or shift that with the 12 bits. The next one is the reserved. Let me see if it really is reserved. It should be, I believe. Reserved. Okay, so it is reserved. We will just call it just like that. Equals, and since that one is the middle, we need to perform actual multiple logical expressions or shifting parts. The header, the fifth element, we need to shift it 6 bits. And then what we need to do is end it to the actual, where is okay, so here it is, 0x03ff. So after that, we are left with one more, which will be the flags, which we will need to actually split all of them one by one. But for now, let us just add the flags variable to be equal. So flags equal TCP header. And since that is the last element, all we have to do is end it with the 0x003f. After that, everything is good to go, and we only need to separate these fields into each element one by one. So we have 3 left, so let us finish them. Window is the next, equals TCP underscore header, 7th element, or pardon me, we are not there yet, so 5th element or 6th element, and then the checksum, which we also had in the IP header, will be equal to TCP underscore header, 7th element right now. And we are left with the urge underscore pointer, or let me just check it out. Okay, so urgent pointer equals TCP underscore header, and then the last one, which is the 8th element. And we extract the data. Data equals data underscore receive from the 20 to the end. Okay, so everything is good to go. And now you might notice that actually this header right here has some weird spot right here, as you can see. And basically what these are basically flags. So there are different types of flags, such as urge, ACK, SYN, FIN, and you can see a bunch of these others, or not bunch, just the REST and PCH. What we need to do is actually split them, and we will split them by their actual value. So in order to perform that, or in order to actually add the flag to its variable, we will need to make 6 different variables, each variable for each flag, and we will have to perform the boolean and logical expression with the specified bits from these flags in order to check which flag we have in our packet. So in order to do that, just go down here. First one is the urge equals bool flags, and where is the sign? Can't seem to find it. And 0x0020. Oops, what am I typing? 0x0020. Close the brackets. The next one will be ACK flag. So the same thing we need to perform. We are using the flags variable because the flags variable is storing that value right here, and we need to use it in each of these flags. Once again, I can't seem to actually type. Close the brackets. PCH is the next one. Let me just check it out. Okay, so PCH really is the next one. So flags 0x0008. 3 more left. And then we are good to go, and we can print everything and continue to the UDP packet in the next lecture. The next one is the SYN one, equals bool flags 0x0002. And after we finish actually all of this, including the UDP header, we will be having a full packet sniffer which will split each field of the packet that we receive. So this is not really something useful for hacking, as I said before, but it is good to actually test your knowledge, not test your knowledge, but to learn new things and to learn more in depth about packets and their headers. As we can see now, we know that the packet can contain Ethernet header, which can have attached the IP header to it, and then further on which can have attached the TCP or UDP header. And then we also split all of those headers into different fields, so we know what fields does which header have. It is something useful to know. You never know when you might need something like that. And all we want to do is, in the next video, we want to actually print all of this that we typed right here, and we want to do some actual expressions in order to finish the analyzing the UDP header, which will be smaller than the TCP header, so don't worry. After that we will test our program to see if it will work, and if it does work we can continue to the next section where we will code our reverse shell, which will be multifunctioning reverse shell. And then we will code after that the threaded server, which will accept multiple connections. Right after we code the actual server, which will accept only one connection. And then we can actually see how we can make our own command and control center, which can take the input or the connection from multiple PCs, and we can interact with all of those PCs as we like. So that will be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to the last part of our packet sniffer. And right now what we are left to do is print the TCP fields, and is also to actually analyze the UDP header. So we made everything right here. Just before we actually continue, make sure to add an exclamation mark right here, since if you don't, it will not really work. I forgot to do that in the previous video, so make sure to add it right now. And right now we can actually print everything as we like. So let me just take this right here. We'll also have to print each flag one by one, so this will be a lot of printing, but it is something that we should do in order to make our program look better. So TCP, and then we print everything one by one. So first of all is the source. We just add the two dots right here. Source underscore port, print. Oops, I just noticed right here I have double open quotes, so not really sure why I typed that. Destination, then after that we need to specify the test underscore port, print, we can call this sec, %u, make sure to specify the %u, and for the flags you will also specify the %d as an integer, since that is the value that we are retrieving from the actual flags variables. So this part right here that we coded. So let me just sequence number, so sequence underscore num, print ac %u, then ac underscore num. Then what we want to do is print, since we are starting the flags, as we can see we want to print flags and then two dots, open, and then in the next line we will print urge flag, since that is the urge flag, then %d for the integer, and then %the variable name, which is just urge. Now what we can do is actually copy this and paste it 6 times. Of course we will rename it into appropriate flags, but let's not type the unnecessary things. So the last flag will be the actual, let me just check, fin flag. Let's call it here fin. The one before that is the SYN flag. So SYN, and right here also SYN. Here is the REST flag, RST, the PCH flag, same here as well, and the ACK flag, which is the second flag, and right here. Let me just delete the spaces and add a space right here. So we printed the flags. All we need to print more is the win size and the checksum. So we have this right here, which is the window and the checksum. We do not really need the urgent pointer. So let me just print right here win size. Close these double quotes and then percent window. I believe that is the name of our variable. Let me just check. Okay, so window, and the last one is the actual checksum. So print checksum, and we printed everything from the actual TCP header. So everything should be good to go. All we are left to do right now is make our actual UDP header analyze function. So let me just check out in the main function. Did I call it like that? I believe I did. So it should be analyze UDP and analyze underscore UDP underscore header. And let us also remove all of these hashes from the previous test, since right now the next text will include this part of code right here. And let us analyze our UDP header as the last header we want. Now, if you want to, for example, in order to test your knowledge, you can actually add more headers and try to analyze them as well. Just check out on the internet what certain fields they have, how big are those fields, and unpack them as needed for that special header. So, for example, the def analyze underscore UDP underscore header, data underscore receive. We parse that part right here. We save this. Let me just, from the previous video, now find the UDP header. UDP header structure. Let me just find it. We don't want this. We want the actual picture. And you can see UDP is actually rather small. So it has these 4 fields, which we can actually, if you followed everything really well, you know that this H can represent one of those fields. So all we have to do is specify H 4 times. Now you can just type 4 H's, or you can just type number 4 and then the capital H afterwards, which is what we will do. So UDP underscore header struct unpack. Then in the double quotes or single quotes, however you want, exclamation mark for H for these 4 fields right here. And you can see we will not be needing to do any logical expressions. We can just extract them and add those values to certain variables that we will make right now. So what we want to unpack is the data underscore receive, and the size is 8. So specify in the brackets, in the square brackets 8, and close the normal brackets. And all we want to do is extract the field. So source underscore port equals UDP underscore header, and then the first element. The destination port, which is the dest underscore port, will be equal to the UDP second element. The length is equal, let me just, to the UDP and then the third element. And the last, which is the checksum, is equal to the UDP fourth element. So checksum equals UDP underscore header and 3 in these square brackets. And all we want to do is actually return the data, which will be data underscore receive, stripped from the UDP header size. So all we have to do right now is print all of that and return the actual data. Now, before I do that, let me just check if I return the data from my TCP header. So what I want to do is to actually return the data since I stripped it, even though we don't really need it, since we are not analyzing further on. So return data just in case. Let us go up here. Let me enlarge this, since the only thing I need to do right now is print these 4 fields. So what we want to do is copy the first part right here. So print this, copy, go up here and print that the same for the actual UDP header. Just we will change the TCP to UDP. Okay, for some reason it is getting laggy, not really sure why, but it doesn't matter, we can manage. Let me just tab this one step back. Oops. And add the bracket that I actually deleted by accident, so here it is. And let us print these statements finally. So here it is. Print. And what we want to print is the source first. So source 2 dots then percent the source underscore port, print destination, percent, and then dest underscore port. The third thing is the length, so let us print that as well, length. And then percent underscore, or not underscore, just length. On here we are missing the percent sign, so make sure to add it if you didn't type it as well. And the last thing we need to print is the checksum. So checksum, and then add it to the checksum, or not add it, get it from the checksum variable. And we need to return the actual data. And I believe that we are actually good to go right now. Let me just scroll to the main function in order to see if we are missing anything. We, I believe, are not, so we return from this function afterwards. The data received will contain the remaining size of the packet, if there is any. Yeah, and there probably will be, such as TCP payload, for example, which will contain an HTTP protocol or something like that. It doesn't even matter. We are not concerned at the moment by that. Let us save this and let's actually test it in order to see how it works. So we run this. We have the invalid syntax. So right here, what we are missing is the percent sign. Let me just see where that is. I believe TCP packet. Yep, right here we are missing the percent sign for the destination port. So make sure to add it and save this once again and sniff these packets. So everything is working. Right now let us refresh some page in order to get the packets flowing. We can see Ethernet header, IP header. We cannot seem to see any TCP or UDP. So we got an error. Let us see, analyze UDP header is not defined. So I believe we misnamed something, and we can see we actually did. So analyze, we are missing Z right here. Let us save this, clear the screen, and run it once again. And we can see here are the packets. You can see they're flowing really fast. Unpack requires a string argument of length 8. So let us see what exactly are we having an error on. Okay, so this line right here has for some reason number 9 in the bracket, specifying the actual size of the UDP header, which I'm not really sure why I typed here 9. It should be 8. As you can see, I stripped the 8 as a size in the data. Shouldn't be 9 right here. I was sure I actually typed 8, but it doesn't really matter. Let us run the program once again. So here it is, TCP header, packets flowing around. We can see they're coming, different destination MAC addresses, different source MAC addresses. IP header is split into different sections as well. We are getting a bunch of packets from this IP address right here. We can see packets are flowing really fast. In the TCP header, we can see the source port, the destination port, the sequence and acknowledgement number from the TCP header. You can see different flags which are set for the TCP header. And let us just get some UDP packets, which we probably really want, but it doesn't matter for now on. We know that our program works really well. We split it into all fields we need, and this is your packet sniffer. So that would be actually about it for this section. Now, in this section, what you should have got from is the actual more detailed knowledge about different protocols, about different headers, their fields, and how they actually go with one another. So what we are printing right here is the entire packet, or not the entire, it probably has some different payload in the TCP header, but we didn't really print it. So that will be about it for this tutorial. I hope you enjoyed it, and I hope I see you in the next lecture where we will continue coding. Hope I see you there, and take care. Bye. Hello everybody, and welcome to the multifunctioning reverse shell section. Now what we are going to do in this section is basically coding our own reverse shell, which will be based on the TCP server and TCP client. So we will actually code two programs. One of them will be our server, where we will listen for the incoming connection, and the other one will be the reverse shell, or the payload, or however you want to call it, which we will deliver to the target in order to hope that they will actually run the program and connect their PC back to us, which will then allow us to execute multiple functions that we will also code, such as screenshotting target's PC, running keyloggers, getting administrator password privileges, administrator privileges, opening files, downloading files, uploading files, downloading other scripts from the internet, and so on and so on. So it will all be based on this part right here, which is the code that we need to make in order to be able to connect one PC to another. Now, those of you who are coming from my ethical hacking course have already some idea what we are going to code. It will most likely be all the same. We will change some of the different things at the end, such as actually making our reverse shell to be a song, for example, an MP3 file, which will run a song in the background, or an image, or the PDF file. We will also see how we can add multiple different icons to our file. And those of you that are coming from the ethical hacking course know that we didn't really code the reverse shell to be able to, or not the reverse shell, the server to be able to accept multiple connections. So that is something that we will do in this course. So we will code the reverse shell, or pardon me, the server to be able to accept the connections from different PCs at the same time, so you can actually connect multiple targets in order to execute commands on all of them. We will be able to switch from the first session, for example, to the second session, and so on. It will be something similar to the meterpreter shell and the exploit multi-handler. We will just try to copy all of that, as well as some of the functions, and then we will see how it will all go. That is the base of the actual command and control center, which will be able to create the botnet for your own needs. Now, most likely botnets are always used for DDoS attacks, which you really shouldn't do without permission, but you will be able to create something like that. Nothing really too advanced, since this is also a course for beginners, but I assure you it will have some of the different things and some of the more advanced things that the reverse shell should have. So let us see what we need to code in order to get this to work. This will be the basic principle behind all of this, which will contain the server and the client. The client, in our case, is our reverse shell, and the server is a program that we're going to run on our Kali Linux machine. So as we can see, we will need to create the socket object, which we did before, so nothing really new for us. We know what socket object is. We used socket library before, so all we have to do is create the socket object and bind certain IP address from our Kali Linux machine to the port that we want to listen on. In our case, we can use any port we like. We can use port, for example, 54321 if you want to. You will basically use any port you want, which is not in use on your system. What we need to do afterwards is listen for the incoming connections, and then after we listen for the incoming connections, the target can actually connect back to us. What the target will run is, in the target code we will also make the socket object, and then we will perform the connect function from the socket library in order to connect to the IP address and the port that we specify in the server code to listen on. Then our server code will, as it says right here, establish connection with the three-way handshake over TCP, and it will accept the connection, and then we will be able to send the data or messages or commands, or however you want to call it, back and forth between our PC and the target PC. So afterwards, with the receive and send function, what we are going to do is send different commands, such as, for example, ls or dir, in order to print the files in the working directory, change directory, upload files, download files, and so on and so on. And at the end, when we don't really want to connect back to that target, we can just press a certain command, such as exit, or just type exit or something like that, which we will code in our program to be equal to actually closing the socket or closing the connection, and that will terminate our session with the target PC. So all of this we will be actually coding, so this will be a longer section, so prepare everything you need. This is one of the more useful things you will actually need, since this is the actual Python program that we will convert to the exe, and it will be able to run on any Windows PC. So you can make any Windows PC your target as soon as you find a method to deliver this to the target. And we will see also the method as well. We will see how we can send fake emails, how you can also deliver this if you want over USB drive. So if you're physically close to the target, you can just take your reverse shell exe file and then plug it into the target PC and run it when nobody's watching. Now, the actual bypassing of antiviruses will be, this program will actually be able to bypass most of the antiviruses, but not all of them. We will try to make sure to add some functions that will do literally nothing, just to be able to bypass some of the antiviruses. Such, for example, if you add a function that just does normal things, such as adding numbers, extracting numbers, and so on, it might trick some antiviruses into thinking that this actually isn't any virus at all. So we will be taking a look at all of that in the next video, what we will also need to install, which we will start actually with, is the Wine installation. Now the Wine installation allows us to actually be able to convert the Python file on our Kali Linux machine into the exe file, which will allow us to run that code in the Windows PC environment without the Python interpreter. So that is something really useful. We will use the PyInstaller library from it, and we will compile it into one single file. And the reason why we will not be able to bypass all of the antiviruses is basically because of the PyInstaller, since PyInstaller library for Python by default gets actually detected by some antiviruses as an actual virus. So even if you coded a simple program which just prints hello world and converted it to exe with PyInstaller, it will still trigger some of the antiviruses out there. So that is something that we cannot really change, but we will be doing the most we can in order to bypass most of them. So hope you enjoyed this tutorial, and I hope I see you in the next one, where we will start installing our Wine installer and we will start coding our program. So hope you enjoyed it, and I hope I see you in the next tutorial. Bye! Hello everybody, and welcome back to this tutorial. And right now what we are going to do is we are going to install our Wine in order to be able to compile our reverse shell later on. So all you have to do is run just a few commands, which might actually take some time in order to install, but after you do that, you can safely compile all of your programs that you want to run on your Windows environment as an exe file. So let us zoom our terminal in so you can see every command good enough. And let us run our first command, which would be the dpkg and then -- add -architecture. So just type this, and after you type this, you just want to type i386. Now basically we are running this command in order to add our architecture for our 32-bit Wine, which we're going to install soon enough. And basically I already did all of this process, or the entire process, so I will not be actually running the commands right now. I will just show you which commands you need to run. The reason behind this is because the apt-get install wine32 takes a little bit of time, so I ran it before, so we don't have to wait through this video in order for that to finish. The next command, what you want to do is just apt-get update your repositories in order to be able to download the newest version of wine32. So just update your repositories. This shouldn't take too long, since I didn't really add any additional repository to my sources.list file in Kali Linux. And after that, all you want to do is just install wine32. Now, what wine32 allows us to do is actually run Windows programs in Linux. What it will do, it will create a virtual C drive, the same C drive that you use on Windows, and it will allow us, with a certain command, to actually be able to run all the .exe files in Windows environment. So, the reason why this is failing is because I'm not really connected to the internet at the moment. For you, it should work. And right after that, you want to type apt-get install and then wine32. What this will do, it will install the wine32 for you. It might take a little bit of time, around 10 to 15 minutes, in order to install all the files you need for this. And after you do that, all you want to do is actually navigate to our root directory. And there, if you type ls, you will not notice anything different. But if you type ls-la right after installing Wine, you will see a folder or a hidden directory which is named .wine. Now, this directory is basically where your C drive will be. So if you change your directory to .wine and type ls once again, you can see our drive C right here. Change directory to drive C as well. And there you will have these program files x86, the usual files that you see in your C drive on Windows. But what we want to do right now is install this Python 27. So what you won't have is this Python 27, and right now I will show you how you can install it. So just close down your terminal and open up your Firefox. We will download a Python 2 version, which we will use then to compile our programs with the PyInstaller library. So let me enlarge this and just type the link, or the same link that I'm typing, so www.python.org/ and then downloads/release, and now we want to specify which release we actually want, and we want the release Python-2714, and then add a slash at the end, and you will get redirected to this page right here. Now here, as you can see under the Python 2.7.14, we have different versions available, and the one that we are interested in is the Windows x86 MSA installer. So just click on that. this will start the process of downloading it for you. It will first prompt you to save the file, so click save. Then under this icon right here, you will see that the file will be downloaded in the downloads folder on our Kali Linux machine. So after you do that, we can actually close the Firefox right now and go back to our terminal. And if I navigate to my downloads folder, which is under /root/downloads, there, if you type ls, you should have a file named something like this. Now the reason why I have two files is because, as I said, I already downloaded it before, so I will just delete one. No such file or directory. Okay. Let me try to delete the one that I downloaded before so you don't get confused. Basically what you will have is the other one. Okay, never mind, we will just delete the new downloaded one. So you will have file named something like this, and what you want to do is run a command which goes like this. So wine and then ms iexecute, or just iexec, and then after that /i, and then the name of your download. What this will do, so you just specify enter, it will actually run the Python for Windows in your Kali Linux environment. It will prompt you to install, so you just go next on every actual step you have in the Python 2.7.14 setup, and after that just click finish and you will have Python installed. So I will just cancel this since I actually don't want to install it twice. And that would be about it. Right after you install the actual Python, you can see that you will have Python under the root/wine or /.wine under drive C. If you type ls, you will have Python 27 right here. But we don't only want Python, we actually want a certain library that comes in Python, which will allow us to compile our Python programs in Linux into .exe files. So in order to do that, what you need to type is this command. The name of the library that we're going to install is pyinstaller, so here I will show you how you can do it. So wine, and then you need to specify the path to the python.exe, and the python.exe file or program that we just downloaded is located in Python 27 directory. So you need to specify the full directory, so root/.wine/drive/python27 and then /python.exe. This is the full path to your Python exe program, and then after that you need to specify -m to install the library, and then pip install, and then the name of the library itself, which in our case is pyinstaller, and then just press enter right here. Now this is the actual same command that you will use to actually install any additional library that you might need, since sometimes in compiling of the program you will get a fail to execute error. The reason behind that is usually because you're missing a certain library in your Python exe program. So that will be about it for this tutorial. We successfully installed Python for Windows, and we successfully installed pyinstaller in our Kali Linux environment. So hope you enjoyed this tutorial, and we will continue with coding our server in the next lecture. Hope I see you there, and take care. Bye. Hello everybody, and welcome back to this tutorial. And this is the first tutorial where we'll actually start to code our reverse shell and our server that will accept all of the connections to our Kali Linux machine. So first of all, let us start off with the server, since the socket code for the server is a little bit bigger and more complicated than the actual socket code for the reverse shell. In server there are multiple functions that we need to execute in order to perform the entire connection, while in the reverse shell we will only need to perform the connect function after creating the socket object. So let us navigate to our Python programs, so root Python programs. We can call this mkdir, we can call it reverse_shell. That will be the name of our actual directory where we will save our reverse shell and server and any additional actual programs that we need for this section. So let us first of all nano server.py, just a simple name, we don't need anything to specify else. So just right here add the additional line user bin Python, and we know that we are going to use the socket library as the first library in order to create the connection. So first of all, let us just try to create the connecting of these two programs from two different machines. Now for those of you who are coming from my previous ethical hacking course already know how we are going to do this. So if you already watched this in my ethical hacking course, feel free to skip to the end of this section, where we will actually change some different things and compile the program in a different way in order to see what our available options are for running this attack. But for those of you that are watching this for the first time, let us continue. So what we want to do first is to create the socket object. So we will store it in a variable that we will call simply just s. In order to create socket object, we are already familiar with, we need to run the socket.socket function, and in these brackets right here we need to specify what type of socket object we want to create. So we will paste two arguments right here. One of them is socket.af_inet, which will allow us to create a socket object for the IPv4 address, since we are going to perform the connection function onto the IPv4 address on a certain port. Also, we want to specify whether we want our server to be running over UDP or TCP. We want to actually run a full TCP three-way handshake connection with the TCP protocol. So in order to specify that, we need to just type socket.sock_stream, and we successfully created our socket object. So once again, this stands for IPv4 connection and this stands for TCP connection. So in the next line, we will set some of the options for our socket object. In order to do that, we will use a function called setSockAuth, and in the actual bracket just specify socket.sol_socket, socket.so_reuse addr. After that, 1, and that is all we need to do for our socket object in the entire program. We set some of the options, we also created the socket, and right now we are going to run our next function, which is actually the function that we saw in the previous theory video, where we actually explained what we need to run in order to perform the connection, and that function is actually called bind. So if you just type s.bind, what this function does, what this function does is it will bind your IP address, your local IP address, to the actual port that you specify in between these brackets. So what you need to specify right here is the IP address of your Kali Linux machine, and also to specify the port that you want to bind to that IP address. Now make sure before you specify anything that you make sure that that port is not used by anything else, otherwise this won't work. That's why I always like to use some high port, for example 54321, because I know that most likely non-programs will be running on that port. Also, the bind function takes the arguments between the double open and close brackets, so make sure to specify double open and double close brackets, and in between there, first of all, you specify between the double quotes the IP address. So in order to specify our IP address, we first of all need to check it, run ifconfig, we can copy our local IP address, nano back to our server, and paste it between the double quotes. Right after that, we need to separate comma and add the port that we want to bind to, in my case 54321. So after that, we need to listen for the incoming connection. So now that we created the socket object and that we binded our port to our IP address, we need to listen for the incoming connections. In order to do that, we need to specify the listen function, and in between to how many connections we want to listen for. For example, specify 5. You can even use 1 for this actual test, but 5 will do the same job as well. After that, we can actually print a few statements which will allow us to know whether we completed these statements right here correctly, or whether we ran into some error. So let us print the successful execution in red, in green, and the failed attempts in red. So from term color import colored. So what we are going to do is right here we can print colored, and then let me just, okay, so we need to specify plus, since this means that it worked, listening for incoming connections. So make sure to close two brackets, and then after that, since we know that we are now listening for the connections, we need to specify two variables where we will store the actual connection. So one of them will be the target, and one of them will be the IP address, which we will use as a string in a later program. So what this means, the socket object we are going to store in the target, which will store it somewhere in the memory, and the IP address, or the IP variable, will store the IP address and the port from where the connection is coming from, which then we will use this IP variable in order to print from where we got the connection. So we can just type here s.accept, since we are accepting to our socket object, and we can see print, and we can print colored connection established from, and then we can use %s since we're going to specify a string, and we can just close the double quotes and here use %string from IP. Make sure to close 1, 2, 3, and or just 3 actual brackets. So I hope, let me just count. So we got 1, 2, 3 open and 3 closed. Okay, so everything is good enough. And basically this is the entire program for actually creating the server side of the connection. So what we are going to do in the next video is we are going to code the reverse shell part, which will only consist of the connect function, and then we will test if our program can actually connect to our server. So let us just save this, and we will continue in the next lecture with our reverse shell. So hope you enjoyed this tutorial, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back to this tutorial. And right now what we are going to do, we are going to call the reverse shell side of the code. So we can see right here, we successfully coded the server side, and right now let us exit this and nano reverse shell.py. So we will call it nano reverse underscore shell.py. We add the standard user bin Python line, and we will import the socket library as we are going to need it to actually specify our socket object. So we can call it socket or just sock, so we don't actually confuse it with the socket library. So all we want to do right now is specify the same thing as in the previous video. So sock equals socket.socket. We want to use the socket.af underscore inet, and we want to use the socket.sock underscore stream. Or I believe it is stream. Let me just double check. I will just cat my server in order to see. Okay, so it is sock stream. Okay, so we specify the socket object, and what we want to do right now is perform the connect function. So in order to do that, we can just type sock.connect and open double quote, double brackets, double open and double close brackets, same as in the bind function in our server-side code. And between there, you need to specify the IP address to which you want to connect to and the port to which you want to connect to. Now in our case, both of them will be the same, so we need to specify right here once again between the double quotes the IP address of our Kali Linux, which is in my case 192.168.1.9, and also the same port that we used in the server-side code, so 54321. But be careful, if you are running this attack over the internet, for example, and you use the port forward, what you want to specify in the reverse shell code is actually your public IP address that actually your router has in order to communicate with the internet. Of course, you also need to specify the port forward in your router settings that will actually forward this local IP address to a certain port over the router. But from now on, since we are doing just a local tag at the moment, we can just leave it like this. So what we want to do is just save this and see if we can actually perform the connect function. But before we do that, we need to close the socket in both of our programs, which we can do with just sock.close function. So just write that, exit this program, let us nano our server, write right here as well sock.close, save this as well, and we know that this program will work if we get printed this line right here. So we want to get printed connection established from certain IP address at a certain port. So let us save this, close this, and in order to run both of these programs we will need to open two terminals. So just open another terminal. We can enlarge both of them just for better view, even though we don't really need it at the moment, but let's have it just so you can see everything better. And right here, what I want to do is navigate to the same directory, so reverse underscore shell, and first we need to run the actual server. So let us chmod server in order to make it executable, and let's run server code. No module named term color. So okay, we need to run it with Python 3 since I use the term color library, and we can see listening for incoming connections. Now we can see right at the moment that we have something that isn't specified correctly, so we know that we specified the colors, but we forgot to actually add the color which we want to use. So in order to do that, we need to specify the comma after the string and then the name of the color. So we want to print it in green. Same right here. We want to print this in green, and let us save and try to run once again. So Python 3 server.py, address already in use, that is because we actually closed the program 2 seconds ago in the inappropriate way. So let us actually restart our terminal in order to get this to work. Now remember, every time you get server already in use, all you have to do is actually just restart your terminal, and they should all work fine right after that. So let me just go to my Python reverse shell and Python 3 my server. Name green is not defined. Okay. Yeah, green needs to be specified between the single quotes, so make sure to add that as well. And right now, I believe everything should work good. Okay, so listening for incoming connections, and right now this will listen until somebody connects to our program. In order to perform the connection, we need to run Python 3 reverse shell.py. So we run this, it says connection established from 192.168 at this certain port. So this was the port that was used to perform the connection from the reverse shell. Now we have a small error right here since we used sock.close instead of s.close in our server. So let us just run it once again, and let's run this, and we can see everything executed properly. We got listening for incoming connections, we also got connection established from this IP address, and we closed both of these programs in the appropriate way. So what we want to do in the next video is actually try to send some of the commands or some of the messages between these two programs. For now on, we only made them connect to each other, but we also actually want to be able to send something between them, since these are the programs that will be running on two different machines. Just at the moment, we are testing them in the same machine, just from two different terminals. So we will continue coding in the next lecture. Hope you one, and I hope I see you in the next tutorial. Bye! Hello everybody, and welcome back to this tutorial. And as you can see in the previous video, we successfully ran both our server and our reverse shell.py. Right now what we are going to do is add just a little bit of code to our server and to our reverse shell in order to be able to execute or to send messages between these two programs. So let us start off with the server. I will just zoom this in so you can see everything better. Let me just enlarge the entire terminal and let me open server.py. So what we have here is the actual socket creation part. So what we can do with this is, first of all, delete the s.close and put this entire part into one big function, or it is not even that big, but we can just add it right there. So what we can do is just type here def server, and we can tab this entire code into this function right here. So we tab everything right here, as it should be. And also what we need to do right now is actually create a global variable s, since we are going to use the s in other functions as well, and we actually must have the s variable to be global in order to be able, in order for our program to be able to recognize the s variable. So we can do that just by specifying the actual, let me just go right here, in the beginning of the function we can just specify 3 global variables. Since we are going to use the global variable s for our socket object, we are going to use the global variable IP, since we are going to print it later on, and we are also going to use the global variable target once we actually specify functions which we will use to actually send and receive data between these two programs. So all we have to do down here is actually call this function server, so we can actually execute this part of code, and right after that we're going to call the function called shell. So what this function shell will do is it will be a function that will perform the actual sending and receiving of the messages. So let us go up here, type def shell. The function will not take any input right now, and what we want to do is basically at the beginning of the function we want to enter an infinite while loop. So we can do that with while true. Now the reason why we are entering the infinite while loop is because we want to send the commands for as long as we want. But before we actually enter it, let us just try to test the program in order to see if we can actually send messages without the while true loop. So what we can do is just type here a variable called command, which will be our command, or basically we will store the command that we input into this program right here. So what we want to use then is the actual so command equals input. We want to ask for the input of the user or in this case us, and we want to add something like this. So shell, then just paste everything that I type right here, so hash, then we can use this sign, and then %s, so %s and 2 dots in order to make this look like a terminal shell. So you will see how this will look like. If we just add instead of the %s, we will add a string of the IP. So because of this usage right here of the IP variable, we had to specify it in the server function to be a global variable. So we close the double brackets, and all we want to do is actually just try to send this to the target. So we can just use s.send, and what we want to send is actual command. And after we send this, so right now what we want to do is actually receive some message from the actual target. So we can just do something like this, message equals target.receive, and the amount of bytes we want to receive would be 1024 just for this specific task. Now we will do some of the changings later on, but for now let's just leave it like this, and after that let us print the actual message right here. So let me just try this right now. So if I save this, save it, then go and add the code to the actual reverse shell as well. So what we will need to do is actually add another shell function right here, which will actually perform the same thing. So let me just call it down here, shell, and let's call the function or code the function right here. So shell, and we enter the, or not enter the while true loop once yet. We want to type here command equals s or sock.receive. We want to receive 1024 bytes. This is the max value of bytes we actually can receive. So we will see how we can fix that. So for example, if we from the server actually send to the target something larger than the 1024 bytes, or the target sends back to us some value that is larger than this, our program will crash. So later on we will see how we can actually fix this, but for now on all we want to do is simply just get back the message from the target. We want to actually send back, so sock.send, and we can specify here to send hello world. So we will send something to the target, and target will respond back to us with the actual hello world string. So first of all, what we need to do is call the shell function before the socket.close, so we don't actually close the connection before actually executing this function right here. And right now let us see how this will work. So let's lower this, and let us actually run the server first. So Python 3 server, listening for incoming connections, and Python 3 reverse shell.py. So we are prompted for the command, so let us just type here the command hello, a bytes-like object is required, not string. Okay, so if you get this error right here, that means you're running this with Python 3, which actually is the case. So in order to actually, oops, I didn't want to open the reverse shell, I want to open the actual server. And in order to actually do this, you need to actually encode this with the UTF in order to be able to send this and print the message back. So sock s.send, and we want to send the encode UTF -8 or -8, however you want to call it, and then close another bracket. And right here we want to print the message.decode, since we are receiving also with the Python 3 UTF-8. And right now I believe everything should work fine. I run this server. We specify here hello. Okay, let me just check this right here. Okay, so we need to actually change the code in the reverse shell as well. So let's send this in this way. So we will just type it right here. Message.encode UTF-8. And the message will be hello world. So let's see if it will work now. Hopefully it does. Otherwise we'll just switch to Python 2, since it is easier to actually specify this. Encode UTF broken pipe. Okay, never mind. What we are going to do is just run it with Python 2. So what you want to do is just delete these print colors. We will add it later on. For now, it is just presenting as a problem. There is really no point in me just finding the correct syntax for that function, just to run it over Python 3. We will just run it over actual Python 2. so we don't waste too much of our time. We don't need this actual encoding anymore since we're going to run it with Python 2. We want to print the message, we want to send the command. So return everything back as it was before. Do that with the actual reverse shell as well. I'm probably missing some library, but it doesn't even matter right now. We're going to run it with Python 2. So let us see. Let me just double check the server as well. Okay, everything should work good right now. And let us run this. No module, name term color. Okay, let me just run this in a hash. Listening for incoming connections. And right now, if I run the reverse shell as well, I need to chmod it first. So chmod reverse shell.py. Okay, connection established. Hello. Hello is not defined. Command equals input. Okay, so we need to change this as well. Since in Python 2 we don't have input, we have raw_input. Too many errors. I should just start with the Python 3 instead, but doesn't even matter. So let's see right now. Let me just check what the actual error is, since we still have some weird error, not really sure for which reason. So we send the command. Okay, there is the actual error. So this was the error all the time. We need to specify target.send and not s.send, since s.send means we are sending it back to ourselves. So we need to specify target.send. Not really sure how I didn't notice that error. And right now, for the final time, this should actually work. So we run the reverse shell, hello, and we get back hello world printed out. So we actually managed to finally run this program and get it to work. We send the message back to the target, and the target sent back the reply, which said hello world. So what we will do in the next lecture is we will run this in while true loop, and we will make a simple chat program, which then later on will turn into actually commands, or us sending the commands to target, and target sending us back the output of those commands. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back. And as you can see right now, this is our reverse shell code, and what we want to do is actually try to make it to actually be able to send this hello world message in a while true loop. That means for every string we send to the target will send back this hello world string. So in order to do that, we need to place this in a while true loop, so while true, and we need to tab all of these commands so it can execute them infinitely. So first of all, we execute the socket creation, then we call the shell function, then we close the socket after the shell function finishes. Even though this function will actually be in an infinite loop, so that means that we actually need to code something that will make this quit right after we specify some certain command. So let's say, for example, if we send Q to this reverse shell, it will terminate and it will close the connection. So first of all, we need to receive the command, then if command equals to Q, what we want to do is we want to break out of this program, and then we will perform the sock.close. In any other case, we will just basically set this message to be equal to hello world, and then we will send the sock.send message to the server. So let us save this. Let us also nano the server part of the code, since here as well we need to specify a while true loop. So while true, let's tab everything right here. And we also need to specify that in case the command is equal to Q, so if command equals to Q, we want to break out of this program, or basically break out of this loop. In any other case, we will just specify else right here. So in any other case, we want to send the actual command, wait for the reply, which will be a string of hello world, and print the reply. And after we specify Q, we want to actually close the connection. So s.close right after the shell function, and let us see right now how this will work in valid syntax. So let us see. Okay, so we are missing two dots right here in order to determine the function. Okay, let us run this right here, listening for incoming connections. Let's open a second terminal. So let's let the server be here and the second terminal right here. Let us enlarge both of them so we can see everything a little bit better. And if I go to my Python and then reverse and run my reverse shell, we get prompted for the actual command. If we type ls, we get printed out hello world, who am I, once again hello world, and if we specify q, we get the broken pipe. Now let us see why we actually get the broken pipe. So we nano the reverse shell right here. Let us actually try to remove the actual shell function for now on, so we can see if that is the actual reason why we are getting the broken pipe. So we just tap everything one step back and we delete this part right here, which is the shell function. We also need to call the actual socket creation before the while true loop. So we will just paste it right here and we will delete it from here. So if we save this program right here and we try to run this once again, since our server-side code worked good, it quitted after the actual q command. So let's see right now, if we specify q, we once again get the broken pipe for some reason. So let us see why is that the case. In our server-side code, we sent the actual command, so let us just see. Okay, so the reason is because we actually have to send the command first. Since we didn't send the actual q command, our target or our reverse shell didn't know that we actually sent the q. So it actually terminated the connection. It just saw that we, as a server, terminated the connection and it didn't know why that happened. So we need to actually send the command first. So target.send command. The server-side code should be good. So now we know that the problem was not in the actual function itself. So what we can do is we can actually copy this. Now we are doing a bunch of changing the code. So let us actually put this in a function as it was. So def shell and paste all of this code. So right now everything should work good. We actually need to call the function after the socket creation. We will actually right now receive the queue as a command and we will be able to break out of the loop since our code will know that we got the queue back. So let us clear the screen in both of our terminals. Let us run the server once again, run the reverse shell. Okay, so we got an actual error. So while true, let us see what the error is. Okay, so this is not tabbed properly. Make sure to tab it with the tab button, every line right here. That is what the error is about. So I will just delete all of these empty spaces and I will just press tab. Make sure to not actually press the space since you will get the error for your code. So right now, if I save this once again and run the reverse shell, expected and intended block. Oh yeah, since we are in a function, we need to actually tap all of this one step in as well. So just like this. And hopefully after all of this work, we will be able to run the actual reverse shell. So here it works everything good. I specify q and we quit both programs without any error. So we successfully are able to right now send multiple commands. So all we have to do is actually just check out our server. So the next thing we actually want to perform is actually executing the functions or the commands that we send to the target. Since all our program does right now is it receives a hello world string from the actual reverse shell. That is the server part of our code. But the reverse shell part of our code, right here in the else statement, needs to have some execution of this command that it receives. So for example, if we type ls, it will actually print all of the files in that directory. So in order to actually do that, what we will do is we will import an actual subprocess library which will allow us to execute any code that we actually want to execute in the terminal. So in order to do that, just type here import subprocess, and right here the message, we will delete all of this since we don't need this. We will code everything in the else statement from the beginning. We will call our variable where we will receive the output. We will call it result. And there we will store the actual output of this command that we get from the server. But before we do that, we need to create a process. So in order to do that, we need to type here, so just follow with me, subprocess.popen. So we're opening the process, which is the process that is ran by the command that we receive. So it is stored in this variable right here. We need to specify shell to be equal to true, stdout to be equal to subprocess.pipe, stderror to be equal to as well subprocess.pipe. So this is just the syntax for the subprocess library, and std input to be equal to subprocess.pipe. So once we create the proc variable, all we need to do is just take the proc, and from that variable we need to take the standard output.read. So we want to read from it, and we want to also get proc.standarderror.read. And we will store both of these in the result variable, and once we actually store it in the result variable, we can just send or sock.send the actual result. This will happen in every case. Instead of the case where we specify Q, then it will just break out of this loop and it will close the connection as well as the program. So if I just Control O and save this, also check out the server side of code. And let's rename here as well. So we don't want to have message variable. Let us call it result so it doesn't get confusing. And we want to print the result. So our result variable will store the output of the command executed on the target machine. Then we will print that output. So let us see how that will work. We save this. We run the server in this terminal right here. And in the other terminal, we run the reverse shell. We get prompted the shell. It says connection established from this IP address at this port. If we type ls, we can see that we get listed the available files in that current directory. So we know that everything works well. Let's try other commands as well, such as who am I. It says we are the root, such as ifconfig. We get the output of our ifconfig, so we know everything works perfect. Also, if we specify Q, it will quit both of our programs, and we know that we successfully created the reverse shell that is now able to execute commands in the target system. So for now on, we did a pretty good job at actually creating the server-side code and the reverse shell side code. Now we want to actually add a bunch of different functions, and to fix some of the functions is there are errors right here, such as, for example, if you wanted to change directory, you would not be able to, as well as if you wanted to receive the amount of data that is larger than the 1024 bytes, I believe. Yeah, 1024 bytes, which we specified right here. Our program would actually crash, since we are trying to receive more data than we specified our result variable to have. So we need to fix that as well. And we will fix that in the next tutorial. So that will be about it for this tutorial. I hope you enjoyed it, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back. And in this tutorial, let us see what we can actually do in order to be able to receive and send as much data as we want. So for example, some function, or not some function, some command will actually retrieve a larger amount of bytes than the 1024 bytes. For example, some netstat command could be retrieving like 2000 bytes or something like that. So we want to actually fix it so it can receive any amount that the command output is. So we will add two different functions right here, which we will then need to add in the reverse shell as well. So for now on, we will call the send function reliable_send. And what we will paste in that function is the actual data for to send to the target. All we need to do right now is import a library which will allow us to finish our process with these two functions. And basically, let me just add another function, which will be reliable_receive. This function will be used to receive data. And we will use JSON in order to perform this process of sending and receiving as much bytes as we want. So in order to send the data, we need to create some variable which we can call JSON_data. You can call it anything you want, but it needs to perform the dumps function, so JSON.dumps, on the actual data that we specified as an argument to this function right here. So after we do that, we can just simply send the actual data with the same sock.send function, or not sock, in our case it should be target.send, since we specified the target to be the actual socket object for the target machine. we need to target.send, and what we are sending is the JSON data. So this is the actual entire sending function, and we will be using this reliable send function to send any data from now on. We will not be using target.send anymore in any case. Now we want to code the reliable send. We need to also make a variable which we can just call data and specify the data to be empty. So we specify that just by opening double quotes and closing double quotes right after. Make sure to not have space right here, otherwise this will actually give the empty space to this variable. We need to open the while true loop in order to receive the data for as long as there is something to receive. So what we will try to do is we will try an except rule, which will allow us to actually receive. So if I just type right here, data equals data, which will be empty data, plus target.receive. And we want to receive 1024 bytes. We close the brackets, and we actually want to return JSON.loads function. So that is a function in the JSON library from the data that we received. So in any other case, or if we get any error, we want to actually use the accept value error. Now let me just write this and I will explain what this means. We want to continue the process. So let's explain these functions so you can understand it a little bit better. What we did right here is, first of all, we created a simple variable, data, which is empty. Then we entered the while true loop, and in this while true loop, what we will do is we will try to receive the data. We'll try to receive 1024 bytes, and we will try to return that data to the actual shell function right here. In case we get any error, or not any error, in our case value error, which means that we actually trying to receive less bytes than the output of that command was. So that means that we actually still have some bytes left to add to this data. What we will do, we will then continue, which will go to the beginning of our true loop, and then it will add those remaining bytes to the data. And it will perform all of this until the entire data has been sent and stored in this data variable. Then we can return the data variable and print the output of that command. So one thing we need to make sure as well is right here, instead of using this target.send right now in our shell function, we need to use reliable_send to send the command. And in order to receive the actual output, we need to use reliable_receive and make sure to remove the 1024 bytes, since our reliable receive doesn't take any argument in the brackets. So we will not specify anything right here. Everything else can remain the same. So let us save this program and let us copy these two functions, since here we will actually paste same functions in the reverse shell side of code, just we will do minor changes to that part of these, or to the part of those functions where we specify the sending and receiving. So paste these two functions in the reverse shell code and change every target.send and every target.receive into actually sock.send and sock.receive. Since the target variable is not actually something we have in the reverse shell program, so make sure to specify right here sock.send JSON data, and right here make sure to specify sock.receive. And also in the shell function, we need to specify that command equals reliable_receive. We want to receive data with this function, and we want to actually, let me just see, send the result with the reliable send. So right now, if we coded everything successfully without any error, we should be able to send and retrieve any amount of data that the user or that the target sends back to us. So let us save this. Now let's test our program to see if it works. Let me just put this down here. Run the server. We are listening for incoming connections. Then run the reverse shell. Let's execute ls. Global name JSON is not defined. Okay, so in order to fix that, the reason why the global name JSON is not defined is because in our reverse shell code, we forgot to import JSON library. So make sure to have imported JSON library in both server and reverse shell code. Now let us run it once again. Okay, server already, or pardon me, address already in use. We will just restart the terminal as I showed you before. Once you get that, just make sure to restart the terminal. Run the server once again. Run the reverse shell. Execute, for example, ls, it works, ifconfig, netstat.-nr works as well, whoami works. So basically anything that we do now works. we will be able to receive any amount of data, and our program will not crash if the data is bigger than 1024 bytes. Let us specify Q in order to close the connection. We can see it worked perfectly, and our program is now even better than it was in the previous video. We got a fully functioning reverse shell that can only execute commands from now on, but what we will do from now is actually specify some different things that our reverse shell will be able to do, such as, for example, download files, upload files. We will try to perform the connection every certain period of time. We will also try to perform the screenshot function that will actually screenshot the target's PC. We will also check for the user privileges or administrator privileges, and we will see how we can hide our program or our backdoor somewhere where the user will never find it. So hope you enjoyed this tutorial, and I hope I see you in the next one where we will continue coding. Bye! Hello everybody and welcome back, and in this tutorial what we are going to do is we will actually try to perform the first test of our reverse shell. So this is our first test right after we saw how we can execute commands on the target system. Now let's try to actually test this on our Windows 10 machine before we start adding any new functions we might need and any new libraries that we need to import. So let's see how we can compile our reverse shell, since right now if you see, let me just delete the server.save. Okay. Since now you can see that we have the reverse shell.py, which can't really be executed on Windows target system unless the Windows target system has the Python interpreter. But we know that what we can execute on the Windows target system is the actual executable files or .exe files. So let's see how we can make our reverse shell.py to be an actual executable. So let me just delete this socket as well, not really sure what that is. And let us right now use our wine in order to actually compile this program. So what we want to do is, first of all, go right here and just type this command as the same command as I will. So wine /root/.wine /drive/c/python27 /pyinstaller /python27 /scripts /pyinstaller. And then after that, once you specify that we want to use the pyinstaller library in order to compile this, we need to specify some of the actual additional options that we want our reverse shell to have, such as we want it to be one file, which we can specify with double dash and then one file right after it, and then double dash no console, which will specify our reverse shell not to prompt the console open once it starts the file, which can be a little bit of actually weird if our target actually gets prompted a console, so we want to make sure to remove it from this program. Then right after you specify all of this, you need to specify the name of the program that you actually want to compile, which in our case is reverse shell.py. Press right here enter. This will take a few seconds to compile, and you will get some directories right after it in this reverse shell directory from where we will get our executable. So then you can actually use any type of delivery method you want. Let me just show you. If you just type ls right here, you will have this build directory, this directory, and this reverse shell.spec directory. Your actual executable will be in the dist directory, so just type cd dist. And if you type ls once again, you can see there is reverse_shell.exe. That is our actual executable. And let me show you how you can actually transfer it via USB drive. So just plug in your USB drive. And your USB drive will be plugged into your main machine, as you can see right here. What you need to do is, first of all, let me delete the previous reverse shell from here. Actually, I can delete all of this, don't really need it at the moment. In order to actually import the USB drive into your Kali Linux machine, you need to go up here on Devices, USB, and find the name of your USB drive and just click on it. In my case, that is the Kingston Data Traveler. I'll just click on it, and right here, it should be imported into my actual Kali Linux. As we can see, it is imported right here. So in order for me to copy that file or the reverse shell to the actual Kali USB drive, I just need to specify move reverse shell to the media, root, and then Kali Live, which is the name of my USB drive. So this is the path where your USB drive is or will be imported. So /media/root, and then all you have to do is afterwards specify the name of your USB drive. Then if I just click here enter, it will move the reverse shell.exe to my USB drive, and after this finishes I can just eject my USB drive and paste the actual reverse shell to my Windows desktop environment. So this is taking a few seconds, since this is probably the first time. Okay, so let's wait for this to finish, and afterwards all we have to do is just run our server on our Kali Linux and run the reverse shell on our target system. Okay, so it has finished. You can see if I just type ls right here, there is no longer reverse shell.exe in my directory. And what you can do right now is delete all of this that you got during the compilation program. So we can delete the build directory with rm-r, we can delete this directory with rm-r, and we can delete the reverse shell.spec. All we need to do right now is run the actual server.py, and we can now eject our USB drive, go right here, paste the reverse shell onto my desktop on my Windows 10 machine, and then if I just double click this, you can see nothing really gets prompted to the actual target. It will look like this program didn't run at all and didn't open anything. But if we go to my actual Kali Linux machine, we can see connection established from the IP address of my Windows 10 machine from this port. In order to make sure that this really is my Windows 10 machine, in case you doubt, we can just type ipconfig in my command prompt on my Windows 10, and you can see the IP address of my Windows 10 is 192.168.1.4. So we successfully got the connection from the Windows 10 machine. Let's see if we try to execute some of the commands, such as, for example, ipconfig, the same from our terminal. We can see the results from ipconfig, dir, which will list all the actual files on my desktop. As we can see, the path is to my desktop. These are all the files on my current desktop directory, as you can see right here. So for example, you can just make dir, so I'm pretty sure, I believe it is make dir, test1. You just execute that, and we can see right now on my desktop there is a directory called test1. If we wanted to, we can delete the test1. So we just type del test1. But that is a directory, it might actually cause a problem. Okay, yeah, it will cause a problem. Doesn't really matter, you can see right here it will hang. We will see how we can fix that in the future tutorials, but right now we can see that we successfully compiled our program and we can successfully execute some of the commands on our target system. What we will do in the next video is we will continue fixing our program. We will see how we can actually change the directory from the desktop to some other directory as we like, and we will also see how we can execute some of the commands that present us the problem, such as, for example, this command. Also, if we actually try to specify to delete a file that doesn't even exist by making a typo or just not specifying the correct name of the file, our program will right now crash in case we do that. So we will see how we can actually fix that as well, so we don't actually lose the connection, just like we lost it right here, while trying to perform some task. So hope you enjoyed this tutorial, and I hope I see you in the next lecture where we will continue coding. Bye! Hello everybody, and welcome back to our reverse shell coding. So in the previous video, we saw how we can actually run our commands in a while true loop, and also how we can execute the commands on the Windows 10 host. We tested our shell while after being compiled on our Windows 10 machine, and we saw that actually everything works well except some certain commands that cause our actual shell to crash. So the first thing we need to fix is the inability to actually change the directory once we run our reverse shell. So in order to do that, we need to import a certain library, which is called the OS library, which will allow us to use a function called change directory in order to perform the changing of directory in our reverse shell. So first of all, go up here. Let me enlarge this one so you can see it a little bit zoomed in. And we want to import OS. The OS library is standard library in Python, so we will not need to pip install it in order for this to work. What we want to do right now is perform an else if statement right here in the shell. So what we have for now, if the Q command is specified, this will close the program. In any other case, it will execute the command in the command prompt. But we do not want to execute this in the command prompt, so we will add an else if statement, and in order to specify the actual changing of directory, we need to know how it actually looks like once you change directory in Windows 10 machine. So in order do that, open up your command prompt, so cmd, it is same for every Windows host, and currently we are in this directory. So for example, let's say I want to go to my desktop directory, I will do that with this command, so cd desktop, and then you can see my directory is now changed to the desktop directory. So right now we know that the command for changing directory starts with these two letters, which is cd, which basically just stands for changing directory. Same if I wanted to change the directory back, I can do this like this with cd two dots. It is rather same in Linux as well, so basically those two commands are the same, or this command is the same for Linux and Windows. So let's see how we can specify that in our program. We know that the command will be received in this variable right here, so we can actually filter it out with this statement. So else if command, and then in the square brackets we will specify the first two letters with like this. So if first two letters, oops, not space right here, are equal to cd, and length of the actual command variable is bigger than 1, then we will use a function called os.changeDir. From the command, from third element or from fourth letter in our command to the end. So now you probably, if you're new to this, have no idea what I just typed right here, so let me explain. Once we actually type the command to change the directory, it will look something like this: cd space and then the name of a certain directory. Let's say, for example, cd desktop, as from the example in command prompt. Now we see at this we look at this statement right here. So this statement right here is satisfied. The command, actually the first two letters of the command are indeed the cd. Now this statement right here also needs to be satisfied in order to proceed with changing directory. The length of the command variable has to be bigger than 1, which basically stands for, since we know the counting starts from 0 in Python, the length of the actual command has to be bigger than two actual letters. Now why is that an actual statement? Well, if you open up your command prompt, and you will see that if you just type cd, it will just print the working directory. So cd and cd desktop don't do the same thing. Just cd only prints the working directory, and the cd desktop changes the directory. So we need to specify right here, once there is actually something else specified after cd, then we want to change the directory. Then we proceed to this statement right here, which basically stands for change the directory to the directory that is specified in the brackets. And in the brackets is specify command from the fourth element to the end. Now we can count right here. The C is first element, the second, three, or basically third element is the empty space, and the fourth element will be desktop. From the fourth element, it will be desktop. So in the brackets, basically you can just imagine it says right here desktop, or the name of any other directory you want to change. So that's how this changing of directory works. So let me just delete this right now. But just in case, we actually want to run this in a try and except rule. In case, for example, user specifies the directory with a wrong name, we don't want our reverse shell to crash, so we will just try and accept. We will accept, and in any case where the user actually specifies, for example, directory that doesn't exist or any error occurs, we will just continue with the program. So basically this is the entire code we need to specify right here. Let me just check this out. Okay, everything seems to be goodly specified, and all we need to do is right now save this and nano our server code, since there we need to code something as well. So right here we can code, since you will see that if we actually send the cd command, we will then proceed to this statement right here, which will then wait for a certain bytes to be received from the target. And with cd command we really don't receive anything, since there is no output to that command, we just change the directory. So right here we need to specify something that will just go back to the beginning of the loop. So we can just use else if the same, so the same as in the reverse shell, so command and first two letters are equal to the cd, and length of the command is greater than 1. Oops, let me just add space right here. All we want to do is just continue with our loop, which will basically just go at the beginning of this loop. So let us save this let us compile our program to see whether this will work. So wine, then we need to specify the actual path. So wine, root wine, drive C, Python 27, scripts, and then py-installer.exe in order to compile this, -- no console, and -- one file. And then the name of the file that we are compiling, so reverse_shell.py. Make sure to still have the actual USB drive, since we will perform the same task as before. Right now I will just not explain what I'm doing. Basically do the same as before in order to transfer the actual reverse_shell.exe onto the desktop on your Windows 10 machine or any Windows machine you're running. Let's wait for this to compile. It should take just a few seconds. So we go to this directory. There we are going to have our actual exe file. We import our USB drive. ls, okay, there is our exe file. And now I move my exe file to media root Kali live, which is the name of my actual USB drive. Now right here, of course, you will not have this name. You might have a different name for USB drive, so make sure to specify it. As soon as this actually transfers, you can unplug this. Go on to your Windows 10 machine, and I can just transfer it on my desktop. Now before I run the reverse shell, I must run this server. So let me just delete the unnecessary directories that we don't need anymore, same as in the previous video, and I will run my server. Now after that I will run the reverse shell.exe. We can see nothing is really opening right here. There is nothing being prompted, but if we go right here, we received the actual connection. So we know that we are in the actual desktop environment or desktop directory, so let's see if we can change the directory. We will create a directory called test. We can see on our desktop right now it is created. And let's try to change the directory to test directory. And if I just tap there once again, there is nothing here because our test directory is empty, but we can see that we are currently in the test directory. If I go one step back, another step back, so that means that I will be in the actual directory, which is one step before the desktop directory. So you can see our actual changing of directory works really well. We can change to any directory we want. So basically our program works fine now. What we will do in the next video is we will see how we can actually download and upload files from the target PC and to the target PC. So hope you enjoyed this video, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and in this tutorial we are going to see how we can code a part of our server and reverse shell in order to be able to download any file that is stored on the target system or upload any file that we want from our Kali Linux machine. So we will need to specify a few different things in order to be able to download any type of file, such as exe files, pictures, mp3 files, VBS files, and so on and so on. So let us see how we can do that. We will start off with our server code. So nanoserver.py. For now on, all actual options we have is the queue option, the change directory option, and the actual executing of command option. So what we want to do is add the upload and download option, and we can do that the similar way as we added the cd option. So what we will do is we will code another else if statement. So else if, we will add the command, and first of all let us add the download command. So let's actually think how we can specify this. Well, we can actually specify the same as cd. So first first 8 letters, since that is how many letters download word has. If the first 8 letters are equal to download, then we will see what we will do. So first of all, let's see how our command will look like. I will just write it right here. So for example, let's say there is a test.txt file on the target desktop. So let us create it. We can just use notepad. Hello world, exclamation mark. I will just save a file on the actual desktop. So we will call it test.txt. I save it, I close this, and we can see our testing file is right here. So we will try to download this file from target PC. So what we need to do, first of all, the command will look something like this. So download test.txt. We checked if the first 8 letters equal to download. If they do, then what we will do is, first of all, we will open a file on our Kali Linux machine with the same name as the file on target machine, and we can specify the same name to be as from the command variable and from the 9th element to the end, which will basically stand for it will cut out the first 8 elements, which will be the download word. Then it will cut out the empty space, and it will basically name the file what is the remaining, which will be test.txt or any other file name that you try to actually specify. So that this is the name of the file. The second argument of opening files is how we want to open them. So we want to actually write to a file on our Kali Linux machine, and we want to write bytes. You specify that with W and B. Basically, W stands for write and B stands for bytes, and we close the brackets. So these are the two actual inputs that the file creation in Python takes. Now we need to specify as which file descriptor we want to open it, so we can just call it as file. So simply just call it file, it doesn't even matter. And then once we do that, once we actually open the file, we want to receive the data from the test.txt file on target PC. So we will just make a variable called result, even though we already have it right here, but this is the part of code that will not be run once we actually run this command. So we need to specify another variable right here. We'll call it the same result, and it will be just result underscore receive. Or if you want to, if you're actually getting confused by two same named variables, we can just type here file result or file data, let's call it like that, file data equals result underscore receive. And then what we want to do is write to this file that we opened right here, which is saved on our Kali Linux machine. So file.write, and in file.write, we need to actually write this data that we received. But in any case, in the case of this file actually being a text file, we can just simply specify here file data. But for example, if we try to download a picture, we would need to first of all base64 encode the picture before sending it from the reverse shell, and in our server code we need to perform the base64 decoding of that picture. Now we will use the base64 library in order to be able to download and upload any file we want. So we'll just import base64 so our program doesn't crash, and in order to write right here we will need to perform a decode function, since in the reverse shell later on we will perform an encode function. So right here, instead of file data, between the brackets you need to specify base64 dot b64 decode, and in the actual brackets open and close another brackets and specify what you want to actually write, and we want to write file underscore data. So this is basically everything we need to specify for the actual download function right here. As we can see, we open the file to write bytes, we receive the data in this variable file data, and we wrote the decoded file data, which we will encode later on in the actual reverse shell. So that will be actually about it for the download function. Let us code right now the upload function for our server. So we will start off the same. Let me just delete this download test.txt since I will forget to delete it later. And right now what our command will look like is upload test.txt. Just right now this test.txt will actually be on our Kali Linux machine, and we will upload it to the Windows 10 machine. So else if, oops, not here, we want to code down here, else if command, and we count how many letters upload has. It has 6 letters, so first 6 letters of the command are equal to upload. What we want to do is basically, first of all, open a file. So open a file that is already on our Kali Linux machine. So right now, instead of actually opening a file in the download function, we need to open it in as reading. So we want to read from that file. So with open and then a command, we want to name it the same as from the actual command itself. So from the 7th character till the end, which will just leave the test.txt as a name, which is right now important since it will not open a file if we don't specify the correct name. So then make comma, and how we want to open it, we want to open it to read, and we want to read bytes. So RB between double quotes, close the brackets, and we can call this one fin. It doesn't even matter, you can call it anything you want, as long as you make sure that later on you specify the write and read function the same name. So we open the file, and what we want to do right now is actually send the contents of this file. So we will reliable underscore send. And now, since we are the ones sending the data, we need to encode it before sending it. So we will use base64.b64 and now encode, and not make sure to make a difference between the decode and encode. Don't type both of them the same. And right here, once we encode it, we want to send the actual fin.read. open and close brackets, since this is a function, and close another bracket from the actual reliable send function. So we successfully send the file, but make sure to add a try and except rule right here, since we don't want our program to crash if we, for example, specify the name of the file that we want to upload to target PC, the wrong name. We want to run this in a try and except, so try, then tab these two, we will try this, and then we will accept. If any error occurs, we will just basically send to the target a failed variable, which will contain a string which will say failed to upload, which we can then check. If we cat the target, the actual target file, we will see that it says failed to upload, and we will know that something is wrong with the actual upload function, or that we specify the name incorrectly. And all we want to do is reliable send the actual failed string. So we can use base64 once again, since we need to encode it, base64 encode failed. So this is the entire download and upload function in the actual server. Now what we want to do is basically just code the same thing in the reverse shell. So in order to not type this twice, I will just copy this. I will close the actual program, save everything, save it under that name. Let me just check if I saved everything correctly. Okay, I did. Then I go to my reverse shell, and right here under the actual change.go directory, I can specify what I copied from the server code. But of course we need to change a few things right here. We cannot leave it just like this, since the download and upload function will not be the same in our server code, or pardon me, in our actual reverse shell code. So let me just check here. If we get the command to be download, that means that our reverse shell is receiving, or basically it is sending the file. So we first of all need to change this write bytes to read bytes in download in the reverse shell. We can leave it to be named the same, and we are not actually receiving the data, we are sending the data. So let us delete this. Let me just go right here. And what we want to actually do is basically reliable send, or we cannot leave it like this. This is writing to a file, so let us do it like this. Reliable send, open and close brackets to our function, and send base64.b64 encode. Since in our server we decoded the download function, right now we need to encode it in order to send it. We open the brackets, and we are sending the file.read. Open and close another brackets, and close two other brackets. Since make sure to have 3 brackets open and 3 brackets closed, so you don't run into an error. And all we are left to do before testing our program is to fix the upload function as well. So in the upload function, first of all, we need to fix the actual RB to be write bytes, since in our target PC we are now writing the file that we are receiving, and all we have to do is just receive the actual file. So we need to delete this first of all. We don't need the try and except rule right here, there is no point. So let us delete all of this, and then we will write what we need. Also delete the try. And let us see what we need to do in order to make the upload complete on our reverse shell. So what we will do is file data will be equal to reliable_receive. So what we are doing is we are receiving the file data, and we want to write, so fin.write the base64.b64 decode, and what we are writing is the file_data. So if I'm not mistaken, everything right here should be good to go. And right now if we save this and compile the actual program, let me just find the command from the previous video so I don't type it once again, just actually compile it with the same command as usual. Press enter. We let this compile, takes a few seconds, and right now let us see if we are going to be able to download this test.txt file, as well as upload some file that I will create right now in our Linux environment. So let us just wait for this to compile. We can right now import the USB drive, go to my disk directory where my actual reverse shell.exe is, and move it to my media root and Kali live, which is my USB drive. So we wait for a few seconds. Okay, so it has finished. I unplug the USB drive. Let's paste the actual reverse shell to the desktop. Now make sure once you're actually downloading and uploading the files, you can only specify only the name of the file once you're in the same directory as that file. For example, if this reverse shell was one directory back and not on the desktop, you will need to specify the full path to this test.txt file in order to be able to download it from a different directory. So before we actually run our program, let me go one directory back, delete the dist, delete the build, delete the reverse.spec, and before I run my server, let me create right here in this directory a file which we will call hello.txt. And we will type here hello there. We will save it, so we can have it right here, and then we will try to actually upload it to the target PC. So let us run this server, upload test.txt. Okay, so in my server code, what I forgot is to remove this line. And there is also another thing that I think I forgot, which is unfortunate, but we will have to actually fix it. Yeah, I didn't import the base64 library like here, so make sure to import it. Import in reverse-shell.py, and right now I will compile it once again because our program will not work. The one that we actually pasted on our desktop, I will just delete it. It will not work because we didn't compile it with the base64 library. So I will compile it once again, just give me a second. I will plug in my USB drive real quick in order to transport this reverse-shell.txt to the target. Okay, change to dist, move reverse shell to the media root Kali live. Sorry for this, forgot to add the base64. Make sure you add it as well, otherwise your program will not work without that library. And we are good to go right now. So let's run our server. Okay, so we have an actual error. Let me just find it where it is. Except, why is there an error right here? Not really sure. Oops, what am I doing? Okay, it could be because we are missing something somewhere. For example, right here we are missing another bracket in our server code. So make sure to add a third bracket right here. And right now, if we run this, everything works well for now. So let me unplug my USB drive from the Kali Linux machine. Then paste the reverse shell to my desktop once again. And I can run it right now. So hopefully if everything worked well and we coded everything well, our reverse shell should connect back to the Kali Linux as it did. So let us check some usual commands such as who am I and basically dir for actually listing all the files on the actual desktop environment. And right now, let's first of all try to download this file to our Kali Linux machine. We, for example, saw an interesting file, which is test.txt. So let us type download space test.txt. We press enter. Result underscore receive is not defined. Oops, so we named something not really correct. So let me just try it once again. Let me just remove all the unnecessary directories so we don't actually confuse ourselves with them. So somewhere I specified result.receive instead of reliable.receive or underscore receive. Let me just find it where it is. Okay, so here is the error. It's not result underscore receive, it is reliable underscore receive. Let me just clear the screen, run it once again, run my reverse shell once again. It connected back, there, works, and let's download test.txt. Okay, so it seems like we didn't get any error. If we run another command, we can see we can execute further commands. So we hope that we actually downloaded the file successfully, which we will change as soon as we terminate the connection. But before we terminate the connection, let's try to actually upload to the desktop the hello.txt from our Kali Linux machine. We can see right here there is nowhere hello.txt file. So if we go right here, type upload hello.txt, we press enter, everything seems well. If we go right here, there is now hello.txt file, we open it, and it should say hello there, as it really does say. So our upload function works. Now let's terminate the connection with Q and type ls, And we can see our download function works as well, since we have the test.txt file right here. If we cat the test.txt, we can see it says hello world exclamation mark, which indeed it does if we open it right here. So our upload and download function work really well. We managed to code them, and in the next video we will code some different functions useful for our reverse shell. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now what we are going to do is we will see how we can hide our reverse shell. So in the previous videos we saw once we actually ran the reverse shell, it was rather here on desktop, and the user could simply just delete the file as soon as they run it, right after they close it with Task Manager. So they would be like, why is this file not running? It's not opening anything, I do not need it, and then they would delete the file. But what we can do is as soon as they actually open the file and run it, we can actually make a copy of that file into a different directory where they will never find it. So for that directory we will use a hidden directory in Windows called the app data directory. We will hide our copy of our reverse shell there, and then we will try to create a persistence which will allow us to actually run our reverse shell right after the target restarts their computer. So basically what we are doing in this video is we are hiding the program and also creating the persistence for our backdoor. So let's see how we can do that. In order to do that, we will need to import a library in order to copy our file. So let us nano the reverse shell first of all, and import a library which is called shuttle. So import shuttle right here. And where do we want to actually create the persistence itself? We can actually create it at the beginning of the code. So before it even connects back to us, it will perform the copying of the file, and then it will connect back to us. So what we can do is we can create a variable called location, which will store the location to the new path of the actual place where we want to copy our backdoor. So we will specify that place with os.environ, and in the square brackets between the double quotes we need to specify app data. What this will do is it will find the app data path on our target PC or on our Windows PC. Now make sure once you run this reverse shell it is a Windows target, because app data folder doesn't exist in the Linux systems. So let me show you where it is. If you open your command prompt and at your path of your user, just there you can just type cd app data, and you will be in the hidden directory. There you can just type dir, and you will see some different directories as well. Now the path where we are going to actually save our hidden or our copy of our backdoor will be in the roaming folder in our app data path. So this is basically the path of app data, and this function os.environ will return this path right here. All we need to add to this location is the name of the file, so we can add it like this, plus, since we can concat the strings in actual Python, we specify right here // in order for this to actually work, and we can name the copy of our file anything we want. So let's name it, for example, windows32.exe, since that looks something, or it basically looks like something that could possibly exist on target PC. So even if the victim or the target actually found this file somewhere, they would probably not worry about it, since it pretty much has a normal name. Now you can call it anything you want as long as it has .exe extension, and make sure to close the double quotes right after it. So right now what we are going to perform is checking if this location exists right after we run the program. Now the reason why we are checking if this location exists is basically what happens if we actually run this file twice on the target system. So in the first time it will actually create this path with the file right here. We do not want to create it a second time. We only want to create it once. So in order to do that, we can just type here location, or not location, we can just type if not os.path.exists, and this function will basically check if a certain file at the specified path exists, and our specified path will be location. So if it doesn't exist, we want to create it. In order to create it, we can just use shuttle.copyFile, which is a function that will copy a file. Now we want to copy our executable, which we can specify with the sys.executable. It will specify the actual executable that is running in this program and the comma, and then we need to specify the path where we want to copy it. We want to copy it in location. Now in order to use sys.executable, we need to also import a function called sys, or pardon me, not a function, a library called sys. So once we copy the actual file, we want to create the persistence. Now this is an optional, you don't need to create a persistence if you don't want to. I will show you how you can do it. There is one command which you can run in your command prompt to create persistence, which will basically add a registry key to your Windows 10 machine. So let us do that. So subprocess.call. In the brackets right here, since we are using subprocess.call, what this will do is it will execute the command. We need to specify this command, so just type everything. I type open single quote reg add hkcu capital backslash software backslash Microsoft backslash Windows and then backslash current version and once again backslash run. Then space, then normal, whoops, not space outside of the bracket, so space, then normal slash small v, then the name of the actual registry key that you want to create. So I will just call mine, in this case, backdoor. Doesn't even matter, call it anything you want as long as it is one word. Then the type of the registry key we are creating, it is reg_cz. I will show you later on where you can find all of this. You also need to specify the /d option, then close double quotes, then close single quotes, then add the actual location with the plus, so we can concat a string. So plus location, plus, and then single quote, double quote, single quote. And then comma, shell equals true. Oops, T has to be capital. And this is the entire actual command. So what this will do is it will create a registry key, which will make our file run after every restart. It will create a registry key at this path, so it is a registry key at the current user host key, or pardon me, hkey current user. Let me just show you how to get there. You just type in your search bar right here, you can type run, and it will open up this small window where you can type regedit. It will prompt you for the administrator password. You just, since I don't have, I will just type yes, and it will lead you to a page like this where your registry keys are. So we can see we created in the hkey current user, since hkcu is the name of our path. Now make sure to not delete anything from here that you don't know what it is, since it can actually crash your PC. So right now we go to the same path that we actually specified right here. We click on hkcu, we want to go software, Microsoft, Windows, current version, and then run. So let us go hkey current user, software. Then we need to find Microsoft, which will be under M. So let me just find where M is. Here it is. Then what we are finding is the Windows. Okay, so here it is. Current version, and then run. And right here is the place where we actually want to create a registry key. And basically this run path right here, here are all the files or all the programs that will run once you actually restart your PC and log into the same account on your Windows 10 host or any Windows host at all. So basically, once we actually run the program, right here we will have something called backdoor, which will be the type of reg_cz, and the data will be the path to our file that we copied. So it will be the path to the app data folder where we have windows32.exe file, which is basically just a copy of our backdoor. So let us just tab this down. Let's see what else we need to type right here. Basically, this is for now on enough. We don't need anything else. Let me just check if this command is good enough. Then we proceed to create the socket object, and then we enter the shell. So let us see if I save this, exit. Now we want to compile the program once again. So wine/root.wine, drive C, Python, and then scripts, PyInstaller, -- no console, and -- one file. Now we don't need to fix anything in the server code, since this is something that will only run in the actual reverse shell. Now here it is prompting me this because I forgot to specify the file that I need to compile, which is reverse_shell.py. Okay, so we will see how this will work. Right now we don't have anything named backdoor right here. And also if we go to our app data roaming folder, so open your command prompt, go to your app data, which you can just go to your actual user account and then see the app data and then see the roaming and type dir right here. Right here is where we will have our windows32.exe copy of backdoor once we execute the reverse shell, or once the target executes the reverse shell. So let's leave this open as well as this open, and let's unplug our USB drive in order to transfer the actual reverse shell. So let me go to this directory, move the reverse shell to media, root, and the actual USB drive. Let's see, why is it not plugged in yet? So USB, let's unplug it and plug it again. For some reason it won't plug in. Okay, so let's wait for it to plug in. There it is. Right now, if we move the reverse shell to media, root, Kali live, takes a few seconds. You can also transfer this reverse shell over Apache 2 web server if you want to, whatever you find easier. For me right now, I will just use the USB drive because it comes pretty handy and I believe it's faster, maybe not. But just make sure that you know that once you actually download the file from the internet or from the Apache 2, it will prompt users saying this is an exe file, would you like to run it? But that actually comes with every file that is actually exe and download from the internet, so it doesn't have to do anything with the viruses, so don't worry. Right here we want to go one directory back and run our server.py. Let us actually remove the USB drive. Type right here, or put it right here, and then run it. Let's see if our reverse shell.exe will work right now. So as soon as it connects, and it already did connect, we can execute commands. So what this means that it already completed the process of copying the file and creating the persistence with our registry key in our HKey current user registry. So let us see. First of all, check the command prompt. Right here, you cannot see any Windows32.exe folder or file. If you type here once again, let me just find it. Here it is. So right now we do have a Windows32.exe, which is a copy of our backdoor. And if we go to our actual registry edit, when we refresh with F5, we can see right now we have a new registry, which is the backdoor. It is called backdoor. Now you can call it anything you want, just specify in the actual reverse shell the different name. If you think this is actually noticeable, which indeed it is, and we can see the path to the program that it will run at the startup, which is the path to our Windows32.exe. And right now, even if the actual target took this reverse shell and deleted it, and even if they shut down their PC and turned their PC tomorrow, or in 2 weeks, or in 2 years, you would still be able to connect back, or basically to connect to their target PC and execute the commands. So let's just close this, since we don't need it, even though, let me show you, even after you actually delete this, so it is deleted, but it will still remain in here. So that would be about it for this tutorial. We saw how we can successfully create persistence, we hid our backdoor into a different file, and in the next video we will see some of the different options we can actually add to our reverse shell. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and in this tutorial we are going to see how we can actually perform the connection to the actual server every 20 seconds. So you might have noticed that every time we actually tested our reverse shell, we needed to wait, for example, before we actually ran the reverse shell, we had to set up our server in order to connect back. Now what, for example, if our target suddenly opens the reverse shell without us listening for a connection? It will not be able to connect back to us, and it will basically just close the program, and we will not be able to execute the commands or do anything else on target PC. So we want to implement something in our reverse shell which will try to connect back to our server basically every 20 seconds, or doesn't have to be 20 seconds, it can be any amount of time you want to specify. So in order to do that, let us go to our reverse shell. Oops, let me just delete from the previous compilation unnecessary files and folders. So we can only have these 2 files. Let us also delete the hello.txt and test.txt, and let us nano the reverse shell.py. Right here, what we want to do is, instead of this connection right here, first of all, what we want to do is delete it. Since we don't want to connect right here, we will make a simple function which will do that for us. So just delete this right here. Oops, not everything. So socket.sock_stream. Okay, and right here, we will basically just call a function which will be called connection. So this function is the function that will perform the connection. Just go up here, right here, go up, and we can code the actual function right here. So def connection, open and close brackets, let's add the 2 dots, And in order to be able to actually execute the connection every 20 seconds, we need to run this in an infinite while loop. So while true, we will add something called sleep, which is a function that comes in the time library, and in order to use it we need to import time. This is a library which will allow us to use this sleep function, which will basically just not execute any part of the code for the specified amount of time. So this sleep function actually takes one argument, which is the amount of seconds you want your program to sleep. In our case we will specify 20 seconds, and after that we can try to connect. So try sock.connect, open double and open double close brackets, and between the double quotes we need to specify the IP address, which in my case is 192.168.1.9, which is the IP address of my Kali Linux machine, then comma, and the port that we are listening on, so in my case 54321. And after that, once it connects, we can actually enter our shell from here. So if we are entering our shell from here, we don't need to have the shell specified right here, so we can delete the calling of the shell function from here, and we will call it from the actual connection function. In case it doesn't actually manage to connect, that means that our server is not open and running and it is not listening for connections. So in that case, we will call connection function once again. So this is a recursive function. It basically calls itself. As you can see, we call the function connection from the connection function, and this will go in circles until it manages to connect to our server. So for example, if someone ran this reverse shell and then 3 hours later you actually opened and started your server, it would actually connect to it even 3 hours after running the reverse shell. So let us say this. Time sleep, 20 seconds, everything is good. We can now try to compile the program. So wine root.wine drive C Python 27 scripts by installer. Okay, so no console, one file, and then reverse_shell.py. Let's press enter right here. Let us import the USB drive. And right now what we are going to do is we are going to run the reverse shell first, then we will wait a few seconds, and then we will run our server in order to see whether it will connect or not. So let me just go right here, go to dist, and move the reverse shell to my USB. Also, since we already have from the previous video the copied backdoor into our roaming folder and also a registry key in our registry editor, this reverse shell right now will not perform the persistence since it already performed it in the previous time we actually ran it, as you can see in the actual code. So let me just go right here. It is good to know that .py. You can see that we coded right here that it should not perform these two commands in case this location right here exists. So since it does exist, since we coded it last time and we actually copied it, it will exist and it will just skip this part right here and it will go straight to the socket creation and then connection function. So that is good as well. Let us run our server. Let us unplug the USB drive. Copy the backdoor or the reverse shell to the desktop. Run it. Oops, we actually made a mistake. Let's wait for it to actually connect. We should have waited 20 seconds and we should have run the reverse shell first. So what I will do is I will just close, as soon as this connects, I will just press Q to close the connection, and then I will start the reverse shell once again and just basically wait a few seconds before starting the server. So I quitted the server. Let us start the reverse shell once again. Okay, so it is started. We can see nothing is opening, nothing is running. Basically right here we don't have our server opened. And let's wait a few seconds and actually start our server. So clear the screen. There wasn't really point to clear the screen, but doesn't really matter. And let's right now run the actual server. It is listening for incoming connections even after we run our reverse shell. And right now, hopefully, we will get connection back. So let's wait a few more seconds since we specified the timeout to be 20 seconds. So in less than 20 seconds, we should connect to the target. And we did, so we can see we got a connection from our Windows PC at this port, or the connection is from this port. We can execute the commands, we can do anything as in the previous videos, so our actually persistent with the timeout of connecting actually works right now. So at this point, all you need to do is deliver this reverse shell to the actual target, and you will be able to connect to them anytime you want, as long as their PC is on. So that will be about it for this tutorial. I hope you enjoyed it, and in the next video what we will do is we will see how we can actually download some files from the internet with our reverse shell. Hope you enjoyed this tutorial, and take care. Bye. Hello everybody, and welcome back to this tutorial. And right now let us call the function in our reverse shell which will allow us to download to the target system any program we find online. So all we will need to specify is the path to that program in a certain website, and our reverse shell will automatically download it in the target PC. So let us go to our reverse shell. Let me just delete once again everything unnecessary, and nano my reverse shell.py. And right here, in order to do that, what I need to import is the actual requests library. So import requests. What this library allows me to do is actually navigate through the actual website and get a certain URL and get its content so I can write it back to a file. So that is basically what we are going to do. We are going to get the URL, read its content, and write that content from that file into another file that we make on target PC. So we will call that function right here, and we will call it download. So simply as that. Now don't actually confuse this download right here with the download from here. This download is basically downloading the files from the target PC, and this download is actually downloading the files to target PC from the internet. So let us paste it right here, and this download function can take the URL as an actual input. So we will paste the URL to this function, and all we want to do is make something called get response from this certain URL, and in order to do that we need to code requests.get. This function right here will basically get this URL that we specified with the requests library. Then these contents we need to write to the file. In order to actually name a file the same as the file that we want to actually download, we can just type here file underscore name will be equal to the URL.split. We want to split it at the slash. Now I will explain this in case you don't understand. And we want to take the last part of the split. This -1 basically represents the last part. So let me show you what I mean. So for example, if you have google.com/release/downloads/python.exe. For example, this is the URL, and python.exe is the file that we want to download to the target PC. What this right here will do is it will split the URL everywhere there where it has slash, and it will take the last part from the URL, which will be just python.exe, which will be our file name. So let me just delete this. Our file name is specified. All we need to do is run our with open, and the name that we want to write to the file is basically stored in the file name variable. We want to write bytes, so VB, and we will call it the file descriptor as out_file. We can call it just like that. And what we want to do is out_file.write. And the thing that we want to write to this file is from the get response so get_response, we want to get its content. This will be the content of the file that we are downloading. So this is basically the entire function. All we need to do is call it in our shell function once someone specifies a certain command. So in order to name that command, we can just call it get. So if you specify get and then there's an empty space and then the URL, it will download that file. So let's do it like this. We know that get has 3 letters, so else if command and then first 3 letters equal to get. Then we will try and accept the download function. So we will try to download the URL. So right here we need to specify the URL, and in order to specify any URL that the user of our server specifies, we need to type here command, and from the 5th element till the end. Since our command will look something like this, so get google.com/release/blah blah blah, and then we need to get the URL from the 5th element, so it will just print the rest of this string. So let us go back here. We specify the download function right here, and what we want to do is send to our server reliable_send. We will send with a plus, downloaded file from specified URL. So we will send this, and in case it doesn't work, we will just send, so reliable underscore send failed to download that file. So these are the two strings that we were sent, whether the download function works or whether it doesn't work. And right now I believe this is all we need to code. In the server side of the code, we don't really need to code anything because we send the command to download the actual file from the URL, and then we wait for the reply. The reply will be stored in the result, and it will get printed either failed to download the file or download the file successfully. So nothing really here to code anymore. All we need to do is compile the actual program, root.wine, drive C, Python. We will see this 1,000 times in this section. So scripts by installer, no console, one file, reverse underscore shell.py. So let's let this compile, then we will transfer it to the actual Windows 10. So let me plug in my USB drive. Okay, USB drive plugged in, reverse shell compiled. We need to remove it or move it to the media root Kali Live. Let me just delete everything right now. And I will run my server right here in order to listen for the connection. Let's run the reverse shell as well. So run it like, okay, so fail to execute script reverse shell. Now this is a good error because I believe I know why it happened. So let me just show you what we can do. First of all, we will need to close this. This can happen because our reverse shell, if I nano it, you can see we right here have a requests library. Now, basically, our Pi installer, or pardon me, our Pi installer doesn't really know this library, so we probably need to actually download it to our wine folder. Or let me just check if I name this library correct. Requests. Okay, so that is correct. In order to get the requests library for the Pi installer, we can type wine.root.wine. Then we need to specify drive C, Python 27, and then python.exe -m, and then pip install requests. You just press here enter, and right here it will collect the requests library, and then if we compile it once again, right now it should work. Hopefully this is the error, so we can actually fix it right here. Let's wait for the requests library to actually download for our wine, and you can see it is downloading it. So that was the actual error, and this is a really good error to actually get, since right now you know how to download any library that you might not have for the wine. So you can just download it with that command. Just at the end, all you need to specify is the name of the actual library. But right now what we need to do is actually compile it once again. So we compile it, we will plug in the USB drive in order to send it once again back. Okay, so USB drive is plugged in. This is compiling. Hopefully it shouldn't take too long. Here it is. Let us go to this directory and move reverse shell to the media root and Kali Live. Go one directory back, run our server. Okay, address is already in use. We will fix that just by actually restarting our terminal. So open once again terminal. Let me enlarge this in. And let me go to my Python reverse and then run my server. Right here I will paste once again my reverse shell, run it. You can see right now we do not get any error, so everything works perfectly right now that we actually downloaded the requests library. And here in a few seconds, since the 20-second timeout, we will be getting the connection from our Windows 10 machine. And then what we can do is actually test our get function. So in order to test it, first of all, we need a file to download from the website. We will use my Apache 2 web server. So in order to actually run the Apache 2, you can just type service Apache 2 start. Once you start the Apache 2, we go to the cd var www.html, and there you will need to download some of these files. So in my case, let us download the index.html. So let me just remove the other file so it doesn't confuse us. And we will try to download this index.html file. So if you go right here, 192.168.1.9, the index.html file is basically this HTML file containing the Facebook page. It is from our previous part in our course. So we'll try to actually download that file, which will contain the HTML code for the Facebook page. So let me close this. It is at place. We try to execute some command right here, and then we get http 2.168.1.9/index.html. Downloaded file from specified URL. So let us see if we go right here. We have the index.html file right here. If we open it, it should open the same page as the Facebook page saved on our Apache 2 web server running on Kali Linux. So let us see. It is opening, and here it is. Okay, our get function works really well. So that would be about it for this tutorial. Hope you enjoyed it, and we will continue coding in the next lecture. Bye!
Hello everybody, and welcome back to our reverse shell coding. And in the previous video what we did is we coded a function that will be able to download a file from the internet to the target PC. Now let's see what else we can code for our reverse shell for it to have multiple functions that we can use once we actually infect the target with our payload. So let me just zoom this in, and we will navigate to our Python programs, reverse shell, and we will nano our reverse shell. Now let me just delete from the previous compilation these unnecessary files, so we can only have our two main files, which is the server and reverse shell, and let me nano my reverse shell. So we have the download function right here. We perform the connection every 20 seconds. Now let's see, for example, how we can take a screenshot from the target PC. For example, let's say they are using Facebook and sending messages, and we want to, for example, see what messages they are sending. Without implementing a keylogger yet, we can actually run a screenshot and see their entire screen as many times as we actually want. So in order to do that, we will need to import a library, which I'm not really sure if it comes with the PyInstaller. Maybe we will need to install it while compiling the program. So the library is called MSS, and we will import it like this. So from MSS, import MSS. Now before I do this, let me just check out in Python, import MSS. Okay, so Python 2 doesn't have it. Let me just try to import it like this. So from MSS, import MSS. Okay, so we know that the library is not in Python 2, and we can install it with pip install MSS. Now if this doesn't work, we will just install it for the actual PyInstaller in the wine folder, since that is actually where we need it, but you can also install it for your own Python in Kali Linux if you want to. We will not really be running this on the Kali Linux target, we will be running it on the Windows machine, as usual. So we can see it's successfully installed, and now if we go to the Python and import MSS, it is there now. So you also have it in Kali Linux Python. So we imported it. Now let's make a function right here, for example, and we will call it screenshot. Let's leave it for now on. Right here, we will code it in just a second. What we want to do is add an actual option right here. So we want to create another else if statement for the actual screenshot. So let us add it right after the get command. We can just go down here, make else if, and then the usual command, and then let's count the letters. So screenshot actually has 10 letters. So we want to make sure that we specify everything until the 10th character equals to the screenshot. This is the function that we will use in order to screenshot target PC. So we will just type in the server command line screenshot, and then we will get back the screenshot from their PC. And what we will try, since this doesn't work every time, for example, I tried getting this to work on Windows XP and it just doesn't work. I believe it works on Windows 10 and Windows 7. On Windows 10 it works for sure, on Windows 7 I'm not so sure, we will have to try it out later. So we need to run it in a try and except rule in order for our program not to crash, for example, once we encounter a target that cannot take screenshot. So what we will try is we will try our screenshot function that we will code in just a second. Once we do the screenshot function, we need to send that screenshot to our Kali Linux machine. So basically, since we are on the reverse shell code right now, what we will do is we will actually open that file for reading bytes, and we will send the actual data to our server. So Now, before we do any of that, the actual screenshot, once you use the MSS library, will save the screenshot under the name like this. So monitor -1 .png. So this is the name how this MSS library will save the screenshot under, and every screenshot will be actually saved under this name. So that can present a problem to us, because if we make one screenshot and it saves under this name, and we want to, for example, take a second screenshot, and we take it, it will rewrite this screenshot right here, because it will have the same name. So we will no longer have the first screenshot. So we need to actually make sure that doesn't happen. So how we will do that is we will actually fix that in the server-side code. For now on, all we want to do is open the file under this name, since after we perform this function, there will be a screenshot on target PC. We want to open it, read data, and send data to the server. And in the server, we will rename this so it doesn't actually rewrite other screenshots that we take. So first of all, with open and close brackets, between the double quotes, let's specify monitor -1. Now make sure to specify exactly the same name, otherwise this will not work. So PNG, and then comma, and we want to read bytes from that screenshot. Since we are getting a picture, whoops, we don't need another bracket. We want to open it, let's say, as CS, so shortly for the screenshot. And what we want to do is reliable send, reliable_send, base64, base64.b64 encode. Since we are the one that are actually sending this, we want to encode, and the thing that we want to encode is the sc, or our screenshot.read. So let me just count the brackets. We have 1 open, 2 open, 3 open, and 3 closed. So everything is good right here. And also, for example, let's say that the reversal is running on the desktop. So the target found it on the desktop, double-clicked it, opened it, and we took a screenshot. The monitor-1.png file will be saved on the desktop, which can actually trigger some users. They basically find the screenshot of their own PC, so they maybe believe something is wrong by then. So what we want to do is actually delete the screenshot as soon as we send it. Now you will notice that you will not even be able to see the screenshot for a fragment of a second, so nothing will be suspicious. If after the actual opening of the file and sending, what we want to do is use the OS library, and we want to .remove, which will remove a file that is specified between the brackets. So let us just copy the name of this file, which is monitor-1.png, paste it between these brackets, and this will remove the actual screenshot right after we send it. And in the except rule, what we want to do is reliable send_send, and let's send a string, basically a string, that will say failed to take screenshot. Now why we are sending the string? Well, basically, if we fail to take the screenshot, we will have a file, or not a file, we will get prompted this string right here, failed to take screenshot, and then we will know that the screenshot function doesn't really work on that target. So now that we did this, what we need to do is actually code the actual screenshot function, which is rather short. It is just 2 lines, so don't worry, nothing really too much. Our MSS library already did the entire job for us. All we need to do is type with MSS, and then as a function, as screenshot, so this is the name, you can specify anything you want, it doesn't really matter. We want to use screenshot.shot, and this will save the screenshot for us. This is the entire screenshot function. So basically, if I'm not mistaken, this should be entire actual code for the screenshot. Now let us save this. So Ctrl-O save, Ctrl-X to exit, and let us nano our server and see what we need to do once we actually get the screenshot back. So let's first think about it, or let me just at the beginning create the actual else if statement. So else if, we need to perform the same thing, command first 10 characters equal to screenshot. Let's think about it, what we actually need to do right here. As I said, it will save every screenshot as the same file, so we need to change that. We will use a counter, for example, or not a counter, we will just increase the variables. For example, let me show you right here, so maybe we want to send it better. If you go down here, and for example, at the beginning, you create a variable count equals 1. So count equals 1, and that is a global variable, so we can use it in this function right here. The reason why we are using the global variable is because we need to actually increase that count variable every time we run this screenshot function in the while true loop in the shell function. So let me just show you. We will actually receive the data first of all, but before receiving it we need to open the file under a specified name that we want. So what we will do, in order for that file not to rewrite, since every screenshot has the same name, we will name it screenshot %d, and then we need to use the %count to be replaced instead of this %d. So since count is 1 at the first screenshot, it will be the name of screenshot 1. Then we will increase it at the end and it will be screenshot 2 and so on and so on. So since we are the server, we need to open for the writing bytes, and the name, we can name it fin. Doesn't even matter. You can name it anything you want. Or maybe if it is actually confusing for you, just name it just screen, so you know it is a screenshot file. And actually we need to receive that file right now. So let's do it like this. We will create an image variable, and that image variable will store the data from the received screenshot, so reliable receive. And since we encoded it with base64 encoding, we need to decode it, so we will create image underscore decode, or decoded, equals base64.b64 decode. And the thing that we are actually decoding is the image itself. So just type here image. And now what we want to do, since the try rule in our reverse shell actually saves the image or sends the data for the image, what we want to do is if we successfully took a screenshot, we want to save that to a file. If we didn't take successfully screenshot, that means that we are getting the string back, which will say failed to take screenshot. In that case, we want to print it to our screen. So in order to check that, we can just check first 4 characters, for example. So if image underscore decoded, and then first 4 characters equal to this string, which is the string that we specified at the beginning of the fail to take screenshot function, then we want to print image underscore decoded, because that means that the actual image failed to take. So image underscore decoded. And in any other case, we want to actually write it to a file, because that means that we successfully took the screenshot. So we'll just use screen.write, and we want to write image underscore decoded. And make sure that you increase the count variable right after you do this, but not right here, since that it will increase it even after you don't take the screenshot. You want to increase it right here, so count plus equals 1, which will just increase the count variable by 1. So that is the entire actual program. Let us now save this. We can compile our reverse shell. So wine root drive c python scripts installer -- no console -- what's the next thing? Okay, one file, and then reverse shell.py. Let us run this with enter. This will compile, and then we will run it on the actual Windows 10 PC. And later on, when we'll actually code the threaded server, which will accept multiple connections, we will try to run a screenshot on Windows 10 and on Windows XP. So let's wait for this to compile. Now, if my IP address changed, we will need to compile it once again, since I just started Kali Linux. Didn't really check the IP address. Hopefully it didn't. Okay, so let us check the IP address. .1.9, and let me check the IP address that is specified in the actual Kali Linux machine. No, pardon me, in the program. Okay, so it is .1.9. Good. So right now, let us plug in my USB drive. Or let me actually show you another way that you can download this reverseshell.txt without plugging in your USB drive. You can just go to the Google Chrome. If you, for example, for some reason don't have USB drive, then you can just go cd dist, and you can move this to the move the reverse shell to the var/www/html, which is the standard Apache 2 folder. So you just move it right there. You can see it's no longer here. We can delete the rest of the files. And all you need to do right now is actually run the Apache 2. So you can do that with service Apache 2 start. And this will start the Apache 2 for you. All you need to do right now in order to access that file is you need to know the IP address of your Kali Linux machine, which we already really know. It is 192.168.1.9. So we can just go right here, just type 192. 192.168.1. Oops, we have two dots, so .168.1.9. Okay, so we still have the Facebook login page from the previous tutorials. Let us just remove the actual Facebook login page so we can see the file. If we remove index.html, we only have our reverse shell.exe. If we refresh, here is our reverse shell.exe. So all you need to do is just click this in order for this to download. You can see it downloaded successfully, but you will notice one thing. Let me just show you. Once it is on our desktop and we downloaded it from the actual Apache 2, it will no longer run as the USB transfer station. As you can see, this is something that we didn't really encounter before. Right now it says Windows protected your PC, prevented an anachronized app from start running. This app might put your PC at risk. All you need to do is go to the more info and run anyway. So now our reverse shell is ran, and for some reason we get fatal error. Okay, I think I know what the reason is. The reason is because we actually only installed the MSS library for the actual Python in Kali Linux. We forgot to install it for the Python in Wine, which for some reason I said we need to do that and then I forgot to do it. But let me just do that real quick. In order to install it for the Wine, run this command right here. So wine /root /.wine/drivec/ Python 27, I believe, and then python.exe. Then you need to specify -m and then pip install and then MSS. Run this command, and this command will basically just download the MSS library for the Wine, and then hopefully everything will work as usual. So until then, I will just plug in my USB drive because I find it easier to actually transport via the USB. Okay, so we can see here it is. Now we have the MSS library. Now we can actually, let me just find where the reverse shell is. Okay, so here it is. Let us navigate to the previous command. Here it is. I will compile this real fast so we don't waste time. Everything is finished. Go to the dist, move the reverse shell to your Windows 10. So root media, or it is media root. Or basically I just need to plug in the actual USB drive before I try any of that. So /media root Kali live. We move the reverse shell. Hopefully that was the error. I really can't think of anything else being the error. So remove this, remove build, remove reverse.spec. Let us unplug my USB drive. And I can run my server for the listener, even though we can actually run the reverse shell first, as we saw that we actually created a function to connect every 20 seconds. And right now, if we run, first of all, you will notice we don't get that error prompted, we don't get that warning prompted that says this app might put your PC as a target or something like that. I'm not really sure what it even said, but it doesn't even matter. Right now it doesn't say it because we didn't download it from the internet. And here we get the connection back. So all we need to do is first lower this so you can actually recognize the screenshot once I take it. And if we just type screenshot, oops, local variable count referenced before assignment. Okay. What do you mean? So nanoserver.py. Yeah, actually, let me just double check everything right here. We need to actually code this at the beginning because it goes through all these functions and then it runs to a count variable which it doesn't really recognize. So let us code it. Just move the count equals 1 at the beginning, even though we didn't really run that function yet, but it doesn't even matter. Let us just try once again. We listen for the incoming connections. It should come any second. As you remember, we have a timeout of 20 seconds before connecting. And as soon as it does, we will just, first of all, check a simple command to see if our program works, and then we will run the screenshot and see how it looks like. So here it is. Let us just run who am I just for a simple check. Then I can lower this so you can see the screenshot better. And if I just type screenshot, what do you mean count referenced before assignment? Oh, I think I know what does it mean. Sorry about that. It doesn't really know what count variable we are using. We need to specify right here at the beginning that we are referring to the global count variable. I believe that is the problem. Sorry about that once again. And hopefully third time, third luck, so we will be able to run this right now. Even though we crashed already 3 or 2 times, something like that. But hopefully everything will be good to go right now. The problem was, I believe, because that global count string, or pardon me, global count command wasn't really implied in the actual shell function. So let us just run it straight away. Screenshot, we can see it finishes relatively fast. Now let me just lower my screen right here so you can see. Screenshot, if I run it, you can see there really isn't anything on the screen that appears, such as the monitor1.png, since this performs really fast and it sends the data, and as soon as it does it, it will remove the screenshot. And if you want to check actually where the screenshots are, we can first of all press Q to quit the program, and you can just type ls and you will see in this folder there is screenshot 1 and screenshot 2. Let us navigate to that folder. It is in the root Python programs and then reverse shell. Oops, we need to go to the places, I believe. Then go to the computer. Then find the root right here. You just find it. Here it is. Go to the Python programs. Go to the, where is it? Reverse shell. And screenshot 1 is basically just the screenshot of our full screen Kali Linux, as you can see. You know it's a screenshot of Windows 10 PC because we can see our Windows 10 icons down here. And the second one is more convincing since we can see even the Windows 10 background in the actual screenshot. So our screenshot actually works perfectly. It is even a good resolution, so everything is good to go. You can see everything in the actual picture and you can perform as much screenshots as you really like. All I need to do afterwards is just delete these screenshots if you want to. So remove screenshot 1, remove screenshot 2, and you will be good to go for running the next program. So that will be about it for this tutorial. What we will do in the next one is we will code a simple help function that will print the help to anyone using our program. So we will just implement all of these things that we coded in a help function, and later on we will continue implementing more things to our actual reverse shell. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye!